Hello, I am Varun Joshi and welcome to Cloud with Varjosh, where we talk about cloud, DevOps, and everything in between. What you are about to watch is a fully consolidated version of my GitHub Actions Basics to Production course, bringing together 13 structured lectures and approximately 12 hours and 45 minutes of hands on practical learning into one continuous learning experience. I value your time, and my goal has been to make sure that every minute you spend here adds value to your understanding. This video is for those who prefer learning complete topic in one focused flow rather than moving between multiple individual lectures. For completeness, I have retained the original lecture transitions so you can easily map different sections of this video back to detailed notes and demos available in the accompanying GitHub repository. Before we begin, I want to thank the community. The support and feedback on my courses, whether Kubernetes, Jenkins, Argo CD, Git, GitHub, has been overwhelming. Hearing that someone cleared a certification, cracked an interview, built a project, or finally understood a concept by following these courses genuinely motivates me to keep creating deeper and more structured content. And that brings us to GitHub Actions Basics to Production course. GitHub Actions has become an important part of the modern DevOps and CI CD ecosystem. It allows us to automate builds, tests, deployments, infrastructure changes, and much more directly from GitHub. But learning GitHub Actions is not just about writing a YAML file and getting a workflow to run. To build real automation, you need to understand why different features exist, how they behave, and how they connect together. And that is exactly what this course focuses on. You do not need prior experience with GitHub Actions. We start with the fundamentals and gradually move towards more practical and production oriented concepts. However, you should have a basic understanding of Git, GitHub, and Docker. This includes concepts such as repositories, commits, branches, pull requests, Docker images, and containers. If you are completely new to Git and GitHub, I recommend going through my Git masterclass first. For Docker fundamentals, I have also covered Docker as part of my CKA or Kubernetes course, which you can refer before starting this course. This is not a collection of disconnected GitHub actions features. This course is designed as a progressive learning journey where concepts introduced earlier become useful as we move into more advanced topics. We begin with the core building blocks, including workflows, triggers, jobs, steps, runners, and contexts. From there, we explore filters, conditions, expressions, variables, and functions to control workflow behavior. We then cover inputs and outputs, artifacts, caching, matrix strategies, environments, secrets, approvals, and protection rules. As we move further, we explore reusable workflows and GitHub custom actions, including Composite, JavaScript, and Docker actions. Finally, we explore concurrency and learn how to prevent related executions from overlapping when parallel execution could create problems. You may occasionally see me revisit important concepts, and that is intentional. Understanding something once and being able to confidently apply it later are not always the same thing. Sometimes seeing a concept again in a different context is what helps everything connect. The goal of this course is not simply to teach you GitHub Actions YAML syntax. Anyone can copy a workflow, change a few values, and get something up and running. The real goal here is to help you understand why a configuration exists, what problem it solves, and how GitHub Actions behaves under different conditions, and how different features work together. That is why the course includes hands on demonstrations throughout. We create workflows from scratch, modify them, trigger them in different ways, pass information between components, reuse logic, and observe how GitHub Actions behaves. As you follow along, keep asking yourself, why are we doing this? What problem does this solve? What happens if we configure it differently? And when would we use this in a real project? Because production engineers are not the people who memorize the most commands or YAML syntax. They understand how systems behave, why they behave that way, and what can happen when things do not go as planned. Alongside this video, you have a structured GitHub repository containing the workflows, YAML configurations, hands-on demos, and detailed notes for each lecture. The repository can also serve as a revision resource, whether you are learning a concept for the first time, preparing for an interview, or revisiting a particular GitHub Actions feature. My recommendation is to keep it open while following the course and experiment with the examples yourself. And if you find it useful, consider giving it a star so more people can discover the content. If this course helps you understand GitHub Actions, build a workflow, prepare for an interview, or implement something in real project, I would genuinely love to hear about it. And if something feels unclear or you think it can be improved, let me know that too. Your feedback helps shape the content I create next. By the end of this course, my goal is that you should not just know how to write a GitHub Actions workflow. You should understand how the different pieces fit together, how to reason about workflow behavior, and how to build automation that is practical, reusable, and suitable for real world CI/CD scenarios. We will start with the fundamentals, build our understanding step by step, thought by thought, inch by inch, and gradually connect those concepts into more advanced implementations. If this course adds value, consider liking the video, subscribing to the channel, and leaving a comment. And if you would like to support the work further, you can also consider joining as a channel member. Nothing is locked behind paywalls. Membership simply supports the continued creation of pre-structured and in-depth cloud and DevOps content. So if you are ready, let's begin our journey through GitHub Actions Basics to Productions course. Let's get started. Hi, I am Varun Joshi and I welcome you to the first lecture of this GitHub Actions Basics to Production course. In this lecture, we will build the conceptual foundation required before writing production grade GitHub Actions workflows. We will start with a quick refresher on CI/CD and understand how modern software delivery pipelines operate in production environments. From there, we will walk through a typical CI/CD pipeline for a Java containerized application and understand how applications move from source code to deployment. Next, we will understand what GitHub Actions is, why it became popular, and how it fits into the modern CI/CD ecosystem. We will then explore the core constructs of GitHub Actions, including workflows, jobs, steps, and runners, followed by GitHub-hosted and self-hosted runner types. Finally, we will create and execute our very first GitHub Actions workflow. So let's get started. What I will do is I'll go to my browser first And here I will zoom in a little, and then I will go to this repository that is for this course. I'll go here and I will go to the very first lecture, that is this one, and then I'll scroll down and I will go to prerequisites for this course, because there are certain prerequisites for this course and this course expects you already understand a few things. And fortunately, whatever are the prerequisites for this course, I have covered all of them in this channel. The first prerequisite is you must understand Git, and that is the obvious, because whenever you version control, the most popular tool for same is Git. So you must understand what are commits, how to check commit history, what is branching, merging, rebasing, cherry picking, pull requests, code reviews, and so on. Because as we progress with this course, we would be using some advanced features. And of course, you may understand while I'm running the commands, but if you want that deeper understanding and those aha moments, then understanding Git is imperative. Next is YAML. As you know, most of the DevOps tools, including Kubernetes, Ansible, Helm, Argo CD, all of these use YAML. So you must understand YAML. So here is the video where I teach how to write YAML. I recorded this as part of my CKA playlist. Then you must also understand modern SDLC, software development lifecycle. Along with this, in this lecture that you see here, you will understand what are compiled languages and how they are different from interpreted languages. Because if you do not understand these languages from a high level, then there is no point in deploying applications that are using these languages. So watch this. We will also learn here build workflows for containerized applications, build workflows for non-containerized applications. For example, if you are deploying directly onto virtual machines, then how would you approach that? Build automation, why it matters, why deployment standardization matters. So you will be learning all of these things in this lecture. And this lecture I recorded as part of my Jenkins CI/CD series, but it has no relevance with Jenkins, so to speak, because the concepts that I have taught here apply to all CI/CD tooling. So be it Jenkins, GitLab CI, or GitHub Actions. And then you must also understand CI/CD fundamentals. I do have a refresher on what is CI/CD in this lecture, and we are going to go there soon. But if you want deeper understanding, not just about all these practices, but also about what are the branching strategies that are used in production, what is Git flow based branching strategy, what is trunk based branching strategy, environment promotion strategies, how are artifacts updated from dev to stage and then from stage to production. So we have detailed discussions on that in this lecture. Then production deployment workflows, of course. So you can watch this. Now comes an interesting thing. So understand GitHub Actions or any CI/CD tool acts as an orchestrator. Orchestrator that is orchestrating between different tools and services. So if, for example, I have integrated Kubernetes for my application, then I must understand Kubernetes. If I am working with Docker, if I have integrated Docker in my CI/CD flow, then I must understand Docker. Same applies for all these tools that you see on screen. So if you do not understand these tools, then there is no point in learning CI/CD. So for example, if we are creating a pipeline that is deploying onto Kubernetes and that is creating container images using Docker, you must understand these things. Now for this very first lecture, this understanding is not needed, but as we progress with this course, I will let you know that this is something that you want to know before proceeding with this lecture. So for example, if we are building an application, Java application, then I would tell you, before watching this lecture, go and learn what is a Maven. Before integrating security practices, I would ask you, go and watch this lecture where we discuss in greater detail what is DevSecOps and what is SonarQube. So I will mark these prerequisites wherever needed, but understand CI/CD tooling, act as an orchestrator. You must understand individual tools or services to work with CI/CD. Now that we understand the prerequisites, let's move on to the diagram. So I'll go here and I'll scroll down, and let's understand what is CI/CD. CI/CD refers to modern software delivery practices used to automate, standardize, and operationalize application delivery workflow. So let's break this definition. We are calling this CI/CD. CI means continuous integration. Now, what is it integrating? Why does the name have integration? So what it is integrating is application code changes, whatever you are committing onto your repositories. It is integrating those with certain workflows that you have already defined. So for example, if I am a developer, I push my code onto my repository, then based on my push, there must be certain triggers that would build my code, will test my code, and ensure my code does not have any vulnerabilities. So all these things are called continuous integration. In the next section, we will look into how a typical pipeline looks like so that you have better understanding of continuous integration. And when it comes to continuous integration, you have things like fetching source code from repositories, building applications and binaries, running automated tests, executing security and quality scans, building container images, publishing artifacts, and so on. Then comes the CD part. CD deals with deployment. Now, this deployment could be automatic, so as in there are no manual approvals involved, or it could also have manual approvals. Now, your deployment, you could be deploying onto dev environment, stage environment, or onto production environment. But when you deploy onto production environment without any manual approvals, then you call it continuous deployment. So understanding this key difference between continuous delivery and continuous deployment is important. So continuous deployment, you only call it continuous deployment when you are deploying onto production environment without any manual approval. Rest you call continuous delivery. So let's read this. CI automates build, testing, and validation workflows. CD keeps applications ready for production deployment. Production deployments may still require manual approvals. CDP, that is continuous deployment, automatically deploys validated changes to production. Auto deploying only to dev, test, staging, or any other environments is not continuous deployment. So maybe you have a workflow where you are deploying onto development or deploying into staging without any manual approvals, all automatic, all automated. In that scenario, that is not called continuous deployment. So continuous deployment only deals with production where you are deploying without any manual approvals. Then what are the advantages of CI/CD? Standardizes build, security, testing, and deployment workflows. This is true because if you have defined everything that has to be done, then you have standardized that. No matter how many times the pipeline is run, whatever the steps were performed the last time, the same will be performed the next time. So you have standardized your build standards, your security standards, your testing standards, and your deployment workflows, reduces repetitive engineering and operational activities, which is true. When you have defined everything in a file, you do not have to perform things in silos, because understand, CI/CD is orchestration. If you have that orchestration layer, then you do not have to build the software separately and then deploy the software separately. All of these things are coordinated and combined within your CI/CD workflows, enables faster, safer, and reliable software releases, which is true because CI/CD is meant to do that. Improves deployment consistency, scalability, and auditability. Now, if you have means in place via which you are auditing whatever your CI/CD systems are deploying, you get this because everything is at one place and you can audit it in a better way. And why we are calling deployment consistency? Because even when your application is deployed multiple times, the results, the steps that will be performed will be consistent. Now that we have this understanding of what is CI/CD and what are the advantages of CI/CD, let's move on to the next section where we'll discuss a typical CI/CD pipeline for a Java containerized application. And you see the icons for Jenkins, GitHub Actions, GitLab CI/CD here. Why all the three icons, Varun? Because the pipeline that you see here can be built using any of these tools. Like I said, these are just orchestrator. The actual tools that are used to perform actions will still be there. CI/CD is not replacing them. CI/CD tools are just ensuring the automation and orchestration works in an expected manner. Now, what I have done with this diagram is I have segregated this diagram into different sections so that you understand how CI is different from CD. So if you see all the top blocks, and we should be calling them stages, all of these stages are part of continuous integration, and both of these stages are part of continuous deployment or delivery. I also want you to know that this is not something that is written on stone. You can have more stages in continuous integration. Maybe you are performing additional security scans because you are using this CI/CD pipeline to deploy a banking application. Maybe your CI stages are less because you are doing testing right now. You are just starting to build your CI/CD pipeline. So keep these things in mind. This is a typical CI/CD pipeline, not the pipeline. And then you also see observability here, that is operation feedback. Now let's see what all things are being done here. And before I move forward, there are terms in this diagram that you may not understand right now, which is okay because this is the very first lecture. But then Varun, why did you keep this complex CI/CD pipeline here? I kept this here so that you understand the breadth and depth of CI/CD pipelines. And as we progress with this course, we will be breaking these things down, or I will be pointing out to recordings and videos that I have done in the past, which you can refer and then proceed with the lecture that is in question. Now, the first stage is fetch source code. So if your CI/CD system has to do something, it must have visibility on your source code. And how does it have that visibility? It gets that visibility by fetching the source code from your repository. But when should it fetch the source code? It should fetch the source code based on what you have defined as a trigger. I, as a DevOps administrator, could have asked my pipeline to fetch the source code when there is a push event, or I could have defined whenever there is a pull request, you fetch the source code, and then proceed next. And why would you want to fetch the source code to begin with? You want to fetch the source code to run the pipeline. If the source code is not available to the pipeline, then how will the pipeline build your application and then finally deploy your application? Then there is build the application, and this step is critical when we are talking about compiled languages. Even interpreted languages have build steps, but build steps in compiled languages are often quite heavy, because that is the point where we are building the application. So if we are talking about Java, this is the stage where we are converting the source code to bytecode, and there are different tools that you could be using. You could be using Maven, Gradle, or Ant, Maven being the most popular. So in this stage, you compile the Java application artifact. An artifact is a new word. What is an artifact? Anything that results from a build is an artifact. So for Java application, it could be your .jar file, .var file. And if you are building a container image, then container image becomes your artifact. So whatever the result of a build is, it could be a log file as well. That's an artifact. Then execute Maven build lifecycle. So whatever build you want to do, you can use Maven to do that. Next is execute automated testing. Now, if you are using a build tool like Maven, it is not just a build tool, it can do a lot more. So you can even perform unit tests and integration tests using Maven. And what are unit tests? Unit tests is, understand, your application is a big chunk, okay, but your application is made up of different small units. So testing each of those units individually is called unit testing. What is integration testing? Integration testing is how those units work when they are integrated with each other. So that is integration testing. So when I talk about Maven, you have various plugins. There is Surefire, there is Failsafe that you can use for testing. Stop pipeline upon failures. I don't want my pipeline to continue running if something is not in line with what is expected. I expect my testing to be 100%. So all unit tests must succeed. All integration tests must succeed. If any of those fail, then you fail the pipeline. What happens, Varun, if the pipeline fails? I go back to my developer along with the logs and tell him or her that you need to fix these tests. You need to fix the code because I see there are unit and integration testing errors. Next step is run security scans. Now understand, here we have verified that your application is working as expected because it is succeeding all the unit and integration tests. Now don't quote me on this because there could be other stages as well where you could be testing whether your application is behaving as expected or not. But from a unit and integration test perspective, let's say your application works fine. Then in the next step, you want to see whether your application is secure or not. So here you will be performing your static security scans, dependency scanning, and here as well, if something fails, if let's say you have defined that code coverage when it comes to scans must be 80%. If that code coverage is less, let's say if it is 75%, then I would have a quality gate that will say, okay, this pipeline is failed because you do not meet my criteria. And who sets this criteria? These criterias are set by DevOps engineers, by DevSecOps engineers, and so on, along with discussions with your application architects, of course. And then the next stage is build the container image. And again, there are popular tools that are used in this stage, and these tools could be SonarQube, Trivi, Sneak, and so on. All of these have different purposes, and we will see them as we progress with this course. Then you have build the container image. What is building the container image? Now understand, you have an artifact. Understand, what we are discussing a typical pipeline for a Java containerized application. Now, if your application is not containerized, you are deploying onto virtual machine, then of course you will not have this step. But here, since we are talking about a containerized application, we will be building the container image, package application into containers. Second is tag images for registry uploads. Now, once the container image is built, you would also see enterprises also perform scans on the container images using tools like Trivy and Sneak. So you have your container image also scanned. Once everything is in line, you push your container image to a registry. And what is that registry? That registry could be ECR, it could be Docker Hub, it could be GitHub container registry as well. So push images into registries. Now, it is not just images that are pushed onto registries. You could also be pushing your artifacts. But Varun, I won't be pushing my artifacts onto container registries, right? And yes, you are right. You will be pushing these artifacts, these SBOMs, and let's say build artifacts, not container images. What you will be doing is you will be pushing them into different repositories, and there are various offerings from Nexus and JFrog that can be used for saving your SBOMs. SBOM is software bill of material. Understand, your application is made of different libraries, different modules. All of these, the inventory of what your application is composed of is called SBOM. Till here, it is continuous integration. Then we come to continuous delivery or deployment. And what is continuous deployment? It is when you are deploying onto production without any manual approval. So for deploying the application, you have various things. So since this is containerized, let's say we are deploying our application onto Kubernetes. So the tools that you would be using are Kubernetes, Helm, Argo CD. Now, there are two ways. First is your orchestrator is given access to your Kubernetes cluster, and then it accesses it and then runs commands to deploy it. Let's say kubectl apply or Helm is used. But most of the enterprise applications are now following GitOps strategy. Now, what GitOps means is there is an agent running continuously in your cluster, which is comparing the current state with the desired state. Current state, what is the current state? Current state is what your cluster has right now. What is the desired state? Desired state is what you have defined in your repository, as in GitHub, GitLab, code commit, or any of these repositories. So based on what is there in the repository is deployed onto your Kubernetes cluster. So if you are using the first strategy, if you are using a non-GitOps strategy, then your orchestrator will be deploying workloads into Kubernetes environments. But if you are adhering to GitOps, then it is the responsibility of the GitOps agent like Argo CD to check what is there in the repository and then deploy it onto the cluster. Execute post deployment validation. So execute smoke and health validation. What is smoke testing? Smoke testing is verifying the basic functionality of the application. Now here itself, if the application is not behaving as expected, then the rollback is also performed in this step itself. So this is about continuous delivery or deployment. Then lastly, what you have is operation feedback. So this is observability. Monitor the application based on the health metrics that you have decided and then trigger alerts for anomalies. Again, I will mention, if you did not understand a few terms, it is okay. I want you to have a high level view right now, and nitties and gritties we will see as we progress with this course. Now let's see what I want to discuss next. What is GitHub Actions? GitHub's native event-driven automation and orchestration platform. So let's stop here and dissect this. Event-driven, like I said, a pipeline will trigger based on what you have defined. It could be a push event, it could be a PR event, that is pull request, it could be a release event, and so on. So it is event driven automation and orchestration platform. What is automation? Automation is performing tasks. Now, what are those tasks? Those tasks could be performing testing, performing security scans, building container image. So these are the tasks that are automated. Then orchestration. What is orchestration? Coordinates workflow execution logic. That, for example, I will only build the container image once security scans are performed. I will only publish the container image or artifacts once the build of container image is done. So understand, it is critical that these steps, these stages are performed in a sequence, and that is what your CI/CD tooling is doing. Understand, CI/CD isn't doing anything on its own. It is just calling the right tools at the right time. So that is why we are saying GitHub Actions is a native event driven automation and orchestration platform for modern software delivery workflows. First is managed service maintained and scaled by GitHub. I want you to know that when we are talking about any tool, there is a control plane, which is the logic, and then there is a data plane. So data plane is the one that actually does the work, and the control plane is the part where you define what has to be done. Okay, so control plane is the brain, data plane is the one that is doing the actual legwork. So when I talk about GitHub Actions, we are saying it is a managed service maintained and scaled by GitHub. So in that sense, the control plane is managed by GitHub, and also the data plane is managed by GitHub. Now you have options via which the data plane could be managed by you, and we will see that as we progress with this course. But for now, understand that GitHub is a managed service maintained and scaled by GitHub. Now, if you are familiar with Jenkins, Jenkins was different here because you were the one who was managing the Jenkins installation and the configuration part, the patching part, the update part. So the control plane was also managed by you, and the data plane, which are the agents who actually run the job, they were also managed by you. But in GitHub, this is a managed service. Second is deeply integrated with the GitHub ecosystem. And this is so cool. So I'll take you to the GitHub repository. Okay, I'll go to my browser, and if I go here, and then if I see, these are the options. Okay, this is the code, and you see actions. GitHub Actions is right here. That is why we are saying deeply integrated with GitHub ecosystem. So GitHub Actions can have visibility on your code, of course, on pull requests and so on, which is why this tool is so powerful. Then the third point is automation pipelines are defined using YAML, which is why I said YAML knowledge is imperative. And another thing is, in parentheses, you see workflows, and I don't really know why did they call these workflows, because pipelines, the term has been there for so long, but GitHub Actions calls these workflows. So pipelines and workflows, think of these as synonyms. Okay, now I want to discuss the advantages. So I have categorized this into two sections. Advantages of platform native CI/CD. Platform native as in you have the repository also, and then you also have the CI/CD at the same place. So for example, GitLab, that is also an example of platform native CI/CD. GitHub Actions, that is also an example of platform native CI/CD, because your code and your pipelines, the CI/CD system lives in the same place. Now I am choosing my words carefully. I said the CI/CD system, that is the GitHub Actions, and your code lives in the same place. But understand, even when you are using something like Jenkins, your Jenkins file will also reside with the code, and with GitHub Actions as well, your CI/CD file, your pipeline file that is written in YAML will also reside with the code. But the plus point is the CI/CD orchestrator also lives right there, which is why we are calling these platform native. So first point is no separate CI/CD server setup and management. So if you have worked with Jenkins, you manage your control plane and data plane. Native repository authentication and permissions integration. So when you use something like Jenkins, understand you have to provide Jenkins ways via which it can authenticate to your repository. Your repository could be hosted in GitLab, Code Commit, GitHub, or any other version control system, but you had to provide Jenkins with authentication information so that it can check out your code, right? But when I talk about platform native CI/CD, there is no need to provide that, because if I go here, actions are part of all the repositories. You are using it or not is a different story, but it is there at your disposal to use it. And since you are repository and actions, they live in the same account, so to speak, same cloud with Varjosh account, I don't have to provide any separate authentication information to my CI/CD system, that is GitHub Actions, to access my code. This is a very cool thing that you can have. Then is workflows triggered directly using repository events. And that makes so much sense. With Jenkins, you had to configure webhooks, and via those webhooks, your pipeline was triggered. Okay. But here, you don't have to have any webhooks based on events that happen in your repository. And like events, we said push, PR, release event, comment event, and all of these. Based on that, your workflows get triggered. Again, workflows is the term that GitHub uses for pipelines. Unified platform for code, PRs, and automation. Absolutely. Managed runners reduce CI/CD infrastructure overhead. Now, when we were dealing with Jenkins, we had our own agent. So when you have your own agents, it is your responsibility to patch them, upgrade them, secure them, and so on. But when you are dealing with a managed service, all of these things are taken care by the provider. The provider is GitHub in this scenario. Now, all these points also hold true when you talk about GitLab. And another thing I want you to know is, if you are dealing with a cloud provider, for example, if you are on AWS, you have AWS code commit that can act as a repository, and their CI/CD system is AWS code pipeline. So they also largely fall under this bucket. So if you're talking about Azure, you have Azure pipelines and Azure repos. They also offer similar features, if not same. Now let's talk about advantages that are specific to GitHub Actions. And this is why GitHub Actions is so popular. Massive GitHub developer ecosystem adoption. Now most of the developers, they prefer GitHub, and if you get your CI/CD system integrated right in the platform that you love and use for your repositories, how good is that? Which is why it is so popular. And when I started my YouTube journey, I always had in mind that I will be creating detailed GitHub notes, and I did not have any question on which platform my notes will be hosted. GitHub was an automatic response. I created all my notes in GitHub because GitHub is so popular. So GitHub Actions is also becoming more and more popular because GitHub as a repository solution is already quite popular. Second is large reusable GitHub marketplace actions ecosystem. Now, when I talk about GitHub Actions, you have different actions that are available at your disposal and you can use them. So they are pre-created for specific workflows. Now, those workflows could be creating a container image, performing security scans, and so on. And we'll be exploring these in detail as we progress with this course. But GitHub Marketplace is a place where there are many pre-built actions that you can use. And of course, you can create custom actions which you can host onto your repository. So we'll see all of those things. Last point is strong open source ecosystem and community support. So these points are quite limited to when I talk about the repository solution that GitHub has to offer. So if you see most of the open source tooling, the repository of choice is GitHub for them, which is why GitHub Actions is getting so much popular these days. Now, let's see what I want to discuss next. Next is core constructs of GitHub Actions. So when I talk about core constructs of GitHub Actions, you have a workflow. Understand this is singular, and then you have jobs, which is plural, and then you have steps, which is also plural. And there is a reason why I have mentioned this specifically. So if you talk about a workflow can have multiple jobs, and each of those jobs can have multiple steps. So this is the skyby view, and this is the structure you would see. So workflow is your pipeline itself. Then you define jobs within your workflow, and each workflow has different steps, and these steps is where you define what is supposed to be done. And understand, if you have defined something that has to be done, you will need compute resources to perform those actions. And who is the one that provides the compute resources onto which those steps are run? They are called runners. So runners provide the execution environment that is required to run your pipeline. And on this screen, what you see is a workflow. So this is the pipeline, so to speak. And here you have jobs, and each job can have multiple steps that you can see here. This job has 2 steps. This job only has a single step. Now that we have this basic high level understanding, let's dissect each of these. Workflow, top level automation definition inside GitHub Actions. Perfect. Defines triggers using GitHub repository events. Now here you see on. So this pipeline, this workflow will be triggered whenever there is a push event. Now, if I would have written PR here, then this workflow would have triggered based on a PR being raised, a pull request being raised. Third is contains one or more executable jobs. And here we see 2 jobs are there. Again, the high level dictionary that you see, jobs is a dictionary. This is a plural, and then we have defined 2 jobs, job 1 and job 2. I am categorically calling this job 1 and job 2, but when you are dealing in production systems, the first job could be checking out the code. The second job could be running some tests. Third job could be running security scans, and so on. Stored under .github/workflows inside repositories. Now this is critical. Whatever files, YAML files are there in this directory, GitHub Actions will be taking actions based on that. So if I have a single file, let's say I have a file created, my first workflow.yaml, then GitHub Action will look at that file, and based on what is defined in that file, it will take action. So for example, it will see, okay, this file must be triggered when there is a push event. So whenever there is a push event in your repository, GitHub Actions will come into play and do the things that you have defined in your workflow. Again, you can have multiple files inside the workflows directory. But Varun, why will I have multiple files? So let's take the example that we discussed right now. So we had this pipeline with us, correct? Now We could have a single workflow that is performing all these stages, or what I can do is I can have one file for CI, one YAML for CI, and one YAML for CD. Or maybe I am performing all the security in one file, and then I am performing all the pushes in a different file. So it is your decision how you want to do it. You want to have multiple workflow files, or you want to have a single where all the stages are defined, all the jobs are defined, if I talk about GitHub Actions. So this was about workflows. Now let's talk about jobs. Logical execution stages inside a workflow, like we have seen. Each job executes on an independent runner. Like you can see, runner 1 is associated with job 1, runner 2 is associated with job 2. So when I talk about GitHub managed runners, and we will shortly see what is GitHub managed. But when you are using a complete managed solution, even for your data plane, then GitHub will spin one runner per job. So that's why you see there are two jobs. There is runner 1 for job 1, and then there is a runner 2 for job 2. These are two separate virtual machines. Nothing is shared here. Each job executes on an independent runner. Now, but Varun, what if I have done something in job 1, and whatever result was there from job 1, I want to use that in job 2. How do I do that? And we will see all of those things. So park that question for now. Jobs execute in parallel by default. So job 1 and job 2 will run in parallel. But Varun, I don't want to run job 2 until and unless the container image is created, because in job 1 I am building a container image, and in job 2 I am pushing that container image into my container registry. Can we please have a solution that only when job 1 has completed, job 2 starts then? And yes, you can use something called needs. So here in job 2 I have defined needs. So this implies only run job 2 once job 1 has completed. But the default behavior, if we were not using needs, is to run both of these jobs simultaneously, parallelly. Jobs execute in parallel by default. Steps inside jobs execute sequentially. So if your job has two steps, first step 1 will be performed, then step 2 will be performed. So here, first hello from step 1 will be seen, then hello from step 2 will be seen. Supports dependencies using the needs keyword, like we have seen. Now, what are the steps? Smallest executable units inside GitHub Actions job. So inside jobs, you have steps, like we have seen this structure. Perform actual operational and automation tasks. So it is your steps where you are actually defining what has to be done. Now, if you have worked with Jenkins, workflows can be thought of as pipelines, jobs can be thought of as stages, and steps, Jenkins also calls these steps as individual operations inside stages. Execute sequentially within the same runner environment. So like we discussed, commonly use run and uses keyword. Now when I talk about run, like you see here, a run is used to run any commands that you want to run. So for example, if I want to run kubectl apply or helm related commands or terraform related commands, or I have to run mvn package, npm test, maybe I want to run customize commands, all of these commands are run using the run keyword. So for example, here I am also running a command, and that command is echo. So I am using run. Then what is uses? So uses is used when you want to perform certain GitHub actions, certain actions. And we will see what these are in detail as we progress with this course. And then what are runners? Execution environments responsible for running workflow jobs. So whatever is being run would want some compute, and that compute is provided by your runners. And runners are similar to agents like we had in Jenkins, because agents were the one that were actually performing the legwork, which were actually running your jobs. And that is what runners are doing in GitHub Actions. They are the one that are executing your workflows. Receive jobs, execute steps, and return execution status. Now, runners will also provide execution status back to your GitHub Actions that this job has failed, or this workflow has succeeded, or this workflow has failed, and so on. Now, when I talk about runners, there are two types of runners in GitHub Actions, and these are self-explanatory. You have GitHub hosted runners, which are managed by GitHub. There are self-hosted runners that are managed by you or your organization. One more thing I want you to understand is this .github/workflows, you cannot change this. Okay, this is the naming that you must adhere to, because based on this only GitHub Actions will take action on your workflow YAMLs. While workflows, jobs, and steps define the automation logic, the actual execution is performed by runners. So let's talk about GitHub hosted runners. And another thing to understand is the control plane is always managed by GitHub. You don't have a role there. But when it comes to runners, you can either have GitHub hosted runners or you can have self-hosted runners. Fresh ephemeral execution environments provided for each job. Like we said before, each job will get its own execution environment. No patching, scaling, or infra maintenance required. GitHub will take care of everything that is there. Then you have limited infra and networking customization capabilities, because since these are GitHub hosted runners, you can have minimum customization. Examples, you have 3 operating systems that you can use. You can use Ubuntu, you can use Windows, or you can use Mac OS. Ubuntu being the most popular one. Now again, but Varun, where are these runners spun? Who owns GitHub? Microsoft. What is the cloud offering by Microsoft? Azure. So whatever GitHub hosted runners are created, they run on Azure cloud. Now let's talk about self-hosted runners managed by you or your organization. Jobs may execute on persistent runner environments. Now, if you have multiple jobs, job 1, job 2, job 3, they can be executed in the same runner. So in the same virtual machine, let's say. Organizations manage patching, scaling, and lifecycle operations. Of course, if it is self-hosted runner, it is you who is going to take care of patching, scaling, and lifecycle operations. Supports private networking and deep environment customization. Since you are the one who manages the operating system, patches, and so on, you are free to use it. Now, if let's say your execution requires a machine that has GPU, in that case, you can spin a runner that has GPU. And then if you want a specific OS related patch or application related patch to be available in that runner, you can do that with self-hosted runners. But when it comes to GitHub hosted runners, you don't have that customization. Examples, you can have your self-hosted runners run on EC2, you can have Kubernetes pods, on-prem servers, Azure VMs, and so on. So any compute that has access to GitHub Actions, you can use them as runners. Another thing I want you to understand is GitHub will create virtual machines for you when it comes to runners, and we'll see that in the demo as well. What you can also do is you can run your jobs onto a virtual machine, or you can run your job onto a container that is created on top of that virtual machine. So as we progress with this course, we'll see all these options, but I want to plant that concept in your head right now as well. Now, Varun, what should I use? GitHub hosted or self hosted? So, most production organizations use a hybrid runner strategy where standard CI CD workloads execute on GitHub hosted runners, while security sensitive compliance controlled, private network, GPU based, or highly customized workloads execute on self-hosted runners. So that is understandable. You can use a mixed strategy. Now, Varun, can't I just use self-hosted runners? Because I have reservations or savings plan in AWS. I want to use only self-hosted runners. Of course, you can. And there are projects where I have seen just self-hosted runners being used. There are projects where I have seen GitHub hosted runners being used, but there are also projects where I have seen a hybrid runner strategy. Now that we have this understanding, let's move on to the demo section of this lecture. So what we are going to do is we'll be creating a simple workflow just to understand the syntax and where everything is placed. We won't be creating a production grade pipeline just now. This demo is only meant to orient you with GitHub Actions. So let's go to the browser, and here let me open this in new tab. So here let's click here. I want to create a new repository, and let's call this repository cloud with Varjosh, and let's call it GHA GitHub Actions practice. You can give a description, and then visibility is private because we understand that enterprise applications that you would be typically working with will be hosted onto private repository. So we'll make this private, and then we'll click on create repository. Now we have created the repository. We want some means to authenticate with our GitHub repo so that we can push code from our local system to this GitHub repository. So what I will do is I'll come to my iTerm, and here I'm already on courses, GitHub Actions, first lecture 01 GitHub Actions, and project files. So what I will first do is I will be creating a key pair because I want to use SSH for authentication, and most likely when you are a developer, you will likely be using SSH to authenticate with your platform. Again, in enterprises you would see SSO being used, but for now we will be using SSH. So what I am doing is I'm generating a key using ED25519 algorithm. If you don't use this flag, then RSA is used by default. I think -c is the comment that I want to add. Always add meaningful comment, and the comment I am adding is my email address, and then I'm specifying the name of the key pair. So I am saying name this cloud with Varjosh GHA so that I know that I created this key pair for GitHub Actions. I would encourage you to have proper naming for anything that you do so that when you look back at it 2 months down the line, 3 months down the line, you clearly know why you did what you did. So I'll press enter, and this says creating a key pair. I don't want a passphrase, so I'll press enter. I'll press enter again, and this says your key pair is created. Now what I want to do is I want to start the SSH agent. So I will paste this command. I'll tell you why I'm doing this, and then what I want is I want to load the key in the SSH agent. So Git operations like git push, git pull, they all want some sort of authentication to authenticate with your remote repository. That is what we are doing. So we have started the SSH agent, and then we have loaded the private key onto the SSH agent so that whenever we want to perform git operations, we can securely authenticate with GitHub. And you can also check whether the key is loaded or not. SSH add -l you can use, and this shows that the key is indeed loaded. Now what I want to do is I want to first let's run ls. I will go to my home directory, and here in .ssh let's run ls. So you see whatever we created, this is our private key and this is our public key. Now what I want to do is I want to provide my remote server with this public key so that whenever I authenticate, it knows that this user Varun is authenticating using a private key that is associated with that public key that is uploaded in GitHub. I want you to clearly know that your private key never leaves your system. Okay, it will remain here and you should keep this secure. So I will do this and then I will add that name of that public key GHA and dot pub. I'll come at the very front and then I'll use cat. So this will show me the public key. So I will copy my public key from here. Then I will go to my browser. In the browser, I will go to settings. I'll go click on this profile tab and I'll open settings. Understand, I am opening settings for this account, my Cloud with Varjosh account, not for the repository alone. So I'll go here. I will open this in new tab. And then here I will go to SSH and GPG keys. I'll click on new SSH key. I will give it Cloud with Varjosh GHA-practice the name, and then I will paste it here. I will ensure I don't have any leading or trailing spaces. I will add SSH key. Use passkey and it will ask me for my fingerprint. I'll provide that and the SSH key is now added. Never used and read and write access. So what I will now do is I will go to my iterm and then I will clear my screen and I will run git init. So git init will initialize this as a git repository. Then what I will do is I will run that command make dir and then I will create .github, and in that directory I want to create a directory named workflows, and then I have to add -p because I want to create this entire structure, and then I will press enter. So this directory is created and this is in line with what we discussed in our theory part. So we said that whatever files you create, they should be created in .github workflows, and the files that are created inside it will be actioned by GitHub Actions. So it should be a YAML file, and then of course the syntax must be valid for GitHub Actions to take action on your file. So I'll come back to my terminal and here I have created this. So what I can also do is now I can cd into .github workflows and create my file here. So what I will do is I'll rather go to my Visual Studio Code and then I will expand this lecture 1 project files, and here you see workflow. I'll also zoom in a little, and then in workflows I'll create a new file and I will call this my workflow.yaml. I'll press enter, and what do you see? You see that I see an error here because this is saying that this is not a valid GitHub Actions file. But how does it know it is a GitHub Actions file? It knows because I have an extension installed, which I would highly encourage you to do it. This is called GitHub Actions. So I have installed this. Does not have a very good rating, but this helps. So install this extension. It will help you as we progress with this course. Now we have already seen how this file looks like. So we are going to create a similar file, but we won't be using needs here. So let's do that. So I'll start from the very scratch. I will give it a name. Name would be, let's call it my first workflow. You don't have to have double quotes, it would work. Now see, it has started suggesting me. So you have given the name, but required property on is missing. So when do you want to run this workflow? I'll add on, and then I will add run it on push. And then again, I see a line. It says required property is missing, and that required property is jobs. And you see it is also showing you the allowed values. So I will write jobs here, and then I'll press enter, and then I will write job 1, and job 1 runs on Ubuntu latest. So I am defining the runner here, runs on Ubuntu latest. And then I will have steps. What are the steps that will be there in this job? Let's call it step 1. Okay. And then next, let's tell what to run. So we are using the run keyword, and run keyword is used to run shell commands like kubectl, apply, and so on. So here we are saying hello from step 1, and then I will close the double quotes. I have just one step right now. What I'll do is I'll copy this and then I will paste it just below it. And I'll call this step 2, and I'll call this hello from step 2. So we have created job 1. We have defined job 1. Now let's also define job 2. So I'll copy this entire block and then I will paste this block here. So I will select all of this. I will press command and square bracket. It will move here. And then I have to also indent this because YAML, your indentation must be correct in YAML. So I have this, and this I will call job 2. So the red line is indicating that keys must be unique. So I'll write job 2 here. And this also, let's execute this on Ubuntu latest. And then I will only have one step here, and then I'm going to call this, let's say, final step. I'll call this final step. And then what we are doing is I'll also indent this correctly, and here I will write hello from final step. Final step job 2. Let's write this. So we have defined our workflow has 2 jobs, and job 1 has 2 steps, job 2 has 1 step. I'll save this. Now I will come to my terminal. Now we have to push the code. So we have already done the authentication. So what I'll do is if I run git status, I see that .github is not tracked right now. So first I'll run git add dot, and this will move this to the staging area. Then I will write git commit -m, and my commit message would be something meaningful. CI add initial GitHub actions workflow, and I'll close this, and then I will press enter. Now again, if your branch is not called main, then you would see something when you ran git init, you would see how to set your branch name permanently to main, because by default it calls it master. So what you can also run is git branch -m main. So what this will do is this will rename your branch to main, and this is something that your this screen would also tell you. So you see here git branch -m main. This is for renaming the branch. So you have renamed your current branch. My branch name is already main. If I press enter, this won't change anything. So if you run git branch, it tells you that our branch is called main. So if this is resulting in master, I would encourage you to name it to main. And then what I want to do is I want to add my repository now. I'll run git remote. I'm adding a remote, and that remote, let's call that remote origin. You can give any name, but origin is the most popular name that you would see. And then I would go here. I will, since we are using SSH authentication, I'll copy this. If you are using pat, then you will have to copy this one. So I'll copy this name, and then I will paste it here. I'll press enter, and now if I run git remote, then I see origin listed here. So now let's push it. I'll write git push -u to set the upstream, so local to remote branch mapping, and then I will write origin main. I'll press enter, and the push is successfully performed. So if I go to my repository now, and let's click here, you see the .github workflows is here, and you see this orange dot which says pending. If I click here, my workflow job 1 and job 2 finished in 3 seconds, finished in 2 seconds. And if I close this, this orange will change into a green tick because our workflow ran successfully. So let me just close this. Why this is not changing? So I'll click on this again, and you see this is green tick, success. Now let's see what has changed or what is happening in action. So this is the tab that you will be visiting a lot. We see our first commit here, that is our initial commit, add initial GHA workflow. So let's click on this, and I want you to observe one thing very clearly. This is calling it my first workflow, and this is what we called it, my first workflow. Your pipeline or your workflow is called my first workflow, which you see here as well. And if I go to job one, I expand this. So set up the job, then step one of job one, then step two of job one. So if I go to my Visual Studio Code, job one had two steps, step one and two, and we are seeing both of these steps here. So set up the job, let's see what is happening here, and I will expand this as well. So runner image provision, hosted compute agent, Azure region, North Central US. I told you, under the hood, runners are running on Azure. Operating system, you see Ubuntu here because that is what we defined, Ubuntu latest. And then runner image, this is the image that that virtual machine is using, which is executing the job. Understand, there was a virtual machine that ran job 1 and there was a different virtual machine that ran job 2. Like I said, when we talk about GitHub hosted runners, each job will get its own virtual machine, its own runner. Step 1, whatever we ran is here. Step 2, whatever we ran is here. Complete job, and this is saying job completed, cleaning up orphan processes. If I go to job 2, similarly I see the same thing here. Setup job, here you will see the characteristics of the virtual machine that ran this job, and this one ran in East US, which also implies this is definitely a different virtual machine in which job 2 was run. Operating system, it's similar to what we saw there because we used Ubuntu latest for both of these. And then we only had one step here, which was called final step. Hello from final step job 2. This is what we echoed, and the job is completed. Now there are additional things that are here, and as we progress we'll be looking into those things, but for now I want to do something else as well. Let's do one thing. Let's go here and add another step here. So what I will do is I will copy this and I will paste this here. Let me fix the indentation first, and I will call this, let's call this ANOTHER, another step, right? And I will write here hello from another step. Now understand, we have configured our workflow to run on push. So what I will do is I'll go to my CLI, I'll clear my screen, I will run git status, it will show me that the file is modified. I'll run git add dot, and then I will write git commit -m ci add another step in workflow. Okay, and then I will press enter, and then I will run git push. Now since we have already defined upstream, I can just run git push. Now I will run this, and let's go back to GitHub, and here let's stay here. We will see the workflow will get triggered automatically because we have said on push trigger it, and you see add another step in workflow is also triggered and has completed successfully. So if I go here, if I go to job 2, I will see final step, and then there is another step which we just added. So I hope you now understand this. That concludes the first lecture of this GitHub Actions Basics to Production course. In this lecture, we built a strong conceptual understanding of modern CI/CD systems and the foundational architecture of GitHub Actions. We explored CI/CD concepts, GitHub Actions architecture, workflows, jobs, steps, runners, execution behavior, and the difference between GitHub hosted and self-hosted runners. At this stage, you should now clearly understand the core execution model of GitHub Actions and how modern workflow automation platform operates conceptually. In the upcoming lectures, we will move deeper into GitHub Actions. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 2 of GitHub Actions Basics to Production course. In the previous lecture, we built foundational understanding around workflows, jobs, steps, runners, and GitHub Actions execution model. In this lecture, we will move deeper into how workflows are triggered and where they execute. We will start by understanding different workflow trigger categories, including repository events, manual triggers, scheduled workflows, external triggers, and reusable workflow orchestration. We will then understand built-in GitHub Actions contexts and see how workflows dynamically access runtime metadata during execution. From there, we will perform hands-on demos using different event types and GitHub hosted runners. We will also understand standard versus larger GitHub hosted runners, runner sizing considerations, and production runner selection strategies. So let's get started. Workflow trigger categories in GitHub Actions. Firstly, what is a trigger? Trigger is an event or activity that starts workflow execution. So I have a workflow defined. Now there must be something that will trigger that workflow. And in this part, we will be discussing what are different categories of those triggers which can trigger your workflow or trigger your pipeline. GitHub Actions workflows remain idle until triggered by configured events. So if I have a workflow defined in my GitHub repository, that workflow will not trigger until and unless there is an event that triggers that workflow. Now let's orient with this diagram. So what we have is we have different triggers written here, and then in the below YAML, what I have done is I have taken a screen grab of a specific section where we define when the workflow will be triggered. And we have already seen this in the last lecture, but in that lecture what we did was we only used the push event to trigger that workflow. But in this snip, what you see is multiple lines which are responsible for triggering the workflow. So what I am saying is this workflow will not just be triggered when there is a push event. This will be triggered when this happens, when this happens, when this happens, when this happens. So the crux is a workflow is not limited to getting triggered by only one thing. It can get triggered based on multiple things that you define in your workflow YAML. With that understanding, let's get started. First is repository events, and this is something that we have already seen in the past lecture. So what happened was whenever there was a push event, our workflow got triggered, and this is exactly what this is talking about. Now we discussed the push event in the past lecture, but there could be multiple repository related event. Maybe I want my workflow to get triggered when there is a pull request. I want my workflow to be triggered when there is a release event, when there is an issues event, and there are multiple options that are available at your disposal. So first point is triggered automatically by repository activities. foundation of CI and validation pipelines. Now, like we discussed in the past lecture, there are various steps that are performed in a typical CI/CD pipeline. So if I come here and zoom in here, what we saw was there were different stages when we talked about a CI phase. What we are saying is, whenever there is a pull request, whenever there is a repository event that we define our workflow to get triggered on, then what you can do is you can fetch the source code, build the application, execute automated testing, run security scans, and so on. But again, I want you to know that not all workflows will be doing something like this. We all at this point understand that GitHub Actions is not just a CI/CD platform, it is an automation system. An automation system can be taking a backup, it can be triggering another workflow, it could be doing so many things, because at its core it is an automation server. What we have been using it thus far as the DevOps engineers is CI/CD pipelines, but that does not mean that the functionality of a CI/CD system is just limited to your pipelines or your workflows. It can do a lot more than that. Use case is PR validation and automated testing. There could be multiple use cases you could be using this repository events for, but performing these things is the most general use case that you would see being performed. The next is manual triggers. If you have worked with Jenkins, you see that you can always trigger a pipeline manually from the UI. Similarly, if I talk about GitHub Actions, when you use workflow dispatch in the on part, you see workflow dispatch here. Whenever you do this, what happens is in the UI, you will see an additional button. And when you press that button, you can trigger the pipeline, the workflow manually. Now, this is not just limited to UI. Think of it like that. So whenever you define workflow dispatch, you can call the workflow dispatch via GitHub CLI and also via REST. You have an API endpoint, and when you hit that endpoint of the workflow dispatch, then also the workflow will be triggered. So what I will do is I'll take you to my browser, and then here I will go to GitHub Actions Basics to Production course. And if you are finding this helpful, I would request you to please click on this star button. It helps a lot. Now I'll go to 2, and then if I scroll down, I have manual triggers here. I will zoom in a little here, and you see on workflow dispatch, and I said you see a UI button. That is, of course, we'll see that in the demo part, but I also want you to understand it is called manual trigger, but you can also trigger this programmatically. Hence, you can use GitHub CLI to trigger your workflow like this: gh workflow run, and here I'm naming the YAML of my workflow. And here you can see you can also trigger using post. So REST actions are also supported. Then I'll take you back to the diagrams and let's read this. Supports controlled on-demand workflow execution. I have seen applications or workflows where the CI is not triggered automatically. It is manually triggered for production workflows. And I don't want you to judge such teams. Maybe they have a use case which warrants manual execution. For example, they are dealing with a ultra critical application and they want to only trigger that manually. So this is one use case. And when you are testing something, then also you may choose to trigger the pipeline manually. And understand, let's say you did not have push here. So previously in our demo we had push. So what we were doing is, as soon as there was a push, the workflow was getting triggered. But let's say you didn't have push, you just have a workflow dispatch. In that scenario, you have no other option to trigger your workflow than manually triggering it using the UI button or the CLI or API. Use case, production deployments, and rollbacks, as we have just discussed. Then you have scheduled triggers. As the name implies, when you want your workflow to trigger based on a schedule that you define, then you would be using scheduled triggers. Executes workflows using POSIX cron schedules. And this is one example. Here the cron expression dictates that you should be triggering this pipeline every 5 minutes. And the second point is critical: uses GitHub's best effort scheduling model. Now GitHub says that I don't guarantee that whatever you define here, I will trigger the workflow in that interval. And I have seen that while I was practicing, I used the same cron expression and I waited for half hour and my workflow never triggered. Then what I did was I used a different value. I used 17 here. So trigger this workflow every 17 minutes. And I went away to run some chore, and when I came back after 3-4 hours, I only saw 3 triggers, which is low based on what I defined. So that's why I'm saying uses GitHub's best effort scheduling model. Another thing I want to highlight here is, here we are saying run this pipeline every 5 minutes, run this workflow every 5 minutes. 5 minutes is the lowest you can go. You cannot go below 5 minutes. Use cases: security scans, cleanup automation. Like I said, your workflows are not just meant to trigger your CI. It could be taking backups, it could be performing cleanups, because at heart, this is just automation. What you want to automate is your decision. Next, what I want to discuss is external triggers, and you can use this using repository dispatch. I want you to know that in production implementations, when you advance, when you see mature applications, when you see the workflows for mature applications, what you would also see is at times those workflows are being triggered when there is an event that happens somewhere outside. For example, if there is an ITSM ticket, let's say a ServiceNow incident, that incident can also trigger your workflow. Maybe there is an alarm in your CloudWatch which is triggering your workflows. So understand, you can always have external triggers that can trigger your pipeline. Allows external systems to trigger workflows, supports custom event payload integrations, use case monitoring, and incident automation workflows. And I want you to broaden your imagination. So imagine, let's say you have a ServiceNow incident. Whenever you are invoking a DR, and when that DR is invoked, when there is an incident, that incident triggers your pipeline that is supposed to deploy resources onto your DR site. So broaden your imagination and think like a system design engineer, how things will work when you are using all of these in combination. When would you use scheduled triggers? Because there is no definitive answer which is the most popular of these triggers. Of course, you would see a lot of times repository events are the triggers, but these are also used in production implementations. Now, when do you use it? It is subjective. It depends on what your application demands. So always keep that in mind. Whenever you are designing anything in IT, it must cater to what the application demands, not what you think is the most popular choice, because popular choice may not apply to your application. Last one I want to discuss is cross workflow triggers. And if anyone has a Jenkins background, we had something called we have something called Jenkins shared library. Now what that did was, let's say we have 20 pipelines, and all those 20 pipelines, we have 70% of the work that is exactly same in all those 20 pipelines. And I personally don't want to write the same thing in that 20 pipelines, because I don't want repetitive work as a DevOps engineer. So what I did was, I took that 75 or 70% of the work from all those 20 pipelines and centralized that into a shared library, and then asked those 20 pipelines to refer that shared library whenever you want to do that 70 or 75% of the work. Similarly, in GitHub Actions, you have cross workflow trigger. And I want you to understand that, let's say you are dealing with an application that uses 5 microservices. It is low, but let's say in our example, 5 microservices constitute the application. Now, all of these 5 microservices can have its own repositories, right? They can be deployed into a single repository. It depends on the repository design, but typically you would see that if it is a big microservice, it could have its own repository. So for this application, we would have 5 different repositories. Now imagine all these 5 repositories will have its own workflow YAML file. But let's say, since these microservices are part of the same application, I am performing the same security scans, I am performing the same SBOM, I am performing the same artifact signing, deployment logic, and so on. And I personally don't want to repeat all of those things in 5 different places. What I would therefore do is, I would create a central logic, and that central logic will consist of all the common steps that are required by my 5 workflows, so that whenever those 5 workflows want to perform those common actions, they can just refer to the workflow that has all the common steps. What happens when you do this is, you don't have to do repetitive work. And in my example, I just took 5 microservices and 5 repositories. There could be hundreds of repositories which are performing the same steps. Their workflows of those respective repositories are performing the same steps. In that scenario, I don't want to define all of these things into different places. I want one place that has the standard for my organization, that my organization will not let go of an application until and unless all of these things that I have defined in a common workflow YAML are adhered to. That is what cross workflow triggers will do for you. Enables reusable workflow based automation patterns commonly used for centralized CI/CD logic, use case organization wide standardized pipelines. Now what I will do is, I'll take you to my browser, and then I'll take you to this page, and this is the page that defines all the triggers you can use. Now what I did was, I categorized all of these into these 5 trigger categories. You can have more categories, because this is something that I did, because I thought this will help me explain you the concepts in a better way. But you may see that you need a 6th category as well, based on what you read here. So you can see there are plenty of things. If I talk about repository events, you have pull request, you have pull request comment, pull request review, workflow dispatch, we already saw, you see that here, and so on. So I will let you give a brief read of this documentation page. I'll link this in the GitHub repository notes. Just have an overview of it, because as we progress with this course, we will be dissecting the important points step by step. So for now, let's go to the demo and see what we want to do. So I'll stay here for a while, because I want to show you something. I'll scroll down and I'll go to demo. And then here, step one is what we did in the past lecture. We won't be repeating. So I hope you already have a repository. You can name that repository anything. I have named my repository this, and it is a private repository. And you must have authentication in place so that our local Git client can push the code onto our remote. So ensure the authentication is in place. And if you have any doubts about it, then you can of course visit lecture 1's video again. Now let's go to the Visual Studio Code, and here I am in workflow triggers and I am in project files. And if I go to my terminal, I see the same. So let me do one thing. I'm in project files. I will make directory -p.github/workflows. And why I am doing that? Because all your workflow YAMLs must be residing in this path so that GitHub Actions can take actions based on the YAMLs that are available in this path. I'll press enter and this will create a directory structure for me. So if I do this, I see that there is a workflows directory inside the .github directory. Now let's go to Visual Studio Code, and here I will create my first workflow YAML, and I will call this 01 CI contexts. And why I'm calling this contexts? Because here I want to explain what are contexts when we are dealing with GitHub Actions. So let's press enter and we see this, and we will name this appropriately. Let's call this 01 understanding context. And in the first demo, I am typing these things, but as we move on, I would prefer just copy pasting and then explaining, because my lectures are usually long and I don't want them to be, extended, because I take time typing. And then I'll press enter. So name is this, let's say understanding context, and let's also add a hyphen for effect. And then I will move down and I will say, when do you want to trigger this workflow? I want to trigger this workflow whenever there is a push. Then what are the jobs that should be there in this workflow? So let's define jobs, and the first job that I want this workflow to have is event info job, and then I will press a colon. Now this is the name of the first job. Now I have a habit of giving proper nomenclature so that when things are on fire, I can exactly see what thing is doing what. That's why you see I have a suffix here, that is job, so that when I look at it, I exactly know straight away that this is a job. Hence I add a job suffix. If you don't want to, you can omit this, but I would recommend whatever helps you remember things, do that, because when things are on fire in production outage scenarios, then proper nomenclature does help. So this is the job, and where do I want to run this job? So I will add runs on, and then I will say this job must run on Ubuntu latest, and this is fine. Then I will come here and then I will define what will be the steps in my job. My job will just have one step, and the name of that step will be print trigger event. And what is that you want to do here? I want to use run, and we know from our past lecture that run is used to run scripts. Now commands, it could be your bash when we are talking about Linux, it could be PowerShell if you're talking about Windows. I'll write run, and then I will write echo my trigger event is. Now I'm writing an expression and I don't want you to be afraid of that, okay? So I'll add a $sign, curly braces, I'll hit space, and then here I will write github.event-name, and then I'll add one more space. What is this? Firstly, this in its entirety is an expression. What is this? This is part of the syntax. What is GitHub here? GitHub is the context, okay? And what is event name? This is the property inside the context. Again, entire is an expression. These are part of the syntax. GitHub is the context, and this is an object or a field inside that context. Now I will contrast this with Jenkins. When we used Jenkins, we had something called built-in variables. Now those built-in variables like build number, job name, workspace, build URL, git commit, and so on. There were plenty of built-in variables that are available at your disposal with Jenkins. With GitHub Actions, what they have done good is they have divided all those variables that they have into different contexts. Now, GitHub is one context. So if I take you to the documentation, here is this, and here is context. I'll open this in a new tab, and you see there are multiple contexts. There is GitHub, there is job, there is jobs, there is steps, there is runners, and inside these contexts they have different fields. So for example, in our example, we are using the GitHub context, and within the GitHub context we are using a field that is event underscore name. So if I go here and then I click on this, and then what I do is I search for event underscore name, then you see github.event name is a string, and then what it will give you is the name of the event that triggered the workflow run. And again, there are multiple contexts available at your disposal, and as we progress with this course, we will be using multiple contexts. Again, contexts are good because they provide you structure, and this structure was not there in Jenkins. So this is a plus point of GitHub Actions. What this also helps us do is it helps us categorize things. So when I want to have certain repository actions, they could be found under the GitHub context. If I want to find things that are specific to jobs, then I can find them in the jobs context. So for example, here jobs.jobid.result. If I want to see the result of a job, I know which context to look into, because I know GitHub Actions has categorized things into different contexts. If I want to see something specific to a runner, then I will go to runner context. And then if you want to see something specific to steps, then you can use the steps context. I'll leave it there, and as we progress, we will learn more about this. So back to Visual Studio Code. I hope this is understood. So essentially what this should do is, when I push this, what I should have is I should have an output which says my trigger event is push event. I'll add an event here as well. So let's go to our terminal, and here I will run git init in under project files, and if I now run git status, I will see that .github is not tracked right now. So what I will do is git add .git commit -m, then I'll have a good commit message, and that could be, let's say I'm adding a feature and I'm saying add workflow event trigger demo. I'll close the double quotes and I'll press enter. So this has committed. Now what I will do is, in case your branch is not called main, and you can run git branch to see that my default branch is called main. So in case your is not main, then you can always write git branch -m main. So my branch is already called main, so this will not do anything for me, but for you it could. I'll run git remote add. I want to add a remote, and that remote I'll identify as origin. But Varun, what is the URL for that remote? Now I will add the SSH path of that remote. So I'll go to my repo, and here is my GitHub twvj gha practice, and I will do not copy this path. If you are using personal access tokens, then this would work, but we are using SSH, so I'll copy this one, and then I will go here and I will paste this here, and then I will press enter. And if I now run git remote, I should see origin there, and which is expected. Now I will run git push hyphen u and I will say origin main. I press enter and this will perform the push. And if you look at our on when to trigger this workflow, we have said trigger it on a push, and we have just performed a push. So if I go there and if I go to code again, let's press here, you see that GitHub actions actioned on the workflow and it got triggered, and we see a success message here. If I go back here, you see 01 understanding contexts, because that is what we named our workflow. Okay, so I'll go here, I will click here on the trigger, and then I will click on the event info job. I know this is a job because I named it event info job. So I'll go here, and then you see I will set up job. We have already seen this in the past lecture, so I'll expand this, and this is what I wanted to show you. My trigger event is push event. So push was populated dynamically based on what we used in the context section. I hope this makes sense. Now I want to use multiple events. So what I will do is I will come here, I will create a new file, and this file I will call 02 ci hyphen, and this one I will call events. Okay, and I'll add .yaml here, and this time what I will do is I'll just copy paste the contents here. So very simple, let's understand this. So we are using workflow dispatch so that we see that manual button in the UI, and in addition to manual button, we already know that we can also use CLI or API to trigger that workflow. And then we have push, we have already seen this. We also have pull requests, but I won't be demoing pull request right now with a dummy demo, because I want, when we are dealing with production grade projects, then we explore more of pull requests. Then we have schedule, and we have defined a schedule here. The cron expression says this. If you are not familiar with cron, then you can always Google cron expression generator, and there is cron tab guru. This is the one I've used most often, and this will tell you the first is for minute, then hour, then day, then month, then weekday. So if you define what we have defined there, so what we have said is we have said this. So this says at every 5th minute you run this cron expression. So what I will do is like I told you, I have not seen success. It does not run as defined. So what I will do is I'll make this 17, so that as we progress with this lecture, we can come back and see what are the results of this cron schedule. Okay, now, or let's make it 13. I want it something unusual so that it clicks. So let's keep it 7, runs every 7 minutes. And then jobs event info job runs on Ubuntu latest. Steps is print trigger event. My trigger is, I'm using the same thing like we used in the previous part. Now let's come to our terminal, and here I'll clear my screen so that I have more real estate, and then I will run the same thing. I'll run git add dot to move this to the staging area. Then I will write git commit -m, and the commit message would be, let's say it is a feature, add multiple workflow event triggers. I'll close this, and I want to show you one more thing. So let me go to Visual Studio Code. So here on is a dictionary. So what I can also do is let me just comment this out. Okay, and then I can also use list here and here as well, and then I can remove this colon, and this will also work. But what happens is when you have to define, a cron schedule, or when you are in pull request section, you want to define certain branch names and so on, then this will not work. You will have to have dictionary. So that's why I recommend always use dictionary to begin with, so that when you advance, let's say when your application matures and you want different flavors within your pull request or schedule, then you should be using dictionary to begin with, so that that jump becomes easier. So I'll press Control Z so that we see what we had before. Okay, so this is this, and then I'll go back to my terminal, and what I will do is git push origin main, or I can just write git push and that will also work. And if I go back to my browser and I go to my repository, and if I go back understanding context, and you also see now 0 to understanding events. So if I click here, you see we have a single job, and there is a new button here, run workflow dispatch event trigger. So let's go inside here. Inside we only see one run, and that one run is because of the push event that happened when we performed the push. So let's go back and let's run it one more time. Run workflow. And this time, if you see here, if I go here, because understand every job is running onto a different virtual machine. So the previous virtual machine that ran the push job was different, and the runner that is running this job is different. And we learned that in the past lecture. When you are dealing with GitHub hosted runners, then your each job receives a new runner, a new virtual machine. And if I expand this, you see my trigger is workflow dispatch event. So if I go back here, we can see the holistic view. This understanding events workflow, it ran a couple of times. The first time it ran because of the push event. The second time it ran because of a workflow dispatch event. I hope this is understood. I want you to understand one more thing. See how good this is looking. You have GitHub Actions, and this repository right now has two workflow defined. Now you could in actual production, and as we progress, we'll be doing projects that will do this. Your first workflow could be security centric. Your second workflow could be dealing with creating container images. And it depends on how you want to do things. You can even have one workflow doing everything, or segregate tasks, jobs into different workflows. Now that we understand this, I want to talk about GitHub hosted runners one more time from a different lens. So let's go back to our repository. I'll scroll at the very top, I'll scroll down, and then I will go to GitHub hosted runner types and configuration. And whatever we have done is defined in these notes step by step. So do refer them while you are practicing along, and do start the repository if it is helping you. I'll go here, and then we know that there are two types of runners, GitHub hosted and self-hosted. GitHub hosted runners can be categorized into further two categories, standard runners and larger runners. So what GitHub is provisioning for us right now is standard runners. Now these standard runners, they have an approximate configuration. So for example, if you are using Ubuntu OS, then you may get 2 to 4 CPUs and 8 to 16 GB of memory and 14 GB of storage. But what is the configuration that you receive depends on what OS you are choosing. So for example, if I go here, it is saying that there are different configurations for standard runners for public repositories and different for private repositories. So let's concentrate on private repositories. I'll click here, and what you see here is if I am using Ubuntu Slim, then the configuration that I get is one processor and 5 GB of memory, and this is the storage. If I use Ubuntu latest, which we are using, then you will see this configuration. So it depends on what is the OS that you have chosen, and it also depends on whether your repository is private or public. So if you go to public repos, you see the configurations here are, I think, a little higher. So Ubuntu latest has 4.16 and here Ubuntu latest had 2.8. So the configurations when it comes to public repositories is a little higher. Now let's go back and see what I want to discuss next. Why running size matters. Now I want you to know that not all jobs that you are running may require similar type of configuration. What if you have a heavy application and the security scans that happens require more amount of vCPU? What would you do in such scenario? What you would do is you would choose a larger GitHub hosted runner, or you will choose a self-hosted runner, because of course whatever you are doing is resulting in memory exhaustion, disk pressure, timeout failures, unstable pipeline behavior, workflow behavior, or failed workflow execution under heavy workload conditions. So in such scenarios you may not want to go with what is available by default, and what is available by default is standard runners. In certain scenarios you may want to use larger runners or self-hosted runners. Now I want to tell you one more thing. This is my insight, what I have seen. I have worked with multiple GitHub Actions projects from a pre-sales standpoint, and I have not seen any project use larger GitHub hosted runners. So what instead organizations or projects do is they use something called self-hosted runner. Important, GitHub hosted larger runners are available only for organizations and enterprises using GitHub Team or GitHub Enterprise Cloud Plan. So this also must be taken into account. Again, what I told you is my personal experience. Maybe architect 2 may have a different experience. In your experience, maybe you would have seen larger GitHub hosted runners used a lot. So it depends on what application you are dealing with, what are your organizational goals, what are your goals with a heavy machine, maybe you want a custom network configuration and so on. In such scenarios it is always preferred you use self-hosted runners, but I want you to also know that you have larger GitHub hosted runners as well at your disposal. Again, this is runner strategy in production environments. I would let you read that. This only covers what I just told you. Runner strategy in production environments is influenced not only by technical workload requirements, but also by security policies, because it will always be the security team that will be holding hammer to your heads and telling you do not diverge, and compliance controls, networking constraints, infrastructure ownership models, scalability requirements, and overall CI/CD operating costs. With this understanding, let's go to the demo. So I will go to Visual Studio Code, and here I will create a new file, and this file I will call 03 ci runners.yaml. And what I will do is I'll paste something that I already have here. I'll paste it here. Again, very simple. 03 understanding runners. Name of this workflow is this. On, we are saying on push, you trigger this workflow. Jobs, we have one job that is called runner-info. And let's also add a job suffix so that I know this is a job whenever I see it. We run this on Ubuntu latest, and steps we are saying print runner details, and you also see a pipe symbol here. This pipe symbol, when I talk about YAML, this is called multi-line block syntax. Now what this is allowing us to do is it is allowing us to run multiple commands, and all these commands will be run in sequence. That is what multi-line block will do for you. This pipe symbol will do for you. If we were not using that, we would have to use some sort of chaining, using and or something of that sort. So we don't want that, hence we are using a pipe symbol to execute multiple commands in a specific sequence that we have defined here. Now, Varun, what is runner name? What is runner OS? What is runner architecture? Understand, whenever you are running a job, like I said before, those jobs run somewhere, right? And that somewhere is runners. Runners is where your jobs execute. There are certain environment variables that are defined in those runners. Again, I am not talking about what we learned in Jenkins, let's say built-in variables, or what we learned in GitHub Actions context. We are not talking about that. Here I am talking about the environment variables that are defined in the operating system of your runner. So if I go to the documentation and let's come here, you see variables here, right? I'll right click, open link in new tab. I'll go here and this will tell you what all environment variables are there at your disposal. And I want you to concentrate on, let me come down here. You see runner architecture, runner debug, runner environment, and this will tell you a description about what this will do. But here we know runner OS is obvious, runner name is again obvious. So this will tell you things that are associated with your runner. So I wanted to tell you this, which is why I have added 3-4 variables here. And let's now commit this and push this. So I'll go to my terminal. I will clear my screen. I will write git add. I'll move the files to the staging area. Then I'll write git commit -m. And this time I will write feature. And let's say this feature is add GitHub hosted runner variables. Okay. And then I'll close this. I'll press enter. And then I will write git push. And then I will go to my browser and I will go here. I will go, all workflows are here. 1 is here, 2 is here. Now the third workflow that we have just defined will also come here. So if I refresh this, I should see a 3 here, understanding runners. So if I go to all workflows, this will give me all the executions, all the triggers, what happened in all the workflows. But if I go to specific workflow, then I will see the triggers only for that specific workflow. So if I go here now, you see I have this. If I click here, I wanted to show you a couple of things here. So if I expand setup job, I see the image of the runner, okay? And we used Ubuntu latest, but what you can also see is included software. This will tell you whatever is installed onto your runner. So if I open this, you see that's why the configuration was a little higher. There was certain amount of CPU that was assigned and certain amount of memory that was assigned, because if you look at it, it is running, the runner is running so many software. It's package management software, then there are environment variables, then there is project management software. You see Maven is also here. Then you see what all tools are installed: Ansible, Git, Kind, kubectl, Customize. So there are so many tools that are already installed. Now, if you want to install any tool that is not listed here, then you can of course go here and in the run command, in run, you can mention the command to download that tool, whatever you need, and then install that tool. But I want you to know that most of the tools that you would use for CI and CD tasks are already here, and they also have AWS CLI. So if you are deploying onto AWS, you are covered here. So I will let you read these and then let's see what we printed. So if I expand this, you see runner name GitHub Actions. So this was the name of the runner that ran our job. Runner OS was Linux and the runner architecture was x64. Now I hope this all is making sense to you, but I also wanted to show you a Windows runner. So I'll click here, I'll click on new files and 04, and I'll call this CI runners 2.yaml. And then what I'll do is I'll quickly copy this, and here I'm calling this workflow understanding runners Windows plus Ubuntu. On push jobs, I have two jobs, Ubuntu runner job and Windows runner job. And then this job runs on Ubuntu latest and this job runs on Windows. And here I am printing the same details, and here as well I'm printing the same details. But what additional you see here is shell colon bash. Now by default, when I talk about Ubuntu, the chosen shell is bash, the born again shell. But when I talk about Windows, the default is PowerShell. What we want is we want this machine, this Windows runner, to be using git bash, which is why we have said shell is bash. And if I expand the installed software onto this runner, you will see that git bash is already installed, which is why we can say that the shell that you must be using, my dear runner Windows machine, should be bash. And when it is bash, it can run our echo commands successfully. So let's go to the terminal and I'll clear my screen. I will run git add dot to move the files to the staging area. Then I will add git commit hyphen m, and here I will mention, let's call this feature, and let's say add multi runner workflow demo. I'll close this, and then okay, I have to spell it right, and then I will run git push to push this. And if I go back to my browser and then I go back, I should see a workflow 04 understanding runners. I see it now. You see all of these are also running because there has been a push event. So we said that whenever there is a push, you should be running. You see it ran now. If I go here, it also says it ran now, because in all of them there is one thing that is common, and that one thing is push. And while we are at it, I also want to see that. So we used cron in 02, right? 02. Here I'm in 02. Manually run. This is commit event understanding. This is all. So you see the cron expression did not run the workflow. So if I check here, so it is saying it only has push and workflow dispatch. If there was cron, I would have seen something schedule or something of that sort here, but I don't see that. So the cron job has not yet run, and I'm sure the time that we defined there, I think 11 minutes or 7 minutes, that time has already elapsed, but you don't see it here. Our syntax is not wrong, this is from the official documentation, but it just doesn't run. Like I said, it's on best effort basis. If I go here now, this was supposed to run in push, so it's Windows plus Ubuntu. If I go, it will have two jobs. We are concentrating on Windows runner job here. I'll go there, setup job, and then I want to expand the image part so that I can show you the installed software. If I go here, it is telling what all is installed. So you see bash is here. Now let's scroll down. I will expand this, and then you see runner name GitHub action. This is the name of the runner. Runner OS is Windows. Architecture is x86. I think that's all I wanted to cover in this lecture. In this lecture, we explored workflow trigger categories, GitHub actions, contexts, GitHub hosted runner architectures, runner sizing considerations, and production runner strategies. Through the demos, we also observed event-driven workflow execution, predefined runner environment variables, Ubuntu and Windows runner behavior, and cross-platform workflow execution patterns. In the next lecture, we will move deeper into GitHub actions, events, contexts, and actions, while understanding how workflows dynamically exchange data and execute reusable automation logic. If you have questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 3 of this GitHub Actions Basics to Production course. In this lecture, we will move deeper into one of the most important concepts in GitHub Actions called actions. We will start by understanding what actions are and how modern CI CD pipelines rely heavily on reusable automation instead of manually scripting everything from scratch. From there, we will understand different sources of actions, including official GitHub actions, third party vendor actions, and organization specific reusable custom actions that you create. After the theory section, we will move into hands on demos, and hands on demos constitute the most part of this lecture. In demo 1, we will build and run a containerized Flask application using GitHub Actions while understanding how workflows execute inside GitHub-hosted runners. In demo 2, we will integrate Docker Hub authentication, GitHub secrets, reusable Docker actions, and container image publishing workflows using production style automation patterns. So let's get started. What are actions in GitHub Actions? GitHub Actions uses reusable automation components called actions to simplify CI/CD and workflow automation. Firstly, I want you to know that GitHub Actions and actions are separate things because GitHub Actions is the overall automation and CI/CD platform provided to you by GitHub. Whereas when I talk about action, it is an individual reusable automation component that gets executed inside your workflow. So understanding this distinction is important. Another thing I want you to understand that we as DevOps engineers have already been automating a lot of things. For example, if you had to run, let's say, 10 different commands, then what you would often do is you would take those commands and create a script out of it, so that when you want to run those 10 commands, and let's say those 10 commands are part of your daily operations and you run them every day, so you create a script out of it, and whenever you want to do those tasks, you just run that script. And what it does is, doing things like this saves time, reduces manual effort because every time you don't have to type those 10 commands, minimize human errors, and standardizes operational tasks. Here as well, when I talk about GitHub Actions, it's like a glorified name for that script. Underneath, there are certain things that are programmed into actions, and when you run those actions, those things that are defined underneath those actions are performed. As simple as that. So when I talk about creating a workflow YAML, you have two ways via which you can tell your runner what to do. The first is run, and run we already understand is a way via which you can run regular commands or even scripts. Another way is uses, and uses keyword is used to define actions. So when you want to run certain standard scripts or certain commands, then you can use run. But if you want to use automation that has already been created, or maybe you have created that automation, you can run uses, which underneath uses actions, and actions underneath use the logic that you have decided, the logic that you have decided for that action to perform. So for example, the action that you see on this screen is checkout action, which is version 6 right now, and this version may change when you are watching this recording. Maybe when you watch this comes to version 7 or version 8. So this is something that is mutable, but checkout is the name of the action. So here, this checkout action, what this does is this will check out your code from your repository. There are multiple other things that you can define this action to do. I mean, apart from checking out the code, as in if you want this to check out a code from a specific branch in your repository, this action can do that. And there are ways via which you can instruct this workflow. You can have with parameter which will let you do those things, and we'll see that as we progress. But at large, this action is checking out your code, because until and unless you check out your code, how are you going to run your workflow? So in most of the workflows that you would see, this will predominantly be part of the first job itself, and within the first job, it could be part of the very first step. Now that we have this high level understanding, let's understand these pointers. Actions execute predefined automation tasks inside workflows. Like I told you, underneath actions, there are certain things that are defined, and those things are performed when that action is called. And it is similar to what you did when you were doing scripting. When you call that script, whatever inside that script is defined, those things are done. And this is similar to that, if not exactly same. Consumed using the uses keyword inside workflow steps, like we have seen here. Replace repetitive scripting with reusable automation logic. And like we know, when you are running 10 different commands, it is always good to automate that, to bundle those 10 commands into a single thing. And that single thing in our example is action. So for example, if you were running commands like, let's say, git fetch, git pull, git clone, and so on, then you could rather use this action which will do something similar to that, if not same. So it is fetching your code, this action specifically, and we'll see this in detail as we progress with this lecture. Engineers must configure action inputs and parameters correctly for their use case. So for now, I am just calling this action, but what if I only wanted to get the commits that are available in the main branch? Then I should specify that parameter. I should tell this action that don't just run it in the default behavior. What you do for me is you only fetch the commits of the main branch. So that is configurable. This is exactly what this point is saying. Engineers must configure action inputs and parameters correctly for their use case. So if I only want the code for main branch, I should specify that. Large GitHub marketplace ecosystem of reusable actions. And this is the best part. I do not have to go and create an action that can perform the checkout for me. That action is pre-created for me. If I have to build a Docker image, that action is pre-created for me. If I want to log in into AWS, that action is pre-created for me. So in this marketplace, you will find plethora of actions pre-created for you by GitHub or by different vendors like AWS, Docker, Azure, Aqua, and so on, depending on what your use case is. But Varun, what if I do not find an action that satisfies my use case? What do I do then? My friends, you have an option to create custom actions for yourself. So if your use case is not already available in the actions that are in the marketplace, then you can create your own actions. And what will your actions hold? Maybe you are a enterprise that has a specific deployment strategy, and whatever your deployment strategy is predefined in the custom action that you have created. Now, when you want to execute your workflows, you just call that custom action, and under the hood, that custom action will deploy your application or do whatever you have asked that action to do for you. And that is the beauty of this ecosystem. You have a large GitHub marketplace ecosystem of reusable actions, and we'll see more of this in the next section. Then I want to talk about uses versus run. And at this stage, you already know, when you want to use actions, you use uses. When you want to run commands, you use run. Now, Varun, what is used in production? Modern production workflows commonly use both together. Now, let's say if I want to run a specific command and that command is not part of an action, then I would not go and create a custom action for that, right? I will just simply use the run keyword and run that command. So understand, you can create custom actions, but it does not mean that even if you want to run 2, 3 commands, a couple of commands, you are creating custom actions for yourself. Of course, you can, but should you? Now that we understand this, let's move to the next section. Sources of action. Now, like I told you before, actions are available by GitHub. So, GitHub, as in GitHub, is the author of those actions. Then there are third party and vendor actions. So, for example, AWS, Docker, organization specific internal actions. And these are the custom actions that I talked about. Official GitHub actions, officially maintained and published by GitHub. So, if there is something that is made available by GitHub actions themselves and by a third party vendor, then I would suggest you prefer the official GitHub action. Then commonly used for core workflows, automation tasks. Now, you, like I showed you, checkout is a common behavior. So such common behaviors, you would find that GitHub already has an action created for you. So like actions checkout, setup Java, cache, setup Python, they have multiple actions available at your disposal, pre-created for you. And in a little while, we'll go to the marketplace and explore those. Third party and vendor actions published by vendors communities, and these could be open source communities as well, and external maintainers, commonly used for cloud, Docker, and infrastructure workflow. So you would see there are plenty of actions available by Docker. They are offered in the marketplace by Docker themselves, and those are the actions that we will be using in this lecture to build our image, to perform login, to push our image, and so on. Example: Docker, AWS, Azure, Terraform actions, or all of these vendors, and many more are available in the marketplace. Next is organization specific internal actions. Now, if you do not find actions that are suitable for your use case, or maybe there is an action available that is suitable for your use case but is not secure, in that scenario, what you would want to do is you would want to create a custom action for yourself. So custom reusable actions developed internally by organizations, standardize CI/CD and automation across repositories. Example: maybe you have a specific deployment guideline, maybe you have a specific compliance that must be adhered, there are security scans that you want to perform in a specific order in the process that has been approved by your chief architect. In that scenario, you would be using custom actions. Choosing actions for production workloads. Prefer verified creators and well-known vendors. And this is obvious. So when we go to the marketplace, we'll see there is a blue tick. So prefer the actions that have that blue tick, but do not automatically assume that the actions that do not have this blue tick are dangerous. It's not like that. It's just that these are trusted a little more. Then prefer widely used, highly starred, and actively maintained actions. So the actions for which the development that you see is in progress, people are actively contributing, they have high number of stars, and we'll see GitHub does a good job in grading whatever is popular so that users can give stars to those actions. We will see that popular actions have high number of stars. review documentation, release history, and issue activity. And that goes without saying. So if you want to use something in your production pipelines, then you want in your production workflows, then you would want that thing, that action, to have proper documentation, release history, issue activity, and also you must ensure that the permissions that that action desires is in line with the security or compliance standards that you have set for your application. So that's why the last point says inspect source code and required permissions wherever possible. So let's go to the marketplace and just explore how these actions look. Okay, so I'll run github.com/marketplace, and this is where we'll find all the actions. So here I'll zoom in a little, I believe. Yeah. And then I'll go to actions. I'll go to all actions, and you see there are so many actions available. So blue tick, like I told you, are verified. And if I click on buy here, I can also check verified creators so that I only see the actions from verified creators. So for example, if I go to this checkout action, I see this is by actions, and actions is the official name for the actions that are made available by GitHub themselves. So if you see actions here, then you are safe. And here you see this has 7.9k stars. These are the contributors, and then you can check the details of this GitHub actions here, and this documentation does a wonderful job. It will tell you how to use this action, and if you do not get what you want here, then they will have external links or examples that will help you understand what all things can be done using this action. So for example, in the example that I showed you, we were not using the with block, we just used this, correct? But if you see the examples, they are using much more. And as we progress with this course and this lecture, you will learn more things about it. So for example, if you see this, this is calling with block with the path main. And if I scroll down, then here you see it is saying repository is this, the full path. Maybe you have something in the directory, and that is where you have to fetch. So you can be descriptive based on your requirement. If your code is already present in the root and you want to fetch the entire code base irrespective of the branch, and let me also tell you, this will not fetch the entire code base by default. What this will do is, if I have given this, for example, if I have given this here, then it will just fetch the latest commit. And that's the beauty. That is why it is fast. Imagine you have a git history that is of 100 commits. It does not make sense for your runner who is running your job to fetch the entire code base. In that scenario, you would only want to fetch the latest commit, and that is what the default will do. So if I scroll here, you would see that only a single commit is fetched by default. For reference, SHA, that triggered the workflow. Set fetch depth 0 to fetch all history of all branches and tags, and you will learn more as we progress with this course. And now let's go back and let's search for Docker. And if you search for Docker, you will get the actions that are named in accordance, that has Docker in the name. So if I go here, you can easily see that this has the name build and push Docker images. So this is used for that. And here the buy is Docker. So this is published by a third party, and that third party is Docker. So anything that is not published by actions by GitHub, you would call that third party. And if it is owned by your organization, then you could call it custom. And in that case as well, by would be your organization name or whatever you want to call that. I will go back, and here you can also search for AWS, Azure, and you will find different actions that are available at your disposal. So I will leave this here and I will let you explore this further. But now I want to go to the demo. So let's see what we are going to do in the demo. Demo 1, building and running a Flask application inside GitHub Actions. The orchestrator that we are using is GitHub Actions. Of course, that's the name of the course. And there will be exactly 4 steps in the job that we'll be doing. The first step will be to check out the repository, and that is where you will have access to the code, not you as in the runner will have access to the code. I want you to clearly understand that it is your runner who is running your job. Hence, all of these steps that are part of a job will be performed by a single runner that is associated with the job. So for example, that runner will first check out the repository, and here you see we will be using an action to do so. Next, what that runner will do is it will build a Docker image. And why can a runner build a Docker image? It can build a Docker image because we saw in the past lecture that our runners, Ubuntu latest especially, already has Docker installed, which is why it can run Docker specific commands. If your runner does not have Docker, then this will fail, because I want this to be engraved in your mind that you can only use the tooling, only use the packages that are available in the runner. If something that you want to do is not available in the runner, not installed in your runner, then you won't be able to do that. So if that scenario comes in, then you will first install whatever you need using run itself and then use that tooling. I hope that is clear to you at this stage. Next is run container in runner. This is a critical piece to understand. The container that we will create will be running inside the runner itself. After that, we will perform a quick smoke test. Smoke test as in we'll quickly verify that our application is accessible, and we will be doing that using run itself. So our job will have 4 steps. First step will be performed by an action which will be using the keyword uses, and then rest will be performed by the keyword run. Now, another thing I want you to know, once this job gets executed, the runner will be destroyed like we have learned before. I hope this makes sense. Now let's start with the demo. I'll first go to my GitHub notes because I want to show you something. And GitHub Actions basics to production, if you have not yet started, I would request you to please do the same. I'll go here and then I'll go to lecture 3 here, and then the step 1 is a repository setup and authentication. So you must already have a repository created whose authentication, so you should be able to push and pull to that repository from that repository just fine. If you do not know how to do it, we have discussed that at stretch in lecture 1, so go and check that out. So I am assuming you already have authentication in place and you can push and pull to the repository that you have created. I will be using this repository name throughout this course. Okay. Now, visibility could be private or public, but I would suggest keep it private because you want to do things like the things are done in production. And then I want to show you the directory structure. I'll go to Visual Studio Code. I'll expand 03 actions. Then I will go to project files. So project files is the place where I have kept everything that we will need to do this demo. We will be building a real application, and then we will be containerizing that application as we saw in the demo introduction. So I'll first go to app.py. This is a Python based code and you do not have to understand it deeply. I'll tell you what this code will be doing. This code uses the Flask framework. Now, Flask is a lightweight Python web framework which is commonly used for, microservices, lightweight web applications, and so on. So we are creating a web application, and that web application uses the Flask framework. And what this will do is when you access this application, this will say welcome to Cloud with Varjosh. platform is GitHub Actions, and runtime is Docker plus Flask. And then we also have a endpoint that will tell us about the health of the application. So if I access /health, I should receive 200 if the application is up and healthy. Here we are saying our application listens on port 5000, and we have host 0.0.0, which says that in all the interfaces that my container or my host, wherever this application will be running, the application will be listening on all the network interfaces available to that machine. So this is a very simple code. Now let's take a look at the Docker file. So here is the Docker file. I am saying from Python 3.13 Slim, I am using this as the base image. Work dir is /app. So this becomes the working directory. Copy requirements.txt to dot. So dot here will imply requirements.txt will be copied to /app, because that's the working directory for us now. What is requirement.txt? So this file is commonly used in Python applications to define application dependencies. Now, why this is useful? This is useful because within that file, you can define all the versions and the packages that are needed by your application. So you have all that standardized at one place. You do not have to look at separate commands in the Docker file itself. Everything is centralized in requirements.txt. So here we are saying run pip install no cache dir -r requirement.txt. So we are saying use pip, which is the package manager for Python. Use pip to install whatever is there in requirements.txt. And what is there in requirements.txt? We have defined that we want Flask that has version 3.1.1. Copy app.py to the working directory. So /app will have app.py, and app.py is the actual Python program. Then we are exposing port 5000. I want you to clearly know that expose 5000 is just for documentation. If your application is not listening on port 5000, then putting this will make no sense. So for now, we know that our application listens on port 5000 because we have asked our application to do so. Hence, this what you see here is just for documentation, so that any DevOps engineer or any developer who looks at your Docker file clearly knows that the application that this Docker file is dealing with listens on port 5000. And then cmd, I am saying the command that you want to run when this container starts is python app.py. So this will essentially start my application. Now we have this understanding. Let's get into the actual work of creating the GitHub workflow. So I'll go here and then I'll expand this. I already have .github created, and inside .github I already have workflows created. So what I will do here is I'll create a new file, and I will call this file 01actionsdemo.yaml. I will not be typing the entire YAML. I will be using copy paste, but I will be explaining it to you step by step, line by line. So I have copied this here. What are we doing? We are calling our workflow 01 cloud with Varjosh Flask CI pipeline. When do we trigger this workflow? We trigger this workflow upon a push, and pipeline is the word I'm not happy with. So let's replace this with workflow, because that is the term that GitHub Actions use. Jobs, I only have one job, Flask CI job, and that job is supposed to run on a runner that has the latest version of Ubuntu. My job has 4 steps, and we all know that all these 4 steps will be run sequentially, because the steps inside the job, they run sequentially. But if you have defined multiple jobs, they by default run in parallel. We learned this in our lecture 1. Now, someone is thinking, Varun, why do you have all the steps defined in a single job? Can't we split that? We can, but does our use case warrant that? No, if you look at these steps are dependent on one another. So for example, step 2 depends on step 1, step 3 depends on step 2, step 4 depends on step 3. Hence, all of these steps are interdependent, which is why all of these are part of the same job, because we know if, let's say, the last step would have been part of a different job, that different job would be scheduled onto a new runner. Because when we talk about GitHub hosted runners, we get a new runner, a fresh runner for every job. And if we just ran this step in the new runner, that new runner would not have any context. It would say, what is this? I don't have anything deployed on port 5000, and this will fail. So I hope you understand why all of these steps are part of the single job. Now let's see these steps. First is checkout repository, and we are using an action for that. Next is build Docker image. So here we are building the Docker image. Docker build is what initiates the building of the image. -t, here we are specifying the repository name would be this, the tag that will be associated is this, and this whole combined is called the image name. And then we have a final dot. This specifies the build context. So we are saying everything that is needed to build this container image is available in the current directory, in the present working directory. Next is run container. Here we are actually running the container. Docker run to run the container. -d, I want the container to run in detached mode, that is in background. Then -p is for port forwarding. What we are saying that anything that comes to the host on port 5000, and what is our host? Our host is the runner onto which the Docker is installed. So we are saying if anything comes on port 5000 on my runner, I want you to send it to port 5000 of my container. And which container? The container that will have the name cloud with varjosh -flask -container. And what is the image that that container should be using? The image is this one, the image that we built in the previous step, which is why I told you all these steps are interrelated. You cannot run this step before this. And finally, we are performing smoke test, and this is exactly what you would see in production. In production, as soon as the application is deployed, a smoke test is performed so that we know for sure that the application is healthy. And this is exactly what we are doing here. We are polling the health API to know that our application is accessible. We are using a pipe symbol here, which allows us to write multi-line commands. We are running two commands here. Why sleep 5? Because I want to allow this container some time to start properly before I run this command. And I think that's all I wanted to talk about this. So now what we want to do is we want to push the code to our repository. So let's go to that point now. I'll go to my command prompt. I am already in project files. I will first run git init. It is initialized. And then I will run git add dot. This will move everything to the staging area. And then what I want to run is git commit -m. The commit message can be demo1. And I will write build and run a container. Let's keep that simple. I'll press enter now. This is committed. Now what I want to do is I want to push this, but before pushing I will have to add the remote. So I will write git remote add origin. I'm calling my remote origin, and what is the path. So I will be specifying SSH here because we learned how to do this in lecture 1, and we know that when we are developers we would likely be using SSH, but of course if you're dealing with an enterprise environment you would be using single sign-on, so that uses tokens under the hood. But if you are a single developer you would probably be using SSH, but no one is stopping you to use tokens, so you can use that as well. So I'll press enter and this is done. Now what I want to do is I want to run git push origin and main. I'll also have to add -u because I want to define my upstream, the local to remote branch mapping, and this says successfully pushed. Now as soon as a push happens, this workflow should trigger because we have defined that this workflow should be triggered on a push. So let's go back to our browser, and here I'll go at the top, and then I will open Cloud with Varjosh in a new tab. Here I will scroll down, I will click on show more, and then I want to go to, where is show more, GitHub practice, yeah, CWVJ practice. I see all the files here along with the workflow, and we also see a green tick that we love. And then we go to actions and we see there is a workflow. So all workflows, whatever workflows are there associated with the repository will be listed here. The workflow that we created right now is named this, which is why we see this here. I will click here to only see the jobs or the runs associated with this workflows. Only one, so it does not matter right now, but it matters when you have multiple workflows here, because if you click on all workflows it will show you the runs of all the workflows. I want to see only for 01. I'll go here, I'll click here, and this is the commit message that I gave, demo1 build and run a container. I'll click here, I will click here because this is the job name that I gave, Flask CI job, and I have suffixed job so that I immediately know this is a job. So setup job, I'll expand this. Here we have already explored this, but what I want you to concentrate on is this part, download action repository. So your runner, whatever runner is assigned to you, will first download the action. And here we only defined one action, that was checkout at the rate v6, v6 being the version of that action. So if I scroll down here, if I expand checkout repository, this was our step 1. So here the repository was checked out. Second step was build Docker image. And another thing I want to highlight here is I keep on calling this Docker image, and the reason for that is we are using Docker to create the image, and GitHub Actions uses certain terminology that makes calling this Docker image a little more sense, but I prefer calling them container images. See, the point is we are using Docker to create a container image, correct? And we can use any other OCI compliant tool to do the same. We can use Podman, we can use Canico. Will we call it Podman image if we use Podman to create our container image? Will I call it Canico image if I use Canico to create my container image? Hence, Docker image is not something that's technically precise, but you would see a lot of folks using this because Docker was the pioneer when it comes to creating container images and so on. Hence, the term Docker image is quite popular when you discuss with DevOps engineers, but the correct way to say this is container image. So anyway, for this lecture we'll call it Docker image, but we discussed this in deeper details when we were dealing with our CK course. Anyway, so build Docker image. So here we are building the Docker image, and this is something that you would see on your terminal if you were to do this in your laptop. Because what is this, what we are seeing, these are just the logs, these are just the runtime behavior we receive from the runner itself that is running this job for us. So finally, if I scroll down, I see done. We see in 0.4 seconds a container image was created for us. If I expand run container, here is the command that we supplied, and you see this is the container ID of the container that was created for us. Then we move to smoke test, and if you expand this, you see status healthy. And why do you see this? Because if I go here, that is what we asked it to do. Status is healthy. And then when the job is completed, I want you to see cleaning up orphan processes, and after that this machine was dismantled. That's the beauty of it. So if I scroll up, I want to show you one more thing. Here, runner image, operating system is Ubuntu, runner image provisioner. Yeah, this instance is spun in West US 2 Azure region. And we know why this is using Azure, because GitHub is owned by Microsoft. Azure is also owned by Microsoft. So you get that picture, right? And then let's see what I want to discuss here. Let's see what more I want to discuss. So for demo 1, we have already discussed what I wanted to. So let's move on to demo 2 now. So I will go to my diagrams, and here I want to move to demo 2, and demo 2 is building and pushing Docker image using GitHub action. So in the previous demo we did not push the image, but in this demo we are going to be a little more realistic, and as we progress with this course we'll be fully realistic. So then this workflow that we will create, that will also have just one job, but that job will have 5 steps. So the first step, and what you also see is we will be using 3 different actions for these 3 different things, and then finally we will use a run to run the container and to perform smoke test. So first we'll be checking out the repository. Second, we'll be logging into Docker Hub. Why Docker Hub, Varun? Docker Hub, because when you are pushing your image somewhere, you have to supply authentication. So in our example, in our demo, we will be using Docker Hub as our container registry, and container registry is the place where you store your container images. And we will be using Docker Hub to store our Docker images. Hence, we must authenticate. Our runner must have means via which it authenticates to our Docker Hub, and we'll be using personal access tokens for that. Then we have build and push. This is the action that we will be using to build our image and then push our image to the specified registry. Then in the second last step, we will be running our container using Docker run like we saw in the previous demo. And then finally, we will be performing a smoke test. And this time, we will not be polling the health API. We'll just be accessing the application on localhost so that we know what our application displays to us. Now let's do one thing. Let's go to our browser and perform the very first step of this demo. And the first step would be creating a private Docker Hub repository. So I will go here. I'll go to hub.docker.com, and I am already signed in, and these are the repositories that I have. I will click on create a repository, and the repository I create, I will call it cloud with varjosh -flask -app. So this is what I'll call it, and I want a private repository which is only visible to me. I would suggest you also use private, because this is something that you would be using in enterprises. I'll click on create here, cloud with varjosh Flask app. I will click on create. The repository is created, a private repository is created. I see there have been no pulls for this repository, which is okay. Now what I will do is I'll go here. I'll click on account settings, because we want to generate a token, and that is the token that our runner will use to interact with this Docker Hub account. And why would runner want to interact with our Docker Hub account? Hello, because runner wants to push the image that we created to our repository. So I'll come here, I'll go to personal access tokens here. I will click on generate new token, and let's call this token GHA demo. Expiration, I would suggest you to have it custom and maybe expire it tomorrow, because you don't want your tokens to, be valid for more time than needed. And I would also highly encourage you, once you're done with this demo, just delete it. And then access permissions, I want read and write. I clearly want you to know that the token that you are creating is not restricted to the repository that we just created, the repository cloud with Varjosh Flask app. This will give access to everything. So use this with caution. I will click on generate, and let's increase this time to 2 p.m. And then I will click on generate. And this token will only be shown to you once. So I would recommend you copy this. So I'll copy this token. I will keep it somewhere safe in my machine. Rather, I will paste it here so that I can come back and use it. And I will delete this token after this lecture. So there is no point in messing around with this. So what I'll do is, I'll then personal access token is generated. Now, what do I want to do next? I want to go to my GitHub, and here I am in my repository CWVJ practice. I'll go to settings here, and then I will scroll down secrets and variables. I'll go to actions, and this is the place where I can define my environment secrets and my repository secrets. And this is the place where you can also define your variables. Now understand that if you want to, let's say, redact your username as well, then you would use secrets, but you can also use variables for your username. But in our example, we will be using secrets to store both our username and passwords, because I don't want my logs that I see in my workflow screen to show me my username. I want that redacted, which is why I am using a repository secret. So I'll click on new repository secret here, and let's call this one Docker Hub username. And my Docker Hub username is cloud with Varjosh. Cloud with Varjosh. I'll click on add secret. Ensure you have your Docker Hub account name here. I'll click on add secret. So first secret for username is added. Then I will come here, new repository secret, and this one I will call Docker Hub underscore token. And this is where I have to paste the token that we just created. So I'll copy this token, and then I will paste this token here. And then I will click on add secret. So we have added both. Now the work in this screen is done, but I want to highlight a few things. GitHub secrets, they provide a secure mechanism for injecting sensitive information, and token we know are sensitive, into your workflows. So what GitHub will do is, GitHub will automatically mask secrets inside your workflow logs. So once we run this workflow, I'll show you how your tokens and your usernames are redacted when you use secrets to store them. Let's go to Visual Studio Code now, and here I'll copy this and I will paste this here, and then I will rename this to 02 actions demo. What I will now do is, I'll copy my workflow YAML content and I'll paste this here. So here 02 cloud with Varjosh Flask CI pipeline, and pipeline is not something that GitHub Actions like, so I'll call this workflow. And then on push, we have seen this. We have already seen this. We are calling it the same Flask CI job. You can even add a 2 here so that you know that this is associated with demo 2. Runs on Ubuntu. First step we already know. Second step is an interesting one. Login to Docker Hub. So let's go to the marketplace, because I don't want you to be afraid of these things, because once you know how to maneuver the documentation, these things are pretty simple. I'll search for Docker, and you see Docker login, and it is obvious. If it says build and push Docker images, this would be used for that. So I'll go to Docker login, and this will exactly tell you how to use it. If you scroll down, you will also learn that this is not just limited to logging into Docker Hub. Of course, Docker and Docker Hub are products of the single company. But when I talk about using this action, you can use this action to log in into most of the popular container registries. You can see AWS ECR, you can see Azure Container Registry, you can see Google's container registry, and so on. And it also tells you usage. So I told you in the previous section that the with block can be used to supply whatever you want, your parameters. And where do you find what all parameters or inputs are available at your disposal? Documentation, right? So here I am in the documentation for this action because we are using this action, and the documentation clearly tells me how to use it. Right now we are using secrets for Docker Hub token, which is why we have this. You see, in password we have this. In this example, they are using variables for username. We also could use variables for that, but I prefer using secrets for my username as well, which is why I have used secrets. Now if you were to use variables, then you can use that, but here instead of wherever we created that, right here, you would go to variables and create that for yourself. It's pretty obvious, right? So this is how you can do it, and it also tells you what to do when you are using a different container registry and so on. So I'll let you explore this documentation to use this action for your specific use case. Now what I will do is I'll go back to Visual Studio Code and let's discuss next. Here, build and push Docker image, we are using a different action here. So let's first see what we are doing. We are saying with context is dot, this is the build context. So we are saying whatever you need to build this container image, this Docker image, is available in the current directory. Push is true. This implies that once the container image is created, you must also push that container image, which is why when I talk about tags, our naming is in that format. Cloud with Varjosh is my account name. Cloud with Varjosh -flask -app is the repository name. And then this is the tag I want to give my image. And this whole is my image name. And this is what the syntax of this action is. So let's go to our browser. If I go back and if I go to this, then you would see examples on how to use this action. You see, this is for the login. And if I scroll down, yeah, so you see this is for the build and push. I also want you to know that here we are giving name to all of our steps, and this is optional. You don't have to give this name, but I always prefer giving that so that everyone knows what my intentions are with this specific step. So you can maybe remove this and then bring this run here like this. This will also work. You see, there are no red lines, so it is accepting, but I prefer what I prefer. And then this is fine. Then we have already seen this. We are running the container using this command. And finally, we are performing a smoke test. And this time we don't have that /health here. So we'll see what our application has to say. I hope this is understood. So I'll come to my iterm. And here what I will do is I will run git add, then git commit demo2, and then build push and run, and I'll press enter. And then I will run git push. Only git push would do this time because we have already defined the upstream here. And if I go to my browser, I go to my go to actions tab here. Demo2 is running, and you see one thing. Workflow 1 is also triggered. And why is that triggered? Can anyone tell me? Why did this workflow trigger? Workflow 1 triggered because you have defined in workflow 1 as well that whenever there is a push, you also must run, which is why you see a second run here. But if I talk about workflow 2, this should only have one run because it has only seen one push, and that is successful now. So let's go here, and you see you can check your build artifacts here as well, Docker build summary, and I will let you explore these. But what I want to walk with you is this part, job 2, because we named that job 2. And if I expand this now, you would see that we were using 3 actions, correct? And all of those 3 actions were downloaded. In the previous demo, only checkout was downloaded. And then if I go to login to Docker Hub, the steps performed will be same even if you run run this login command using run. It will essentially be performing the same thing, but here you are using something that is available at your disposal with a packaged system, so packaged automation, so to speak. That's why we preferred using actions here. Similarly, build and push, we could have used commands to do this, but we chose to use an action that is pre-created for this thing itself. So the login was successful, here the build was done, and the push was done. And why was the push successful? Because the login succeeded. If this login failed for XYZ reason, if your token expired or something of that sort, then this step would have failed, and then rest of the steps of course would have also failed. And here you see at the very last, here is done, then a run container, and here you see this is the container ID, and our username is redacted because we created a secret. And then smoke test, now you see the whole message. Welcome to Cloud with Varjosh. Platform is GitHub Actions, runtime Docker plus Flask. And why this? Because that is what we defined in our application code. I hope this is understood. Now I want to show you something else. So this repository should now have a tag, version 1.0.1, pushed 3 minutes. If I go here, this is the image that we just pushed. So I hope you have understood all of these things. So this concludes this lecture. In this lecture, we understood reusable actions, the difference between uses and run, GitHub Marketplace, and the different sources of GitHub Actions. Through the demos, we also explored workflow execution inside GitHub-hosted runners, Docker image builds, smoke testing, GitHub authentication, GitHub secrets, and reusable Docker automation workflows. Most importantly, we saw how modern GitHub Actions workflows combine reusable automation with custom scripting to build production style CI/CD workflows. In the next lecture, we will continue building on these concepts while moving deeper into advanced GitHub Actions capabilities and reusable automation patterns. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 4 of GitHub Actions Basics to Production course. In this lecture, we will move deeper into workflow execution logic and trigger behavior. We will start by understanding how production teams refine workflow execution using event filters and activity types instead of triggering workflows for every possible GitHub event. In demo 1, we will practically understand event filters and activity types using feature branches, pull requests, and synchronize events. After this, we will deeply understand variables, contexts, and expressions, while also exploring workflow engine evaluation, runner execution behavior, and conditional workflow logic, which will be followed by demo 2, where we practically understand variables, contexts, and expressions. So let's get started. Now, what we have done thus far is we have defined a certain event, and based on that event our workflow got executed. For example, whenever there was a push event, our workflow got triggered. But do we want that behavior at all times? Our engineers, our DevOps engineers, our developers will have multiple branches created and they will be pushing all the time. And I don't want my CI to trigger every time there is a push or every time there is a certain event, because my CI runs are costly. So for now, we should be grateful that whatever we have been doing is free of cost. But when you are dealing with enterprise applications, you would have an enterprise plan with whatever CI tooling that you are using. In that scenario, it's not just about GitHub Actions. Any CI tooling that you could be using, you do not want your pipelines to trigger until and unless you want to run the CI. Correct? Hence, we don't want our pipeline, our workflow in GitHub Actions to trigger whenever there is a certain event. We want to have conditions in place, and those conditions must define exactly when we want to trigger our pipeline. Hence, we do not want a blanket event calling the shots. And that blanket event that we have used thus far has been push. So whenever there was a push, our workflow got triggered. And why this is bad? Not just from a cost perspective. When you talk about unnecessary workflow executions, it is unnecessary for your application. For example, let's say if you updated certain documentation about your application and then performed a push, in that scenario, you do not want your pipeline to trigger because you have not made any modifications in the code. You have just changed some documentation. Maybe you have just made changes in your MD files. In that scenario, you don't want your workflows to trigger. And again, for the sake of operational efficiency as well, when you are triggering your workflows left, right, and center, and let's say you are using self-hosted runners, in those scenarios your jobs will be queued because maybe you are using a single hosted runner, single self-hosted runner to run your jobs. In that scenario, you do not want to overburden that. And if you overburden these things, your feedbacks are slower because your application is not getting deployed as fast as you would like it to be deployed. And again, wasted runner resources. Runners spend time executing irrelevant jobs, pipelines, and workflows if you do not control this behavior. And to control this behavior, my friends, we have two things when I talk about GitHub Actions. There is event filters and then there is activity types, refining workflow trigger behaviors. So let's discuss each of them and understand how we use them. First is control under what conditions workflow execute. Now here, previously we just had push here, but now we have defined certain event filters. We have said that you must trigger this pipeline when the branch is either develop or when the branch is prefixed with release and a forward slash. And then we have also said only trigger the workflow when the changes are made in these paths. So we have used two event filters here. First is the branches event filter. Second is the paths event filter. And we'll go to the documentation and see what all filters are available at your disposal. But for now, within the push event, I have two event filters, and I want you to understand at this juncture itself that when we are talking about a specific event. So here we are talking about push. Here we have defined two event filters and they function in an and fashion. What is the and fashion? And fashion says this must be satisfied and this also must be satisfied. So this says the push must target these branches, and this says and changes must occur in app directory, Docker directory, or in this directory. Now there are two possibilities here. You can either use a single asterisk or you can use double asterisk. Double asterisk signify that this is a wildcard that represents recursive matching. So if you have a directory under app1, and then you have certain files where you make modifications and the branch in question is this, then this workflow will trigger. If you had a single asterisk here, that would imply if there are changes made to any file that is directly inside the app directory. So with this understanding, let's see this one. And again, I want you to know one more thing at this stage itself. Here you see we are using the branches filter, and here we are using the branches ignore filter. Now the point is you cannot use both of these filters together. You either use this or you use this, which is why I have two separate YAMLs from where I have taken just the on section. So the same implies for paths as well. Either you use paths or you use paths ignore. And this is obvious. What does branches ignore mean? Whenever there are pushes to these branches, the workflow will not trigger. Whenever there will be changes made to these files, the workflow will not trigger. Understanding this is critical because in production implementations, you would be using both of these. Second is help reduce unnecessary workflow executions. We already discussed this. Commonly used filters, branches, paths, tags, and ignore filters, as we are seeing here. Commonly used for branch control, selective CI execution, mono repo optimization. That is pretty obvious. So I want to go to the browser and show you how to maneuver the documentation, because that is very important in my opinion. So we will go to docs.github.com, and here I will zoom in a little, and CI CD and DevOps, you see GitHub Actions. I will go here, and then there are two sections that I want you to concentrate on. First is concept, second is reference. So we have seen the reference section a couple of times already in this course, but when I talk about concepts, if you want to learn something about a specific feature, when you want to read the theory, then you go to the concept section, obvious. And when you want to see examples on how to use something, then you go to reference. So I'll go to reference here. I will go to workflow and actions, and here I will go to events that trigger workflows. And if I go to this push event here, you can see that this is on push. This we have used in the past. And then you see you have multiple options that you can use, paths, and then there are multiple options. And if you go to workflow syntax, in this page you can find some more options, some more ways via which you can use this. So I will let you explore this, and in the demo we'll also explore a few of these. Now what I want to do is, now I want to discuss the next one. So if I go to my diagrams again, activity types controls which operation within an event trigger workflow. So for example, the larger event is pull request. Within pull request, you can have certain activity types, and based on those activity types, you can trigger your workflows. Now, Varun, how do I know the activity types supported by an event? So documentation. So if I go here and then I scroll down, what I want to do is event that trigger workflows. I'm at the right place. Let's go to pull request. And if I go here, the first section will tell you what are the activity types supported by a pull request. And it is imperative that you read what is given here. Now, again, I want you to understand one more thing. It is not possible for anyone to go in the documentation and read everything. But what I want my students and my viewers to inculcate at this stage itself is understanding the foundations, that if I want to do this, I can go there and maybe that place will have the information about what I want to achieve. So any good engineers, they do not know everything that is under the sun, but what they know is how to figure out things. And when I was in operations, I used to figure out things by reading documentation, searching here and there, Stack Overflow, and so on. But you can always use AI along with the documentation to figure out something. So use those things to figure out how to achieve what your requirement is. Maybe your requirement is whenever there is a pull request, and under that pull request, whenever a PR is closed, you want your workflow to trigger. And if someone comes to you with that requirement, you will say, okay, maybe let me see if in the pull request there is an activity type for closed. If there is, I can achieve this requirement. So I want you guys to think like this. Now let's come back to the topic again. So if I talk about pull request, when you just use pull request without supplying any activity types, it is telling you the workflow will by default run whenever a PR is opened, whenever a PR is reopened, and whenever there is a synchronize event. Now what is synchronize? Synchronize is when there is a PR already opened and then you perform some new pushes. In that scenario, the synchronize will happen. Understood. But if let's say you also want your CI to trigger, your workflow to trigger whenever a PR is closed, or whenever a PR moves from a draft stage to a ready for review stage, in that scenario as well, you may choose to run your workflow. And again, I have taken this pull request example, but if you go to the documentation, if I go to push, there are no activity types supported here. But if I go to labels, there are 3 activity types supported: created, edited, deleted, and so on. So based on the event that you wish to use, you see what activity types are supported and along with the filters. So if I scroll down, if I go to my diagrams, then you can see when it comes to event filters, you can see in the example what all are supported. Activity types you already know how to check. Now second is help improve workflow execution precision, which is fine, commonly used with pull request, issues, release events, and so on. And in production implementations, what I have seen is at least 95% of the times, push and pull request as events are pretty much always used. So these two are the most common ones. And you may also see label tags being used. So keep those things in mind. So let's go here and see common examples: opened, synchronize, reopened. And I want you to notice one more thing here: the indentation. So if I talk about push, branches and paths are event filtered that are indented at the same level and they are within the push block. If I talk about this, these two, they are inside the pull request block. So what we are doing here is we are combining activity types here, and then we are combining that with something called event filter. So you can combine both of these. These are just bifurcations, logical bifurcations for you to understand these things. But at large, both of these will help you to execute the workflow based on your specific requirement. So I hope all of this makes sense to you. With this understanding, let's go on to the demo and see how this works in real time. So I will firstly go to my browser and then I want to go to the repository for this course. And if you have not already started, guys, please do start this repository if this is helping. So I'll go here and you can just click here and you can start it. I have self-started, I am guilty. And then what we'll do is we'll go to 04, that is lecture 4. And then what I want to do is I want to go to the first demo here. And then step 1, you already should have authentication in place and you should have a private repository named this. You could have named this anything, but you must have a repository created and you must be authenticated from your local Git to that, so that you can push whenever you need. Then let's start with the demo. So what I will do is I will go to my command prompt, and here you see I am in lecture 4 already. So what I will do is I will run mkdir, because we know GitHub Actions will look for files that are available in GitHub/workflows directory, and I will create this directory structure, and I'll also have to add -p here so that it creates both these directories for me. And rather, before I do that, I also want to create project files here. Do I have project files already created? I don't know that yet. Hold on. Let me run ls here. I have project files created. So I'll cd into project files. I'll clear my screen. I'll press ls -a. I have nothing here. So what I will run is mkdir-p .github/workflows. GitHub is spelled right. Workflows is also spelled right. I'll press enter. I'll run tree-a because .github is hidden file because it starts with dot. So you see this is created. Now what I want to do is I'll go to my Visual Studio Code, and then I will expand this. I'll expand project files, and in the workflows directory, I'll right click here, new file. I'll create a new file. I'll call this 01, and then I will call this filter types because we are doing the demo on this. And then I'll add a demo, and then I'll add YAML here. So like I did in the past lectures, what I will do is I'll copy paste, and then I will explain you what we are doing. So I'll copy this from here. I will paste it here, and I think I'll have to zoom in a little so that you can see a little better. So let's see what we are doing. We are calling this workflow 01 production workflow trigger demo. We are saying that this workflow must trigger on a push when the push is performed on these branches, and the modified content is available in this directory. So if there is something available in the root of project files and I push it, this workflow will not trigger because I have clearly defined when this workflow must trigger: branches and also the paths. The second is pull request. I want this workflow to also trigger whenever there is a PR opened, and that PR opened, the target for that PR, the base branch for that PR is main. So let's say if I create a feature branch and push onto that feature branch, and then I raise a pull request for the base main, the target is main, then this workflow will trigger. Another thing I want you to understand, that within the event, so for example, this is a push event. Within that, I have two blocks, right? Branches and paths. Both of these, they work in AND fashion. Like I already told you, both of these conditions must be met for this to trigger. And within pull request as well, both of these conditions must be met for this workflow to trigger based on this event. But Varun, what about these two? I want you to know that when there are multiple events, the workflow can trigger based on all of these or a single one of them. So for example, if let's say this is also true, and maybe in parallel someone opens a pull request as well, then this for the main branch, then both of these, this workflow will trigger 2 times. So a workflow can trigger multiple times based on the events that are defined. So for all true events it will run. So for example, if right now I perform, let's say, a push in the feature branch and I modified something here, then the workflow will trigger because of this push event. If I am on the screen, I'm on the UI, and then I open a PR whose target is main, then this workflow will trigger because of this event, not this event. So I hope that distinction is already in place in your heads. Now let's scroll down. So what is the job that we are doing? We are creating only one job, that is the validation job, that runs on Ubuntu. And the steps is, we already know this, name is print workflow context, and we are using the pipe symbol because we are running multiple commands in the same run statement. And then we are defining two of these events. So again, if you want to check what, from where did I take these variables, again you go to documentation. I'll go to my browser, I will go to the page that I already opened. I'm already in the references section, and I am using variables here, and in the next section of this course we'll discuss these deeply. But for now, just understand, if you go to variables, you can use any of the variables available at your disposal. I am using two variables. First is the GitHub event name, second is the reference name, and reference name will give me the reference for the thing that triggered this workflow. It could be the branch name, it could be a label, it could be a tag, and XYZ. If you want to learn more about this, go here, search for ref underscore name, and you can read the short reference name of branch or tag that triggered the workflow. If I said label, please pardon me, only two things, branch or tag that triggered the workflow run. This value matches the branch or tag name shown on GitHub. For example, feature branch 1. I'll let you read it. Maybe you want the repository name, maybe you want the repository ID. You can use all of these based on your specific requirement. So let's have some fun. I'll copy this one, and let's also call this echo owner. So I'll write echo, and then I'll have owner here, and then let's write this here. So this will now also show me who is the repository owner. I hope this is understood. So let's go to our terminal, and then let me clear my screen here. And then what I will do is I will come here, and then let me create two directories, app, and I'll create one Docker. So I've created two directories, and then what I will do is I'll create one more file, app. In the app directory, I will create a file called app.py. We won't be writing any Python code here. I'm just creating this to show you a few things. I'll press enter. Now what I will do is I'll initialize my repository, git init, and then I will also write git branch -m. I don't have to write this, but I'm not sure what your branch is called. My is called main, and this main is coming here because I have defined something in my ZSHRC file. If your branch is not called main by default, and from version 3 onwards, Git will call this main by default, but for now, Git calls it master. So if your primary branch or the default branch is called right now master, then I would request you to run this command so that your branch is renamed. For me, it will not do anything, but if your branch is named master, it will rename it to main. Now what I want to do is I want to run git remote add origin. I'm calling this origin, you can call this anything. I'll go to my browser, and then I will come here. Let me just duplicate this tab, and here I want to go to a repository that I have already created. I'll go at the top here, and then if I expand this, cloud with Varjosh GHA practice. So I have this here. I'll copy the SSH path from here, and then I will go to the command prompt terminal, and then I will paste it here. So if I run git remote, I can see that my origin appears here. Now I will write echo. So I'll add something in that app.py file that we created. I will write print, and then I will write GHA GitHub Actions trigger demo. And then I will close these double quotes. I'll close this single quote, and then I will add this to app.py. So if I cat app.py, I see that print GHA trigger demo. What I want to do is, now I want to push this to the main branch. So what I will do is git add dot, I'll move this to the staging area, git commit -m, and I'll give a meaningful commit message. Let's add feature, and I will add here add trigger demo application. What I also want you to understand is, so let's first commit this, and I will first run git push -u, and then I will run origin. I'll write origin main. I want you to first understand that right now we are pushing onto the main branch. So if I go to my workflow should not trigger, because we are not saying that our branch is main when the push happens. So this workflow will only trigger when this condition is met and this condition is met. So for us, this condition is meeting because we are making some changes in the app directory, but this condition will not meet because we are not pushing to any of the feature or develop branch. We are pushing to the main branch, and main branch is not part of this condition. Another thing I want you to clearly know, so when it comes to the branches that have your releasable code, for example, main branch, production branch, release branch, or it could be named anything. So your primary branch, the pushes will be disabled because your releasable branches are protected using branch protection rules. If you have been through my Git and GitHub course, you already know how to protect branches. And as we progress with this course, when we do actual production like demos, we will be using the same methods as you would see used in production. Similar, if not same, let's say. Now git push -u origin main. I'll press this, and let's go to our repository. So I'll go to my browser. I will go to actions, and you see there has been no trigger. We see 01 production workflow trigger demo here, but there are no workflow runs yet. I want you to clearly understand this. And if I go to code, you see our code is already here. App is here. Docker directory is not here because that directory is empty, hence that was not pushed here. So you see GHA trigger demo, it is here, but actions, no trigger of this workflow. Now when this workflow will trigger, when the conditions that we have defined will be met. So let's do certain things that will meet those conditions. So I'll go here to my terminal, I'll clear my screen, I'll run git switch -c. I want to create a branch, and I want to call this branch feature, and let's call this trigger demo. I'll press enter. So I have created this branch, and I've also switched to this branch. Now what I will do is I'll write one statement, and this time what I'm doing is in app.py, I'm adding triggering workflow from feature branch, and I'm adding this to app.py. I will clear my screen, and if I run git status, we see that this has been modified. So what I will do is git add dot to move this to staging area, and then what I will do is I will commit this with a meaningful commit message, commit m feature trigger workflow from feature branch. I'll press enter, and then what I will do is git push -u to define local to remote mapping, and then I will write origin feature trigger demo. I'll press enter, and this time let's go to our browser, and I will refresh this. Yes, and you see this has appeared here. So if I go here, and then this is the validation job that we defined, and if I print workflow context, because that was the name of our step here. So if I go here, you see print workflow context was the name of the step, and that is what we see here. And we see workflow triggered successfully, event type push, branch is this, owner is cloud with Varjosh. So all the variables that we have defined we see the values for those variables. I hope this is understood. Now I want to take this one step further. So let's do one thing. If I go to my code, you will see that compare and pull request tab will come, and it is here. So let's also see, will this also trigger when we create a pull request? So I'll click on compare and pull request here. We have already discussed this deeply in Git and GitHub course, so I won't be explaining this, but I want you to understand we are creating this pull request so that whatever changes we have done in this branch can be merged onto main. But before we do that, we want our CI to trigger, our workflow to trigger. I'll click on create pull request, and as soon as I click on create pull request, my workflow will trigger. Now if I map this to production scenarios, what you would often want to do is, whenever someone raises a pull request to merge the code with the main branch, and main branch is the one that is holding your releasable code, and you want main to only have tried and tested code, which is why whenever someone creates a PR to merge whatever they have done, in their feature branches, develop branches, bug fix branches, hot fix branches, and so on, you want to perform certain checks on that code so that you only merge that once you know that that code works. Hence, whenever a PR is raised, you want to run your workflow or your pipeline. Similarly, here also we are raising a pull request towards main, whose base is main, whose target is main, a PR whose target is main. Once that is raised, the workflow must trigger. That is what we defined. And if I come to actions, you see a second run, and here you see this run, you see pull request here. If I go here, I go to validation job, I expand print workflow context, you see event type was pull request, and branch, this is calling this right now. The owner is Cloud with Varjosh. I hope this is understood. But while we are at it, let's also study the synchronize event. So understand, the pull request is not yet closed. The pull request is still open. The pull request will only close when I merge it and then close it. I want you to also experience the synchronize part of the pull request event. So let's do one thing. I'll go to my terminal again. And when will the synchronize be seen? When the PR is opened and you have new commits in your repository, in your branch, so to speak. So let's come here. I will clear my screen, and this time I will add another statement in our app.py. I'll paste it here, and we are saying testing synchronize activity, and we are making these changes in app.py. And then I will run 3 commands. The first is to stage this. Second is we are committing and writing validate synchronize workflow trigger. Lastly, we are pushing the changes to the feature trigger demo. I'll press enter. And now if I go to my browser, and let me go to actions, and you see this has been triggered, and you see this has been triggered twice. If I refresh this now and now, can anyone tell me why this workflow ran twice? Remember, what were our conditions? I told you your workflow will run multiple times if the events that you have defined dictate that. And if I go back to Visual Studio Code, what did we say? We say you run this whenever there is a push which meets these conditions, and our push met both the conditions, feature branch, and we made changes to app.py. Hence, this also triggered the workflow. And here, since we said that we want to synchronize whenever there is a pull request and pull request opened and there is a synchronize type there, then also you run, and we have this opened to the target main. Hence, if you go here, this triggered because of the push, and this triggered because of the synchronize part. So if I go here, this will still show you pull request, but under the hood it is synchronize activity type that triggered this. I hope this made sense. Now that we have this understanding, let's go to the next topic that I want to discuss, and that topic is variable, contexts, and expressions. So I want to go to the repository for this lecture, and then I want to go to variable, context, and expressions in GitHub Actions. GitHub Actions allows workflow related information and execution logic to be handled in three primary ways. First is variables, and we have been using this is not new to us. There is context, and this as well we have been using it. There is nothing new here, and we used this, if you remember, in this lecture. We said run echo my trigger, and I explained this to you that this whole is called an expression. We learned GitHub is the context here, and event name is the context property. We learned this, but we are just defining it specifically in this section because you will be using these in your GitHub Actions journey. So variables used mainly inside runner shell commands, scripts, and runtime commands execution after the job starts running on the runner. So for variables, we are saying use them when you want to run certain commands. So where do you run commands? You run commands in the run block, which is why that is what we are doing here. But we are saying this for variables, but here we are using context. So there is nothing written in stone. I can use context as well, or I can use variables, but what you should be using. And I always say, as a rule of thumb, if something is made available to you in form of variables, then use that when it comes to commands and shell scripts, and you in the run block use them, use variables. But if something is not available via variables, then of course you can use contexts as well. But then there is one more thing. There are certain things that are available as both variables and as contexts. In that scenario, what would you want to do? So here we are using context, but if I go to the documentation and I search for event underscore name, then I see GitHub underscore event underscore name is a variable. And if I go to contexts and I go to the context GitHub and I see the properties that are there, I also see event underscore name there as well. Then what should I use? If you are in the run block, then I would recommend you use variables, not context. Now the second is context. We already know, used mainly for accessing workflow related metadata and information such as repository details, events, job, steps, runners, secrets, variables, and matrix values. And secrets, we have already seen this in the past lecture. So if you remember, in this lecture where we created a pipeline, and if I go to this step here where we created the workflow, and if you see, we defined certain secrets and then we called those secrets in our workflow YAML. So we defined these in our at repository level, and then we call these, and you can use context like this. So if I go here to the documentation, and if you see context, you see there are various contexts available: GitHub, env, vars, jobs, runners, secrets, and so on. And within these contexts you have multiple properties. So if I talk about the GitHub context, you have action property, you have action path, and there are plenty more available at your disposal. And based on your requirement, you should be using these. And if some of these things are not making sense right now, because these are the things that only make sense when you start doing it. So in the demo, all the dots will be connected. If something is hazy right now. And the third is expressions, used mainly inside workflow YAML at workflow, job, and step level for conditions, dynamic evaluation, workflow orchestration, and execution control. So in essence, if I talk about this, GitHub is a context. In github.ref, context property is ref. If I talk about this whole becomes an expression. And if I talk about this becomes a conditional expression. And we'll see how conditional expressions will help us later in this course. And I'll also show you a small example in this section itself. Now, there are few notes I want you to know. GitHub documentation commonly uses the term variables, while many engineers also casually refer to them as environment variables because they become available inside the runner shell environment during job execution. And whatever I have written here, this is also at place recommended by GitHub Actions documentation. And I have to admit here, the documentation for GitHub Actions is not as rich as the Kubernetes documentation or as rich as AWS's documentation. But at this stage, I don't think it is as solid as it should be because the tool is already quite popular. So use variables inside shell commands and script wherever possible. Use contexts and expressions for workflow logic, conditions, orchestration, and dynamic evaluation. These are some jargons I'm throwing at you, but we'll see in the example how do we use them. So variables, they are of two types. There is a default variable that are provided by GitHub. Then there are custom variables created by users. If you remember, if you go to the settings in your repository and then you go to secrets and variables and then you go to actions, here what we did was we defined our secrets at repository level. You could also define variables at your repository level, or you can define these variables at your organization level. Now I want you to understand something. So let's say you are using multiple workflow YAMLs. Okay, instead of defining a variable in each of those workflow YAML, what you can do is you can define the variable at repository level so that all your workflows can access them. Another thing is, if you define your variables at organization level, we have not discussed that, we'll see that soon. But if you define them at organization level, then all your repositories and their respective workflows can access those variables. So you have multiple options. And in this example, we'll also see how to define these variables within your workflow YAML. So in the past lecture, we defined a secret. You can also define variables the same way. But if I go here, if I scroll down, default variables we have already seen. These are available here. You can see what all variables are available out at your disposal. There is a runner specific, there is GitHub specific, and so on. But if I go here, these are the common examples and this is how we use it. And we have used this in the previous demo as well. Custom variables is the important thing. You can define these at repository level, at organization level, or in the workflow itself. And this is how you define them in the workflow. So here I have defined two of these variables and you see how I am using those defined variables. And we will see this in the demo as well. Then context we have already seen, expressions we already seen. I want to show you an example where we are using this. So what we are saying here is you run this workflow on push and you run this job only when the github.reference is equal to main. So the reference here is, the reference could be tag or it could be the branch name. Here the reference is the branch name. We are dealing at job level here, not at this level. So in job level, we are saying run this job only when something has happened in the main branch. I hope this is clear. And similarly, you can have some more jobs where you define only run these jobs when something happens in the feature branch. And in the demo, we will see that. So let's move to the demo and do this in real time. So I will go to my Visual Studio Code, and first let me go to the terminal, and what I will do is I'll clear my screen. I will run rm -rf app.py. I also want to remove docker, and then I also want to remove .git, and I'll press enter. So if I run ls-la, I see .github created and app is still here. rm-rf. I'll also remove app. If I run ls-la now, I don't see anything here. So I'll clear my screen. There is .github, but that we need. And I'll go to Visual Studio Code, and let's also delete this because right now we don't need this. I will delete this one as well, move to trash, and then we have a clean structure now. So I'll go to my terminal, and here I will run, let's initialize this, git init, and your branch should already be called main. And then what I will do is I'll go to Visual Studio Code, and in workflow I'll create a new file, and this file I will call 02, and here I will write expressions, variables, contexts, demo, and then I will write .yaml. Pretty long name. So, oh, you should see how I name in when I was in operations. I mean, I used to have some really lengthy names. So I'll go here. I'll copy the workflow YAML. Okay. So this is long, but very simple. What we are saying here is this workflow should only be executed when there is a push to the main branch or there is push to any of the feature branches. Then we are defining 3 environment variables. Application name is payment service, deployment environment is production, AWS region is AP South 1, which is Mumbai. Jobs, we have demo job. This runs on Ubuntu latest runner. Steps, the first step is we are just saying print variables, contexts, and expressions. So what we are doing is here we have different variables. In the first command, we have different variables, and all of these we have already seen at some stage in this course. Then we have some custom variables. We are displaying those custom variables, and as we progress with this course, we'll be doing production like examples so that everything gets connected. But right now I want you to understand these concepts, because these concepts, these foundations will tell you how you deal with production environments and interviews. Then you have context values, and here as well I am using what is already available to us. We are using GitHub repository, we are using GitHub actor, GitHub workflow, runner OS, and so on. And similarly, here we have context versus variable. We are using the same thing. But like I told you before, if you are within your run command, then prefer using variables if something is available as both variable and context. Here I want to show you certain examples, which is why I'm using all of them. And then here is the important piece. So if I talk about expression, let me go to the documentation here, and then I will go to expressions. So if I go to expressions, you have multiple ways via which you can use them, and I don't want you to read all of them. Just have a glimpse of it, and then when the requirement comes, you should be able to understand which one to use. So for example, if it has contains, it will tell you if that is there, something is there, then use that. Starts with, is something starts with this, then use this. Starts with, we are using this in this demo, and so on. So I'll let you read these, but I'll go here, and what I'm saying is expression evaluation. Echo is main branch, GitHub reference is equal to this. Echo is feature branch, starts with GitHub reference name, feature this. Now, when this runs, we will see what this outputs. But this is the piece where I want you to concentrate on. In this step, what I am saying is demonstrate feature branch condition. So if starts with this: if the push has happened in the feature branch, then you run this. Feature branch detected, we are echoing this. But if it is main branch, then you run this step. So if we have performed a push on main branch, then only this step will run. Otherwise, if the push is performed in feature branch, then this step is run. So it is imperative for you to understand that at certain times you may not want to run certain steps. You want to run certain steps only when push is performed onto certain branches, and that is where this becomes extremely powerful. And when we do the production grade demos, we'll be using the combination of all of these to achieve our desired outcome. Now we have understanding of this. What I will do is I'll come to my terminal, and here I will run. I'll also have to git remote add origin again because we deleted the .git directory. And I'll come here. Where is our, yeah, this is it. And then what I will do is I'll come here. I will copy this, and this is saying that your main branch isn't protected, because we are able to push onto the main directly, and we recently created a PR, which is why this prompt has come. So this is also telling you main branches are often protected and yours is not protected. So I'll come here and then I'll paste it here. I'll press enter, and then let me just quickly copy the command. And what we are doing here is git add. Let's move to the staging area. I'm not copying the command because I'll have to do a force push here. And then I will come here, and if I do a normal push, it might not work. I'll paste it here because the work that is there, this work is entirely different. So I'll use a force flag here. I'll press enter. And if I go to my browser, and I want you to know whatever we have done from the main branch, okay? So if I go here, let me just refresh this, and then this is running variables context expressions demo. I'll come here. Oh, this is our file itself. I'll go to actions, and you see now this ran just now. I'll go here, demo job, this is fine. And you see this one did not run this step because we had a condition that this step should only run when there is something in the feature branch. So if there is nothing in the feature branch, then this step will not run. So if I go to Visual Studio Code, that is what we said in this step, demonstrate feature branch condition. If I go here now, print environment variables, you see whatever is there. Default variables, event name is this, branch name is this, commit SHA is this, runner is this, and these are the custom variables that we defined, environment variables also you can say them. And here context values is whatever is, this is the repository, actor is cloud with varjosh, workflow 02 is the name of the workflow, runner OS here, context versus variables. You see both are giving the same thing. What you want to use is your choice, but like I said, if you are running commands or shell scripts, prefer using variables. Expression evaluation, is main branch true, and you see is feature branch is false because the push was performed in the main branch, which is why main is true and feature is false. And finally, if I expand this, you see main branch deployment logic triggered. And why did it say this? Because we defined this step ran because we pushed to the main branch. I hope all of these things are getting connected, and I think that is all I wanted to discuss in this lecture. That concludes this lecture. In this lecture, we understood how GitHub Actions controls workflow execution using event filters, activity types, variables, contexts, expressions, and conditional execution logic. Most importantly, we saw how modern GitHub Actions workflow intelligently control execution behavior to reduce unnecessary workflow runs, optimize runner utilization, and build scalable automation pipelines. In the next lecture, we will continue building on these concepts while moving deeper into GitHub Actions functions and workflow execution flow behavior. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to Lecture 5 of GitHub Actions Basics to Production course. In this lecture, we will move deeper into workflow logic by understanding functions, one of the most powerful capabilities available inside GitHub Actions expressions. We will start by understanding what functions are, why they are needed, and how they help workflows process data, evaluate conditions, and make dynamic execution decisions during runtime. After this, we will explore both general purpose functions and status check functions while understanding their real world production use cases across CI CD pipelines or workflows. Finally, in our hands on demo, we will build a production style Flask CI pipeline that brings together everything we have learned so far, including actions, event filters, activity types, variables, contexts, expressions, functions, secrets, and conditional execution while implementing a real world Docker build, test, and publish workflow. So let's get started. Functions in GitHub Actions. Now, before I start this discussion, there are few things in life that you only understand fully when you do demo for them. So, functions, I believe, is one of those topics. I could have stressed a lot on theory, but I don't want to do that because I want you to understand the core of functions. Like, when would you use functions and what are all the functions that are available at your disposal which you can use. Now, understanding when to use which function is critical, and that understanding you will develop once you start looking into scenarios, once you start looking into production implementations, and of course, as we progress with this course, you will develop a thorough understanding of functions in general, because functions constitute of every workflow YAML that you would see, every production grade workflow YAML, because functions allow you to have conditions. They help you to manipulate values, they help you get dynamic expressions, and so on. So with that understanding, let's get started with functions. Functions are built-in capabilities. So I want you to concentrate on this word built-in. You cannot create custom functions as of now. If there is something that you want to achieve and there is not a function available to do that, I would suggest you create a shell script for that and then execute that script using a run. But for most of the things that you would want to do, I believe functions will serve the purpose. But again, if there are corner use cases, then of course you can use shell scripts for that. Functions are built-in capabilities because these are the functions that are made available to you by GitHub themselves. That's why we are calling them built-in capabilities, and these functions are used within expression, and we have already seen this. So this is the syntax, and inside this is where you define a function, and these functions can be used to process data, evaluate conditions, manipulate values, and make dynamic workflow execution decisions based on runtime information. I know a lot of jargons are here, but as we move ahead with this lecture, a lot of these things will get clarified. Now, functions can be categorized into two. There are general purpose functions and there are status check functions. So if I take you to my browser and then I go to docs.github.com, and let me also zoom in a little. I'll go to GitHub Actions, and here I'll go to reference, and then here I will expand workflow and actions, and then here I will go to expressions. And we have visited this page before as well, but today we are going to see what functions are. So I'll go to functions here, and then you can see there are functions and then there are status check functions. So this name that you see here, general purpose functions, so these are generic functions. General purpose is the name that I decided. You won't see this in the documentation per se, but at large, functions can be categorized into two. One is normal functions or general purpose functions or generic functions. You can call them anything, but I like to call them general purpose functions. And then second type is status check functions. So let's dissect them step by step. General purpose functions, they help workflows process data, evaluate conditions, and manipulate values, work with structured data, and build dynamic automation logic during execution. Varun, simple English, please. Now let's understand the examples so that we understand what all these jargons mean. Now I'll give you a one-liner about all of these. When we talk about contains function, it will let you check whether a string or array is there or not. If I talk about starts with function, it is used for prefix matching and validation. If I talk about ends with function, it will do suffix matching. So starts with prefix matching, ends with suffix matching, contains if something contains something. For example, if I want to search for work in progress, then I will search for, within the contains parenthesis, I will have work in progress, so that the contains function can be used to search what I want to search. Understand, these are functions. They provide you with flexibility of doing what you want. For example, maybe I want to execute a certain job only for branches that contains the word feature in them. Maybe I want to upload an artifact that starts with a prefix called my artifact. Maybe I want to execute my job, execute my step on the basis of if that something, and let's call that a branch, ends with the name -prod. In that scenario, I can use any of these based on my specific requirement. And then you have format function is used for dynamic string generation. So how you would use this is you would use by combining multiple pieces of information into a single string. And I want you to think like a DevOps engineer and broaden your imagination. For example, maybe I want my image tag to have the commit hash, let's say first seven characters of my commit hash, along with the run number, GitHub run number. In that scenario, I could be using the format function to achieve that. So think like an engineer here. Hash files. So maybe I want to run a specific step only when the hash changes. And what is this hash? Hash will change when I have modified certain content of a file. Maybe I want to run a step only when the hash of a file changes, because when hash changes, it implies there has been some sort of updation, removal, or modification in that file. Only then the hash will change. So for certain things, maybe if I am running a security test, I only want to run a security test when my main code has changed. or when my dependencies have changed. So think like that. Then from JSON, it's, as the name implies, converts a JSON string into a usable actions, GitHub actions object. To JSON converts a GitHub actions object into JSON format. And then you also have join function, which can be used for array to string conversion. Again, depending on what is the use case you want to achieve, you will then brainstorm which function I would want to use. Again, this list is not comprehensive. If you go to the documentation, you will see that there are plenty of general purpose functions that are available at your disposal. So these I have already named, but if you scroll down, then there would be more that I have not called out there. So for example, hash files we have already seen, but then you have a case function. Then you also have few more functions that I have not called out here. But do not restrict yourself to what you see on the screen. Always refer to the documentation, because GitHub will keep on coming with new functions that you could leverage in your workflows. Now that we have this basic understanding, let's see what all functions are here, along with example and what exactly would they produce. So for example, if I want to use contains function, the GitHub reference as release, so this is the function, contains is the function, and inside that function what I'm saying is, if the GitHub reference name is release. So for example, what is reference name? We know from our previous learning. So if I open this context page and then I go here, because what is this? Ref name is inside the GitHub context. So if I go to the GitHub context and I search for a ref name, then I see what is ref name? The short reference of the branch or tag that triggered the workflow. So what we are saying here is, if something contains that GitHub reference and that reference is released, then this condition becomes true. And where can you have this condition? This condition can be defined at the job level, at the step level, and at many other levels that we will see as we progress with this lecture, and of course with this course. Produces output true for branches like release, this one, because it is contained. So as long as something contains this word, this condition will be true. And this is just one example. Another example could be execute workflows based on pull requests label. So I can have that logic here. I don't want to show that logic right now, but you can have multiple things. So for example, if I created a PR and I can associate labels with my PR, what sort of labels? Labels like production approved, security review required, documentation. There could be multiple labels that I can associate with my pull requests, and based on what labels I have associated, I can trigger a job or a step. So if for example my PR has a label production, then I want to run extra security scan. So I can achieve that logic using contain. So you have to broaden your imagination to understand or to see what all possibilities are there at your disposal. Then starts with, if something starts with GitHub reference name feature forward slash, then do something, and that do something could be a job, that do something could be a step. So true for branches like feature login. So as long as the prefix has feature forward slash, this condition will be true. Ends with, if something ends with hyphen prod, and that something in our example could be the branch name or could be the tag, as we have seen from the documentation. Reference name could be the branch or tag. So always correlate what you are learning with the documentation, because if you know how to maneuver the documentation, how to navigate the documentation, then possibilities, my friends, are endless. And then you have format, like I said. So see, what I'm doing here is I'm saying, let's say we are creating a container image, and in that container image name, what I want is I want payment service to be the prefix, which we have added here, payment service. And then I'm saying colon, first look at what is at the zero place, and what is at the zero place, GitHub reference name. And then look at what is at the first place. At the first place is GitHub run number. So what it will do is it will check the branch, and the branch name, let's say, is feature hyphen login. It will keep feature hyphen login. And then we are saying github dot run number. What is run number? You know, the execution of that workflow. So if that workflow is executed, let's say the 42nd time, then you would see 42 here. And the run number, you can learn more about this here itself. A run number, you will see a unique number for each run of a particular workflow in a repository. And of course, this number begins with 1, because when you execute the workflow for the very first time, it is the first run of that workflow. So I hope this is making sense to you. Then we have join. We are saying from JSON dev QA prod, you have this as a separator, and then you get dev QA prod. When would you use this? This is typically used when you want to see the logs for something. You want to modify these names, and you want to see something specific in the logging of your application. And this is just one use case. I'm telling you, based on your requirement, you can have plenty other use cases. Again, if any of this is not making sense right now, that how to use them in actual workflow, do not worry. We have a detailed demo where we'll be doing everything production grade. So do not worry about that. The next is status check functions, and these are pretty simple to understand. Purpose: help workflows make execution decisions based on the success, failure, or cancellation status of the previous jobs and steps. Quite simple. So let's see what we are saying here is success implies return true only if all previous steps completed successfully. So what this is saying is only execute when wherever this is defined. This could be defined at step level, this could be defined at job level. So we are saying if you are using this, true when all previous jobs or steps succeed. Failure is another function. So if failure, what failure says, returns true if any previous step or job fails. Simple to understand. What is always, irrespective of what has happened, be it failure, be it success, or be it cancellation, whatever block as in a job or a step has this defined, you run that step or job in all conditions. Now what would be a use case when you want to do this? Maybe you want to upload test reports even when tests are failing. When would you want to use success? Maybe you want to use success to deploy applications only after validation is successful. When would you use failure? Failure to collect troubleshooting information after a deployment has failed. And these are just one-liners I'm throwing at you. There could be endless possibilities. Then you have the cancelled function. As the name implies, if let's say your workflow is getting executed and someone cancels that workflow, then what would happen? So if you have defined this function, then whatever you have defined within that job or step will get executed irrespective of the workflow at large being cancelled. So maybe you want to clean up partially deployed resources. So if someone has cancelled the workflow, there is a possibility that 70% of the workflow was already executed. In that scenario, you would want to clean up the things that the 70% of the workflow created or modified. You want to clean up those things. So based on your requirement, you can use any of these functions. Now that we have a solid understanding of the theoretical part and also some of the practical scenarios when you would want to use functions, I would want to go to the demo, and in the demo we'll be connecting all the dots together. So let's start with the demo, and I'm really excited about this demo because in this demo what I have done is whatever we have learned thus far, so be it actions, be it your variables, expressions, activity types, event filters, I have used everything in this demo so that you can see how everything comes together in production to form a workflow. So let's get started. So what I will do is I will first go to my browser, and then I will go to the repository for this course, which is GitHub Actions Basics to Production. And then what I want to do is I want to take you to 05 functions. And if you have not started this repository yet, then please do start it if this is helping you folks. So I'll go to 05 functions, and here is the demo. I want to go to step 1. Now, as all my demos after lecture 1, I have always said that you must have a repository created. It would be good if your repository is named like this and the visibility is private. And then if you don't know how to do this, how to also perform the authentication between the local Git and your remote repository, then I would recommend you watch lecture 1. But we are starting this demo with the understanding that you already have a repo created and the authentication is already in place. Authentication implies you can push to that repository just fine. Okay, now since we are doing a production level demo, and here in this demo as well, if I go to my draw.io and I take you to the demo that we did in lecture 3 and this one, and if I zoom in, we are pretty much doing all of these things, but now we are adding extra functionalities and extra things onto our workflow like a production would. So we would be checking out the repository. We know why we are doing this, because our workflow, our job will be executed by a GitHub hosted runner, and that GitHub hosted runner cannot execute our job until and unless it has visibility onto our code. And where is our code? Our code is in the GitHub repository. Then we'll have to log into Docker Hub. Why, Varun? Why do we have to log in? Our runner will have to push the image that we create onto our Docker Hub, which will be acting as our image registry. Hence, we must have login in place, authentication in place. Then we'll be building and pushing. We'll be running a container, and then we'll be performing a quick smoke test. I want to add one more thing here. In this demo, the push will be performed at the very last after the container runs successfully. And why we are doing that, I will tell you while we discuss the workflow YAML. So let's go to our browser. I will go to hub.docker.com because here is the place where we will be creating a private repository. And once that private repository is created, we will also be creating a personal access token, because that is the token that our runner will be using to push the image onto this private repository. So let's click on create repository. I will call my repository CWVJ Flask app, and I will be making this private, and then I will write app. Just let me do this, and then I will press, let me check for any spaces here. Okay, it's fine. I'll click on create here. So a private repository is created. Understand that the name of the repository is Cloud with Varjosh Flask app, and then within that repository I will have multiple tags. So when I talk about a image name is a combination of the repository name plus the tag. That is the whole thing that you call an image name. Now let's click on this profile picture icon. I'll go to account settings, and here I will go to personal access tokens. Click on generate new token. I will call this token GHA demo, GitHub Actions demo. Expiration, let's make it custom, and let's say this will expire on 9th of May. And then I will click on read and write. And I also want you to know, these personal access tokens that you create, they are not just limited to the private repository we just created. They apply to all the repositories that you have, be it public or be it private. So whatever permissions you give here, you give here with utmost care. So I'll click on generate, and you only see this one, so it is better if you copy this. I will copy this and I'll paste this in this tab so that I can use it whenever needed. And I'll also not close this so that I can copy it from here as well. So we have done two things. We have created a private repository. We have created a personal access token. Now we have to store this personal access token in GitHub somewhere so that our runner can access that and can perform the authentication. And understand, we should not be defining this token in our workflow YAML. Why, Varun? Because these are supposed to be secret. We want these things to not be available in the workflow logs or any logs whatsoever. So we want to define this personal access token as a secret. So I'll go here. I already have a repository created, CWVJ GHA practice, which has the visibility of private. What I will do here is I will go to settings. I will then scroll down. I'll expand secrets and variables. I'll go to actions. And here is where I will define a repository secret. I clearly want you to understand that when you create a repository level secrets, all the workflows that are part of this repository can access this secret. If I were to create this secret at my organization level, then all the repositories part of that organization would be able to access that secret. So I'll click on new repository secret. If I click here, I already have this because I used this in our previous demos. I will click on Docker hub underscore token. So this is the variable name, and what will be the value of this variable. I will go here. I will copy this. This is the token that we generated. I'll come here. I will paste this secret here. It ends with 4. I hope I don't have any spaces here, and I don't. So I'll click on add secret. Now the secret is added, Docker hub underscore token. Now when we run the workflow, and if we call this somewhere in the workflow, then we will have our runner able to access this variable, and then runner can do whatever the runner wants, and it would be pushed to our Docker hub image registry. So now let's go to Visual Studio Code and see our project structure. So I'll expand 05 functions. That is the lecture 5. These are the notes for lecture 5. I'll expand project files. I've already created project files, and inside project files, I have 2 directories. So .github will have .github and workflows. So this will have our workflow YAML, and there is also an app directory. So both of these directories, .github and app, they are under the project files, and project files is under 05 function. So I'll expand app here, and let's see what our application is. It is an extremely simple application. So what we have is we are exposing 2 endpoints. One is the root, which shows whenever someone hits this, they will see a message, welcome to Cloud with Varjosh, platform, GitHub Actions, runtime, Docker plus Flask. Then we are also exposing a health endpoint, and this is used to check whether the application is healthy or not, or in simple terms, accessible or not. And we'll be using this endpoint in our smoke testing as well. So what we are saying is, if the application returns healthy status, that is status code 200. And then if I scroll down, what we are saying is, if someone defines the port using the port variable, then the port of the application can be changed, the port on which the application listens on. But if this is not specified, this variable is not specified, then our application by default listens on port 5000. I hope this is clear. And then there are few other things. Host 0.0.0, this implies allow this application to listen on all network interfaces that are available to the container. So we'll be creating a container and this application will be listening on all the network interfaces of that container on the port that we have defined, or if someone has changed that port using the port variable. So there is no need to understand Python, so to speak, to understand this. This is a pretty simple code. Now let's see what is the Docker file. The Docker file again is very simple, very basic. We are using Python 3.13 slim as our base image. Then our working directory is /app. So any commands that we run will run on this directory by default. Then we are saying copy the file requirements.txt to the current directory, and this will be the current directory. So whatever is this file and this file is here will be copied here. And then we are saying run pip install. Pip is the package manager for Python. We are saying no cache dir. No cache dir implies when something is installed, there will be certain packages that will be downloaded. What we are saying is discard those packages once the installation is complete, because we don't want our image size to inflate. Our aim as DevOps engineers is the image size should be as less as possible, and that image should also meet all the application requirements. And then we are saying requirements.txt has the name of the package that we want to install. And if I go to requirement.txt, we just need Flask for this application. And then in the next step, we are copying app.py, which is our code, to the image. And then we have a documentation statement. It is optional, but it is recommended you have it. We are saying the application listens on port 5000. This is just for documentation. If you don't have this line here, then this will not magically open port 5000 for your application. And then we are saying the default command that will run is python app.py. So this will start our code. I hope it's very simple, and we have discussed this in lecture 3 as well. Now let's do the interesting thing. So now we'll create the workflow YAML. So I'll right click on the workflow, new file, and I will call this file 01 functions demo.yaml. I'll press enter. Now this is created. Now what I will do is I'll copy paste the content, and then I will be explaining that to you line by line. So I'll copy something and then I will paste it here. I'll scroll up and let's see this line by line. I'll also remove this, and then view, I will do word wrap. The workflow is named 01 cloud with Varjosh Flask build test publish pipeline. And this could very well be called, instead of pipeline, we can have the word workflow here. And then we are saying you run this workflow when any of these two events happen. So at large, there are two events. One is the push event, then is the pull request event. And within that push event, what we have done is we have defined two event filters. One is branches and the other is paths. So whatever is defined inside the push block, inside any of the events that you define, they work in AND fashion. So both of these conditions must be true. So what is the first condition saying? The branch should either be main, or the branch should have feature / as prefix. What is path saying? The modifications, those modifications should take place in app / anything app /. So any directory, subdirectory, file, if you make any modifications, this condition will be true. Or if you make any modifications in .github workflows, anything inside that workflows directory. So if both of these conditions are true, then only the workflow will execute based on this event. And what are these conditions? The first filter is the branch and the second is path. Then we are saying pull request, and pull request has an event filter, and then what it has is an activity type. So what we are saying is you run the workflow when the pull requests target branch is main. That's first condition. Second is and, so they behave in and fashion, and the pull request type is either it is opened or it is synchronized. Synchronize is when you have a pull request open and then you again have new pushes to that branch, then the synchronized condition becomes true. And then ready for review. So what typically engineers would do is they create a draft PR and then they continue working on that draft PR. And once they have done their work, what they would do is they would move that PR to ready for review status. And once that status changes to ready for review, then this will trigger. So now I want you to clearly understand that if there are 10 events and all those 10 events are true, then your workflow will be running 10 times. Okay, so keep that in mind. We discussed that in our previous lecture as well. So all of these conditions, if multiple are true, then the workflow will run multiple times. If only this is true, then also it will run. If this is true, then also workflow will run. If both of these are true, then the workflow will run 2 times, one for the push event and one for the pull request event. Understood? Then we are defining 2 environment variables. Again, I want you to understand that we are defining these environment variables at the workflow level. And when you define something at workflow level, then all the jobs, all the steps can access these environment variables. And I have purposefully defined them here. But you must be explicit. When I say explicit, you must be precise. If let's say environment variables are only getting used in, let's say, single step, then it is better if you define environment variables at the step level. If let's say there are multiple steps within a job that are using environment variables, then you define those environment variables at job level. It is your call how you want to do things. Here I'm defining them at the workflow level, and 2 environment variables I'm creating: application name cloud with varjosh flask app, docker username cloud with varjosh, and this is the username of my Docker Hub account. I also want you to know one more thing. In our previous lectures, what we have done is we also created this username as a secret, but this time I am using environment variables for this. But never use these sort of environment variables for your secrets, for your personal access tokens, for any of your passwords. Then comes the jobs section. In the jobs section, we are only creating one job, and that one job is named Flask build test publish job. I like to suffix whatever I'm doing. So this is a job, so I have a job suffix here. We are saying this job runs on Ubuntu latest. Now comes the interesting part. Don't be afraid, we will dissect this step by step. So we are saying if github.event_name is equal to push and the branch that you are dealing with starts with feature /. So what we are saying, I want you to clearly know, this is defined at job level. This is not defining when the workflow will run. When the workflow will run is already defined by this. Here we are saying this job within the job section, this job should only execute if all these conditions are true. So what are these conditions for this job to run? Event name should be push, and the branch name, because ref name, branch name, or the tag name, here we have branch name, feature /. If the branch name is this, so this condition must be true or this condition must be true. Now why I'm saying or? Because this is the AND operator. For this condition to be true, both of these must be true, correct? First, the event should be pushed, and then that push should happen in the feature branch. Or the event name should be pull request and GitHub base reference. Interesting. So if I go here to my documentation and then I go to context and then I search for branch reference. It was branch reference. What was it? Base reference. I'm sorry. Base reference. The base reference is the base reference or target branch of the pull request in the workflow. So if I'm raising a pull request whose target is main, or some people also call it, if the base is main, then this will be true. And we have an exclamation mark here which says does not contain pull request title work in progress. So this condition says it should be a pull request and whose base should be main, and the title of the pull request should not contain the word work in progress. You see how we use the contains here. You see how we used other starts with here, how we used other things together. So this is how everything comes together. Your team lead or manager will come up to you with a requirement, and based on what your manager or your TL has said, you must design this. As simple as that, right? And then let's look at the steps. The first step is check out repository. So this we have already seen. This will check out the code because our runner who is executing this job must have access to the code. And this is another interesting step. Here we are generating a dynamic image tag. So what I'm saying is echo image tag. So I'm creating a variable whose name is image tag. And what will be the value of that image tag? I'm saying v. I have a v here, and then I'm saying GitHub run number. So if run number is 1, then the image tag would be v1, and then what I'm saying hyphen GitHub underscore SHA, and then I'm saying take only the first 7 characters from the commit hash. SHA is the commit SHA. I only want the first 7 characters. Now, if I'm tagging an image like this, I know 2 things right when I look at the image. I know that this image resulted from GitHub workflow run number this, and the commit that resulted in this run, the commit ID, the commit SHA was this. Extremely important. Then Varun, what is this? GitHub underscore env. Now GitHub provides you with this special GitHub environment for passing dynamically generated value between workflow steps. So if I have generated something and I have added it here, then I can access it from the subsequent steps. Any variables written to this file becomes available. So any variables written to this file becomes available to subsequent steps within the same job. So this is something that you would often see used in production. Next step is pretty simple. We are just displaying few things, and I also want you to notice one more thing. We could have used contexts here, but we are deliberately using GitHub variables here, and we are saying application name, just print the application name. Application name is here. Of course, for this we would have to use variable. For this we would have to use variable. For these 3 we could have used context, GitHub context, but we are using variables. And as we have learned in our past lecture, that when we talk about variables, we use them within the run step. It is recommended. Although if something is not available as a variable and that something is only available as GitHub context or any other context, then feel free to use that. In the next step, we are performing the Docker login. And here also we used an action to perform the checkout. Here also we are using an action. And how do we know we are using an action? We know that there are 2 keywords. There is the run keyword, which is used to run shell scripts or command, and then there is the uses keyword, which is used to perform certain actions, which is used to use actions that are available at your disposal by GitHub, or there could be custom actions, or there could be third party vendor actions that you could be using. So here we are using an action by Docker that is called login action, and for that action we are using version 3. And here we are saying with username this, and we already know that all these fields can be checked from the documentation when we have done that in the past, so I will not repeat those things. Here we are saying the username is env.docker username, and this is how we are using the environment variable, and we have seen this before as well. We are using the environment context, and that context has docker underscore username. We know that this whole is called an expression. We have learned this in the past. And env.docker username. So this will result in cloud with varjosh, and then we are using this secret which we have already defined at repository level, and we called that docker hub underscore token. So if I go to my GitHub repository and I go here, you know that our secret was named this. And then there is build docker image. Here as well we are using an action called build push action, whose version 7 we are using, with context app. So if you remember the build context for Docker, when you are building that image, we are saying look for the files that are needed by you. In the root you will find /app, because when we push our code to the repository, our code will be available in /app, correct? And that has our docker file, that has requirement.txt, that has app.py. So the build context that Docker would want is available in app directory, hence the context is defined like this. And then I scroll down, push, we are not pushing the image yet, and I'll tell you why we are not pushing the image. This is false here, and this is the interesting thing. What is the tag that we are giving? We are saying environment docker username, so cloud with varjosh /application name. What is the application name? Cloud with varjosh Flask app. And if I go to browser and I go to my this docker hub, you see that is what we have named our repository, cloud with varjosh Flask app, cloud with varjosh Flask app. And then what is the tag of that image? To pick the tag from this. And what is this? This is something that is available inside this image tag. So this is accessible to the subsequent steps. Now we are accessing the image tag value that results here, and when we see this step in action, we'll see how this works. And then run container. In the next step, we are running the container. Docker run -d, run in the background in detached mode, or then we are saying -p, any one that hits port 5000 on my Docker host. And who is my Docker host? My GitHub hosted runner is my Docker host. If anyone hits port 5000 on my Docker host, you send that to port 5000 of the container, and our application that is running on that container is listening on port 5000. And then the name of the container that you are about to create, my friend, should be Flask container, and the image that you should be using is this image. So cloud with varjosh cwvj Flask app, and then the tag, and this tag will be a combination of my run number and the first 7 characters of my commit hash. And then we are performing a quick smoke test to see whether our application is working fine or not. And then we have this, and then the next step is push Docker image to Docker hub. Now this is the interesting piece. Here we are saying if success, then only perform this step, because if this is failing, hello, I don't want to push a bad image, a not working image to Docker hub. I only want my image registry to have images that are tested to be working properly. And how do I know my image, the container, that resulted from that image is working fine because I have performed a smoke test in the previous step. So we are saying run this step if the previous steps have been successful. And once we know that this is successful, if this is successful, only then, or previous and all the previous steps have been successful, only then the image push will happen. And then we are saying collect container logs. If there are failures, then you collect the Docker logs of Flask container. Now there is a possibility that even if the failure occurs, we don't see anything because maybe our job failed before even the container was creating. So this will not give you anything, but I've just kept this so you know you can use it to collect certain logs from any stage. And then finally we are saying always, be it a failure, be it a success, or be it a workflow cancellation, you always delete the container. And then we are saying or true. So if there is no container, then this step will fail eventually. That is why we have true, so that this step always succeeds. Now we have everything in place. So now let's perform the push. So I'll go to my terminal. I am in project file. I will run git init, git to initialize my local repository, git add dot to move all the files that are available to the staging area. Once the files are moved to staging area, I will write git commit -m. I'll give a commit message. I'll add feature, and then I will run trigger workflow from main branch, right? And then I will close this and this, and then I will press enter. And then I'll also have to add the remote, git remote add origin. And then I'll go to my repository. I'll go here. I'll scroll up. I'll go here and then SSH. Yes, I'll copy this and I'll paste this here. Press enter. I'll run git remote to verify I see this. I see origin is here, and then I will write git push -u origin main. And our workflow, if I go to my Visual Studio Code, this condition is met. So we are working on the main branch. We have modified things that were here and we have performed the push. So the workflow must trigger. So I'll go to my browser. I will refresh this and I'll go to actions. And you see one workflow run, but the job did not execute. Why didn't the job execute? If I go here, see the job was skipped. Why was the job skipped? My friends, I told you there are two things. These are the conditions for the workflow execution, and this is the condition for the execution of the job. And this condition was not met. Hence, the job did not execute because we pushed to main. And we are saying that only run this job if this happens, push to the feature branch, or if there is this thing. So we did not meet the condition. So let's meet the condition by creating a feature branch and then pushing to that branch. So let's go to our terminal again. I'll clear my screen. This is so interesting, guys. So I'll run git switch -c. I'll create a new branch, and this time I will call this branch feature GitHub Actions Functions Demo. GitHub Actions Functions Demo. Pretty lengthy name, but let's go with it. And it has created the branch, and I am also in that branch now. So what I will do here is I will echo, and let's add a comment in our code, and let that comment be feature branch change. Okay. And then I will redirect it to app.py. I'll press enter. So I have modified. So if I run git status, I would see that I have made changes to this file. So I'll run git add dot. So this will move it to the staging area. And then I will write git commit -m. and then I will write feature, and let's call this add feature branch workflow demo. I'll close this, enter, and then I will write git push hyphen u origin, and then feature this branch name. I'll press enter, and this will perform that push. Okay, the push has been performed successfully. Now let's go to our browser, and I'll go back. Our job is getting executed. And why this is getting executed? This is run number 2. Run number 1 of the workflow was this. Number 2 run of the workflow is this. And why did this workflow trigger? This workflow triggered because of this commit. This workflow triggered because of this commit. This workflow triggered because of this commit hash. And if I come to my terminal, I run git log hyphen hyphen one line hyphen hyphen all, then you see 6D-A6. And if I come here, 6D-A6. And you can see this from the GUI as well, but I like the terminal better. So this is successful. So if I go here, and you see there are so many things, I'll let you read what this is, okay? And then I'll go to the job, and you see this collect container logs did not run. So why it did not run? If I go to Visual Studio Code, collect container logs did not run because that was only supposed to run on failure. Since there was no failure, this step was skipped, my dear friends. And then you can check all the steps that we performed. Generate dynamic tag. Let's see what resulted here. So if I expand this, you see that application name is this, Docker username is this, and as we move forward, you will see what is the output of this. So I'll expand this, display build information, all the information. See image tag v2. Why v? Because v was part of our syntax, right? V was here. GitHub run number, we know this is the second run of this workflow. And then first 7 characters of the SHA. And if I go to my terminal, first 7 characters ends with 6D. 6D. How cool is that? Log into Docker Hub, succeeded. Build Docker image, succeeded. And why is our runner able to perform Docker specific commands? Although we are using actions, but under the hood, those actions are also using Docker commands. And why are those commands successful? Because our GitHub hosted runner has Docker already installed. And I think we already saw this as part of lecture 1 or 2. Then I expand run container. And you see, this is the container ID of the container that got created. And here are all the things that were used. You see, how cool is this? And this is already moved in the environment variable section, whatever we created, because you know how to use these things. You know that you can use this environment variable to store certain information, and that information is available as environment variables for the subsequent steps. So smoke test, once the smoke test was successful, you see we were running 2 things. We were hitting the root endpoint, and then we were hitting the /health endpoint. Push Docker image to Docker Hub. This push was also successful. And if I go to my repository, there is no tags. I have to refresh this. We see this v2, and this is the commit hash. This is how we tagged our image. So again, let's go here, clean up containers. This deleted the Flask container. Post build Docker image, removing temp files, and all of these things are happening. And then post login to Docker, post checkout repository, complete the job. So our job was completed. How good is that? Now I want to do something else as well. What we also define is when there is a PR, the workflow should trigger, right? This is what we defined. When we open a PR to whose target is main, then the workflow should also trigger. But we also said that if the title has work in progress, then the job should not run. The workflow should run whenever there's a pull request created. But we also said, but if the title of that pull request contains work in progress, then don't run the job. So let's test that. So I'll go to my browser, and here what I will do is I'll go to code. I could also go to pull requests, but here you see compare and pull request. And let's add a WIP here. I'll just remove this WIP. This is so cool, right? And then I will, here you can create a draft pull request as well, like we discussed, but I'm creating a pull request. I'll click on create pull request. And we know as soon as pull request is created, whose base is main or whose target is main, then our workflow should trigger. So if I go here, actions, our workflow did trigger. You see number 3 here. But my friends, what we do not see here is the job getting executed, because we have said that the title of the pull request should not contain work in progress, but our title had work in progress, so the job did not run. So let's do certain changes. So let's go to the browser. I will go to pull requests. I will come here. I will then click on this edit button here, and then I will remove this work in progress and I'll save this. Okay, I have saved this. Now let's perform a push. I'll go to my command prompt, and here I'll clear my screen, and then let me just copy paste what I want to do. So what I'm saying is, first add this in the app.py and then move that to staging area, then commit this feature update pull request and then git push. I'll press enter. And I want you to notice few things right away. So if I go to my browser and I then go to actions, this has triggered 2 times. Why, Varun? Understand, we did a push to the feature branch, and when you did push to the feature branch, this point held true. So one execution resulted from the push, and second execution resulted from the synchronize part, because we learned when a pull request is opened and then you perform certain new pushes, then the activity type synchronize will be true. And that is what happened, my friend. So if I go here, you see one run was because of the commit and the second run was because of the synchronize. How good is that, right? And if you have understood this till this point, I'm telling you, you are already GitHub Actions Ninja. It's just the matter of doing few additional projects, and I'm sure you will rock in production and in interviews. So let's go here and let's see. And let's first go to Docker Hub. So one image, we should see 2 more images now. And you see run number 5 and run number 4. Both images are here. 3, 4, the run number 3 did not run successfully because this job did not execute here. So you don't see 1 and 3, but you see 2, 4 and 5. 2, 4 and 5. How cool is that? So I hope everything is understood, and this is where I want to end this lecture. In this lecture, we understood how GitHub Actions functions help workflow process data, evaluate conditions, and control execution behavior dynamically during runtime. We explored both general purpose functions and status check functions while understanding how they are commonly used in production CI/CD environments. Through the demo, we built a production style Flask CI pipeline that combined functions, expressions, contexts, variables, secrets, Docker image publishing, smoke testing, and execution control into a real world automation workflow. In the next lecture, we will explore inputs and outputs, understand how data can be passed between jobs and workflows, and learn how to share information and artifacts across different stages of CI/CD workflows. If you have any questions, feel free to ask them in the comments section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to Lecture 6 of GitHub Actions Basics to Production course. In this lecture, we will explore inputs, one of the most important concepts for building dynamic, reusable, and production ready GitHub Actions workflows. We will start by understanding what inputs are, why they are needed, and how they allow workflows to receive information at runtime rather than relying on hard coded values. After this, we will explore the different types of inputs supported by GitHub Actions, including workflow inputs, reusable workflow inputs, and action inputs, while understanding where each type is commonly used in real world CI/CD environments. Finally, through hands on demos, we will build an environment aware CI pipeline using workflow inputs and then learn how organizations centralize deployment logic using reusable workflow inputs to standardize automation across multiple applications and teams. So let's get started. Inputs. Firstly, when I talk about real CI/CD pipelines, the workflows that you would use, they rarely operate with fixed values. Organizations, what they often need is same workflow to support multiple environments. And when I say multiple environments, it could be dev, QA, pre-prod, prod, and so on. Not just multiple environments, but multiple applications, deployment strategies, and operational scenarios. When you have a situation like this, when you want to provide some data to your workflow during runtime, that is when you use inputs. So what are inputs? Inputs are parameters used to pass user defined values into workflows. User defined is the keyword here. Previously, the steps or jobs within our workflows were getting run or executed based on whatever we defined in our expressions and functions. But now what we are saying is whatever user defines at a runtime, user provided data, as in based on that the workflow will execute. Now what inside the workflow, maybe step 1 of a job should only run for development, it should not run for a production workload. In that scenario, inputs will help you, and as we progress we will dissect various scenarios. So inputs are parameters used to pass user defined values into workflows. Reusable workflows, that is the second type of inputs, or actions at runtime, that is the third type. So we have covered three types of inputs here. First is the normal generic workflow inputs, second is reusable workflow inputs, and the third is action inputs. Now we will be doing this lecture in a different way. So what we will do is we will first discuss the theory of workflow inputs, then we'll be doing the demo for workflow inputs, and then we will come to reusable workflow inputs. And when I talk about the third type here, we will only discuss the theory part. We'll not be doing a demo for this. And why? The reason is we have not discussed how do you create custom actions. So I don't want to demo something that has a foundational concept pending. So first we will learn how to create actions, how to create custom actions, and then we will zoom in into action inputs at a later stage in this course. So now let's understand what workflow inputs are. used to provide values when triggering workflows using workflow dispatch. Now, what is workflow dispatch? And we have seen this in the past lecture. Workflow dispatch, whenever you use this event, what happens is you see a button in the UI from where you can run your workflow manually. And we have discussed various events via which you can trigger your workflow. We have discussed push, pull requests, and now what we are seeing is workflow dispatch, which will allow you to run your workflow manually from the UI. And this statement manually from the UI has few gaps, and I'll tell you what the gap is. So it is not just limited to the UI. You can trigger a workflow that has workflow dispatch as an event using GitHub API or GitHub CLI. It's not just limited to the console, the UI that you see. So let's take an example of something that we already know. So if I talk about creating an EC2 instance, you can go to the console and create an EC2 instance, or you can use AWS CLI that is configured and installed onto your laptop to create an EC2 instance, or you can use Terraform to create an EC2 instance. And what these things will do under the hood is they will be calling the EC2 API to create your instance. Similarly, if I talk about workflow dispatch, when you have this configured, you can either use the UI to click on the workflow and then run it, or you can use GitHub CLI or GitHub API to trigger that workflow. And we will see that theoretically how to do. Used to provide values when triggering workflows using workflow dispatch. Now, what are these values? Now, I want you to concentrate on what we have here. So what you see here is a snippet that we will be using in our demo. So in our demo, we'll be making this a little advanced, but at this stage I wanted to have snippets right in front of you so that you exactly can create that mental picture in your head that okay, this is how it is working. So you have the inputs keyword, obviously, because we are dealing with inputs, and all of these will have the input keyword, all of these types I mean. And then you have environment. What is environment? Environment is something that is user defined. Varun Joshi said, I want an input named environment. You can have an input named something else, maybe deployment strategy, maybe security scans. So this is something that you provide. So this is the input name. For me, the input name is environment. So let me zoom in a little as well so that we can concentrate on this part only. And then you have a required. So required is the keyword which is true here. This implies that this field is mandatory to be filled. If this field is not filled, then we will not be able to trigger the workflow. Again, there is one more thing I want you to notice. You also have a default here, which is dev, which implies if someone does not provide the required field, then we would take default as dev. And why we are calling this dev? Because you have various options here, and those options are dev, QA, and prod. And we will see how this is very useful in a little while, but for now I want you to concentrate here. So if I would have not provided this default, then it would have been must to provide something in the drop down that you would have seen, because the type here is choice. The type of this input is choice, implying user who is running the workflow will have a choice to choose any of these options. And why these options? Because I have defined these options, and I have only defined dev, QA, and prod. And I want you to know whatever I teach is subjective. Whatever configuration I do when it comes to configuring your workflows is subjective. Your application, maybe it has a pre-prod or staging area as well. I have not defined that here. Maybe your application is not that critical or not that compliance heavy, hence you do not have QA, you only have dev and prod. So these things are subjective. I want you to keep that in mind. Now, let's discuss this again. Description optional, but you should provide. Required is true. So there must be some choice. If the some choice is not provided by user, then default dev will be used. Type is choice. So there are multiple types of inputs that you can use. We are using choice here. And then options, you have three options: dev, QA, and prod. So if the user chooses dev, then if this workflow is to be completed, you would have a step that is calling whatever inputs the user has provided. So for example, let's say echo deploying to, and how do you call input in a workflow? You have the same expression that we have been using, the same syntax, and then you have inputs dot environment. Pretty simple, right? If you do interpolation, you first have inputs and then you have environment. So exactly like that you are calling. And I also want you to know that it's not just one input you can have multiple inputs. So here I have environment. Let's say I also have an input called deployment strategy. In that scenario, I could have called inputs dot deployment strategy as well. So broaden your imagination that way. So this is how you call it. Now I want to discuss what other things are achievable when I talk about type. So the type we are using here is choice, but you also have other options. So let's see what all other options you have. You can have string, and string is a free form text input. Application version, this common use cases, or you can supply a Docker image tag, release identifier, branch name. So depending on what choice you want to make. But I think I should be adding one more thing here, why these choices are useful. So for example, let's say you have a workflow, a single workflow where you have defined everything that is to be done in dev, everything that is to be done in QA and prod. But I also want you to know that not all jobs and not all steps are to be performed for all these environment. Maybe when I talk about dev, I only want to perform a build and then I want to deploy. When I talk about QA, I just want build plus, because it is QA, quality assurance, I also want to perform security scans, integration tests, and then deploy. Maybe if I talk about prod, I want to first build the application, then I have certain approvals, manual approvals or automated approvals, and then I am deploying. Now, based on what user has selected, only the jobs or steps that are to be performed for that specific environment will be performed. How good is that? So this is one use case. Now let's come back here. If someone has provided a Docker image tag, then whenever I'm tagging my image, what I can do is I can call that input, whatever user has provided in the string, I can use that input to tag my image. And same applies for application version. Maybe I'm also adding application version somewhere in my logs or in my echo statements, and there I can always use this. So for example, if I'm displaying certain logs, then I would write logs for inputs dot whatever the name I have given to my application version, whatever string I have defined. So if it is v1.2.0, then I would see that. I hope you can connect the dots here. Now choice. Now choice, as we saw, it is something that you as DevOps engineer or you as developer will be defining, and based on that certain jobs or steps will run, and we'll be seeing this in the demo. The demo will connect all your dots. Another thing I want you to understand, when you have an option to choose between the type string and choice, then I would typically choose choice, because choice does not have room for human errors. Because if someone is supplying a string, they have option to type it, and we all are humans, we can make mistakes. So it is recommended that you use choice, but if you must use string, then who is stopping you to do so? Then you have boolean. Boolean is simple, true or false. For example, if I have an input defined for security scans, it could either be true, it could either be false. Then you have number, numeric value. Maybe you want to supply the replica count, timeout value, retry count, scaling parameters, and so on. So the possibilities are many, but based on your requirement, based on your use case, you would be using these types. Environment, now this one is special. So if I go to my browser, and then let's open my CK certification course repository, and if I zoom in a little, what I can do is I can go to settings, and if I go to settings, I have something called environments here. You see this. So what you can do is, within GitHub you can define multiple environments. Now these environments, what they will do is they will allow you to do certain other things as well. So if I go to my diagrams again, choose environments with associated secrets, approvals, and protection rules. So when you create these GitHub environments, each environment you can associate some of these things, and based on that your environment will behave. Now this is an advanced topic, so I don't want to go deep into it right now. Later in the course we will be looking into it. So I hope all the types are also clear, and this snip is something that I want to tell you. So what I told you was, it's not just UI from where you can run this. That's why I have this snip which tells you, if you want to run a workflow that is named this workflow input demo, then you have to provide certain input. So if let's say you have defined the default there, like we have defined here, we have defined default here. If you have defined defaults for all your inputs, here I'm just using environment, but you can have multiple like I told you. Then if default is defined, then you don't have to supply this if you want to run for the default values, of course. But here I'm telling you a scenario where you provide the inputs. So you provide the environment to be production, you tell that perform smoke test is the second input name that I have defined, which is true, and we'll be seeing this in the demos shortly. And then of course, like I told you, one method is GitHub API, another one is GitHub CLI. Like I told you, with AWS there is AWS CLI, and then there is also AWS API under the hood, Terraform or anything that will hit the API to run your EC2 instance or anything that you want to do. So here is how you would use GitHub CLI. GH workflow run, this is the name of the workflow, and then you provide the environment and perform smoke test input value. So for this the value is prod, and for this the value is true. And there is one more thing I want to tell you, that we have studied functions in the past lecture, so I don't want you to get confused between functions and input. So inputs is the data that you provide, and functions and expressions, they decide what to do with what you have provided. Okay, so for example, if I'm providing an input as prod, then it is expressions and functions that will decide what to do with that data. So for example, if the data provided is, let's say, dev, then we would be echo deploying to, and then here we have an expression, and inside that expression we are using the data that is provided by the user. I hope this is extremely clear to you. Now let's go to the demo. So first I'll go to my browser, and then I will go to the home page. I'll close this one, and then this is the repository for this lecture, and I would request you to start this if this course is helping you. I'll go here, and then I'll go to today's lecture, which is 06 inputs, and I'll scroll down. I will go to step 1 of demo 1, and this is clickable GitHub notes, extremely useful. So whatever I'm speaking, consider everything is mentioned here along with additional details that cannot be provided in the lectures videos because it could get very long. So I have added production insights, operational notes for you to refer in all of these lectures so that you have solid understanding. So let's go to step 1 for now, and this has a prerequisite. Prerequisite is you must already have a private repository created. It could be a public as well, but I would recommend create a private one, and then you must be able to push to that repository. So that implies your authentication must be in place. Now if you are not aware of that process, of course you can watch lecture 1 where we discussed authentication in detail. So if you have that in place, let's go to Docker Hub and create a token. So here in this lecture for production, we will be pushing onto Docker Hub. We'll be pushing the container image to Docker Hub. That's why I'll be creating a token so that we can push to Docker Hub. And to push to Docker Hub, a token is needed. We all know that from our past lectures, because a runner would need that token to perform the push onto our repository, onto our image registry. Image registry is Docker Hub, and here we'll be creating a repository. First, I will name that repository Cloud with Varjosh Flask app. I will change this to private, and then I will click on create. After that, I'll click on my profile icon. I'll go to account settings. Here I will expand personal access token. Settings is already expanded. Then I'll come here, generate new token. I'll call this token GHA demo, GitHub Actions demo. Expiration, let's keep it custom, and I will be expiring this in, let's say, 2 days. Since we will be pushing onto this repository, what I want to use is read and write, and pushing onto the repository is not the correct word here because this access token is applicable to your entire account. So all the repositories that you have, anyone who has this token will have read and write access to those repositories, implying they can push and they can pull. They can pull even your private repositories, private images. I'll click on generate. The token is generated. You will only see this once, so it's better you copy this. I will copy this. I will then go to Cloud with Varjosh GHA practice. This is the repository that I would be using. I'll go to settings, and then I will go to secrets and variables. I'll go to actions then, and then I'll click on repository secret. Again, I'm creating a repository level secret. If you create an organization level secret, then multiple repositories can be using this. This secret that I am creating will only be accessible to the workflows that are created in this repository. So the value for the secret is this one, the token that we just created. I'll click on add secret. It is recommended that you create secrets like this. You do not define your secrets in the workflow YAML. Secret is created, repository is created. Now what we want to do is, now I want to give you a walkthrough of our code, and we have already done this in our past lecture, so I will be pretty fast this time. So I'll expand 06 inputs, and I have a directory called project files there. I'll expand that too. And then here I have app.py. It's a very simple Python code, and this Python application uses the Flask framework. What it will do is, if you hit the root, it will display welcome to Cloud with Varjosh, GitHub Actions, Docker plus Flask. I have also created an endpoint which will tell me whether the application is healthy or not. It is /health. If it returns 200, that is the success code, then my application is healthy, and my application listens on port 5000 by default. If you want to change that, you can use the variable port to change that. Host 0.0.0.0 implies the container onto which this application is deployed, or the virtual machine onto this application is deployed. The application will be running on all the network interfaces that that container or that virtual machine has, or that physical machine has even. So anywhere where it is deployed, it will listen on all the network interfaces. And then you have the Docker file. Docker file, straightforward. We are using the base Python slim image working directories /app. We are copying the requirements.txt. Requirements.txt has the package that we want to install onto our container image, because our application uses the Flask framework. That is why we are installing Flask. So we go here, pip install. Pip is the package manager for Python, and then we are saying the packages are listed in requirements.txt. No cache dir implies the package that you download or any of the caches that are being downloaded, just discard those caches, because what we want is a smaller image size, as small as it can be, while fulfilling all our requirements. We do not need the package bundle once the package is installed, hence we are discarding those things. Then we are copying the code app.py onto /app. We have this for documentation, which is recommended. We are saying our application is exposed on port 5000. If you do not have this here, then this line will not magically allow your application to listen on port 5000. This is just for documentation. And finally, we are running our code by using Python app.py. We have good understanding of this. So let's start creating our workflow. So I already have .github created here. I'll expand this. I already have workflows created here, directory, and this is the path where your workflow YAMLs must reside for GitHub Actions to take action to run your workflows. So I'll right click here, new file. I'll call this 01 workflow inputs demo.yaml. And then what I will do is I'll quickly copy paste the contents, and then we will discuss the content line by line. I'll copy this, I'll then paste it here. It's going to be very interesting. Okay, so name 01 type 1 workflow inputs demo. Always give reasonable names so that anyone who is seeing the logs, and you can have multiple workflows for enterprise applications, so ensure your workflows are named properly. This name is what you will see in the UI when this workflow is triggered. We are saying trigger this workflow on workflow dispatch. This will give you a UI button which you can click and then run the workflow. This we have already discussed in our theoretical section. So we have inputs. In this we have two inputs. First input we already understand is environment. And then I also have a second input which says perform smoke test. So this is what you will see in the UI. So as DevOps engineer, I would be given one drop down where I have to choose which environment I want to run this workflow for. And then I'll choose one of these. If I don't choose, dev will be chosen. And then the second input that is needed, because required is true, you will have to supply a boolean. The boolean could be a true or false. So do you want to perform smoke test or not? If for example you choose dev here, then you may not want to run smoke test for that. So we are giving developers or DevOps engineers options to choose whether they want to perform smoke test or not based on the environment that they have chosen here. And this is so wonderful when you have authority on what DevOps engineers or developers could be running, because I have choice used here. So whoever is executing the workflow will have to choose from one of these values. And here as well, I have a boolean true or false. So they'll have to choose whatever I have decided. And that's so powerful. And then we have three environment variables defined. We have application name, which is cloud with varjosh flask app, Docker username cloud with varjosh, image tag we are giving manually here v1.0.1. And in the past lectures, we have seen how you can use dynamic values for image tag as well. Let's scroll down. jobs. The first job is Flask CI job. This job runs on Ubuntu latest runner, that is an Ubuntu based runner. The first step in the job is to check out the code. Hello, our runner is executing this job, and our runner must have the code to execute that job. Hence, the first step is check out a repository, and we are using an action here because there is the users keyword. Then you have the second step, which is display input values. Now, this is simple. We are just displaying what user has chosen when the workflow was executed. So here we are saying echo environment is whatever user chose. So if we chose dev, you will see dev here. Perform smoke test. If it was false, you would see false here. Then build Docker image. So we are again using an action here. The action name is build push action, and the author of that action is a third party vendor, which is Docker. It is not by GitHub themselves. Like this action is by GitHub themselves. So this is by Docker. With is used to supply different configurations that you want, and you can check the documentation for the action that you are using to know what all options are there at your disposal. And we have seen this before. Context is just dot. Why is it just dot? Because app.py docker file requirements.txt, the build context will be made available at the root of the repository. Hence, we just have a dot here. Push is false because push will be performed as the part of some other step. Tags. Now this is the image tag. What is the tag that we want to give to the image? So this is first the username. What the username is, cloud with varjosh. We have already defined that here. And then environment.application name. So the repository name here is Cloud Flask app. And if I go to my browser, that is what we also named our repository, CWVJ Flask app. So this is already there. Now we are giving a tag, and tag we are saying env.image tag. So this will be v1.0.1. Simple. Then the next step is QA validation, and here comes the interesting part. Here we are defining a real logic using expressions, and as we progress in the mega demo, what I intend to do is I want to combine everything that we have learned. So be it functions, be it expressions, be it inputs, and whatever we learn in future lessons like outputs and so on. Then here I'm saying the QA validation step must only run, because I have a if condition here, if the input provided is equal to QA. So this step will only run if the input provided by user is QA. Next step is login to Docker Hub. We are not performing the Docker login, the Docker Hub login for dev environment. So this is not when the environment is not dev. And why is that? Because if I am running something in dev, I don't want to push the image to Docker Hub for that. Because if, let's say, my container run fails, I don't want my image registry to have stale or faulty images. I only want my Docker Hub to have pushes that are legitimate, that results in container running successfully. Hence, I am saying in dev, don't push, because I don't know what the result of that workflow will be, of that container will be. And here as well, I'm performing the push only when the input provided is not dev. So for QA and prod, we'll be pushing the image. And at this stage, I also want you to understand one thing very, very clearly. And if you have watched my, the prerequisites for this course, I covered day 1 and day 2 of Jenkins, where we discussed about SDLC and, branching strategies and so on. We discussed that there as well. Typically, what happens in production is you only create an artifact once. So container image is created once, then the same artifact is promoted onto different environments. So you create the container image for dev, and then the same image is promoted to QA, same image is promoted to staging, same image is promoted to production. So generate once, deploy multiple times. And we discuss why we do that in the prerequisite part itself, in those lectures itself. And then what we are doing is we are running the container. And simple, docker run -d, run the container in background or detached mode. -p, our runner is listening on 5000 because that is our docker host, and whatever comes on port 5000 is sent to 5000 of the container, and our application listens on port 5000. Name of the container is Flask container, and this is the image that you should be using. Simple. And then we are performing the smoke test. And from where are we taking this input? We are saying only perform this if user has supplied true during execution of this workflow. So simple. And finally, we have a step where we are deploying to Kubernetes, and we are only performing this deployment when the input provided is production. Again, like I told you, each application or each environment or each strategy is different. Maybe in your application, when dev is provided, then the application is deployed onto dev namespace of a Kubernetes cluster, or maybe you have a different cluster altogether for dev and QA, and then you have a different Kubernetes cluster for your production. All of these possibilities are there. So broaden your imagination and don't just be stuck with whatever I'm showing. Possibilities are many, but in our scenario, we are saying when the environment is production, then you deploy to Kubernetes. Again, these are dummy steps, I know, but first I want you to learn how to walk. And once you have learned that, we will learn how to run and how to sprint. So for now, I hope whatever is defined here is crystal clear to you. Now let's perform the push and see the magic happen. So I'll come here to my terminal. So I am in GitHub Actions 06, lecture number 6, inputs in project files. And here if I run ls-la, you see we already have this .github, and under this we have workflows, and then we have our workflow YAML, and here is our code in the root itself. So what I will run is git add dot to move. So first I will run git init because this is not initialized, and then I will run git add dot. This will move everything to the staging area, and then I will write git commit -m, and then I will write here feature add workflow inputs demo. Okay, press enter, and then I will write git remote add origin, and this name could be anything. I'm calling this origin because that's most common. And then I'll move to my browser, and here is my GHA practice, and then I'll go here. I will copy the SSH link from here, and then I'll paste it here. I'll press enter. This is added. I will write git push -u to define upstream local to remote mapping origin main. I'll press enter, and this should work. And then I will go to my browser. Ensure your authentication is in place. Okay, and then I'll go here. I will refresh this. I see my code is there at the root of the repository, which is why we just provided dot as context in the action that we are using. Here we'll go to actions tab, and you see 0 workflow runs, but we just pushed, right? Why don't I see a workflow run? Because we have not said that you should be running this workflow on a push. We have workflow dispatch here, and workflow dispatch gives you a button in the UI, right? So if I click on this drop down, aha, this is nice. Use workflow from, this is main for us right now, And then deployment environment. What is your development environment? My development environment is, let's say, dev. And it is asking, do you want to execute smoke test? This is true right now. I'll uncheck this and it is false. I'll now click on run workflow. And based on my inputs, this workflow will run. So if I go here, the steps will be performed based on the input that I have given. And that is so wonderful. The workflow, the steps will run based on what I have provided. So if you look here, build Docker image in either scenario, be it dev, QA or prod, we were building the Docker image. But if I scroll down here, QA validation is skipped. Why this is skipped? Because I said you only should be running this QA validation when the environment chosen is QA. Because in QA, you want to perform all the security scans, the compliance checks, and so on. So if I go here, this is skipped. This is also skipped because we are only pushing the image in QA and production. We are not pushing the image in dev. The container ran. So smoke testing is also skipped because I chose false there. I unchecked it. Deploy to Kubernetes was only applicable for production, as we have defined here. Deploy to Kubernetes only for production. So let's run this one more time for QA, and then we will run it for prod as well. So I'll run it for QA once and I'll execute smoke tests this time. And then from here itself, I will run it for prod 2. I'll come here, prod, and let's run the smoke test there as well. And I'll run the workflow. The push will happen twice, but our tag is the same because we have manually added the tag. Let's go here. Let's step one step back. Let me scroll to the top. I'll go back, and first I want to see this one, which was done for QA. If I go here and if I click here, deploy to Kubernetes is the only step that was skipped because this is production and we chose to run smoke test. And if I go here to my repository, if I go to tags, you see there has been a push here. We see the tag that we defined here. So if I click this, you will see whatever image that was built. So I'll go back, and then let's also see what we have for the last run, which was for production. This was for production. And if I go here, I come here, QA validation was skipped here because QA validation was only supposed to be performed when QA was selected. I hope you have understood this end to end. Now, with this understanding, let's go and understand the next thing that we want to discuss. So I'll go to my diagrams, and the next thing that I want to discuss is reusable workflow inputs used to pass values from a calling workflow to a reusable workflow using workflow call. So there are two workflows that we are talking about. Previously, the inputs were provided by the user. Varun provided the inputs, and based on the inputs that Varun provided, the workflow ran. Correct? Here we are saying it is the calling workflow that will already have the inputs defined, and based on those inputs, the workflow will run. So there are two main things that we are talking about here. There is a reusable workflow, and then there is a calling workflow. I want to contrast this with Jenkins. So if you have worked with Jenkins, what you did, if there were certain common steps that were to be performed by, let's say, in 15 of your microservices, then what you would do, you would keep those steps in a centralized shared library, and the pipelines for those 15 microservices will refer to that shared library whenever they want to run those common steps. Similarly, you have reusable workflow inputs in GitHub Actions. So, whatever commonalities are there in your microservices, you centralize them in the reusable workflow, and then you call that reusable workflow from a calling workflow. It's just that you have two workflows. One is the reusable workflow, and as the name implies, which can be reused multiple times, is called a reusable workflow. Calling workflow is the one that calls any of the reusable workflows. As simple as that. Now, let's discuss a little deeper. So, if you see here, we have on. So understand, here we have two workflow YAMLs. One is this workflow YAML, and you see this weird L shape, and we'll discuss that. So this is part of a single reusable workflow, and then you have a calling workflow here. And if something is a little hazy, I'm pretty certain that you will understand that part in the demo section. So for now, reusable workflow, we have defined workflow call. Previously, we were using workflow dispatch because it was the DevOps engineer or developer who was providing the inputs. Here, the inputs are pre-populated in the calling workflow, and based on whatever you have defined in the calling workflow, the reusable workflow steps will get executed, and more on this as we progress. Here on is workflow call. Inputs, we are defining three. And why this is workflow call? Because this is the syntax. So you use the workflow call, and the name is pretty obvious, right? You are calling a workflow from a different workflow. And then you have a reusable workflow. So inputs, application name, we are giving three inputs: application name, run security scans, and replicas. And let me also give you a use case. I forgot that. So let's say you are dealing with 50 microservices, okay, and an application that contains 50 microservices, and all these 50 microservices could have their own repositories, correct? And all those repositories can be part of a single organization. That is how it works. So in GitHub, you have a GitHub organization, and then that organization can have multiple repositories. It could have multiple repositories for multiple applications. Here we are taking an example of only one application. Let's call it app1, and app1 has 50 repositories. And when app1 has 50 repositories, since all those repositories are depicting microservices that are associated with application 1, then most of those microservices will have common steps, because these conditions, for example, if you want to perform security scans, if you want to perform naming, these are decided per application. And one application, all the microservices of that application will have similar steps, if not same. Of course, there will be certain steps or certain jobs that will be doing something new, but at large, they will have a lot of common jobs or steps. In that scenario, you would have to maintain 50 different workflows, and all those 50 workflows will have same logic that you are repeating multiple times. And if you have to change something, God forbid, go to those 50 workflows and perform those changes. You don't want that. What you want is, I want to deal with 50 workflows. That's okay. I will deal with them. But what I want is something that will only contain all the common steps. So 50 workflows will shrink considerably, because whatever the common steps were in those 50 workflows are taken out and sent to something called reusable workflow. How good is that, right? So that is where reusable workflow inputs or reusable workflows come into play. Passing application name, replica count, security scan settings to a centralized deployment workflow, maybe AWS region, cost center number, all of these will be same for microservices that constitute an application. And like I said before, all of these microservices may have their own repositories, and do not quote me on that, because maybe you have a single repository for your application, and then different microservices have their own directory within a single repository. That design is also there. But when I talk about enterprise grade applications, enterprise microservices, they will typically have their own repositories, because each microservice is managed by different teams. Even if the teams are same, the development life cycle, the release life cycle of each microservice could be different, which is why it is recommended you have segregated the microservices into different repositories. Okay, I diverged for a little while, so let's come back here. So inputs, we are saying you have three inputs. Application name, it is required, and that is of type string, so you type that. Then you have run security scans, required is true and type is boolean, so it's either true or it is false. Then you have replicas, required is true and type is number. Okay, I have defined that these are my inputs. Then in the calling workflow, see how good is this? I have a job called deploy job. It's just called deploy here. And then you have uses. Uses is, we have used this somewhere, right? When we had to call an action, we use uses, correct? So here as well, we have uses, and here we are saying go to this place and then refer deploy.yaml. So this is called deploy.yaml, and in deploy.yaml with you fill these numbers. So for payment microservice, the application name is payment service, run security scan is true, and replicas is 5. Maybe I have another order service. Order service also sees heavy usage, so maybe I also want the replica count to be 5 here. Then maybe I have a wishlist microservice. Wishlist microservice does not need 5 replicas. Let's say we only need 2 replicas there. So you can change all of these based on your requirement. But Varun, what are the jobs and the steps that will be performed as part of this? You define it here itself. Because what I told you, it's not just about inputs, it's also about what to do with those inputs. That is also defined in the reusable workflow. That is why I was saying you take out the commonalities from all of those 50 repositories, all of those 50 workflows, and put them into reusable workflow. So here it's pretty simple. I did not want to bombard you with actual production logic here, which is why the things are still logical, but we are just echoing something. So we are display deployment information, we are displaying this, and then we are just echoing deploying application. Pretty simple here, but in the demo we'll take it a notch above. So we understand what is this. So let's go to the demo. So I will, what first I want to do is I want to first clean whatever we have here. Although not cleaning everything will also do, because we don't need this thing here. This one is not needed, but we won't be using our application code for this, so this can also remain here, it won't hurt us. But what I will do is I'll write new file here, and what we are creating first is the reusable deployment workflow, and I'll just call this deploy.yaml, right? I'll press enter, and then let me just copy paste that. See, I deliberately do not type here because I don't want to waste time. My lectures are already so long. Okay, so here name is reusable deployment workflow. Pretty simple, right? And we could also add 01 here to make it more, reader friendly. Then I have on, and then workflow call. Like I said, reusable workflow will have workflow call. Inputs 3, application name, required it should be a string. Run security scans, required it should be a boolean. Replicas, it should be a number. Jobs, first job is deploy application job. It runs on Ubuntu. And then if I scroll down, we are saying name display deployment parameters. We are just displaying whatever the inputs will be. And where will be the inputs? Inputs will be in the calling workflow, my dear friends. And then you have security validation. We are saying inputs run security scan. So this will run based on what our calling workflow will define for run security scans. Then you run security scans. And then you have deploy application. So here we are just saying deploying this, and desired replica is this. Very simple, like we have seen before. Inputs.application name will give you this. Inputs.run security scan will give you whatever value was supplied here. So this is how you use it. And then finally we are saying deployment complete. Now I want to show you something else which will connect all the dots if something is still pending. So I'll click on new file, and this time I will call my file, let's call this payment service deploy.yaml. Now what we are creating is this. We created was a reusable workflow. Now I want to create the calling workflow. So what I'll do is I'll come here and I'll copy this and I'll paste it here. And then I want to compare these side by side so that you have that perfect understanding. Okay, so I'll right click here, split right. This is yeah, this is how you do it. So let's first understand this, then we'll compare these. This is the calling workflow. Okay, what I'll do is I'll also write 0 1 here, and here I'll also add calling so that you pretty much clearly understand that here we already have reusable. So we have calling here for consistency. Okay, let me just add calling here. I'll remove this, and we are saying you run this workflow. I want you to clearly know, my dear friends, very clearly. Okay, workflow call, this keyword was there in reusable deployment, in reusable workflow. In the calling workflow, I want to just define when do I want to run this workflow, and this workflow I'm saying you can run this manually, workflow dispatch, and this also runs on push. So do not just think that you can only manually run this. You can also run these calling workflows based on a push or a pull request and so on. So whatever we have studied thus far. Now see the important part. That is what I was telling you. Certain parts are not common for all microservices. In this, running unit tests and build payment artifact job was not part of all the microservices that would be using this workflow, this reusable workflow. Hence, whatever is specific to my payment service, I'm still defining those jobs in my payment service workflow. But all the common steps I'm defining here. So the deployment related step, when it comes to deploying the application, that I have taken out from here. So let's understand what we are doing. And this is extremely important because I'm also using needs here. Okay. So jobs, I'm saying run your unit tests, run on Ubuntu latest. Steps is execute unit steps. These are just echo statements. Okay. And then the second job is build payment artifact. Now understand, when I talk about build payment artifacts, all microservices can have their own type of artifact, and maybe those steps are not common. Hence, this workflow has this step, runs on Ubuntu latest. This is fine. This is job 1, this is job 2, and this job runs on Ubuntu latest, and this also runs on Ubuntu latest. But this job needs the unit tests job to complete before this job can start. Understand, in GitHub Actions by default, all the jobs run in parallel until and unless you use something like needs, which defines the sequence. And needs here is a list. You can supply multiple jobs here. For example, to run this job 1 should succeed and job 2 should also succeed. So you can come here, define another job name here. So keep this thing in mind. So here I'm saying step build payment artifact, build payment service artifacts, artifact generated success. These are just echo statements for now. And then is the interesting piece. Deploy payment service job needs this job. So you see the hierarchy that we have created. First, this job will run. Okay. Only after this job is complete, this job will be started. And only after this job is done, then this job will start, because we have defined needs here. Uses, this is the interesting part now, uses GitHub workflows deploy.yaml. And where is deploy.yaml? Here is deploy.yaml. And here I have supplied the inputs. In the with block, I have said the payment service name is required. Hence, I have said payment service. Run security scans is true. And replicas are 5. And based on whatever I have provided here, all of these steps will be executed at the very last. So let's go and push this. So I'll go to the terminal. I'll have to use force push because my repository already has some work. So what I will do is first I will do rm-rf.git. I don't want previous history now. I'll run git init again, and then I will run git add dot to move everything to the staging area. Then I will write git remote add origin, and then I'll go to my repository again, and here I'll go here, and then code, I will go to SSH and copy this, and then I will paste it here. I'll press enter, and then what I will do is git push -u origin main, and if I do this, I'll receive an error. Main does not have any error field. Git remote add origin. Hold on. Oh, I have not performed the commit. I'm so sorry. Git commit -m, and then I will write feature add reusable workflow inputs demo. I'll press enter. Okay, and now the push should work. And this will not be able to push because our repository has some other work. So what I'll do is I'll add a force flag here, and then I will push it. The push is done. So I'll go to my repository, and then I'll hit refresh, and our workflow is getting executed. And why is it getting executed, my friends? Because in the calling workflow, I have push as well. So it's not difficult to understand. We are just creating workflows that we have thus far. It's just that now we also have a centralized workflow, a reusable workflow, so to speak. So I go here, and then I go to actions. And these are from our previous runs, so you can ignore these. But this is the one that we just created. You see, calling, reusable, both are listed here. If I go to reusable, you don't see any workflow runs because this is a template. This is a centralized workflow. This is a reusable workflow. So in itself, it will not be running, but the workflows that are supposed to run will be referring this reusable workflow. Now you see this here because we ran this workflow on the push. So if I go here, you see how aligned the jobs are. So first this ran, then this ran, then this ran. We had 3 jobs. Run unit test, we were echoing some statements, and if you expand this, you will see those statements, whatever we said. And then we go to build payment artifact job. you see whatever we echoed. And if I go here, this is the interesting one. So if I go here, payment service, true, 5 replicas, security validation, because we selected. If I go here, we said true here. That's why security scans also ran. Deploy application, desired replica 5, deployment complete. So this is the final step. Deploy payment service job. And I want you to understand that when this job was ran, then all these steps were executed. So if you see here, deploy payment service job, deploy payment service job has a sub job, so to speak, and that sub job is this one, the reusable workflow one. And then whatever steps we just saw, they are part of this job, right? Display deployment parameter, security validation, display deployment parameter, security validation, deploy application, deploy complete, deploy application, deployment complete. So all of these are here. I hope your dots are connected. Now that we understand this, let's discuss the third part theoretically. So I'll go to my diagrams. I will scroll up, and this one is pretty simple. So whatever we have seen thus far is, we have used workflow inputs, we have used reusable workflow inputs, which are defined within the workflow somehow. So if you talk about these inputs, these are defined in the workflow, and then user calls them. Here as well, inputs are defined within the workflow. So in both of these, you are defining the inputs in the workflow. But when I talk about action inputs, here you define your inputs in the custom action that you create. And then whatever values are for those inputs, you define them in the workflow using it. So for example, here the custom action is inputs image name required is true. So within the workflow, you would be telling uses, because uses is the keyword to call an action. We are using this action. Company is, let's say we are the company. It could be Cloud with Varjosh. It could be any company based on where you work or whatever your application architect has decided. And then you have Docker scan action at the rate version 1, because this is the custom action that you have. And then with, we are saying image name is payment service v1. So this is just a very small example, but as we learn about custom action, we will know more about this. Used to pass values from a workflow to a custom action. So here is a workflow, and we are supplying the value for custom action, and maybe custom action based on this will be performing certain security scans. So examples are providing an image name, Slack channel, or Terraform workspace to control action behavior. I would recommend you to go and also read about this in the repository. The next thing, I personally do not like demoing something that I haven't covered yet, because I have not covered custom actions. That is why I'm not demoing this. But once we learn custom actions, I assure you we will see action inputs in action. So that is everything I wanted to discuss. So that concludes this lecture. In this lecture, we learned how inputs allow workflows, reusable workflows, and actions to receive values at runtime and dynamically adjust their behaviors. Through the demos, we built an environment-aware CI pipeline using workflow inputs and implemented a centralized deployment model using reusable workflow inputs. In the next lecture, we will explore outputs and learn how information can be passed between steps, jobs, and reusable workflows in GitHub Actions. If you have any questions, feel free to ask them in the comment section and I will reply. If this helps, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 7 of GitHub Actions Basics to Production course. In this lecture, we will explore outputs, one of the most important concepts for sharing information across different parts of GitHub Actions workflow. We will start by understanding why outputs are needed, what they are, and how they help workflows expose runtime generated information instead of repeatedly generating the same values throughout a pipeline. After this, we will explore different types of outputs supported by GitHub Actions, including step outputs, job outputs, and reusable workflow outputs, while understanding the execution boundaries that each output type is designed to cross. Finally, through our hands-on demos, we will learn how deployment information can be shared between steps using step outputs, between jobs using job outputs, and between workflows using reusable workflow outputs. So let's get started. Outputs. First, let's read the definition and then we will understand the why and what. Outputs are values generated during workflow execution and shared across steps if I talk about step outputs, jobs if I talk about job outputs, reusable workflows or calling workflows if I talk about reusable workflow outputs. But first, let's understand, why do we need to share something that is generated in one step with another step, or something that is generated as part of a job with the next job, or any job for that matter? And also, why would you want to share something across workflows? Now, see, let's say you have a step that is performing security scan. Maybe the next step wants to consume that result. For example, if my Sonar Cube scan did 70% of coverage, then maybe the next step or the job wants to have those results so that it can decide what to do with that. Another thing could be, maybe I have an artifact name or artifact location generated. That location could be your S3 bucket, that location could be your Nexus or JFrog repository or anything of that sort. Maybe the next job, next step, or maybe a calling workflow requires that information. So how do you send those informations to the subsequent step, job, or a calling workflow? For that, my friends, we have outputs in place, and I just gave you two examples: security scan results, artifact name or artifact location. But there are many things. Maybe you want to share cloud resource information. It could be a load balancer DNS name, Kubernetes ingress URLs, API gateway endpoints, or infrastructure identifiers. Your next step, your next job, or your calling workflow may need that information. And that is what outputs do for you. They will allow you to share that information between steps, between jobs, or between workflows. As simple as that. I also want to talk about one more thing here. Now, when you are sharing the information that is generated as part of a step, as part of a job, or as part of a reusable workflow, this improves consistency, maintainability, reusability, and even traceability, because every job or the step or the calling workflow operates on the exact same information. You do not have to generate something that you have already generated somewhere again. And that is what outputs will do for you. And that is how they help you maintain consistency, maintainability, reusability, and traceability. Now, If you have watched the previous lecture, which I highly recommend because I want you to follow the course in sequence, we had inputs there. And inputs and outputs are closely related concepts, because if I talk about inputs, what inputs were doing for you? Inputs were bringing data into the workflow, while outputs expose data generated by a step with another step, or a job, or a reusable workflow. So I hope you understand that inputs and outputs are different entities, and it is not you use one or another. In most production workflows, you will use both of these in conjunction to define the software life cycle of your application. There are a couple of other things that I want to highlight before we discuss the types of outputs. Now, I want you to understand that when you think about outputs, think about values and metadata. And that value, like I said, it could be the scan result. That value could be a release version, could be application version, or it could be any infrastructure detail. But I am not saying that you would use outputs to share files or artifacts. Now, what is an artifact? Now, artifact could be anything that gets generated during the software delivery lifecycle. So it includes application binaries, container images, deployment manifests, test reports, security scan reports, coverage reports, log files, and so on. So when you want to share the artifact between steps or jobs or workflows, then you would use a different GitHub Actions feature that is called artifact. But when you want to share certain values or metadata, then you would use output. So understanding this distinction is important, because in the next lecture we'll be discussing artifact. So clear mental model: outputs are used to share values and metadata, artifacts are used to share files and deliverables. And another thing I want to highlight here is, this is the last thing before I talk about different types of outputs, that is, if you have worked with Terraform, Terraform also has outputs. Now, what outputs would do is, maybe you are spitting out the instance IDs or the load balancer DNS name as part of your Terraform outputs, and these outputs in Terraform were consumed by you humans, by us humans, or by automation workflows, external systems. For example, maybe you are spitting out instance IDs as part of your Terraform outputs, and those outputs are consumed by your Ansible playbook, and that playbook is running configuration management onto the instance IDs that were received from the Terraform output. So Terraform outputs were used in that regard. And if I contrast this with GitHub Actions outputs, they are similar, if not same. Here, what we are saying is, whatever is outputted, it could be your instance IDs, it could be your application release version, and so on, that can be consumed by a step or a job or a workflow, and even external systems. So for example, if you are outputting certain things into your workflow logs, there could be an automation system based on your specific requirement that could be using that output that is seen in your workflow logs to perform certain actions. So keep that thing in mind. And I don't want my students to have blinders so that they only see what I show them in the video. It should not be like that. I want you to broaden your imagination and think about possibilities whenever you are learning a topic. Now, with that thorough understanding of what outputs exactly are, let's focus on the different types of output. So there are three types of outputs, and what I want to do in this lecture is, we will do this the inputs lecture style. We will first discuss step outputs, then we'll go to the demo, then job outputs, then go to the demo, then reusable workflow outputs, then we'll go to the demo. But I still want you to have a sky level understanding of all of these three. For example, if I talk about step outputs used to pass values from one step to another step within the same job, because these are step outputs. Job outputs used to pass values from one job to another job within the same workflow. Reusable workflow outputs used to return values from a reusable workflow back to the calling workflow. And we understand the concept of reusable workflows, and I will zoom into this a little bit when we discuss this type in detail. So now let's understand what step outputs are. So I'll zoom in a little here. Step outputs used to pass values from one step to another step within the same job. And this is self-explanatory. If I talk about step outputs, if something is generated in step 1, and I want to share that something with step 2, step 3, or step n within the same job, then I would use step outputs. As simple as that. Is no rocket science. Job outputs, if I have something that I have generated as part of a step in job 1, and I want to share that something with job 2, job 3, job 4, or job n, then I would use job outputs. It's extremely simple concept. Example, a deployment step generates a deployment URL that subsequent steps use for notifications or reporting. So for example, let's say I have generated a deployment URL for my application, and what I want is, in the next step, I want to notify via email or via text message or via anything. It could be Slack, it could be Teams notification. I want to notify my team that the application has been deployed, and if you want to access the URL for that application, here is the URL. So hit it and access that application. And like I said, I want you to broaden your imagination. It is not just limited to notification. For example, you have created a deployment URL in one step. Maybe in second step, you want to perform smoke testing. So in smoke testing, you will say that the URL for this application can be accessed from the previous step. So this is powerful in that regard. Now, I have a small snippet here because I believe when you have YAML in front of you of whatever concept you are discussing, it just creates that better mental picture. So let's discuss what is happening here. First, we have jobs. Of course, the first job, I'm calling it release job. I only have one job in this example. Then I have steps. The name is of step 1, generate release version. And again, I want to bring another thing into your mind, that it is not required to name your step. This is optional, but you all know I recommend always have this name here so that anyone or you understands what this step was designed to do. So first step is generate release version, and then I have ID version. What is this ID? I want you to know, if I want a subsequent step to have information given by this step, then how do I identify that step? Because my workflow, my job can have 10 steps. How do I know if step 10 wants to use information that was outputted by step 1, 2, 3, 4, 5, or 6? I don't know that. Hence, what you do is you give identification, that is ID, to your steps, so that if next step or any step wants to use that information, they can simply refer that I want to use the information that was outputted by step that had an ID version. And this becomes extremely critical when you have 5, 6 steps, and in those 5, 6 steps, maybe step 7 wants to use output from step 1, 2, 3, and 4. How does that step identify the output of a specific step, and that is where this id becomes so powerful. So here I have id version, then I'm simply running a command. I'm saying echo release version is version 1.0.1, and I am sending this into a file called github_output. Now let's discuss that. So I'll take you to my GitHub repository here, and this concept you have already seen. So I'll zoom in a little here, and then I will go to GitHub Actions, Basics to Production. And if you have not already started this repository, please do, because I see there are close to 500, 700 unique visitors every 14 days, but the stars are not depicting that picture. So if this is useful to you, I request you to please star this repository. So what I'll do is I'll take you to 05 functions, and then here I will search for github_env. And what we discussed here in lecture 5 was, when you want something to be stored as environment variable into some file, then you can use github_environment. So this file is essentially used to store environment variables. Now I want you to contrast this with what we are studying right now. So if I talk about github_output file, this file is used to store outputs. So github_env is used to store environment variables that can be used later by your steps. Here we are using github_output file to store our outputs so that the subsequent step or steps can consume that information by referring to this file. As simple as that. And if I talk about this file will typically have key value pairs like we have right now. Release_version is the output key, or the output name you can say, and then the value for that, the output value is version 1.0.1. so this is getting stored in github_output file. One more thing I want you to understand, that you would typically be storing key value pairs in this github_output file, but do not limit your imagination. You can also have multi-line values inside this file. Now I would let you explore that further, but do not think that this file is just limited to storing key value pairs. You can also have multi-line values. So here we are saying echo this, and we are storing this information in this file. This is fine, but how do I use this information that is stored in my github_output in my subsequent steps? So here I am saying there is a step that will just display the release version, and I am asking this step that if you want to display the release version, then release version I have already outputted in a previous step, so you can use that from there. So here I'm saying run echo, and this is plain interpolation. So I'm saying echo, and this is the syntax, and then I'm saying go to steps. Steps is here, then go to version. Why version, Varun? Because that is the ID of the step I want to refer to. And I also want you to notice that a step that is not outputting anything, you don't have to have an ID for that step. So any step that is outputting something like this step will have an ID, but the step that is using that ID need not to have that ID defined, or any ID defined for that matter. So again, I want you to know that if there are 3-4 more steps that are outputting something and some other step is using that output, the IDs of all those steps must be different. You cannot have 2 steps have the same ID, because then how do you refer to that step in a unique way? Then here I'm saying steps, go to then version is this step, then go to outputs. What are outputs? Which is stored in this file. And as this file can have multiple key value pairs and multi-line values, which is the key that you want to refer? I want to refer the key that has release underscore version. That is release underscore version. So this step will result in v1.0.1. Now let's go to the demo and see what I have in store for you. This is going to be exciting. So I'll go to Visual Studio Code. Here I will expand outputs, I'll expand project files. Then I already have all the YAMLs that we are going to use in this lecture. So what I will do is I'll go to 01 step outputs demo.yaml. So I'll go here, I will explain you what we are doing here, and then we will push this. So what I'm saying is the name of this workflow is 01 step outputs demo. Give an identifiable name to your workflows, because this will be your source of truths that you would see in the UI, not the file names. You will see what name you have defined for your workflow. And I am saying, when will this workflow trigger? This workflow will be triggered when the workflow underscore dispatch API will be hit, and we will be hitting this API using the console, using the GitHub UI. But we already know that this API can be called via the GitHub CLI or using generic curl commands or post commands. Then you have jobs. So we only have one job here, and that is the deployment job. And this job runs on a runner that is based on the latest Ubuntu image. Steps, what we are saying is, the first step is called deploy application, and the ID for that step is deploy. Then we are saying echo, we are just echoing deploying application. Then we are sleeping for 3 seconds so that we allow enough time for application to initialize and start properly. Again, this demo is just having echo steps because I want you to learn how to walk before I teach you how to run. And of course, sprint. So we have echo. I'm saying deployment underscore URL is https cloudwithvarjoshdemo.com, and I am adding this information into this file. And why I am doing so? Because subsequent step or steps could be using this information when they refer to this step using the ID block we already have. So next step's name is display deployment details. Here I'm saying run these steps, echo application deployed successfully, echo deployment URL. And what is the deployment URL, my friend? So I want you to conceptualize this like this. Okay, there could be a Kubernetes deployment that is done, and then you are generating some sort of URL for your application to be accessed. It could be a load balancer URL, the DNS name, or it could be an actual application URL that you are spitting out. Here I'm just using echo statements, but I hope you are able to connect the dots. And this step here, I'm just displaying the deployment details. You could also be performing smoke tests onto that URL. So it depends on your use case. Like I said before, broaden your imagination. Here I'm saying go to steps. Where is steps? This is steps. Then go to deploy. Okay, this is the step that has that deploy ID. Then go to outputs. Okay, I have this file that has the outputs. And then I want you to search for deployment underscore URL. And deployment underscore URL is an output key here whose value is this. So when this workflow runs, it will display this URL here in the second step. And then the third step, I'm also sending a notification. So let's say you're displaying the information first, and then you are sending notification to your colleagues, and you are saying the application URL is steps. Again, the same interpolation is used in this step. So what I will do is, I have 3 workflows. I have 4 files in total, because there is the third use case, the third type, so to speak, has that calling and reusable workflow thing, and we'll discuss that later. So what I will do in this is I'll push all of these files so that we don't have to push again and again. So what I'll do is I'll come here to my CLI, and we are already in 07 outputs project file. So what I'll do is I'll first initialize this, and then I will run git add dot so that I move all the files to the staging area. Then I write git commit -m, and then let's say demo, pushing all files at once for simplicity or ease of work, right? And then I press enter. But I also have to add my remote so that I can push properly. So what I will write is git remote add origin, and then I'll go to my browser. I already have a repository created, cwvjgha practice. I'll just copy the SSH path here, SSH link here, so to say. I'll paste it here. I'll press enter. The authentication must be in place. If you don't know how to do that, go back to lecture 1 where we discussed thoroughly how to have authentication in place so that you can push the local contents onto your remote. So I'll write here git push. I don't have to write -u here because we'll be only pushing once, so there's no need to define local to remote tracking. I'll write origin and main. I'll press enter. And if your branch is not named main, then you must rename your branch to main first. That would make it simpler. And then what I'll do is I'll go to my browser here and I'll refresh this. This should have dot. Okay, I have the workflows here. If I go here, I can see all the workflows. Since we have not defined our workflows to run on a push event, none of the workflows were triggered. So if I go to actions, I'll see a blank slate, but our workflows are getting detected because we already know that GitHub Actions will take action onto any of the files that are available in .github/workflows, and the type is .yaml. So all the YAML files will be taken into consideration by GitHub Actions. So let's go to 01 step outputs demo. This is what we discussed, and like we know, we have this here. So I'll click on run workflow. And what I want you to observe is, if I go back to Visual Studio Code, I want you to observe that first step will just add the URL into this file, and then the second and the third step will be displaying whatever was outputted in step 1, that is deploy application step. So let's go there in the browser. Okay, the job has completed successfully, the deployment job, because it is named deployment job. I'll come here, I'll go here, and here are all the steps. Deploy application, display deployment details. So let's expand this. I won't see the URL here. Of course, if I expand this, I'll see what were the commands that were run as part of this step. But if I expand display deployment details, I'll also zoom in a little, I think. And then deployment URL is this. So the output that was received from step 1 is used in step 2 and also in step 3. Of course, in typical production environments, you would have the logic here, which will be sending the notifications to your email addresses, to your Teams or Slack channels, and so on. I hope you get the picture. So let's go back to the theory now and see what is the next type that I want to discuss. So let's talk about job outputs. Used to pass values from one job to another job within the same workflow. We already understand this. Step outputs were used to share information within the same job. So steps within the same job. Here we are sharing information or the output across jobs. So here we have two jobs. There is a deploy job and then there is a notify job. Again, I want you to understand what you want to use depends on you. So for example, I could have generated a deployment URL that we did in the demo, and then we outputted the URL, and then that output was used by the second step. But here I'm saying your use case could be you are generating the URL as part of job 1, and then you are using that output of job 1 of the step in job 1 in job 3. So the same use case, the deployment URL step generates a deployment URL, a deployment job generates a deployment URL. So like I told you, take off your blinders. Imagine how your actual application would behave. You could be using the deployment URL in the subsequent steps, or you could be using the deployment URL in subsequent jobs. If you are using that URL in subsequent jobs, then you would use job outputs. If you want to use that URL in subsequent steps, then you would be using step outputs. Also, if you want to use them in both steps and jobs, then you will be using a combination of step and job outputs. As simple as that. Then let's come back here. Deploy job. We have steps here. Name of the first step is deploy application, and this is pretty much same like we saw here, but there is a small change. So you have deployment URL, and then you have an outputs block. Outputs block was not here. Here we have an outputs block. Why is the outputs block here? I want you to first see the indentation. You have steps and you have this step 1 here, but this output is not inside the steps block. It is parallel to that. So outputs block is defined at the job boundary. Why so? Because you want to access something across jobs. Understand, if this was just this, then you would only be able to access the contents of this file in the subsequent steps. But what I want to do is, I want to access this outside this job. So if I have to summarize, by default, step outputs are only accessible to other steps within the same job. To make the value available outside the step, GitHub Actions require it to be explicitly exposed using the outputs block, and this will become extremely critical when we move to the next type, that is reusable. And then here I have the notification job. So first let's discuss this. What we are saying outputs is, we have a deployment URL. For the deployment URL, you go to steps, then you have deploy as the ID, then you go to outputs, this file, and then you go to deployment URL. But here we are bringing it out so that the subsequent jobs can access it. Notify job, again, it has a needs keyword. And why do we have the needs keyword? Understand that all the jobs, they run in parallel by default. If both of these jobs run in parallel, then this job will definitely fail, because maybe this job will not finish. And then how will this job use the output generated by this job? So what I want is, this notify job needs the deploy job to trigger. So first this job will run. Once this job completes, only then notify job will run. And notify job, because it needs the deploy job, then steps in it is name, send a notification, run, we are echoing. And let's talk about interpolation. So needs is here, it needs the deploy job, and then you go to outputs dot deployment underscore URL. And why, how does it know it has to go to this job? Because this job is dependent on the deploy job, hence it knows it has to refer the outputs that are defined in the deploy job, and that's why we have dot deploy URL. So this could be generating hundreds of output here, but we are only concerned about the output key deployment URL, and hence this will display the deployment URL. And we know what is the deployment URL, because here this is getting resolved from here. So I hope the dots are getting connected. Another thing I want to highlight here, what I have done is, if you see this outputs block, I have kept deployment underscore URL and deployment underscore URL same, and they need not to be same. I could be using a different name here because this value is accessed by just this block via interpolation. I have steps deploy output deployment URL, but this could be anything. I could be calling this endpoint URL as well. They do not have to match, but I would recommend you to match these because it is convenient and it is simple, right? And then if, for example, we were calling this endpoint underscore URL, then of course here you would be calling underscore, you would be calling endpoint underscore URL. I hope this makes sense. So let's go to our Visual Studio Code, and then I'll close this one and I'll open the second one. Here again, we are calling the 02 job outputs demo. On is workflow dispatch. Jobs, here we have the deploy job, which runs on Ubuntu latest. Steps, the first step is name is deploy application. The ID of that step is deploy. Then we are saying echo deploying application sleep 3. And then we are sending this key value pair into our output file, that is GitHub underscore output. And then in the outputs block, which is defined within the job itself, within the deploy job itself, but outside of the steps block, and this is critical to understand. So outputs block is here. You are still, again, I want you to clearly know this, okay, because this gets confusing for people. You are still defining something in the step itself, because the file, that is GitHub underscore output, has the key value pair that we want to use. It's just that outputs block is outside of the steps block. So outputs deployment URL steps.deploy.outputs.deployment URL. So steps deploy is the ID, outputs is this file, deployment underscore URL is this one, the output key. And if I come down, then it is the notification job that runs on Ubuntu latest. Then you have needs. This needs the deploy job. So only after this completes, this will trigger. And then you have steps. The name of the step is send notification. We are running echo commands, sending notification, application URL. And this is the beauty. This is how you access it. Needs deploy job. Outputs is here. The block is defined here. And in the outputs block, I want to access deployment underscore URL. Again, this name should be what is defined in the outputs block. So you have it here, and then you are sending the notification. So it's notification sent successfully. I hope you understand this point. So if I go to my browser, and then we go one step back, and we go to 02 job outputs demo, and I want you to understand one more thing, okay, and that is applicable here as well. So we all know that steps within the job, they run sequentially. So first step 1, then step 2, then step 3, in the order that you have defined. So I want you to know that if you are generating an output in step 2, you cannot consume that output in step 1, of course, because step 1 would run before step 2. So I hope that is understandable. So I'll go here again. Sorry, I'll go to the browser, and then I'm in the 02 job outputs demo. I'll run this workflow. I'll click here, and you see deploy job runs first, and this is the hierarchy that GitHub Actions UI shows you. So you have this deploy job runs first, only then once this completed, only then this started. So if needs keyword was not defined, then they would run in parallel. We already understand that. So if I go to deploy job, you see deploy the application. In this step, this URL is added to this file GitHub underscore output, and then notification job. If I go here, you would see the actual URL here. Application URL is this. I hope this is understood. So now let's do one thing. Let's go back to the diagrams, and understand the third output type. Reusable workflow outputs used to return values from a reusable workflow back to the calling workflow. I want you to clearly understand one thing. What is a reusable workflow? Reusable workflow is a workflow where you put in all the commonalities from your different workflows so that you don't have to define those steps or jobs repeatedly in your workflows. That is why you have a concept of reusable workflow. And if you don't understand this, I would request you to go and watch the inputs lecture. There we discussed this in detail. So understand, your reusable workflows are defining all the common jobs, and if they are defining all the common jobs, then those jobs or steps can also have certain outputs. How do you consume those outputs? And that is what reusable workflow output will do for you. So anything that is outputted by your reusable workflow can be consumed by calling workflow using something called reusable workflow output. So let's discuss this. So this is the reusable workflow here at the top, and at the bottom you see the calling workflow. So reusable workflow, we are saying on workflow call, and this is the syntax for reusable workflow. And then before discussing this, let's first discuss this. So what we are saying, jobs, the first is the deploy job. Only one job is defined here, runs on Ubuntu latest. Steps, name is deploy application, ID is deploy. Run, we are using the same thing. See, we have been using the same example in demo 1, in demo 2, and also in demo 3. The reason for that is I want you to broaden your imagination. The same thing can be shared between steps, across jobs, or across workflows. So think like that. This is also clear, and this we also understand. So we have this so that this output can work across jobs. But here our need is not across jobs. Our need is to use it across the workflow. So where should I define another output block? I have to define it in the workflow call itself. So understand, how will another workflow access this output block? Because this outputs block is defined within a job. For a workflow to access the outputs from another workflow, it must be defined in the outputs block separately at the top level in the workflow call itself, within the workflow call block. And that is exactly what we are doing here. So let's see the interpolation work here. This is fine, we are sending this to GitHub output, and then deployment URL is, again, this could differ like I said before. Steps, deploy, outputs, deployment underscore URL is the output key, which is this. So the value for this is this, we know this. And here what I am saying, the deployment URL's value is go to jobs. Okay, I went to jobs, then go to deploy job. Okay, I am in deploy job. Then go to outputs. Okay, I am in outputs. Then output the deployment underscore URL, whose value will be, of course, this one. And then let's see the magic that is happening in the calling workflow. So the calling workflow has two jobs. First job is deploy job, and deploy job is just saying uses, and we all know that uses is the keyword that is used to use actions, or it can be used to access your reusable workflow. So here I'm saying this deploy jobs job uses whatever is defined in .github workflows deploy.yaml. I want you to know that this reusable workflow must be named deploy.yml for this setup to work properly. Okay, and then you have a notify job. And what notify job is doing, it needs the deploy job. So first this job must complete, then this runs on Ubuntu latest. And here you see I've not named this step, just to show you that you can have steps that don't have a name, but I would recommend you to have names. Run echo Needs, okay. Deploy job, okay. Outputs, okay. Deployment underscore URL, okay. So this gets populated. I hope it is understood. So let's go to the demo. So I'll come to my browser, and then here I have the centralized deployment workflow. So first let's discuss this. I'll go to Visual Studio Code, and then I'm calling this deploy application.yaml. So centralized deployment workflow, this we have already understood. This is pretty much the same that we saw in the image there in the diagram. So I won't be discussing this in detail. What I'll do is I will, hold on, I should have opened these together. Then I'll go here, and then I will split this to right, and then I will do this. So let's discuss the reusable workflow. So here I'm saying that this reusable workflow will trigger on workflow dispatch like we saw before. Jobs, deploy job, uses deploy application.yaml. This one, sorry, this one, right? Deploy application.yaml, and then notification job runs on Ubuntu, needs deploy job, step send notification, run echo sending. This is fine. Needs dot deploy job dot outputs dot deployment URL, and we all know where this deployment URL is. This deployment URL was generated as part of this step, then shared outside, then shared further outside at workflow level as well. So let's go to our browser and run this. I will click on run workflow. I will run workflow, and you see deploy job first gets executed because this notification job needs this job to complete, and this deploy job has a sub deploy job, and sub deploy job is this job. So this job is dependent on this, and here we have already defined this. Only one job is here, deploy job. That is why we only see deploy job here. So if this had multiple jobs, you would see multiple jobs. And if you don't understand this, I would request you to go back and watch the inputs lecture. So I'll come here, deploy job has done its job. If I go to notification job, you would see that the URL is printed here, https cloudwithvarjosh-demo.com. So I hope all of this makes sense to you. With this, I would want to end this lecture. So in this lecture, we learned how outputs allow information to be shared across different parts of a GitHub Actions workflow. We explored step outputs, job outputs, and reusable workflow outputs while understanding how each type helps information cross a different execution boundary. Through the demos, we learned how deployment information can be shared between steps, between jobs, and between workflows. In the next lecture, we will explore artifacts and learn how files, reports, binaries, logs, and other deliverables can be shared across GitHub Actions workflows. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 8 of GitHub Actions Basics to Production course. In this lecture, we are going to explore two fundamental GitHub Actions capabilities: artifacts and caching. So we will begin by understanding why artifacts are needed, what they are, and how they help preserve and share workflow generated files across different parts of a CI/CD pipeline. After that, through our hands-on demo, we will learn how files can be shared across jobs using artifacts. Next, we will understand why caching is needed, what it is, and how it improves workflow performance by reusing dependencies and other frequently used files instead of downloading or generating them during every workflow execution. Finally, through our hands-on demo, we will learn how dependency caching significantly reduces workflow execution time. So let's get started. Why and what of artifacts? Now, firstly, let's understand what artifacts are in general. Forget GitHub Actions or any CI/CD tooling. Let's understand what artifacts are. So whenever you have a software delivery lifecycle, you generate certain files as part of that. Now, these files, anything that is generated during the application delivery lifecycle, is called an artifact. So if there is a build job that generates an application.jar, then that application.jar is an artifact. So if you are deploying onto Kubernetes and let's say you generate something called deployment.log, then that deployment.log becomes an artifact. So whatever files are generated by your CI/CD tooling during the software lifecycle process is an artifact. As simple as that. Now, with this understanding, let's understand why and what of artifacts. Outputs are used to share runtime metadata. I am bringing this up because I don't want you to get confused between outputs and artifacts. So outputs are used to share runtime metadata. Now that runtime metadata could be the release version, it could be a deployment URL, it could be resource identifiers, or it could be environment names and so on. So essentially, when we were talking about outputs, these were just text. So for example, release version is this is text. Deployment URL, this is text. But when I talk about artifacts, artifacts are used to preserve and share workflow generated files and directories created during a workflow run. Now, I want you to imagine a scenario that is given on the left. There is a build job that creates application.jar. Understand, now we already have application.jar. When this job completes, the runner gets destroyed, and when the runner is destroyed, anything that was there in the file system of the runner also vanishes. So when you run the deployment job and deployment job still needs application.jar, what you have to do is you have to regenerate your application.jar. Now, when you are performing the same thing in two different jobs, what are you doing here? You are wasting resources, and not just wasting resources, you are unnecessarily increasing the execution time of your workflow. And when you do that, firstly, you pay the extra money, and your delivery feedback also reduces. And why it reduces? Because you will know the result of the workflow run in a later time. So what you want is your workflow should be doing everything it is intended to do, be it security, be it file generation, or anything, in as little time as possible. So here we first generated the application.jar for the build job, and then in the deployment job, to deploy that application.jar somewhere, it could be Kubernetes, it could be Docker, or it could be a virtual machine as well, you are again generating that application.jar as deployment job. So we do not want to do that. Another example is, let's say you have a test job that generates coverage report.html. Now this is a file, and what I told you, if you have a test job that is generating some file, that is also an artifact. When the job completes, runner gets destroyed. what if the engineer wants to download that coverage report.html? How does that engineer download that report if the runner that had that report is destroyed? So we want some means via which we can share what was generated across jobs and across workflows, so machine to machine sharing. And then we also want our engineers to be able to download certain artifacts for review. So both the use cases, machine to machine sharing and human access, was a drawback. There was a limitation. Hence, GitHub Actions said, let's introduce something called GitHub Actions artifacts, which will allow my users to share the artifacts between jobs or between workflows, and also allow humans, us DevOps engineers, to download whatever is generated. Now, I am calling these application.jar and coverage report.html, but I want you to broaden your imagination. It could also be a test report that is called test results.html. It could also be a vulnerability report or SBOM, which you call security scan.json, for example, or sbom.json deployment job. It could be generating a deployment.log. A UI testing job could be generating UI test results. So I want you to think that way. And even further, if you have an LLM ops pipeline, you could be generating benchmark results, inference logs, RAG evaluation reports, and so on. So do not limit your imagination to just what you see on screen, because anything, any file that gets generated as part of your software delivery life cycle is artifact. Now, I'm not saying anything that is part of your software build is called artifact, because build of course generates artifact, but build is one part of the pipeline, one part of the workflow. Your workflow could be doing 1,000 other things, and those 1,000 other things could be generating 1,000 files. So all of those are artifacts. Not just whatever is resulted from your build is an artifact. Entire workflow, entire software delivery life cycle, whatever files are generated, they are called artifacts. Now that we have this solid understanding, let's come to what artifacts are. So we already know that artifacts solve whatever we discussed here. So what are artifacts? These are files or directories that are generated during GitHub Actions workflow run. So like we discussed, all of these are examples of that. Uploaded and stored separately from the runner's file system. Hello, we know that, because when the job is finished, is completed, the runner gets destroyed. So it is stored separately somewhere. What is that somewhere? We'll see that. Accessible across steps, but Varun, all the steps within a job are executed by the same runner. Then why do I need to share that artifact? Because all the steps in that job already have access to the file system. So yes, you are right in that thinking. Rarely needed, same runner and shared workspace. That is why you don't need it. But if you have a use case, which I haven't had ever, then you can also use it to share artifact between steps. Second is jobs. This is the primary use case, like we discussed here. Build job creates application.jar, job completes, and then the deployment job uses that application.jar. And you can see the typical flow here. Build job creates application jar, uploads artifact, and where this artifact is uploaded, this is uploaded in GitHub managed artifact storage. Now, they have not mentioned it explicitly anywhere, but I'm certain that this would be Azure Blob. Now, if you are coming from AWS and GCP, you have object storage there. You can think of blob storage as similar to that. So Azure blob is binary large object. Now Microsoft came up with this term because they were, I believe, the pioneers for this. So they called it blob, and they carried that nomenclature in their Azure cloud offering. So Azure blob is similar to AWS's S3 and GCP's cloud storage. Now this layer is abstracted from you. You don't have to manage it. However, if needed, you can download the artifact. Now you can download the artifact is an important point, because this is something that will distinguish artifacts with something that we are going to discuss later, which is caching. So keep this thing in mind from now itself. Users and workflow runs. This is an advanced use case. So workflow 1 generated some artifact, and workflow 2 consumes that artifact. Users downloadable from GitHub Actions UI, and we'll see this in the demo. Retained for configurable period before automatic expiration. And while we are doing the demo, we will see what is the default retention, how you can configure it, and so on. Last point is temporary storage, not a permanent artifact repository. Now this is a critical piece. Don't think of this as a perpetual storage that you can store your artifact for as long as you want. Only store it for the time you need it. The maximum configurable is 400 days. We'll come to that. But understand, when you need permanent storage for artifacts, you would use services like AWS Code Artifact. If you want to go third party, you could be leveraging JFrog's Artifactory, Nexus repository, and so on. So these are the solutions that you would use for permanent artifact storage. But GitHub Actions artifact storage, think of this as temporary storage, which you only use and retain for the amount of time that is needed for your workflows, not indefinitely. I want you to understand one more thing, that there is a cost associated with this. So you do not want to retain your artifacts for a longer duration unnecessarily. Now we understand the theory. Let's go to the interesting part, which is the demo. Now I will take you to my repository first. Here is my browser, and I will zoom in a little. I'll request you to star this repository if this is helping you. I'll go here, and then I'll go to 08 artifacts and caching. Here I will click on to demo 1, and I'll go to step 1, which is repository setup and authentication. So this is a prerequisite. So you should have a repository. It will be good if you name it this, and the visibility is private, because next rest of the steps that are given here, they assume that the repository name is this. And then step 2 we will discuss in a while. So what I will do is, I don't have a repository created, I think. So let's go to the top here, and then I'll click on this plus icon, and then new repository, and I'm going to call this CWVJ practice. I will make this private, and then I'll click on create repository. So my repository is created. Now let's understand what we are going to do. I'll go to my Visual Studio Code. I will expand 08 artifacts and caching. I'll go to project files. I will go to app.py. Again, we are using the same Python code, which is extremely simple. From Flask, we are using the Flask framework. As soon as the application starts, we will see this Cloud with Varjosh Flask application started. Whenever we hit the root, we will see home endpoint invoked, and this is what is returned. Whenever we invoke the health endpoint, we will see health endpoint invoked, and then this will be returned that the status is healthy. Our application listens on port 5000 by default, but it can be changed because we have defined an environment variable for that. Now, Docker file, we have seen this a million times. It is similar what we have seen before. So we are using Python 3.13 slim as the base image. Work directory is /app. Requirements.txt is getting copied here, and requirements.txt has Flask defined because our application uses the Flask framework. Hence, a dependency for our application is Flask. We'll learn more about dependency in the next section, that is caching. So here you have app.py, Docker file is here. We are copying the application code and then finally we are running the application. Extremely simple. I will not invest more time here. Now let's see the actual workflow. I'll come here, .github workflows. We know that GitHub Actions automatically looks for the YAMLs that are available inside this directory. So I just have one YAML and I'm calling this 01 artifacts demo.yaml. So I'll go here. I will come at the very top. I'll zoom in a little. I am calling this workflow 01 artifact demo. So this is what you will see in the GitHub Actions UI on workflow dispatch. So whenever this is hit either via the UI or programmatically, the workflow will be invoked. Then you see jobs. The first job I'm calling Flask CI job. This job runs on Ubuntu latest. And then the first step is check out a repository. So we are using an action to check out the repository because we need the code, the runner needs the code to do something. In the next step, we are building the Docker image. Again, we are using the uses keyword, which implies we are using an action. We are using an action that is authored by a third party, and that third party is Docker here. This action is authored by GitHub Actions themselves. And then we are saying with block, and we know with block is used to provide the customizations that we need for that action. So for this action, we are saying with context is a dot, which implies everything that is needed for the build is available at the root of the repository. If these files were inside a directory, let's say the directory was named app, we would have provided app here. Push is false because we don't want to push the image. We have done that multiple times in past demos. Tags, and here is the tag that we are going to give this image. Next is a run container. Extremely simple. We are just saying here we are using the keyword run, which implies that we want to run custom commands or scripts. Uses is used for actions, run is used to run commands or script. Docker run -d, I want to run the container in detached mode in background. -p says when the request comes on port 5000 of the host, and who is my host? The GitHub runner is my host. You send it to port 5000. Port 5000 is the container port. Then I'm saying the name of the container will be this CWVJ Flask container, and it will use this image. That image we created in the previous step, and we know steps within a job, they run sequentially. Only once this step completes, this step will start. Now, the next step is where our interesting things happen, because this is where we have tweaked the workflow YAML to adhere to the demo that we want to do. So in this step, we are doing a smoke test. Now, what I also want to do is I want to take a quick detour and talk about testing a little, because I have been saying this since lecture 1. We are doing smoke tests and so on. So I wanted my students to have an understanding of what testing is. Firstly, when you are, working on an application, testing is typically performed by a different team. So you will have a testing team that will be doing the testing. So if I go here, I go to artifacts and caching, then I have a section called common testing flow in CI/CD pipelines. Now, again, this is not something that is written on stone. Your workflow, your CI/CD pipelines may have a different hierarchy, but what I am saying is typically testing is performed in this sequence. Now, these are the names of the testing. So first is unit testing. Unit testing is what you do is you have a large code base. You test individual functions, classes, or methods in isolation to ensure that these things are working correctly. Okay. Once this is done, then you move to integration testing. Integration testing is how the components of your application work when they come together. For example, if they depend on a certain database, are those connections working as expected? Is my microservice, if it depends on something within the code, then all of those things are working correctly. So that is integration testing. Then there is smoke testing, and smoke testing is one of the fastest. What it does is it just checks whether the application is able to perform the basic functionality. For example, if let's say we are dealing with an e-commerce application, then there could be multiple microservices. So for let's say orders microservice, we would check that whether the orders endpoint is accessible or not. For wish list, we would see whether the wish list endpoint is accessible. For product catalog, we'll see the product catalog API is accessible, and so on. So smoke testing just quickly verifies that everything is working or not. And if you look at our example, we are doing exactly the same. We are just curling this and the health endpoint to ensure that the application is working correctly. And then you have sanity testing. So this is something that will see that when you are fixing a bug or you are adding a new feature, so whatever you have done, let's say you performed a push to fix a bug, so this testing will see whether that bug is fixed or not. So it will check whatever the push was supposed to do. So if it's a bug fix, it will check that. If it's a new feature, it will see whether that new feature works as expected or not. Again, this is not exhaustive. Exhaustive is the next one, that is system testing. Validates the complete application end to end, functional and non-functional business requirement. Functional requirement is validates the complete application end to end against functional and non-functional business requirements. And what these are, we discussed this in, I think, the SDLC lecture. I don't want to waste anyone's time by discussing this again. Regression testing ensures that the newly introduced changes have not unintentionally broken or altered existing functionality. I introduced a new feature. What's the point of that new feature if the old features are not working properly, right? The regression testing is that it ensures that whatever you have newly introduced does not break the working functionality of the application. And this is an important one. Acceptance testing performed by end users or business stakeholders. Now, I want to diverge a little here and also let you know that now it is not end users that would test the application for you. There are simulated acceptance testing mechanisms which will simulate end users. So we don't want our end users to be our guinea pigs. We don't want end users to be the ones who are testing our application. So we want to simulate that. So in enterprise applications, you would see that the acceptance testing is typically performed by your observability suite, wherein you would have someone simulate the user. Someone, I mean a software or a service simulate the users. So your testing team would have idea about all of these things. Now, this is a critical note. Not every CI/CD pipeline executes all of these testing stages. Fast running tests such as unit integration and smoke tests are commonly executed on every code change, while regression, system, and acceptance, which could take some time, are often performed later in the release pipeline or before deploying to production. So when I talk about pre-prod, your staging environment, testing is rigorous there. So all of these, you would see all of them in enterprise applications being performed when I talk about the pre-prod stage. Again, like I said, all of these are not performed for every environment. It depends on your use case. It is subjective. Okay, now let's go back to the topic in hand. Okay, I'll go to Visual Studio Code. So what we are doing here is we are first saying sleep for 5 seconds. Why? Because I want to give my container enough time to start properly, my application as well to initialize properly. And you would see this often because applications take time to start. If you are in Kubernetes, you will have probing in place. You see curl this, and what I'm doing is the results I'm sending to a file called smoke test reports.txt. It is a file. This is an artifact. So this is the artifact that we are going to store and use somewhere else. So start creating that mental picture in your head. Here it is just smoke test reports, but it could be test coverage report. If you're deploying somewhere, it could be deployment.log. It could be your coverage reports and so on. So broaden your imagination that way. And then in the second command, what we are doing is we are curling, but this time we are hitting the health endpoint and we are updating the same file. And then we come to the next step. Next step is also we are generating some sort of log. So what we are saying, export container logs, and logs is the name of the step. What we are running is docker logs. We are seeing the logs of this container and we are sending the logs to container logs.txt. Now if someone is thinking, what will I see in the logs? You will see what you defined in the application. So this is something that you would ideally see. Cloud with Varjosh Flask application started. This part is understood. This is the action that I want you to concentrate on. Again, I will mention that always refer the documentation to see what other things the action can provide you. I am just using the functionality that I want to demo. But whenever you are working with actions for an enterprise use case, I would encourage you to go and read the entire documentation for that action so that you know that the possibilities are endless. And same implies if you are working in operations and you are curious about technology, then review your existing pipelines, your existing workflows, see what else you can use in the actions, what all customizations that you can do in the actions so that you reduce the workflow time. And this is how you get recognized in teams. Okay, now the action that I am using is authored by GitHub and the name of the action is upload artifact whose version 7 I am using. So if I go to my browser and then I go to github.com/marketplace, then I will click here. Listing type should be actions and I will just search for upload. Okay. And when I do that, I see this action. So if I go here, I know it is authored by GitHub themselves, and you can see the entire functionality of this action here. So what are the fields that you can use? I am not using all of them, but of course you can. So I'll go here again to Visual Studio Code. And then what I'm saying is with block, I'm saying you name my artifact Flask CI artifacts. Now, all of these artifacts that I'm generating, they will under a zip file named Flask CI artifacts. And then path, this is the important thing. I am saying path is smoke test report container log. So these are the files that I want to upload. Now again, for your use case, you may be generating 10 files, but out of those 10 files, you only need 5 in the next job. In that case, you will just name those 5, not all of them. So think like an architect, think like a design engineer. So now I have this. I only want these 2 files and these 2 are the only files that we are generating. Then we move to the review job. So here Flask CI job is generating artifacts and this is job is also uploading artifacts. Then review job is the one that will be consuming those artifacts. So we are saying needs imply that you first run the job on which this job is dependent. So you first complete this job and only then you come to this job. So if we were not using needs, then both of these jobs would run in parallel like we already know. The first step is download artifact. So in the first step itself, we are saying our runner that you go to this GitHub artifact storage, and you pull something that is named Flask CI artifacts. And this is what Flask CI artifact is. So this runner uploaded something, and the runner that is running the review job is downloading that. So connect the dots like that. And then in the second step, I'm saying review download artifact, so that you know exactly that this is indeed what we created and uploaded as part of job 1. So here we are just saying cat this file and cat this file. Now let's execute this workflow and see the results. So I'll go to my terminal, and here I will do ls. I want to go to cd project files. So project files is the project files for demo 1, and project files 2 are the files that we'll use for demo 2. I'll go here, ls. I have app.py docker file requirements.txt. If I do ls-a, I'll also see .github here. This is something related to my Mac, so ignore this. Now I'll run git init, initialize this as a git repository. And if your branch is not named main, then I would suggest you to rename it to main. So what I will do is I'll run git add dot, so move all the files to the staging area. Then I'll write git commit -m, and let's say feature, and then let's type add artifacts demo. I'll close this, and here I will write now git remote add origin, and this is, I'll go here, and then I will ssh, I'll copy this one and I'll paste it here. Once I'm done, I will run git push -u. I don't have to have -u, but let's do it because I'm going to only perform one push here. And then, okay, this is done. If I go to my browser, I refresh this, I should see the files that were part of this commit available here. We only have one commit, which is the one that we just performed. So I'll go to actions now and 01 artifacts demo, which is why I always tell you to give logical, sensible names to your workflows. So here we have 01 artifacts demo. I'll come here, run workflow, and you see a good horizontal view, because we know this job will only start once this completes. So let's refresh this, and you see this is executing first. Once this will be green, only then this one will start. So see the time it is taking. Okay, so it is also of course generating the image, but it is also creating some artifacts for us. Now this is a small artifact, so you might not see a drastic difference, but you will always see some difference. If I go to Flask CI job, you see checkout repository. This is fine. Docker build Docker image. This will build the Docker image for us. Run container. This will run the container and spit the container ID. Then generate smoke test report. So this is generating the smoke test report. And then if I go here, export container logs, this is exporting the container logs. Okay, we are exporting it to this. And if I expand this, you would see what were the commands that we executed. Upload artifact. This is an interesting piece. Here is the one that the artifacts are uploaded, and it is also giving you artifact download URL. So you can download the artifacts from here, but I want to use something different, and it is also creating a SHA for it, and this is the artifact. So if I expand this post build Docker image, so this is not of use for us right now. I'll go to review job now and see this is a different runner. So this job was executed onto a different runner. Here setup job is fine. Now let's go to download artifacts. So it is downloading the artifact. So if I go here, yeah, download artifacts was just downloading the artifacts for you. But next step is review artifact, where we'll see something interesting happen. Review downloaded artifacts. You see if you cat our first, and first was, we were catting this one, smoke tests hyphen report. So this should have first the result of this and then the results of this. So if I go here, you see first is this, how is that's the application message. So if I go here to my application code, that is what we were displaying and that is what you see here. And then status is healthy. And if you see the container logs is saying cloud with varjosh Flask application started, because we instructed our code to do that. And then these are something that are added by Flask itself. So if I go to summary and then I go here, scroll down, you see there are two artifacts here. And this one is automatically created by, GitHub Actions. Now what happens is it's typically the this action. I'll take you here, and then here is my workflow. So it is this action that is creating that. Now what this is this is a Docker sort of build record. So what it will do is it will have the build metadata and logs, not the Docker image itself. And this is something that is independent of artifacts that we have used. So if you have been following me from day one of this course, we have seen this before as well. Now this is the interesting one. So Flask CI artifacts, this is the name that we gave to our artifact while uploading it, correct? If I scroll here, this is the name that we gave while uploading the artifact. And I want you to also concentrate on, there was an upload artifact action and here there was a download artifact action. So these are two different GitHub actions that are available, one for upload and one for download. In the download, we have to specify the right name, only then the appropriate artifact will be downloaded. And then if I click here, it will download this. So if I go to my Finder now and come here, Flask CI artifacts, I right click on it, open with, I can open it with text edit. And if I zoom in, you see the same thing here. And if I open this, you would also see whatever we asked. So if I zoom in, the same thing. This was the health endpoint and this was the root endpoint. I hope all the dots are now connected. Now that we understand this, let's go to next. I'll take you to my slides and then let me scroll down. Oh, but before I let you go, I want to talk about one more thing, and that is artifact retention. So let's go to upload artifact action. And if I search for retention, then you see that artifacts are retained for 90 days by default. You can specify a shorter retention period using retention on days input. And I would suggest you to only retain the artifacts for the time you need them. Do not retain them unnecessarily because they take storage and you pay for that storage. So use these efficiently and wisely. That's one. So you can define these in your workflows. Now there is another thing that you can do. There is a default setting that you can define at the repo level itself, at the repository level. So if I scroll up and I take you to settings, and then if I go to actions and go to runners, no, sorry, go to general, and here artifact and log retention. So you can change this based on your requirement, but understand the maximum is 400. This is something that you can set at repository level, but if you set it here at the workflow level by adding a retention days, then you can have a maximum of 90 here. So if you are defining at workflow level, it must be between 1 and 90. However, if you are changing it at repo level, then you can change this to 400 as well. I have not seen a requirement where they are retaining these artifacts for 400 days, because this, I like I told you, it's a temporary artifact storage. Okay, I hope this is understood. Now let's do one thing. Let's go back to the diagrams and see what I want to discuss next. Next is why and what of caching. See, firstly, I want to talk about dependencies. What is a dependency? Anything on which my application depends is a dependency. As simple as that. Do not complicate it in your head. If my application depends on a log file, that log file is a dependency. If my application depends on a package, like our Python application depended on Flask, hence Flask is a dependency for my application. So anything on which your application depends on, it could also be a database. My database must be up before my application. So that is also at large a dependency for my application. So anything on which your application depends is a dependency. Now let's see why and what of caching. Unlike artifacts which preserve workflow generated files, caches preserve reusable dependencies and frequently used files to speed up future workflow runs. But Varun, you also mentioned files here, but files you also mentioned in artifacts. Now, how would I know whether to use caching or artifacts? Understand, it depends on your use case. Firstly, when I talk about caching, the default for caching is 7 days. So the primary purpose of artifacts is preserve and share file produced by a job, such as application deliverables, reports, logs, and other workflow outputs, so they can be consumed by downstream jobs, downloaded by users, or reviewed after the workflow run, or even you can share it cross workflow. And the examples that we discussed were here: application jar, test report HTML, deployment.log, coverage report HTML, and so on. So these were artifacts. But when I talk about caching, caching is used to reuse files that do not change frequently. And what are those files? Dependencies. If your application depends on something, then that's something, if you cache it and the next job or a different workflow requires it, it can just use that. You don't have to download certain things again and again. So for example, let's come here. When I talk about across jobs, let's say your build job downloads dependency, and these are the three dependencies on which my Python application depends. So once these dependencies are downloaded, why would I want the test job to again download these dependencies? I wouldn't want that. If I have a cache somewhere, then I would want my cache to be used. And that is what GitHub Actions caching provide you. They provide you a storage where you can cache your dependencies and frequently used files. I want you to know that if you do not understand build tools, and if you want to understand build tools at large, I would recommend you go to my YouTube channel and search for Maven. Watch that lecture. It will give you a solid understanding of dependencies, libraries, build tools, how build tools help, and why build tools are not just doing builds for you. They can do testing, security, and so on. So you will learn those things. That forms the base for caching. Now, if you already know, then this will make sense. Now, I want you to know that if this build job is run by runner 1, then this test job, a different job, will be run by a different runner. So that different runner will not have access to anything that was downloaded here. Hence, we want something via which we can share whatever dependencies were downloaded with next job or a different workflow. Next or the subsequent job. So dependencies that were downloaded here should also be available to these jobs, any subsequent jobs. And with what we have right now, this is not possible. And that is what caching is solving for you. And now let's see what is written here. Many dependencies and other frequently used files remain unchanged across jobs and workflow executions. And we know that. And again, artifact is something when you are running something and that file gets generated out of that. But when I talk about caching, you would typically use caching for things that are downloaded from the web and are also needed by subsequent jobs or workflows. So make that distinction in your head very clear, that when to use artifact and when to use caching. So caching you would typically use when you have to download something from the internet and then you want to use that something in subsequent jobs or in a different workflow. So understanding this difference is critical. And the next point is, re-downloading or regenerating these files on every run increases workflow execution time. Of course, your workflow will take more time to execute if every job is downloading the same thing again and again. Then network utilization, of course, bandwidth would be used if you're downloading something from the web, if you're downloading some file from the web, if you're downloading some packages from the web, packages like Flask, request, PyTest. And we'll see the same example in the demo in a short while. CI/CD costs, if your workflows are running for a longer time, you pay extra cost. So if you see, all of these challenges were there here as well, and here artifacts was solving it, but here caching is solving the same problems but for a different use case. Now let's read this definition because now it will make sense. Caching, primary purpose, reuse files that do not change frequently, such as dependencies, package manager caches, build tool caches across jobs and workflow executions to reduce execution time, network utilization, and CI/CD costs. Now these common examples I'll show you here. Now what I have done is, here I have some popular technologies and most of these are build tools that you would be using when you are dealing with production applications. Now which build tool you will be using depends on what language your project uses. There could be certain languages like interpreted languages that do not have a heavy build stage, but when I talk about compiled languages like Java, they have heavy build stages because they require build. Now let's see this. When I talk about Maven, it is a Java build automation tool, and whenever a runner is executing a Maven job, by default the cache is created in this location. Whenever Gradle is used, the cache is created in this location. But Varun, what exactly is this cache? This cache is, for example, and I'm talking about the functionality of build tools right now, not caching that is available with GitHub Actions. So now if I talk about Maven, if Maven is executing something for me, Maven will download all the dependencies because it is the job of Maven to go to a central location somewhere, and that central location could be Maven Central if I talk about Maven, and download whatever is needed by my Java application from there and then use it. But what Maven will also do is, whatever it is downloading, it will save it to this location within the virtual machine or container where Maven is running. Correct? I want you to contrast this with our GitHub Actions runner. If a runner is running your Maven related job, then in runners this directory, you will have that cache. Now, what will that cache do when Maven wants to download the same dependencies again, same packages again? Then Maven would refer this and it will not download the dependencies again. And same applies for rest of these package managers. When I talk about pip, that is a package manager for Python, it will download the dependencies in this location. Now, what we will ask GitHub Actions to do, GitHub Actions does not care about what you are using. It could care less. What it cares about is the location that you are sharing, that location will be cached. Now, not the location, of course, the files in that location will be cached. Understand, if I have a runner that is running something associated with Maven, what I will tell my GitHub Actions to do is I will tell it that cache whatever you see here, so that if a different job needs it or a different workflow needs it, it can refer to that cache. Now, if there are gaps in your understanding right now, don't worry, in the demo we will clear everything up. And like I said here, it is not just for dependencies, and now dependencies is anything your application depends on. So the word that I'm searching for is, what these locations will typically have is the packages. Now, packages as in Flask package, requests package, PyTest package, these packages will be there in this location because we are using Python. But if you are using Maven, you will see the packages that are required by your application downloaded in this location. But I also said there are some frequently used files as well. And what are these frequently used files? These are the files that are generated here. For example, your Docker build kit, compiler caches, and so on. Now, let's understand the definition. Unlike artifacts which preserve workflow generated files, caches preserve reusable dependencies and frequently used files to speed up future workflow runs. Restored automatically using cache keys when a matching cache exists. So, what you do is you create a cache key, and whenever you want to use that cache, you call that cache key. If that cache key is found, it is restored. If the cache key is not found, there is a cache miss. So there are two terms here. There is cache hit, there is cache miss. If the cache is found, what you see is a cache hit. If the cache is not found, what you see is a cache miss. Extremely simple. A new cache is created when no exact cache key match exists, and this is simple to understand. A new cache is created when no exact cache key match exists. So of course, when you are running your workflow for the very first time, you know that there is nothing in the cache. So first the cache will be created, and whenever there are subsequent runs or any other jobs that want to use that cache, they can just use the cache. Next is commonly used for package managers, compiler caches, and build tool dependencies. So let's see this. Cache lookup looks like this. Cache key, locate existing cache, restore cached files. Simple. And this is the life cycle. So it could be a job or workflow that is using cache. Request cache. If there is a cache hit, restore files. If there is a cache miss, generate files and save the cache. Extremely simple. So let's go to the demo and look at this in detail. So let's close this. Let's also close this. What I'll also do is I will also delete the repo that I created, because what I want is this demo, I want to be clean. I don't want any previous presence here. So I'll delete this repository and then we'll recreate this repository. I'll just copy this, paste it here, delete repository, and then I'll click on new, and this time I'll create the repository with the same name, and here private, and then I'll click on create repository. So the repository is being created. So let's go to Visual Studio Code again, and I'll expand project files to this time app.py. It is the same file, so I'll not discuss this. Then the change is in requirements.txt. Previously, I only had Flask. Now I have added two more dependencies, two more packages that my application will require, so that I can demonstrate this properly to you. But Varun, Where is the Docker file? I don't have a Docker file. It is not always that you will be deploying onto Kubernetes or onto Docker. You will have scenarios where you have to deploy the applications right onto virtual machines. In that scenario, you won't have any Docker file. So let's expand .github. We'll go into workflows and then see 01 caching demo. Now let's see what is going on with this file. So we are calling this a 01 caching demo. On is workflow dispatch. Jobs is first is the build job which runs on Ubuntu. We are checking out the code, and here is the interesting piece. I am using an action here for Python, and that action is called setup Python. And we are saying via this action that I want Python version 3.13. And if you go to the documentation of this action, you can find other things that you can do with this action, other customizations that you can do. Next step is restore pip cache. But Varun, we have not created the cache. What exactly are we restoring? There is a single action called cache that can do both create the cache and restore the cache. This is different from what we saw in artifacts. There was a different action that was used for upload and a different action that was used for download. This is different in that way. With customization, here we are saying the path that you should be caching or should be looking for the cache is this one, and this is the path where pip caches the packages. So if I go here, if I talk about pip cache / pip, and that is exactly the same path that we are using here. Now here is the cache key we talked about. What we want is whatever our cache is should be uniquely identifiable. Only then we can be appropriately using it, and we'll see how we'll use it in a little while. But for now, we are naming our key pip cache, and then we already learned about expressions. What we are saying is in the runner contexts of GitHub, look for OS, and this is, we know, Ubuntu or Linux will be populated here. And then we are using a function, and that function is hash files, and we understood in our functions lecture that this will create the hash of the file. But Varun, why are we doing this? So this is something that will give unique cache keys to you. In the next step, we are displaying the cache status. We are saying cache hit. We want to show here what is the result of the cache, and you can also use this in production. This will tell you whether your caches are being used or not. So here we are saying cache hit steps dot pip cache, and you see this, we have given an ID, and we have seen this in our outputs lecture as well. We gave IDs to our steps, and then we were referencing those in outputs. Here also we are using outputs, and then we are calling cache hyphen hit. But Varun, here we were adding something in this file github_output, and then calling that. So here we were calling the output key release_version, and here we were calling the output key deployment.url, and whatever the outputs value was getting populated here. But here we have not defined anything like that. We have not defined this file. This is because whatever this action is, they already output certain values. Now this is similar to Terraform. So if you have seen Terraform, you would see that resources and modules expose outputs. GitHub Actions also exposes outputs. Whatever actions you have, maybe custom actions, or you are using any other actions that are provided by GitHub themselves, or a third party action, they could also be giving certain outputs. Both in Terraform, in GitHub Actions, what you are doing is you are just consuming the values that are made available to you by the provider or the action author. You are not creating themselves. So you can also have outputs created yourself, which we did in this lecture. But if you, let's say, create a custom action, you can already define the things that you want that action to output, and then the next step or a job or a workflow can use that output using the output key that you defined in your action. So here that key is cache hit. When you output this, it will tell you what is the status of cache. In the next step, what we are doing is we are installing the dependencies, and these dependencies are being installed in our runner, because these steps are getting executed in our runner. And from where it is checking the dependencies, it is checking the dependencies from a requirements.txt file that has three dependencies defined. Those are three packages that my application depends on. Now once this is done, whatever pip will download, it will store this in this location. We know that because this is the default location, and we are creating the cache for this location itself in this step. Now if I scroll down, we have a test job. Here what we are saying is this simple: we runs on Ubuntu, needs build job. So first finish this, then come here. Steps, this is same, this is also same, this is also same, but this time when this step runs, it will find the cache there, because when this job executed, this job kind of created the cache. Now this test job is using that cache, not directly, but I just want to show you that status. And once we do the mega demo, we'll do a actual production grade project. This is still production grade, but not as exhaustive as I would want it to be. So for now, let's just do this. Install dependency is the last step. All of these steps are same. The crux is in this job. I wanted to show you what a cache miss looks like, and here I want to show you how a cache hit looks like, because first there will be cache miss and then cache hit will occur. So let's go to our terminal, and here I will run. I'll first clear my screen. I'll come one step back. I will cd into project files 2. I will hit ls-a. I see all of those things here. Git init, and then I will write git add dot, and then git commit -m. I will write, let's say, feature add caching demo, and then I'll hit enter, and then I will write git remote add origin, and then I'll go to my browser. I will copy this and press enter, and then I will write git push -u origin main, and then I will go to my browser. I'll hit refresh. I see the contents here. I'll go to actions. I will go to 01 caching demo. Here I will click on run workflow, and let's see this. So build job is complete. Test job is running. So let's see the build job. I am not interested in setup Python or restore pip cache, because here it is saying cache not found for input keys this. So this is the hash that was generated. This was the hash that was generated for requirements.txt that you see here, that is there in the root of the repository. So it is saying not found because the cache was not created here. So if I expand this, display cache status, so cache hit is an empty string here. It should have shown false here, right? No. So whenever there is a cache miss, you will see an empty string. Whenever there is a cache hit, you will see true here. But Varun, when do we see false here? We'll see when do we see false. But for now, let's see install dependencies. Here it is simple. This pip install -r requirement. So whatever we said, now we just had 3, and you are seeing plenty of them because these could be transitive dependencies. So dependency has a dependency, and that's a tree. So all of these things are resolved by package managers like pip. So if I expand this, post restore pip cache, job complete, and I want you to concentrate on this key. It is key is saved as ff69. Okay, post restore pip cache. Now what happens is, this has now created a cache for us, and cache saved with key ff69. Now why this is important, if I come here, ff69721, ff69721. Now previously this cache didn't have anything, but now what GitHub Actions has done is, it has stored whatever the cache is inside this file. So whenever we call this file, we will have the cache available here. And if I take you to this, the documentation, and if I check, search for, let me search for true. Yeah, you see here, cache hit is the output that this action will give. That is why we were using cache hit. If there is a cache hit, this will be true or false to indicate if there is an exact match for a key. Exact match is true, and false you would see when you are using something called restore keys. We'll see what restore keys are in a little while, but for now, if there is a cache miss, this will be an empty string, which is why if I come here, you see an empty string here. And now let's go to the test job. This is so interesting. Okay, now if I click on restore pip cache, voila, cache restored successfully. Cache restored from key pip cache Linux 721 ff69, the same key that we saw in the first job. That is how caching works. So here, in here, the cache was created, and in the post actions you saw that the cache was created, and here in this action we are using the same cache. So when you do pip install dependencies, all of those packages were not downloaded from outside, and that's the beauty of it. Internet was not used, only caching, as in internet from for downloading from the package manager central system was not used. It downloaded from GitHub Actions cache. And if I expand display cache status, now you see cache hit is true. Install dependencies, now this is being installed, and I want you to see post restore pip cache, post job cleanup, cache hit occurred on primary cache key, this one, not saving cache. Now let's do one more thing. This is getting interesting. Okay, so I go to the code, and then let me go to requirements.txt, and let me edit this file, and Flask, let me change this version to 2. Now as soon as I do some change in this file, the hash will change, and again there will be a cache miss in the first job. I'll commit the changes. Okay, I'll go to actions, and let me run this manually, and there should be a cache miss again because I've changed the contents of requirement.txt. Correct? Cache hit is again an empty string, and if I look at the second job, this won't be an empty string. 09e 55c, because this is the post job cleanup. Now cache was saved in here, and this is the cache key 09e 55c, 09e 55c. Display cache status, it should be true. And now if I run this again, this workflow again, both of these jobs will have true in the cache hit. Previously this build job had false because I did some changes, right? Now if I run this again, this is empty string, so that implies that there was a cache miss. So if I run this again, let me run this again, and this time both the jobs will have cache hit as true. Let's see that. So build job we'll see in the first job, second job we know. Restore pip cache, Cache restored successfully. You see 09E55C. Display cache status. True. Cache hit. True. Now let's see when you would see false here. So if I go to my repository and then let me scroll down here, what are restore keys? Now what we have seen is, see, it is downloading the dependencies if we are making a slightest change here. But all of these are still the same, right? If we changed Flask, but these two were the same, right? In this example, I've changed the requests version, but what if I change this? These two should not have been downloaded, right? Why download everything again inside requirements.txt or whatever file you have? Why download everything again? So without restore keys, GitHub treats this as a cache miss, downloads the required dependencies again, and creates a new cache when job completes successfully. And this is what we saw. But what we can also do is we can define a hierarchy. We can say that you can first check this, and then before recreating the cache, you check these files. Now here I'm not providing the hash value. So again, when there is a new hash, a new key will be created and the new key will be used. But if I want to search everything that has this prefix, then I can write this. So what it will do is whatever has not been changed, it will pick from this, right? Or this. I mean, if this is not found, then it will move to the next one, but this will solve the purpose. And then whatever is not found will only be created, and then the cache will be created for that. So I hope this makes sense to you. Instead of restoring only an exact cache key, restore keys allow GitHub Actions to search for similar caches using one or more fallback keys. Here we have two fallback keys. The restore keys are searched from top to bottom, starting with the most specific key and ending with the least specific key. And here is the hierarchy. First, it will search here. If it finds well and good, it will say the cache is successful, cache hit is true, and then it will do the job for you. But if it is not found here, then it will go here. It will say, it will try to restore from here, right? Runner.os would be Linux. If suitable cache is not found, try restore key to pip cache, this one, right? And then if multiple caches match a restore key, GitHub restores the most recently created cache. Conceptually, exact cache match not found, try restore keys, restore closest matching. I'll let you read these things, but I hope you also understood the concept of restore keys. With this understanding, I will conclude this lecture. In this lecture, we learned how artifacts and caching solve two different problems in GitHub Actions. We learned that artifacts preserve and share workflow generated files, while caching improves workflow performance by restoring reusable dependencies and frequently used files. Through our hands-on demos, we learned how artifacts can be used to share files across jobs and how caching can significantly reduce workflow execution time by avoiding repeated dependency downloads. In the next lecture, we will explore GitHub Actions matrix strategy. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi, and I welcome you to Lecture 9 of GitHub Actions Basics to Production course. In this lecture, we will explore another powerful GitHub Actions capability called Matrix Strategy. We will begin by understanding why matrix strategy is needed, what problem it solves, and how it helps us avoid creating multiple nearly identical jobs for different operating systems, runtime versions, browsers, databases, cloud providers, and many other environments. After that, through a hands-on demo, we will learn how GitHub Actions automatically generates multiple job executions from a single job definition. Along the way, we will understand matrix variables, the matrix context, and how matrix expansion works, and how every generated job executes independently on its own GitHub hosted runner. So let's get started. Now, before I discuss the contents of this screen, let's talk about deployment targets. Now, as DevOps engineers, if you are starting with this career right now, then you might assume that every time that we deploy an application, that application is deployed onto Kubernetes or any containerized environment. It could be Amazon's ECS, it could be Google's Cloud Run, and so on. But it is not always the scenario. At times, you will also be deploying application onto a virtual machine, and do not think this is traditional in nature, because you would still see applications that deploy onto virtual machines. And I'm talking about enterprise applications because their use case requires a virtual machine, or maybe it is a legacy application that maybe cannot be modernized. So those applications will still be deployed onto virtual machines, and there is no one stopping to use CI/CD pipelines to deploy applications onto those virtual machines. So, like I always say, broaden your imagination. Another use case could be, first use case we discussed, you could be deploying to Kubernetes, of course, but you could also be deploying to virtual machines. And another use case I want to discuss is whatever applications we install in our laptops. Those applications, they also adhere to some sort of CI/CD pipeline. And when you are developing applications like that, when you are creating workflows for applications like that, what you would typically do, once you have the application package, what you would do is you will upload that package maybe onto a central location. It could be an S3 bucket, it could be Azure Blob, and so on. What matters is you are creating a deployment package, an application package, and then uploading that application package onto a certain location. And once that package is there, we as end users, if we want to use that application, like we want to use Visual Code, we just download the setup for that and then we install it in our laptop. Correct? That's the flow that end users follow. So do not limit your imagination to think that as DevOps engineers, you will only be deploying applications onto a containerized environment. It could be a serverless environment, which could, of course, underneath use containers. It could be a serverless environment which is just running functions for you, and you are deploying functions using your pipelines. It could be an application that is being deployed onto a Kubernetes environment or onto virtual machines. It could be an application package that you are uploading somewhere. I'm sure while I'm saying this, most of you are thinking of other scenarios that could be there. So of course, whatever I am saying are not the only deployment targets. You could have multiple deployment targets. Now that we understand that, I want you to imagine that we are developing an application that we want to deploy onto virtual machines. Okay, because I want you to get out of that cocoon that DevOps engineers only deal with Kubernetes. There are multiple other things as well. So let's say the application that we are dealing with supports Ubuntu, Windows, macOS, and when it comes to Python version, the destination where the application is being installed should have Python 3.11 or Python 3.12 or Python 3.13. So these are the compatibility requirements for my application, and you would see this often when you are downloading applications. You would see that this application requires Java 17 or later. This application supports Python 3.11 or greater. This application is only compatible with Windows, Mac OS, and Linux. So you would see these things when you download software from different vendors. And here we are discussing the same use case. Again, when I talk about Kubernetes implementation, deploying, when you are deploying onto a Kubernetes environment or a containerized environment, that thing is standardized because Docker did that for us. With Kubernetes, with containerization, you just tell that this is the base image that I want to use, and based on this base image, deploy my application, and your application will work the same way like it behaves in my laptop in any other system you run that container. The application will behave the same way because there everything is contained into a container image. But here the scenario that I am concentrating on is deploying onto a virtual machine or hosting the software package somewhere so that end users can download and install those things onto their laptops. So make that distinction extremely clear in your head, because this will start making sense only then. So this is our application. Now, before I ask my users to download this package and run the application, what I as developer would want to do is I want to test all of these in my local environment, because I want to ensure that my application works on Ubuntu, be it any version of Python. My application works on Windows, be it any Python version. My application works on Mac OS, be it any Python version, like you see here. Now, imagine if I were to do this testing in my GitHub Action Runner via workflows, then I will have to have 9 jobs. 3 into 3, like you see here, because I have to validate every scenario. And this is cumbersome for me. I cannot just go and create 9 jobs. That will be so redundant. I can, of course, but that will be too redundant. And here I have just taken the example of operating system and a Python version. This could be, I want to perform the testing in different browsers. Maybe my application is connected to a different database, and that database can have 3 other versions. I have to do all those testings, and to perform each testing I will have to create so many jobs. And if you remember, if I take you to my browser, and in the last lecture I'll go to GitHub Actions Basics to Production, that is the repository for this course. And if you have not already started, please click on this button. Thank you very much. And then I'll take you to artifacts and caching, which we discussed in the last lecture. And then here I'll go to demo 2, creating the workflow. So if you remember here, what we said, I want to use Python. So here in this step, I was instructing my GitHub runner that I want to run Python, but that Python should have this version. So I was configuring Python in my runner with this version. But if I had to test my application for Python 3.12, 3.11, 3.10, then I would have to create separate jobs for everything, because see, one runner is running this job and this job just deals with 3.13 version. For other jobs, I will have to create separate jobs, because remember, there is a runner that is associated with a job. So each job gets its own runner. I cannot say this runner that you install 10 different Python versions. Hello, can I? There are ways, of course, if you are coming from a Linux background, there are ways via which you can have multiple Java versions and multiple software versions. But let's think about this scenario. Can you have 10 different Python versions installed in the same runner? No, right? So you would have to create different runners, and you would have to create different jobs, of course, and those jobs will be executed by different runners. So I hope you get the picture, you get the complexity. And this complexity, my dear friends, is what matrix strategy is solving for you. Now let's discuss what of matrix strategy, because we already understand why we need matrix strategy, because we don't want to create so many jobs with identical configuration, because it is just the version of Python that is changing and is just the operating system that is changing. I don't want to create so many jobs. Hence, let's see what is matrix strategy. And before I do that, I will use the magic of editing to bring another picture here. I have the picture here. Now let's discuss what of matrix strategy. Unlike traditional workflows where a job runs only once, matrix strategy allows GitHub Actions to automatically run the same job multiple times using different matrix values. So you only create one job, and that one job will create multiple jobs for you. You don't have to manage those jobs. You just have to create one job with the matrix strategy inbuilt, and then everything will be taken care by matrix. You will have multiple jobs created based on the job definition that you have done, and this unburdens the operational load so much. You don't have to repeat yourself again and again for individual things. You don't have to create individual jobs. You just create one and it will take care of the rest. Automatically creates one job for every matrix value or combination you define. So before I move forward, let's discuss what is going on in this diagram, because I believe once you visualize this, the YAML itself, then it makes much more sense. So what you are saying, jobs, you are creating a test job. Understand this test job as in this job is performing the testing for me. That is why I'm calling it a test job. And important thing is, within the test job you have a strategy block, and in that strategy block you define matrix. And matrix, you are defining two matrix variable. The first variable is operating system, the second variable is Python version. So this matrix variable has 1 2 3 values, and this matrix variable has 1 2 3 values. So in totality, this job essentially will have 9 jobs. And why 9 jobs, we'll see in a little while. I hope till this point this is making sense. And this matrix variable OS has 3 values. It is a list. I could have used hyphens as well to specify that, and we'll see that in the demo. So for now, 3 values, Python version 3 values. We are saying this runs on. Remember, we supply runs on. If I go here, we used to supply runs on, and runs on defined what operating system you want to use. So you could use Ubuntu, Windows, and Mac OS. And here I'm saying what I want to use is defined in the OS matrix variable. And what we understood in our past lecture when we were talking about contexts, here matrix is the context, and we want to search for OS. So OS is here. We have defined 3 values. So when this job wants to run, it will first run for, let's say, this, then this, then this, and there is no sequence guarantees. Okay, I'm just telling you for reference, but we all know jobs run in parallel. Now runs on matrix.os. So for each OS, this will be populated here. Steps, I'm saying setup Python, and I am using an action setup Python. The version 6 is the version of that action with Python version. Previously, in the previous lecture, we supplied an explicit value here, 3.13. Here, because I want to test my application in all these 3 operating system and with all these 3 Python versions. Hence, I'm saying matrix.python version. So this will be populated from here. Now, 3 into 3 is equal to 9. So this single job will have 9 different jobs. So Ubuntu latest with all those 3 versions, Windows latest with all these 3 versions, Mac OS latest with all these 3 versions. I hope the dots are getting connected, and if they are not, they will connect in the demonstration section. And here, this workflow will result in a test job, matrix expansion, automatically generated job execution. So different jobs will be automatically created for you. Every generated job runs the same workflow steps but uses a different matrix value. So understand, you don't have to create multiple workflows or multiple jobs. Within a single workflow YAML, you define a single job and you use matrix strategy, and it will test your application in different environments. Different environments as in with different environments. Like here, Ubuntu latest with 3.11 first. So one runner will test this, another runner will test this combination, another runner will test Ubuntu latest with 3.13, and so on. So understand the basic funda that we discussed before, that each job gets executed in its own runner by default when you are using GitHub hosted runners. That is exactly how this will work. How this will work is one job will create, this job will have 9 different jobs, and those 9 different jobs will be executed in 9 different runners, because the core concepts, my friends, remain the same. Commonly used to test applications across different runtime versions, operating systems, browsers, databases, cloud providers, and deployment environments. Like I said before, as a developer, I want to ensure that my application works as expected in all the environments my application is compatible with. So if I am saying in my products documentation that my application runs on Python 3.11, 3.12, 3.13, and all these 3 operating systems are supported, then I must ensure that my application is validated to work on these environments. And that is exactly what matrix strategy is doing for me. It is ensuring that whoever runs my application in these environments, my application is guaranteed to work. And why I can say this with confidence is because I have tested my application on these versions. Now, if someone installs my application and is running Python version 3.10, my application may not work. And if the end user reaches out to me via a ticket, of course, I would say, my dear friend, can you please upgrade your Python version? Because my application is documented to work on only these 3 Python versions. And I am using Python as an example here. It could be a Java application, it could be a Node.js application, and so on. I hope everything is clear. Now, with this understanding, let's go to the demo. So I'll first take you to my browser. And here what I will do is I will go, oh, I should have clicked here itself. Anyway, I'll click here, and then if I go here, like my previous demos, there is a prerequisite that you must have authentication in place with your local and remote so that you can push properly. So if you don't have that, you can watch lecture 1 where we explain how do we achieve this. Now let's go to Visual Studio Code and understand what we are going to do. So I'll expand matrix strategy, I'll expand project files. I will first show you the code. Like I mentioned before, not every time you will be deploying onto containerized environment. Not always you will have Docker files. So predominantly matrix strategy, I personally have not used in containerized environment. Maybe you guys have had a use case that uses it. But for me, matrix strategy was predominantly used when we were dealing with applications that were deployed onto virtual machines, because when you have different teams, they can have, install software left, right, and center in their virtual machines. So you cannot always guarantee that they have whatever your application requires. So what you do is you create a compatibility graph for your application that only on these versions, once these are installed, my application will only work then. Now, only is a strong word here because it may work in an earlier version, but as a developer, what you are telling is, I have tested my application in these versions. Now, if my application also works in a different version, good for you. But I can say with confidence that my application will definitely work when you use these versions. That is what matrix strategy is doing for you, so that you can test those versions and say with confidence that yes, my application works on these versions. So now application code is extremely simple. If you hit the root, you get a print message home endpoint invoked, and this is what the application will return. If you hit the health endpoint, this is what you get. and this is what is returned: health status healthy with a 200 status code. And then once the application runs, you see this message. We have seen this application multiple times. Requirements: my application uses the Flask framework. Now the interesting part, let's see what the workflow is. So I will take you at the top, I will expand this, and here I'm saying the name of the workflow is, and this is the name that you will see in the UI, 01 matrix strategy demo. Then on, whenever this API is invoked, and we'll invoke this API using the UI, and then we have jobs, and here the first job is test job, and we are explicitly mentioning that run this on Ubuntu latest. And here in this example, we are only testing in different Python versions, because let's say our application is only tested to work on Ubuntu with these 3 Python versions. Strategy, like we saw before. Then we have matrix. Important thing to understand is within the job itself, you define your strategy. Matrix, Python version. I am calling the matrix variable as Python version 3.11, 3.12, 3.13. And if you see here, I am depicting a list with hyphens here, and in the diagrams, we saw it with square brackets. So you can use either of these. Then steps, the first step is we are checking out the code. Next step is we are setting up Python, and here where the matrix strategy comes into play. So as soon as matrix is seen, GitHub Actions understand that here I'll have to create 1, 2, 3, 3 different runners. And those 3 different runners, one will have Python 3.11, matrix.python version will be 3.11, then matrix.python version will be 3.12, then the third runner will have 3.13. Very simple, right? And next step is display matrix information, and I've added this so that I can show you how you see the OS as well. OS will be Ubuntu, of course, because we are not changing the operating system in this demo, but in the example that we saw there, we were using 3 different operating system as well. So here you would see 3 into 3, 9 jobs, but here you would only see 3 because we only are changing the Python version. So display matrix information, echo matrix Python version. So we'll see the Python version in this step. Next step, we are installing the dependencies. And where are the dependencies getting installed? So whatever you see here, these commands are executed in the GitHub runner. So this, you will see this, and then I'm saying execute application. I'm saying run python app.py, and app.py is the file that holds my Python code. So I'm saying python app.py. And why does this machine have Python? It has because I'm using an action for Python. And we already saw there are certain software, certain applications that are installed in each runner. I think we saw this in lecture 2 or lecture 1. So I'll let you explore that separately. Then I have an and symbol here. Now what happens is, if this runs, and this will run in the foreground, and another command that I want to run will not run until this exits, and we have not defined this to exit. So because it's a web page for us, right? So our website, whatever is there in the code, this will continue to run until and unless we explicitly stop it, because only when we stop this, the runner will say that I have completed the job that I was supposed to complete. So which is why I have added an and here. So and says you run this command in the background, and as soon as this runs, I am saying I'm creating a shell variable app_pid, and this $sign and exclamatory mark says whatever the last job is, you take the PID of that job. So I'll tell you why I'm taking this PID. Then I'm saying sleep for 5 seconds, and then I'm accessing my website because it is deployed onto the local host, which is why I'm supplying this. And then my application listens on port 5000 and the health endpoint I'm trying to access. And once this is accessible, I print echo application executed successfully. Then I am echoing the matrix Python version like this, matrix.python version like this, right? And then I'm running a command of Python which will display the version of Python, Python --version. And finally, I am killing whatever is stored in this shell variable. So I am killing the application, because only when the application exits or application is killed, only then my runner will say the job is executed successfully. Until and unless I kill that job, my runner will continue to operate, because the process is still running. Like containers, if the process is still running, containers continue to run, and as soon as you kill the process, the container also dies, right? I hope you know those concepts. Anyway, so let's push this and see how it works. So I'll go to my CLI, my terminal. I'm already in project files, ls-a. I see both of these. .github I see that has the workflow, app.py, and requirements.txt is also here. So what I'll run is git init, and then I will run git add dot. So I want to move everything to the staging area. Understand that if your branch is not named main, then you should name it main. So I'll run git commit -m, and then I'll add a commit message that could be demo, and let's say matrix strategy, and then I will close the double quotes. I'll press enter, and if I run git branch, you can see that my branch is named main. If yours is not named like that, you can also rename it. So if I go to my browser, I don't think I have a repository created. So what I'll do is I'll click on this plus sign here. I will create a new repository. I will name that repository cwvjgha practice, and this I'll make private, and then I'll click on create repository. So if your branch is not named main, then you can always use this command to rename your branch. So I hope this is making sense, and we have seen this a million times in the past lectures. So I'll copy this SSH, the path, and then I'll go here. I'll run git remote add origin, and this time the origin is this one, remote is this. I'll press enter, and then I'll run git push -u origin main. Perfect. And this will perform the push. So I'll go to my browser. Here I will just refresh this, and this should have the latest thing. I'll also zoom in a little. So whatever we had is pushed here. If I go to actions, I will see 01 matrix strategy demo. I see this in the UI because I named it like this here. So that's why this nomenclature is important. I will run workflow, and let it run. You see, matrix test job waiting for pending jobs. It created 3 jobs immediately. We just defined one, and because we are using matrix, it created 3 jobs for us. Show all jobs, and you see it automatically named the jobs in parentheses. You also see whatever was the Python version. So now let's go to the first job, and I want you to notice one thing. Okay, setup job, I'll expand this. Runner image provisioner, it's in East US. Azure region is East US, and worker ID is 557. Let's go to the different job now, second job, and here I expand this, and this is East US, and this is a different runner. So I want to emphasize on the point that all of these 3, they get a different runner. Now if I expand setup Python, this is a simple step, because this is action that is doing display matrix information. You see, this is the first job, matrix Python version 3.11, and this is the command that we ran, echo runner OS, echo matrix Python version. And I hope you already understand contexts, because we have studied this multiple times. So if I go here, this is the runner context, and this is the matrix context, and I want to also show you the matrix context. So if I go here, and I don't keep these links opened because I want you to also know how to navigate through the documentation. So I go to this page, docs.github.com, then I go to GitHub Actions, and then I expand references. I'll zoom in a little, and workflow and actions, here I should see context. Yeah, so runner context is here, from where we are getting the runner.os, and then matrix context. So I'll let you read about this. Whatever property name we want to populate, we can populate that. In this example, you see they are also doing something similar, so like we did. So here they have Node as example, we took Python as example. So same OS and Node. So here they are saying I want to test my application on Ubuntu latest with version 14 Node, with version 16 of Node, and then similarly I want to check for Windows on with Node version 14 and with Node version 16. So if you understand the foundational concepts, no matter which language you are using, you will be able to get it in a flash. So let's go back here, and then you see this install dependencies. This step is common, we are just installing the dependencies. Execute application. Now you see the interesting part. So it first executed this. So if I go to my Visual Studio Code, what we were doing is we were just running the Python application, and as soon as our Python application run, we saw this Cloud with Varjosh Flask application started. And why did we see this? Because we defined that in our code. Print message Cloud with Varjosh Flask application started. And I'm being a little fast here because we have seen this code a million times before. So if I scroll down, it is running on this is fine. We access the health endpoint, and here application executed successfully, and we quit the application here, right? In this step, if I go here, we quit the application in this step after everything is displayed. That's why, so it first displayed this application executed successfully, because that is what we echoed. And then matrix Python version 3.11 and the Python version, you also see the patch release here. So this is the major version, this is the minor version, this is the patch release 1.5. So you see both of these things. And if I go to test job 2 post setup Python, you can also see these are just cleanup jobs for the runner itself. So this runner would have terminated. And then if I go to test job 2, here again the important part, display matrix information, matrix Python version 3.12, execute application. Let's see this as well. 3.12, and the patch release is 1.3. So 3.12.13 is the patch release that is being used here. Similarly, if I go here test job 3 and I expand execute application, what you see here is 3.13, and the Python full version is 3.13.14. I hope all of these things are understood. It's one of those concepts, once you get it, you don't forget it for life. Now, with this, I will conclude this lecture. In this lecture, we learned how matrix strategy automatically generates multiple job executions from a single job definition. We also understood how matrix variables and why every generated job executes independently on its own GitHub hosted runner. Through our hands-on demo, we validated a Python application across multiple Python versions that are 3.11, 3.12, and 3.13. In the next lecture, we will explore GitHub Actions environments and learn how they help us manage deployments across environments such as development, QA, staging, production, and so on. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 10 of GitHub Actions Basics to Production course. In this lecture, we will explore GitHub Actions environments and understand why they are needed to manage environment-specific configuration, environment-specific variables and secrets, and controlled access across multiple environments. Through hands-on demos, we will create development and production environments, configure repository and environment variables and secrets, associate jobs with different environments, and enhance our deployment pipeline using deployment branch restrictions, required reviewers, and wait timers. So let's get started. Why GitHub Actions environments? As applications move across development, staging, and production, organizations must address several challenges while promoting the same application artifact across multiple environments. So when we talk about this diagram that you see on the top left of your screen, we are talking about different environments, and these environments could be development environment, staging environment, production environment, and I have only listed 3 of them. There are plenty more, as these things are application specific. Maybe if you are dealing with an application that is not that critical, you may just have 2 environments, development and production. If you are dealing with, let's say, a typical banking enterprise application, in that scenario you might have additional environments such as QA, UAT, performance, and even disaster recovery. So in general, I am talking that we are dealing with an application, let's say, that has 3 environments: dev, stage, and prod. Now each of these 3 environments, we have said here, promoting the same application artifact. Now if you have been following this series in sequence, then you already know that we have talked about build once and deploy many, which signifies that when we are dealing about artifacts such as application jars, application wars, container images, and so on, you only create them once, and then the same container image or the same application package is used in the dev environment, in the staging environment, and then in the prod environment. And why build once is such an important concept? Because what you want is whatever container image or application package is tested in the dev environment, the same thing moves to staging, and whatever is tested to be working absolutely fine in staging, only that gets promoted to production or any other environments that we are dealing with. So essentially the central concept is you build once and then you deploy it multiple times across different environments. So the same is suggested by this line: while promoting the same application artifact across multiple environments. But what is this point? This point is talking about organizations must address several challenges. Now, what are these challenges? Now, understand that we are saying that these environments are different, but the artifact remains the same. But application in general would be different in each of these environments. For example, if I am dealing in development, my deployment may only have 2 pods. In staging, it may be increased to 4, but in production, I could be using auto scaling, horizontal pod auto scaler. So configurations depend on which environment you are dealing with. But when I talk about artifacts like container images, like application packages, those are only built once. I gave you an example of number of pods in a deployment manifest, but I want you to broaden your imagination. Maybe in dev environment I am not doing any testing, but in staging I have multiple tests. In production, again, I do not have that extensive of testing. So that implies each environment has its own configuration requirements. In development, my URL of the application could have the dev keyword. In stage, it might have a stage keyword. In production, it could be a generic word like cloud with varjosh.io. So application URLs, application endpoint, whether you want debugging on or off, these things depend on the environment that you are dealing with. Again, your artifact, your container image is built once, but when it comes to the metadata that is needed by the application, it could be a config map, it could be a deployment URL, it could be number of pods, it could be the volumes that are being used. Maybe in dev you are using HDDs, but in prod you are using SSDs. So all of these things are different based on which environment you are dealing with. And this is a challenge. Why this is a challenge? Because we have sorted that we only build once, but different environments require different configurations, and we want something central which will allow us to define all of those things in a central place, so that if development environment wants to adhere to certain things, those certain things are defined in an environment that is created for development. Similarly for staging and for production. So if you look at this, if let's say right now what we'll have to do is, if we are dealing with three different environments, then the whatever variables that we would be creating, we will have to suffix or prefix dev into those variables, because otherwise how would I call them? And of course I cannot have the same name for my variables across all of these environments. I cannot just have app URL. What I will have to do is I'll have to prefix or suffix the environment name to make it unique. Because understand, when I talk about my workflow, I have a single workflow that is, let's say, deploying onto three of my environments, dev, stage, and prod. But how do I ensure that the variable that I am defining for my dev environment doesn't have a dev prefix? Because I don't like these prefixes or suffixes. And here I'm just talking about three environments. Imagine if you have five different environments, then app URL will have to be prefixed with those five different environments, and that is cumbersome for me. I just want to define application URL, and there should be some mechanism which knows which environment I am dealing with. And that is, my friend, what GitHub environments do for you. Now, before I discuss what are GitHub environments, let's see some more challenges. So here I talked about application URL, API endpoint, debug mode. For example, I might want to enable debug mode for dev, but for stage and prod, I might not want to use that. So understand these things, that certain configurations could be different for each environment. Another thing is secrets. If I am using Kubernetes secrets, HashiCorp Vault, I could have different secrets defined for me. There could be a DB password, there could be an API token, there could be an AWS access key, and I do not want to prefix all of these things. I want things to be simplified like you see on screen. And if you have been following along with this course, you already know we have discussed about repository level secrets and variables. You cannot create a variable app URL for two different environments without having a prefix or suffix, because if I just create app URL, then how would I call app URL for dev separately, prod separately? Because you cannot have the same variable name for multiple variable values. Understand this point. So we want something that would segregate things for us. And my friends, before I talk about the last challenge, I want to discuss what the solution is as well. The solution is in GitHub Actions, you create different environments. So for example, if I am dealing with this, what I will do is I will create an environment for dev. I will create an environment for prod. And then within the dev environment, I will create the secrets and variables that are supposed to be used by the dev environment, and there I will name it just like this. I don't have to add any prefix, because at large, at a high level, I have already created an environment that is called dev. So I no longer have to use repository level variables and secrets. I just have to create an environment called dev and an environment called prod, and whatever the values for these variables are, we define that there. And I want to talk about one more challenge. So if you see this, what I want is, now you have created environments, you have created a dev environment, you have created a prod environment. So once you have created these environments, all the variables and secrets pertaining to dev will be defined in dev. All the variables and secrets for prod will be defined in prod. But one more challenge is there. What I want is only jobs that are responsible, that are running because of the develop branch, should be able to use the things that I have defined under the dev environment. And that is also something that is provided by GitHub Actions environment. So if there is a dev branch and that dev branch wants to use things that are defined in the development environment, then only develop branch can use that. We can have protection rules that will prohibit main branch, for example, to use anything defined in development, feature branch to use anything that is defined in production. And if certain things are not making sense right now, do not worry. When we do the demo, all the dots will be connected. Now, one thing is this is sort of a governance, but another thing is I may want that whenever something is deployed for production using the production environment, that should have a manual approval. And here the workflow you see is similar to that. So developer builds and then deploys to production. But before this happens, it waits for approval. A release engineer approves it, and only then the deployment continues. So let's see what is written here. Challenges were environment specific configuration, environment specific secrets, and then controlled deployment. The same application artifact requires different configuration across deployment environments. The same application artifact requires different credentials across deployment environments, because of course you would have separate databases for your different environments. So the connection string for the database would be different for each environment, and database is just an example. You could have multiple other things like API tokens, access keys, and so on. And lastly, you have controlled deployment. This was a challenge. Organizations must control who can use an environment, which branches can use it, and under what conditions jobs associated with environment are allowed to proceed. And we'll be dissecting all of these in the demonstration section. So what are GitHub Action environments? GitHub Actions environments associate a job, and again, this job could be a deployment job, this could be a testing job, this could be a security job. Do not limit your imagination to think that when I'm deploying into production, I might need approval. Maybe in your use case, before running security scan job, you want security architect to approve that. So in that scenario, your that job will have this enabled, and we'll see this in the demonstration section. So GitHub Actions environment associate a job with an environment, enabling GitHub to apply environment specific configuration. And when I say environment specific configuration, I'm implying creating variables and secrets. And when I say protection rules, I'm talking about the controlled deployment that we saw here. Represents environments such as dev, staging, and prod, provides environment variables and secrets, enforces environment protection rules. And then let's see what a typical flow for you could look like. Now, again, like I said, environments are not just specific to a specific job like a deployment job. You can use it across jobs based on your use case. In the demo section, what we will see is we'll be typically using environments to control how things should look like when you are deploying the application onto dev versus production. So if you see this workflow, there is a job, associate production environment with that job, evaluate protection rules, load production variables and secrets, and then execute the job. Again, I want you to understand that these settings, these environments are created in the GitHub Actions UI, and then you call them in the workflow using the environment keyword within a job. So these things are job specific. So if you see here, we are evaluating protection rules, But in the development environment, we do not have any protection rules. We are just using variables and secrets. Understand that GitHub Actions environments, they have multiple features. What feature you want to use depends on your use case. Maybe for dev you just use variables and secrets, but for production environment you are using protection rules as well, and we'll be exploring protection rules as we progress with this lecture. So I hope the theoretical part for now is making sense, but if it is not, then don't worry, we will be dissecting these things deeper in the demo. So let's move to the demo now. So I'll take you to the repository for this course. I'll zoom in a little. Here it is, GitHub Actions Basics to Production course. And if you have not started this, please do that. I'll go here and then I will go to 10 environments, and here is the demo one. So first is repository setup and authentication. So you should have a repository, preferably the name is this, because the rest of the steps I'm using this names, it will be easier for you to copy paste, and the visibility should be private, and you must be authenticated. So your local should be able to push to your remote, and this is the remote repository. So we have discussed authentication in lecture 1. So if you're confused, go and watch that. So what I will also do is I will go to GitHub. Let's go here itself, and then I will also create a repository. I don't have a repository created yet. So cwvj gha practice, I will make this private, and then I will click on create repository. So this will create the repository for me. And then let's go back to Visual Studio Code and let's understand the application at large. And we are using the same application, so I won't be spending much time onto it. It's the project files, and there is app.py here. It's a simple Python application. When you hit the root endpoint, you see this message. When you hit the health endpoint, you see this message, and the application listens on port 5000 by default. So here is the Docker file. Docker file says use Python Slim, working directory is /app. We are copying requirements.txt onto /app. Requirements.txt just has Flask because my Python application uses the Flask framework. And then I'm installing whatever is there in requirements.txt, and it is Flask. Then I'm copying the application code to /app. Expose is just for documentation. It tells DevOps engineers that this is the application that listens on port 5000 by default. So the command that we are running the Python application code that we have. It's Python app.py. So it's a very simple Python application. Now that we have the understanding of the application, let's see what I want to discuss next. Now in this demo, we'll be pushing to Docker Hub. So what I want to do is I want to create certain things in Docker Hub. So I'll go to my browser and I will go to hub.docker.com, and then here so I'm in the repositories page. So I'll create a repository here, and I will name my repository Cloud with Varjosh Flask app, and I want this to be private. So I will click on create here, and once the repository is created, if I want to push to this repository, I should be authenticated, right? So we know that for authentication we would use personal access token. So let's click on this profile icon. Let's go to account settings, and from here let's go to personal access tokens, and here generate new token, and we'll call this token GHA demo, GitHub Actions demo. Expiration, I would say custom, and then I will expire this token on, let's say, 14th of July. And here I will say read and write, and I will click on generate. Once the token is generated, you only see this once, so copy it. I will copy this. Now let's configure variables and secrets. So I'll go here, and then I'll do two things. Okay, I will go to settings first, GHA practice. I will you see environments are here. So we'll come here in a little while, but for now I want you to concentrate here. And we have used this before as well, and we were calling this repository level secrets and variables. So anything in the workflow can access these variables, but environment specific variables and secrets, which we will shortly create, can only be accessed by the part I want to have access to those specific environments. So we'll come to that in a little while. And you see, when you come to secrets and variables actions, you see two bifurcations: environment secrets and repository secrets. So once we create these environments, you will see this also getting floated. But for now, what we want to create is, we want to create a Docker Hub username, and we want to create a Docker Hub secret, because secret will hold the token and normal variable will hold the username. Again, here as well in the variable section, you see environment variables and repository variables. Understanding this distinction is important. Previously, we have only worked with repository variable. So I'll click on new repository variable, and I want to call this variable Docker Hub username, and my Docker Hub username is cloud with varjosh. I'll do a quick spell check: cloud with varjosh, add variable. Now let's add the credentials as well, that personal access token, new repository secret here, token, Docker Hub underscore token is the name of the secret, and the value would be the personal access token. So let me come here, copy this again, and then I'll paste it here. I don't have a leading space or a trailing space, which looks good. I will click on add secret. Now what we have done is, we have created the repository level secret and variable, which will allow us to use these when we go to the step where we want to push the container image. Now here I want to go to now environments, and this is where we will create an environment. So what I will do is, new environment, I will just call this environment dev. Configure environment, you see environment secrets, environment variables. Now if you look at deployment branches and tags, if I expand here, so this will allow us to configure protection rules, and I will come to this in a little while. For now, let's concentrate on environment variables. So I want to create a couple of variables here, and let's see what those variables are. So first I will create app underscore URL, and this is, we are configuring the dev environment, and the value for that would be app.dev.cwvj.io. So it's just a value for the app underscore URL. Understand, we don't have to prefix anything, because we are under the environment that is already named dev. So we know whatever is inside this is specific to the dev environment. And then I will see leading and trailing spaces, nothing there. Add variable, app underscore URL is done. I will click on another add environment variable, and this time I will call it debug underscore mode. And debug mode, since we are in dev, I want this to be true. I will click on add variable. So dev we have configured. I'll go to environments again, and it says it's the dev environment and it has two variables. And if you want, you can also have secrets like we discussed in the theoretical section. So I'll go back, and then I will click on new environment, and this time I want a prod environment. I'll click on configure environment, and this time I will add the same variable names, but this time the values will be different. So app underscore URL, the value for this would be app.cwvj.io. So this is my app URL for my production implementation. I'll click on add variable. I'll just quickly check for leading and trailing spaces. I always do this. And then I'll click on add environment variable, and then I will here also add the same thing, debug underscore mode, and then the value for this will be false. The value is false because we are dealing with production, and I don't want to debug the production. I don't want to unnecessarily load my application by enabling debug mode. So debug mode is only needed in dev to see if something is working correctly or not. And let me just quickly verify that it was true here. So it is true here. And now let's visit that same section again. So you see two variables are defined in each of these environments, and right now we are just using variables and secrets, but environments provide you a lot more things, which we will discuss as we progress with this lecture. I don't want to bombard you with so many concepts at once. So let's go to actions here again, secrets and variables actions. Yeah, so now if I go to this variables tab here, you see this is the repository variable that we created before, but whatever variables we created within the environments that we created, you see all this here. So if you want to review what you have created, I think this is a better screen because this shows everything at one place. I often use this screen to verify my work after I have completed adding my variables and secrets within the environment. So now I hope this makes sense. Now let's see how we are going to use whatever we have created here. So let's go to our workflow YAML. So I'll go to Visual Studio Code. I will close this. I have .github directory, and within that .github I have workflows. This is the syntax that GitHub Actions expects, because this is the part where it will be searching for the YAMLs that GitHub Actions wants to take action on. So I'll go to 01 environments demo, and this is the workflow that I want you to concentrate on. First thing first, our workflow is named 01 GitHub Actions environments demo, and you will see this thing in the UI. So name this properly. We are saying our workflow can be triggered on a push, but not a push on any branch. Our workflow will only trigger when the pushes are made to a branch named develop, when the push is made to a branch named main, and when the push is made to anything feature / you can have whatever naming here. So let this be very clear. Another thing I want to highlight here is I am using a simple architecture here. We have been discussing multiple concepts since the inception of this course, and I have told you multiple times that often long-lived branches. What are long-lived branches? Branches like main, develop, production, staging, all of these branches, they are protected. Protected implies you are not supposed to make direct pushes onto these branches. What you typically do is you make the push to your feature branches, and then you raise a PR to merge whatever changes you have done. And there are automations under the hood that runs to ensure that your work is not breaking the existing application. So we have discussed these things in the past lecture, so I don't want to concentrate on that, but I do want to point out that we are enabling this push on long-lived branches for simplicity, because I want the focus to be on GitHub Actions environments, not on anything else. Of course, when we do the mega demo after this course finishes, we will connect all of what we have learned in 13-14 lectures that this course will have onto a single project. But until then, I cannot have all the best practices merged into all the demos, because that will take the focus away from the topic in hand, which is environments in this lecture. So now I have jobs. Underneath jobs, the first job is called build job. So the name is build and publish image. It runs on Ubuntu. Now see, I don't have any conditions here. So this job will run irrespective of whether the push is performed in feature, develop, or main. But Varun, you said you only build once, and then you promote the same artifact to different environments. But then why you are going away from what you said and building again and again, be it any branch I push to? You are right. I am not doing things that adhere to best practices, but right now my focus is on teaching environment. So that is why whenever a push is performed to any of the branch, the build and publish will happen. But in enterprises, you would often see the build only happens once. So what typically you would see is, now this is not only the way to do things. You would see a workflow that is just building the artifact. It could be container, image, application, package, and there is a workflow that just deals with deployment or security testing. So you could have different segregations of your workflow YAMLs, or you can have everything defined in one. So it depends on what strategy you use, and I will try to bring in the best of all the strategies when we do the mega demo. So for now, this job will be building and publishing the container image whenever a push is there in these three branches. So because we don't have any conditions defined here, steps: first is check out the code, then we log in into Docker Hub, we are using an action. Here comes the interesting part. So I want you to understand one thing very clearly. I could have defined this in a environment as well, and then call that environment here, and we'll see how to call that environment. But I don't want to do that, because this Docker Hub username and password for me is same across all the environments, because all the environments are accessing the same container image, because I want you to take back to build once principle. We are saying we have built the application, we have built the container image, and that container image is placed in Docker Hub. Any environment, the credentials will remain the same. Now, if in your application use case, and this could happen, that maybe you are using Docker Hub for your development environment, but when it comes to production, you are using Amazon's ECR. Possibilities are endless, right? So you have to think like that, how you would do things when if you had three different image registries, how you would do things then. So you have to broaden your imagination that way. So for me, both my environments, be it development, be it production, is using Docker Hub. That is why I have defined those values, those variables and secrets at a repository level itself. So repository variable, Docker Hub username, repository secret, Docker Hub underscore token. So I hope this is making sense. Next is I am pushing my container image. So I'm saying context, whatever you need for the build will be available for you in the root of the repository. And yes, we will be pushing it soon. Push is true. Tags, I'm associating var Docker Hub username. Now vars dot Docker Hub username, and we know this will be filled by whatever we have defined there. So we'll have cloud with varjosh here, cloud with varjosh Flask app, and I am adding the GitHub SHA here, the commit ID here, and then username is this. So I'm pushing the container image with two tags. One is this and another is this. Another thing I want to highlight here is whenever you are dealing with production implementations, you would typically see that these tags are not used. What you would typically use is the image digest, and we saw that in one of the demos as well, I think, but in the mega demo we'll see that again as well. So now there is deploy dev job. So this job didn't have any condition, build job. Then we have the deploy dev job, and I am using environments in the deploy jobs. But again, do not restrict yourself to think that when it comes to deployment only then you would use environments. You can use it with any job based on your requirement, right? Deploy dev job, deploy to development. If voila, now we have a condition, and we have learned about these conditions in our functions lecture. So if you have any confusion, go and visit that lecture. So I am saying run this job only when the branch is developed. So if the push happens in the dev branch, only then run this job, and this job needs the build job. So this job first must complete, only then this job will start. This job runs on Ubuntu latest, and here comes the interesting part. I am saying environment is dev. Now I want you to clearly know that these things, the if condition here and environment, are solving two different problems. Okay, if is saying that only when develop branch has a push, you run this job, right? Because GitHub reference name is develop, only then run this job. But this is saying this job is only allowed to use the things that are there in environment dev, in the environment that we have created with the name dev. If we would have not added this, then this job wouldn't be able to use whatever things we have done in the dev environment. So I hope you are able to connect things that way. They are solving two different purposes. They are doing governance at large, but they are doing different kinds of governance. One is governing what happens when the push occurs in develop, only then run this job. Another is saying you can only use the things that are defined in dev. If I try to use something that is defined in production, I cannot just do that, because environment to be used by this job is dev. I hope making sense. Then steps, display branch information. This is just echoing the branch name. Display environment configuration. This is just echoing the application URL. Application URL is this. Debug mode is this. This is something that will be filled based on whatever we have defined in the dev environment. In dev environment, we had certain value for this, certain value for this. Those values will be filled. Login to Docker Hub. Simple. We have seen this step again. But Varun, we already logged in. Why are you logging in again? We logged in here, right? This should have worked. We logged in here. This should have worked. I will take you back to the very primitive concept. And that concept is each job gets its own runner. So this job's runner will be able to authenticate because we have done the authentication, and then we'll be able to push into Docker Hub. But this job, if we do not have this step, my friend, then this pull, because we have a private repository, it will not be able to pull this image. And this will only be able to pull the image if we have this block here, this step here. I hope all of these things are making sense to you, because these are extremely critical to build that understanding, this ground level understanding. And then finally, this is simple. I'm performing a smoke test. I'm accessing the application, and then I'm displaying the container logs. As simple as that. No biggie. Again, here I am just deploying to a runner which is running our job, but this could very well be a step that was deploying onto Kubernetes. So broaden your imagination that way. Then we have the deploy prod job. So this was deploy dev job, and this is deploy prod job. Again, the same things, the similar things, but different values. Deploy to production. If GitHub reference name is equal to main, only then run this job. If a push has happened to the main branch, then run this job. Needs build job. Build job is where we are building the container image. So build job is needed. Runs on Ubuntu latest. Environment is production. So you are supposed to use things that are defined in the environment, GitHub Actions environment, with the name prod in it. So that's the difference. Again, I want you to know that there could be a scenario when you want to run certain jobs when the push is there in the main branch or the dev branch. So in that case, you would just copy this and you will have the double pipe symbol and you would paste that. So in that case, it will run for both the branches whenever there is a push. Now, if you want your job to trigger when there is a push in multiple branches, then you can use contains. And we studied about this in our functions lecture. So I hope you are starting to create that mental map in your head. Now here we are displaying the environment information. Then we are logging into Docker Hub again, because this is a different runner, so we want the authentication to happen. And here as well, we are using a repository level variables and secrets. Now someone is saying, Varun, if I have app URL here, so let's go back to the browser. So I will come here, I'll go to variables. Someone is saying, Varun, what if I create app URL here as well? Which one would be used, this one or the one you have created at repository level? So if environment is defined here, then whatever is defined in that environment takes precedence, and then the repository variable is used. So the precedence matters. Now let's come back here, and then it's the same. Then we are performing the smoke test, we are running the container, rest things are pretty much similar if not same. Now let's do one thing, let's perform a push and see how everything looks like. So I'll go to my terminal, I will run git init first. I'm in project files 10 environment. I'll go here, git init. If your branch is not named main, then you know how to do that, right? If I go to browser, your this will also tell you how to do it. So you just created it, and this is the command I would use to rename my branch to main if your branch is not named main. So what I will do is I will now run git add dot, so it will move everything to the staging area. Then I will run git commit hyphen m demo, let's call this demo, and then we will add here environments, and I'll close this. I'll commit this, and then I will write git remote add origin, and I'll go to my browser. I will copy this SSH thing from here. Ensure that you are not in HTTPS. You don't have to copy this path. You have to click on SSH and copy this one. And then I will click on enter. I will run git push hyphen u origin main, and then I'll press enter. Now this will do the push for me. So we have performed the push for main, but we don't have a develop branch right now. So let's do one thing. Let's create a develop branch too. So I'll run git checkout hyphen b. I'll just call it develop, develop, and then what I will write is git push origin, develop. I want to push this as develop itself, and I'll also add hyphen u in case we do a push again. We'll just have to write git push. So I'll press enter, and this will push in the develop branch too. Now based on whatever we have defined in the workflow, our workflow will trigger whenever there is a push in main or develop. So in our scenario, main is acting as our production, and you can have any name. You could have named this prod, you could have named this release. It depends on what your application architect has decided, on what your organization follows as a standard. So if you're in a product firm, there would be a standardized format for all of these things. If you are working for a service based company, this will vary based on which project you are working on and who is the application architect. If it's a new application, it's greenfield, your application architect decides how things should look like, what should be the branching strategy, and so on. So I'll go here. So this is already done. So I'll go to my browser now, and then let's look at the interesting part. So I'll go to actions. So if I hit refresh here, you will see that I have main has this content, and the develop will also have the same content. So I'll go to my actions tab here. So let's first see this branch, main one. Now you see this did not run. Why this did not run? Because this was only supposed to run when there was a push in the develop branch. You see here, develop. Only then this job would run. So that's why this job was skipped. Build and publish image was done. That's fine. And now I want to take you to the deploy to production. This will have the interesting thing. Display branch information. You see branch is main. That is what we expect, because main is for deploying to production, like I just told you. Then see, debug mode is false. Application URL is this. Log into Docker Hub. This is fine. Run container. This is also fine. This ran the container. This is the container ID. Smoke test application. This is generic test, and we see the status is healthy. We also see welcome to Cloud with Varjosh, platform, GitHub Actions, runtime, Docker plus Flask. And this is what our application was supposed to display container logs, and it is simple. We just ran that, and this is something that is displayed by the Flask itself. So I hope all of these things are making sense. So if I go back, Similarly, we can also explore the develop branch. So here production job was not run, only deploy to development job was run. So if I go here, you would see, if I expand run container, you see a container ran for this. And if I expand display branch information, you see develop branch here. Display environment configuration, you see app.devcwvj.io, and debug mode is true. I hope all of these things are connected. So I'll go to my repository now. If I hit refresh, I should see image with two tags. See, one is latest and one is with the commit hash. So if I go here, this is my commit SHA, and that is what I asked this to do. So 8C B2B. If I go here, I can go here as well to see this. 8C B2B 0F 0F 8C B2B 0F. So you see the commit hash also here. I hope all of these things are making sense. But Varun, what you have just shown to me is just variables and secrets. How do I see rest of the things? So if I go to settings, I'm in my repository CWVJ practice, and I go to environments, and if I go to dev, I see this. This is saying environment secrets we didn't create, environment variable we created. But here you see deployment branches and tags. Limit which branches and tags can deploy to this environment based on the rules or naming patterns. We see this. Now what I can do is I can click here, and then I can select branches and tags, or I can also supply protected branches. So any branch that is protected is only allowed to use this environment. But I want to use this selected branches and tags, and here dev, I know for dev I have develop branch, right? And I will add that rule. Okay, that rule is added. And then if I again go to production, I can do the same. So if I go to production, I can add deployment branches and tags. That is only what I'm doing is I'm saying only the main branch can use the environment settings that are defined here. Now those settings, for now we just have created variables, but we'll soon be creating more things. So I'll go here, and then I will click here, and here I will write main, and I will click on add rule. But Varun, you were also saying there are reviewers. So if I take you back to the diagram, you would be thinking in the theory section, you also talked about these things, right? Waiting for approval. And where do I configure these things? And the crux is, when you are using a free tier account like we are using, it is my personal account. I don't use any of these. I'm here. I don't use team or enterprise. In that case, with private repositories, you cannot have all those bells and whistles. I will let you read the documentation for more. But to demonstrate this properly, what I can do is I can change the visibility of my repository from private to public, and then I can use those features. Do not do this in your production environment, please. Your production repositories should be private, and then you should be using enterprise or team level plans when you want to use these features. I am doing this because I am in a development environment. I am testing, practicing, demoing it for you. Don't do this in production, please. So now let's do that. So I'll go to settings. I'm already in settings, and then from here I'll scroll down at the very bottom, and here you would see change repository visibility. So I'll click on change visibility. I'll click on change to public, and then I want to make this repository public. I have read, I understand everything, but why haven't you changed it yet, my friend? Make this repository public. Use passkey, and then I will give my fingerprint. Voila. So this should change it to public, and now this is public. You don't see a lock symbol anymore here. Now let's go back to the same tab again, environments. Let's go to prod. Previously we were not seeing these options. but now they have magically appeared. That is because now we are using a public repository, and GitHub allows you to use these features with public repos, but with private repos, you have to upgrade. Required reviewers. Now, I want for that job to start executing, I want someone to review that. Like I told you in the theoretical section. So if I go back to Visual Studio Code for production, we are defining right now. So we are saying you only run this job when someone approves it, required reviewer, when someone reviews it. Okay. Now understand, this is not just limited to deployment. Like I told in the theory section, you could have this for security as well. Before running the security job, the security team must review it. So you can have those things. Do not limit to just think that it is limited to deployment related job. So I'll come here and then I will click on required reviewers, and for now I will just add my account, cloud with varjo. So I'm the one who is approving it or and also creating it. So, but again, we have seen in our past lectures, what you can do is you can add collaborators here. Okay, and then you can add your account as well here. Your, if you own a second GitHub account, you can use that as reviewer. We have seen this in the past in this course itself, which is why I don't want to go there. You can also click on prevent self-review, require a different approver than the user who triggered the workflow. So for us, it is Cloud with Varjosh who is doing both the things. And then there is a wait timer. Now, this I have never used and I have not seen any projects use it. But the use case for this is, let's say your workflow has triggered and all these conditions are satisfied, but you don't want to trigger that job until and unless you wait for a specific set of time. Now why this is needed? Now at times what happens is we do something and 15 minutes later we realize we should not have done that. So it gives that time to your, all the people who owns the pipeline, all the work that is owned by people part of your application. So for example, let's say I have this timer set to 60 minutes, and once this job tries to run, it won't run until this timer elapses. I send a notification to all of the people who are responsible for my application that this job is going to run in next 60 minutes. If you want to do anything before that, make sure you do it. In case you see a problem, raise a flag and we'll stop the execution of that job. So this is for that. So I will let you explore other possible reasons that you could use wait timer for, but whatever reasons I suggested, this is what I could think of. And my research brought these reasons. Now, allow administrators to bypass configured protection rules. This depends on what your use case is. So for now, required reviewers and wait timer I have added. So you can click on save protection rules. This will save the protection rules. So I don't want any protection rules in my develop branch, so I won't create anything there. But you see whatever things that we have done. So I'll go to my terminal again. But Varun, why you are going to a terminal again? Because you know when the workflow will trigger, right? We don't have workflow dispatch, so we cannot trigger this manually from the UI. What we have to do is we'll have to perform a push again. So for that, let's go to our Visual Studio Code first, and I'll just make a small change here. In parentheses, I will write enhancements because we are doing certain enhancements. And then I will go here. I will first, let me switch to main, and then I will write git push because we have done all of these enhancements in the you know uh, prod environment, and our main is related to the prod environment, which is why I am doing the changes. I'm doing performing the push from the main so that the production part gets triggered. So I will write git add dot git commit -m, and this time I will write demo enhancements add, or rather add enhancements, because we have to be imperative, and then I'll press enter. I'll write git push hyphen u. I don't have to write anything. I can just write git push. So because I've used hyphen u before, and if you do not understand this, there is a git masterclass in my channel. The hyphen u anyway is used to provide that local to remote mapping, the branch mapping. So since we have already used hyphen u before, we have provided that mapping, so we don't need to use hyphen u anymore. We can just use git push. So I'll go to, so we are setting the upstream, it is called. So I'll go to my browser, and you see, as soon as there was a push by Cloud with Varjosh, this triggered. So let's go here. Oh, did we change the wait timer? The wait timer by default was 15 minutes. Oh my god. Oh, we should have reduced this, folks. Okay. Okay, let's cancel this. Pardon me, please. And then let's go back here again. Let's go back to environments. Let's go back to prod and then change it to a minute, because 15 minutes is a very long time, right? For testing, of course. So we have saved the production rules. I'll go here again. I'll go to prod just to verify that whatever we have done is there. And then I'll go to my Visual Studio Code. Let's add two dots here. Let's go to our iTerm, and then I will, sorry, iTerm, and then I will git add dot, git commit enhancements. I'll add two dots here, and then I will write git push. So now let's go back to our browser. This should have triggered our pipeline. So let's go to actions tab. Okay, it has triggered. So let's go here. Let's scroll. Let it first build and push, because only this is the part where the wait timer will begin, because build and push, it has no conditions at all. Okay, you see deploy to production, prod waiting for review, prod waiting. So you see there are two things. There is first a review, and then there is also a wait time. Even if I approve it right now, it won't run until and unless this prod waiting timer elapses. So let's wait for this to complete. So I waited for a minute, that timer has gone, and you see wait timer completed, deployment production rules. You see these here. Wait timer completed now, 1 minute wait timer, and then requested review. So if I come here, oh, I should not have clicked there. I'll scroll up, review deployments, prod, and I will say, please proceed. And I may add a change number. So I'll write change number. It depends on what your SOPs ask you to do. So let's say my number is 6767. Okay. I'll click on approve and deploy. And you see, as soon as I do that, if I scroll down, you see first this change to approve now, and you can see the comment here, please proceed, change number is this, and then deploying to production. You see some nice graphics here. So if I go here, you see the application is deployed. I hope all of these things are getting connected, my friends. So I'll show you one more thing. Okay, so let's go to first, let's see what are the tags that are there now. There will be plenty of them now. You see, because we suggested that you have the latest tag, so it is pushed. And then you also see the commit SHA. That is what we added in our workflow YAML. So if you see here, we added github.sha. So GitHub is a context, and then SHA is underneath the property field that we are using. So I go to my browser again, and then I want to show you just one more thing, and I swear this is the last thing. So I come here, GitHub Actions environments versus workflow triggers and conditions. Now, you know what happens is, we have been studying so many concepts. At times, all of these things start to get confusing, because what do I do when, what do I use that feature, when do I use that? So to answer all of these questions, I have added this section here. So Workflow trigger is your on, determines when a workflow starts. So you have this on here that is deciding that. Then you have event filters and activity types, determine which events are allowed to trigger the workflow. So here, if you remember, if I took you through diagrams, and here we studied about filters. So here we said, okay, you are on a push, but when the push is in the develop branch, only then run it. When the path is this within your repository, only then run the workflow. And we said that this is helpful because we don't want to run the workflow when you have, let's say, updated an MD file, when you have updated the documentation. You only want to run the workflow when you have made changes in app directory, Docker, or in the workflow YAML. Similarly, we studied about ignore as well. And then we also studied about activity types. So this is what on helped us to do, along with event filters and activity types. This is what this piece is conveying. On determines when a workflow starts. Event filters and activity types determine which events are allowed to trigger the workflow. Then there are job conditions, determine whether a particular job executes. Now we have already seen this. So this job will only execute when the push is there in the develop branch, because we have defined an if condition. And if you have any confusions, watch the functions lecture. And then what we are saying is, job dependencies needs controls the execution order between jobs. GitHub Actions environments associate a job with an environment, allowing GitHub to provide environment variables, environment secrets, deployment protection rules, deployment history, and other environment specific capabilities before the job executes. See, the job only executes once all of these things are satisfied, your protection rules are satisfied. With this, I think I've covered whatever I wanted to cover. So in this lecture, we learned how GitHub Actions environments help manage environment-specific configurations, environment-specific variables and secrets, and control access across multiple environments. Through our demos, we configured repository and environment variables and secrets, associated job with different environments, and enhanced our pipeline using deployment branch restrictions, required reviewers, and wait timers. In the next lecture, we will explore GitHub custom actions and learn how to build reusable components that make GitHub Actions workflows simpler and easier to maintain. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 11 of GitHub Actions Basics to Production course. In this lecture, we will explore GitHub custom actions and understand why they are needed to eliminate duplication, improve reusability, and simplify workflow maintenance. We will begin this lecture by understanding GitHub custom actions and composite actions from a theoretical perspective. Through hands-on demos, we will then create our first composite action by chaining existing GitHub actions as well as multiple shell commands into reusable building blocks that can be consumed by our workflows. So let's get started. Why GitHub custom actions? Now, since the inception of this course, we have been using two types of actions. First is official GitHub actions, and we have used these to check out our code, upload artifact, download artifact, and caching as well. And then there are community and vendor actions. These are developed, as the name implies, by the community or different vendors. So throughout this course, we have been using the Docker action. And then there are plenty more. There are for AWS, Azure, Terraform, Helm, Privy, and so on. So as we move to the mega demo, we'll be using a lot more community and vendor actions, but we have a good understanding of what these actions help us achieve. For example, if I have to check out code, I know that there is an action available for that. I do not have to write git specific commands for my runner so that my runner can check out the code. I don't have to write commands to upload artifact, to download artifact, for caching, even Docker related commands. I don't have to write Docker login commands, Docker build commands, Docker push commands, because there are already actions available for these things. And if I talk about myself, when I have to do these things, I never think of writing shell commands. I always use actions for these scenarios, because actions are first easy to use and then they're also easy to maintain, and we'll see the maintainability part later. But for now, I want you to understand that actions are there to ease our job, to ease the operational burden from the shoulders of us DevOps engineers. And even when you have these two action types, like official actions and vendor community actions, you still have certain challenges. Not all the use cases are catered by these actions, because let's talk about an organization. An organization could have a different flow, an application can have a different flow, and whatever the flow for that application is may not be achieved by something that is available in the marketplace. In that scenario, what we will have to do is we'll have to chain different things. For example, if I take this example, what is the typical enterprise deployment flow? There is an authentication process. There could be an authentication process with the internal platform. Then there could be a validation of organizational policies. Then there could be a build, and then you finally deploy the application. And the work doesn't stop there. Once the application is deployed, you have to update your internal CMDB, and then you may have to notify internal systems. So this is a typical custom flow that an organization might have. For us, whatever lectures we have done in the past, our flow has been using whatever you see here and Docker actions that you see here. And we didn't have to think further on that. Whatever we wanted, our use cases were simply achieved by using what was already available. But enterprises, different applications, they have organization specific automation. So if you have something like that, you may have a script achieving these things. For example, here you see there is a Python code that is doing the authentication for me, then it is doing the validation, then it is building the application, then it is deploying the application, updating the CMDB, and finally notifying internal system. So what I had to do was I had to have multiple scripts here doing my job. I want you to know that you have a run written here. When there is a run keyword, we understand that run is used to run shell commands and run automation scripts or shell scripts in a simple way. Now, there is another challenge. Challenge 2 is repetitive workflow logic. Now understand, we have been using actions and there is a possibility. For example, if I have 10 microservices that are part of an application, all of those 10 microservices may have the same actions being used across their workflows. Now this is not a problem, of course, but is it viable? Is it wise to repeat all of those actions in all of those workflows? Isn't there a way via which maybe I can create something that can hold all the actions that are to be used for my 10 microservices, and the workflow for respective microservices can call that central place? Isn't there a way to do that? And then there is repeated shell commands. Maybe whatever I am doing, I have to run multiple shell commands to achieve that. And all of those 10 microservices, I have been using these 10 commands. What if I have a way to centralize all of these so that I can just call that central place whenever I need to run these commands? And understand, if I have to change something in these actions, let's say login action has a new version, I'll have to do that change across 10 workflows. And of course, it is doable, but it is cumbersome. I don't want to do these things. I don't want manual efforts. I don't want to call multiple scripts, because again, if I have 10 different workflows, 10 different microservices, I will have to change the code in all of them, or the name of the script in all of them, if I do certain change in any of my scripts. I don't want to do that. Hence, we wanted something that will help us tackle both of these challenges. The first challenge is organization specific automation, which of course is not readily available with whatever we have in the marketplace, because each organization, each application, each project may have a different flow, and that flow requires custom automation. And this is the first time I'm using the word custom, because custom actions are the ones which will help us with both of these challenges. And these are the broader range of challenges. If you look at here, there are more challenges. So first is duplicate logic across workflows. Like I mentioned, if you have 10 microservices, the logic what you have will have to be duplicated. Changes required in multiple repositories. If something has to be changed, you have to visit all of your workflows and perform those changes. Inconsistent implementation across teams. What if someone is still using a previous version which is non compliant? And these things pile up sooner or later. So you think that, okay, I can do this manually, but sooner or later, this will come and bite you. Long, complex, and difficult to maintain workflows. We don't want lengthy workflows. We want something that can be sent to a custom place, and then that custom place can be called in our workflow using a single line. So I do not have to write all of these statements. And for now, I have just used the action part here. But what if these actions have customizations, and those customizations are achieved using the with block? So all of these will have their respective with blocks. And with that, the length of using 5 actions will be so much. You do not want to do that. So understand the challenges. First is organization specific automation, which is this, to understand what we mean here. And then there is repetitive workflow logic. So repetitive workflow logic is you are doing the same thing in multiple workflows. So instead of doing that, why not centralize it? And again, I don't want you to think that these challenges are only specific to when you are using multiple microservices. Even if you have a single application, using custom actions is a better choice in many scenarios. And when you would use that, you would use that when you have multiple long workflow file and you want to shorten that in such a way that there is a central place that is holding whatever you want to do, and then from your workflow you call that central place. Now with this understanding, let's understand what are GitHub custom actions. So what I'll do is I'll bring this up here so that we can see all of these things side by side. Let me move this here. We don't want to see the challenges. I'm moving this here because I want you to see the challenges as well right in front of you. These two challenges while I explain you what are GitHub custom actions. GitHub custom actions package reusable workflow logic into a single reusable component. that can be used, invoked across one or more workflows. And this concept is not alien to us. If I move to the inputs lecture here, we have studied this. So we discussed there are three types of inputs. I'll not go into detail in this. I just want you to know that we learned something about reusable workflow inputs, and here we learned the concept of reusable workflow and calling workflow. So what we discussed here was whatever is defined in the reusable workflow, and this scenario it were inputs. So whatever inputs were defined in the reusable workflow, those inputs can be called from the calling workflow. So what you did was you centralized inputs here, and then you were doing your customizations in the calling workflow. And we'll see this concept in the actions lecture today as well, in the custom actions lecture, because the concepts are similar if not same. So this is the definition: encapsulates workflow steps, shell commands, scripts, or existing GitHub actions. Now this is imperative to understand. When I talk about custom actions, of course you can write your custom automation using custom actions, but another important thing is when you have multiple actions, you can chain those multiple actions using custom actions. So what you can do is, if this is the thing that you have been using across workflows, then you can use a custom action to combine all of these actions into a single thing. You can also use custom actions to combine multiple shell scripts, multiple commands into a single package. And that is what this point is mentioning: encapsulates workflow steps, shell commands, scripts, or existing GitHub actions referenced inside workflows using the users keywords. And we have been doing this since the inception of this course, because I want you to know, at heart, these are also custom actions. It's just that the author of these actions is someone else, not us. When we are the author of an action, we call that a custom action because we have done some customizations in that. But at heart, someone also developed these actions. So from a GitHub perspective, these are custom actions. From the vendor who is writing these actions are custom actions. But from our perspective as a user, these actions are official GitHub actions. These actions are community and vendor actions. And whatever we develop in the demos, you will see that are the custom actions from our perspective. And all of these actions, they use the uses keyword because at heart, all of these are actions. Eliminate duplication. We have seen that you have to duplicate this into multiple workflows. You don't have to do that. Improves reusability, of course, and simplify workflow maintenance with a single reusable action. And this is so cool. You don't have to make changes at 10 different places if you have 10 microservices. And imagine if you have 10 applications and each of those applications has 10 microservices, and most of those use the same steps or the same actions, or they have the same custom implementation logic, because at times these logics are organizational. If you are working for a product company, it is likely that you have an organization standard. If you are working for an IT services company, it depends on which project you are dealing with. Each project, each application may come with its own customization requirements, and you as DevOps engineers and future DevOps architects, team leads will have to design the strategy. And that is where you want the teams that are working under you, they work in a way which is efficient, and the efficient way is using centralization where possible and efficient. So now, with this understanding, let's see what I want to discuss next. So there are three types of GitHub custom actions: composite action, which we'll discuss in this lecture. There is JavaScript action, and then there is Docker action. These two actions we'll discuss in the next lecture. So let's first discuss what is composite action. Now understand, the core principle is the same. You centralize something, and then there is a calling workflow which will call that central thing, and that central thing is action in our scenario. Previously, the central thing that we were calling was called a reusable workflow. In this example, was called reusable workflow outputs in this example. But here what we are centralizing is a reusable action, not reusable inputs like we see here, not reusable outputs that we saw here. It is reusable action, and that reusable action is called by a calling workflow. So have that mental picture right there with you. In inputs, outputs, and in custom actions, there is a central workflow. I should not call that a workflow, because workflow has jobs, but when I talk about custom actions that you would see us create, they don't have this job section. So that is one differentiation. But at large, reusable workflows, or actions, they have something that can be reused, which is centralized. So let's discuss this. Combines GitHub actions, shell bash scripts, or both, as we learned in the previous section. Packages reusable CI/CD workflow logic, we understand that. Supports inputs, outputs, and GitHub context. We will see this in the demo. Most widely used by DevOps engineers. And this is interesting for you, because to apply composite actions, to create composite actions, you just have to chain shell commands, you just have to chain actions, you just have to chain your scripts. So essentially, or a combination of all of them. So essentially, you are chaining something that you already had. Hence, it is very easy to implement once you understand the foundational concepts. Last is, can be local or remote, and this is the key part. For example, if I am creating a custom action that is supposed to be used only by a workflow, then what I will do is I will create the custom action and the workflow in the same repository. Makes sense, right? Why do I create a separate repository? But what if I want that custom action to be consumed by multiple calling workflow, like the architecture we discussed before? If I have 10 microservices, and those 10 microservices, let's say, have 10 workflows, respective workflows, I would want a separate repository that is hosting, let's say, all of my custom actions, and then these 10 microservices will have, each of these will have their own repositories and their own workflows, and then their workflow will be referencing my custom action that is hosted onto a remote repository. And that is what we are discussing here. Can be local or remote, and this specific bullet, can be local or remote, is applicable in both of these actions as well, because the logic, the concept, the foundation is the same. There is a custom action, either multiple workflows are calling it from different repositories, or you are hosting the workflow and the custom action in the same repository. And that is what you see here. There is a repository A, and we have already seen this syntax before, .github workflows, and this is where you have your workflows. And in this example, there are 3 workflows that are associated with this repository, and you store your custom actions in .github, and then there is an actions directory, and this actions directory can have multiple subdirectories, and each of these subdirectories will be hosting your custom actions. And custom actions is nothing but a simple YAML file, and that YAML file has a defined name, and that name is action.yml or YAML. I would suggest you to use YML where possible, because that is consistent with the documentation. So I personally have a habit of using .yaml as syntax, but to be in line with the documentation of GitHub Actions, I think it's better if you use .yml. Does not make much of a difference technically, but it looks nice from a cosmetics perspective. Then, so like I said, actions directory can have multiple subdirectories, and each subdirectory could be hosting its own action.yml. Then multiple workflows reuse the same local action. Now multiple workflows as in multiple workflows within this repository. And the second remote action use case is you have a separate action repository which will host all your actions, and then there are multiple remote repository that are using that action. So if you see this syntax here, and we have seen this syntax before as well, and I want to focus on this thing, just give me a moment so that I'll orient myself. So I'll go to my browser, and then let me open github.com/marketplace. And if I go here, and then let me search for an action, and that action can be checkout. And if I go to this action, we have been using this in the users keyword. So if I take you to Visual Studio Code, or let's stay here. So if I scroll down, yes, this is how you are using this action, right? Users keyword, and then you type the action. So here, when I talk about actions, these actions is your owner or your repository. So if I copy this, hold on, let me take you to Visual Studio Code, because I just need a file to paste this. Or let's rather go to this place. I'll paste it here. This is better. Now, so first is your owner. So my org here is the owner. Now this owner can be a GitHub user, or it can be a GitHub organization. So here it is, my org is a GitHub organization. Then you have repository, the repository where that action is hosted. So this action is hosted in build-action. That's the repository name. And then @version. Now this version can be a GitHub tag, it can be a branch, or it can be a commit SHA as well. So if I go here to my browser, then this is the owner. It can be a GitHub user, or it can be a GitHub organization. Then checkout is the repository where this custom action, where this action is hosted, and this is the version. So if I go to this actions, because this is by actions, you will see there are multiple repositories here, and each repository will have its own action. So for example, if you're dealing with checkout, then checkout will have its own action.yml file, because at heart all of these are actions. Now let's go back to the diagrams, and if something is not connecting, do not worry, okay, the demo will connect everything. So local action, remote action, we understand. Now let's go to our GitHub notes and start with the demo. So I'll go here. I would request you to please star this repository if you haven't, GitHub Actions Basics to Production. And another thing is, in my channel, a whopping 56% of users have not subscribed to my channel. So if you are finding value in my content, I would request you to please subscribe, like the videos, and even drop a comment. It really helps the channel, and it helps a lot more than you think. Okay, so I'll go to GitHub Actions Basics to Production, and another request is please start this repository if it is helping you folks. And then I'll go to 11 Custom Actions Composite. I'll scroll down, I'll go to demo 1. So in demo 1, what we'll be doing is we'll be chaining existing GitHub actions, and in demo 2 we'll be chaining multiple shell commands, so you get the best of both worlds. And my demos are the demos that I have for you right now. Both of these are production grade demos, and you can use this in your actual workflow. So I would suggest you, if you are dealing with production where you are chaining multiple shell commands, or you are chaining multiple GitHub actions, explore if you can use composite actions. And before you start implementing, I would request you to wait for the next lecture as well, so that you have a good comparison in your head, which type of custom action to use when. So with that said, let's get started with demo one. So I'll go to here, and then first step is you must be authenticated to your remote. So I already have a repository created called CWVJ practice. I would urge you to have a repository with the same name so that you can practice along with me. And this is a private repository, as you can see. And you must have authentication in place. Authentication as in you should be able to push code from your local to your remote, and we established that in lecture 1. So please do that. With that understanding, let's move to step 2, where we are preparing the application. So I'll go here, and I want you to see the directory structure right here itself. So you see there is a .github directory, and in that we'll have workflows, of course, because that is where the workflows will reside. But now you see an additional directory that is called actions, and actions has a subdirectory called docker build push, because my action is related to this, which is why I have named this directory like this. Now I am hosting a single action in this action subdirectory. You can have multiple directories inside it. I just have this. You can have one for EKS deployment, one for something else, maybe security scans, and each directory will have its own action.yml. So here we are using a single custom action, which is why we only have one. And then let's see these things. We have already seen this, but let's explore them again in this lecture. I'll just give a glimpse of it because we have been using the same code for so long. So I'll go to demo 1, and in demo 1, app code is simple. Our application will just display this: welcome to cloud with Varjosh, GitHub Actions, Docker plus Flask. And if we hit the health endpoint, we will see this. And then there is a Docker file because we are dealing with containerization. So we'll have a Docker file which will be used when we create a Docker image. So it's a simple Docker file. We are using Python Slim, working directory /app. We are copying requirements.txt, and requirements.txt is here, Flask 3.1.1. Since our application uses Flask, we are installing Flask. Copy app.py. So app.py had our code. We are copying it. Our application listens on port 5000. This instruction is just for documentation. It will not magically open port 5000 for your application until and unless you as a developer have defined in your application that my application listens on this port. And then finally we are running the application. Extremely simple. Now I want to show you an original workflow. I'm calling this original because what I want is I have multiple actions being used here. What I want is I want to contain all of these actions into a custom action. Understand what we learned in the theory section. If I scroll up, what we learned was repetitive workflow logic. So if you have repetitive workflow logic, you can use GitHub custom actions to chain all of those actions into a single custom action. That is exactly what we'll be doing. So if you look at this workflow right now, we are using a checkout action, then we are using a login action, and then we are using a build and push Docker image action. So we are using 3 actions right now. This is our original workflow, and we have seen this multiple times. It is not that we are implementing this, but what I wanted is when I teach you custom actions, I have the original workflow in front of you so that you can create that mental picture in your head. So now what I will do is I'll expand .github, and like we saw, we have an actions directory and then we have a workflows directory. So first I want to explore the actions directory. In this we have docker build push, another directory, and inside that I have actions.yml. So I'll open this here, and then I'll right click, I'll split this to right, and then I will close this, and then let's understand what is going on here. First thing first, do not look at here right now, just concentrate here. So I will name docker build and push. We are naming this action. This description is, I'll also go to view and choose word wrap. Yeah, reusable composite action for building and pushing Docker images to Docker Hub. The first block you see is the inputs block. And inputs block has four things. And we have seen inputs block in the past. So if I take you back to my draw.io, if I go to inputs, we have seen there are workflow inputs, reusable workflow inputs, and there are action inputs. For these two, we did the demo, right? And the action inputs, I told you that we will do this when we move to the custom actions lecture. And today is that day. So whatever inputs you see here, these are called action inputs. Why they are called action inputs? Because they are used in custom actions. That's why we are calling them action inputs. Now these inputs define what values the calling workflow can pass to the action using the with block. So I'll go to my draw.io, and what we learned was we defined certain inputs here, and those inputs were called by the with block. So using the with block, we were defining what are the values for those inputs. So for example, in the inputs, we said one input would be application name, and then the calling workflow using the with block was defining that, okay, this is the application name. Run security scan, it was type boolean, true or false, and then the calling workflow was saying it is true. And then replicas, and the calling workflow was saying, okay, replicas are 5. I want you to create a mental picture right now with me. So in the calling workflow, you had a uses block, and uses block was the path where this reusable workflow was stored. I'm talking about reusable workflow inputs right now because I want my students to correlate what they already know with something that they are learning right now. And these concepts, like I mentioned before, are similar if not same. So if you understood this during the inputs lecture, you will have no confusions in understanding custom actions. Now you see uses, I'm just typing the path of the reusable workflow, and that was named deploy.yaml in our scenario. And then with block, we were providing these values. Similarly, if I go here in the Visual Studio Code, I have defined 1, 2, 3, 4, 4 inputs here, and the calling workflow will be defining the values for these inputs. Because understand, you have a central place where you are chaining your actions, and this is that central place. And then there is a calling workflow which will define these values. And why do we need to define these values? If I take you to my browser, we studied, let's say, checkout action. Okay, now checkout action provided you with certain customizations. Okay, and all of those customizations were defined using the with block. So create that mental picture with me right now. The author of this action would have an action.yml like we have right now. Okay, and then that author would have defined certain inputs, right? And whatever inputs that the author defined, we are only able to use those in my with block. So if the author would not have defined this repository in its action.yml, then I would not have been able to use this. It's as simple as that. And then there are certain inputs that are a mandate, there are certain inputs that are optional, and then there are certain defaults to certain inputs, and we will see how to do those things. So I hope you are able to create that mental picture. So here I will come inputs. My first input is Docker Hub username, and that is true. Required is true, which implies calling workflow must provide me a Docker Hub username. So simple, right? Second is Docker Hub token. Required is true, implying must be provided by the calling workflow. Docker Hub under hyphen token must be provided by the calling workflow. I want to take you to the diagrams now. So here, remember, reusable workflow inputs. What were we doing? In the with block, we were calling all of these. And similarly, here we are calling all of those things. And then there is image name. We are saying required is true, implying the calling workflow must provide this image name. Then you have image tag, description is Docker image tag, required is false here. So the calling workflow may choose not to provide image tag, and if they don't, the default value for image tag will be latest. I hope you are able to connect the dots. Now everything that you see here, these are all the possible fields that are available at your disposal to use in the with block. So whenever you are dealing with different, actions, you have certain things that are to be defined and certain things that can be omitted. And now you know why is the reason, because the author of the action decided to do that. Now if I mark this as, false right now, then Docker username would also have been optional. This part we have understood. But I know there is one more question. Someone is saying, Varun, in the this part, reusable workflow inputs, we were using the same funda. In action inputs, we are using the same funda. Then what is the difference? And you are right. At large, the concept is the same. There is something that is reusable, and then there is something that is calling. The difference is in the reusable workflow, you had jobs defined, right? You had jobs defined, and that's why we were calling it a reusable workflow, because workflow have jobs have, different jobs defined, and each job will have steps. But we are not calling action inputs part a reusable workflow, we are calling it a custom action, and I'll tell you why. Another thing that separates these is here in the reusable workflow inputs, you had on workflow call and then you were defining the inputs, whereas in custom actions, inputs is a root block. So you have it right here. That is the difference. And another thing, like I told you, you see this action.yml, it does not have any job. There is no jobs keyword, so there are no jobs here. You directly have steps. That is the difference. So we cannot call this a reusable workflow, but we can call it just a reusable package or a custom action, because this again is helping in centralization. But inputs are also used here. Inputs are also used here. Here the inputs are defined in on workflow call block, and then in custom actions, inputs are available in the root itself. Okay, enough of this. Now let's talk about this. So runs using Composite. So this is the thing that is differentiating it. We are telling GitHub that this custom action is a composite action. So composite executes the step defined under the step section. So we have a step section and all of these steps will be executed, and this is sequential in nature. Now this will make much more sense, why this is being used when we discuss other two types of custom actions. So for now, just understand that when you have, you are using composite custom actions, you write composite here. If you are using the other two types, you will write their respective names here. So for now, I'll leave it here. Then is the critical part. You have steps here. Login to Docker Hub. So login to Docker Hub. So what we are doing is, see, we are just picking it up from here. So this is the original workflow, and once you can correlate the original with, custom action, it will start making sense. So what we did is we picked the entire block and we moved it here. But this time I want you to notice one thing very clearly. What did I tell you? The values for this will be provided by the calling workflow. I do not want to hard code that, which is why what I'm saying here is, here I was directly calling the variables and secrets that I created at repository level. Here what I am saying is, with block username, take the username from inputs dot docker hub hyphen username. So whatever the calling workflow will supply for this, take those values. So for password, whatever is provided in inputs dot docker hub token, inputs dot docker hub token, you take that. So calling workflow must be defining these things. And similarly, here what I have done is I have copied this entire block and moved it here. I have changed nothing. I have just changed what a calling workflow will define. And I want you to understand one more thing here, which is extremely critical. The context is dot, that is the root of the repository, and the push is true. So in the action.yml itself, I am saying push is true. So the calling workflow cannot change this. If I would have variabilized this as well, as in if I would have asked the calling workflow to provide whether they want to push or not as an input, then this could have also been customized. But in my example, in my demo, I am saying the context will always be root and the push will always be true. So understand that you can customize these things. Understand that this action will have several other customizations within the with block. You have to read the documentation for that, and then you can modify those things based on your requirements. Similarly, this action can have other parameters as well within the with block, and you have to decide which of those you want to use. I am just using username and password. So I hope you have now understood this. Now what I want to do is I want to close this thing, and then I want to show you the workflow which will use this custom action. So I'll go to refactored workflow. I'm calling this refactored because original was this and we have refactored it to like this. So I'll split this to the right, and now everything will connect. So refactored workflow name is Docker build and push composite action on workflow dispatch. So whenever the workflow dispatch API will be called, and we'll be calling that using the UI. Jobs Docker build push job. So it did not have any jobs. This one is a workflow, and a workflow will always have jobs. The name is Docker build and push. In parentheses, you see composite actions, runs on Ubuntu latest. And I am defining two environment variables here. Understand one thing very, very clearly. I am defining these within this job. So only steps within this job can access these environment variables. I hope that is understood, and this should make sense to you because at this stage you already know each job gets its own runner by default. If I'm talking about GitHub hosted runners, and then these we'll see in a while. So I'm saying image name is vars.docker image name, and we'll be creating this variable soon. And here I am using the GitHub context, and the field I am using is run number. So image tag will be this, image name will be this, and we'll be creating this variable soon. And then we have steps. The first step is checkout repository, and I am using the action checkout at the rate v7 for this. And then here is the interesting part. Name of this step is build and push Docker image, and uses is the critical part. So I am telling where my action is located. Understand that I am dealing with a local action. My repository will also host the custom action and the repository, which is why I'm saying the path is .github actions docker build push. Docker build push is the name of my directory which is holding my action.yml. So I just have to provide this, and GitHub is intelligent enough to know that I have to look for action.yml file. It will look for this file and will execute your workflow based on whatever you have defined in action.yml. And here is the with block, and you have these things here, whatever we defined as input. So we have, so I'll scroll up because my face might be obstructing your view. So Docker hub username, vars dot docker hub underscore username. So docker hub underscore username. So I am saying is Docker Hub username, take it from here. And we will be creating these repository level variables soon. So do not worry about that. And it's saying word wrap is take, but yeah. And let me do this instead. So then I'm saying Docker Hub token, and I have to call it like this, okay? So Docker Hub token. So if I have hyphen, I have to have hyphen, okay? Make sure you have exactly same here. So Docker Hub token, I'm saying if you want to look for the token, go to secrets.dockerhub underscore token. So we'll be creating these repository level variables and secrets soon. Image name, env dot image name. So image name is taken from here, image tag is taken from here. So whatever inputs we defined, I have used all of these. I did have an option to not use this input, but I am using anyway. Now I want you to know one more thing. So here we were calling it like this, but Varun, what happens if my action is hosted onto remote? Like we learned, you can have your, if I go back to my diagrams down, exactly like this. You have to have your owner name, repository, and then at the rate version, like we have been doing for our actions which are built by community or by GitHub Actions themselves. What we did was actions checkout at the rate v7. So for example, if it was hosted in cloud with Varjosh organization, then I would write cwvj org forward slash the name of the repository where my action is hosted, and let's call this my action repository, and then at the rate whatever I wanted the version to be. So I hope this is making sense to you. Now that we have a good understanding of what we are going to do, let's go to first our browser and then create these variables so that it is easy for you to understand this. So I'll go here, I'll go to settings, G cloud with Varjo GHA practice. I will go to secrets and variables, I'll go to actions, and here first let's create a secret. But Varun, for what are you creating the secret? Let's first create, I'll go to hub.docker.com. So first I'll have to create a private repository, and then I will have to create a token, and that token will be used by my GitHub Actions to access my private repository, rather my workflow to access that, my runner to access that. So I'll go here and I'll click on create repository. Let's call this one Python demo, and then it is private. I'll create this, and then let's go here, account settings, and then I will go to personal access tokens. I will generate new token. Token is GHA demo, and I will have read and write access. Expiration, let's have custom. I'll expire this on, let's say, Saturday, and I'll click on generate. And then I will copy this because this is only visible once. And then I will go here, I'll click on, there are two things, repository secret. So I want to create a repository level secret, and we've discussed environment secrets in our environments lecture. I'll click on new repository secret, and this time I'll call this docker hub underscore token. I'll paste it here. Why docker hub underscore token? Because my dear friends, we are calling it docker hub underscore token. So that's why. I hope you're able to connect the dots. I'll click on add secret now, and then I will go to variables. I will new repository variable. First one will be docker hub username, and this will be cloud with Varjosh. I'll click on add variable, and next is docker image name. So I'll copy this, I'll go to my browser, and here I will click on new repository variable. I'll add this here, and the value for this will be, hold on, cloud with Varjosh. So what I've done is, this is my username, you already know that, and Python hyphen demo, because this is what I have created here, Python underscore demo. So I've just copied this and pasted it here. I'll click on add variable now. So the variable creation is now done. So, and the personal access token is also created. So the secret creation is also done. Now let's go to our terminal and let's push this. So I will cd into demo1 and ls ls-a. I see all of the files and directories that I had. And now what I will do is git init first and git add dot, git commit add dot will move everything to the staging area, -m. I'll write demo learn actions chaining. Okay. And I'll press enter. Oh, hold on. Learn actions chaining. And then what I will do is git remote add origin, and I'll go to my browser. I will come to code here. I will SSH. Yeah, this is fine. Copy. And then I will paste it here. I'll press enter. And then I will write git push -u origin main -u is for defining the upstream and local to remote branching. I'll go here to my browser and let's go to actions here and then go to this workflow and run workflow, and then the workflow has started running. So it is extremely simple. Okay, it will build the image and it will push the image. That is what we did. So what we did is we chained two actions. So if I go here, so you see we had, if you look at the original workflow, it had two actions. What we did is two actions are combined into this. So imagine if you had 10 actions, you could have done this with all of them. So it is very powerful if you know how to use it. So if I go here, it would have done whatever we have asked it to do. So if you expand this, build and push Docker image, you see prepared all required actions, and you just see this here, but under the hood it has done everything that was defined in your action.yml. So all of these steps were performed. And if you come here, see cloud docker hub username is this, token is redacted, image name is this, image tag is this because it's the git run number, I think. Yeah, GitHub run number. Now I hope all of this is connected. So if I go here and I refresh this, you will see an image here. So we have image with tag 1. Now let's move to the second demo and see what the second demo is all about. So I'll go to my repository here and then let me go to demo 2. And in demo 2 we'll be creating a composite action by chaining multiple shell commands. So previously we chained multiple actions, and this time we'll be chaining multiple shell commands, and I am focusing on composite actions a little more because in cloud and DevOps space you will be using a lot of these. So I'll go here to my Visual Studio Code, and then let's close this. I'll bring it here. Demo 1 I will minimize. I'll expand demo 2 .github. Again, .github has two directories, actions and workflows, and this time we don't have any Docker or any requirements or any other Docker file or something of that sort, because we are chaining shell commands and we will see what those commands are. So first I will expand actions, and then I have a subdirectory there called generate build info. So we are generating build information. Now why this is important, and you will actually use this in production. So for example, for every workflow run, you may want to know certain information. So what was, let's say, who was the one who triggered that, what was the commit SHA, and all of those things. So what I have done is I have chained multiple things that will give us that information. So let's start with understanding what we are doing here. So name is generate build information. I am in action.yml. Description is this. Here I am asking for two inputs. First, I am asking for an application name. Second, I am asking for environment name. So it could be development, production, or anything that the calling workflow defines. And then I have an outputs section. Outputs. We have studied this before somewhere, right? So let's go back to our draw.io. Let's go back to our outputs lecture. Let me zoom in a little. So what did we learn about outputs? There are three types of outputs. There are step outputs used to pass values from one step to another step within the same job. Then you have job outputs used to pass values from one job to another job within the same workflow. And then you have reusable workflow outputs used to return values from a reusable workflow back to the calling workflow. And you see the same structure here. We used to define the inputs as well in on workflow call inputs, and outputs as well. When I talk about reusable workflow, is defined under on workflow call itself. So reusable workflow outputs, reusable workflow inputs, they have a similar way in which they are defined. It's that outputs is defined in the output blocks, inputs is defined in the inputs block, and then the calling workflow calls and uses it. But there is a fourth type of output, and that is called action outputs. So let's understand action outputs. And similarly, like we learned for action inputs, we used to define action inputs right in the inputs block, and it is same for action outputs. Action outputs are defined in the root itself in the outputs block. The difference between reusable workflow outputs and action outputs is similar to what we learned in the inputs part. Reusable workflow outputs are defined in on workflow call, and action inputs are defined right in the outputs block. So in the outputs block, I have an output name, which is build info path. You can also call it output key. Description is path to a generated build information file. And the value is, I want you to clearly understand, the output value is, I'm saying output value as in output build info dot text. So whenever someone, let's say, cat this, they will see whatever is stored in build info dot text. Again, build info path is the output key, and the output value is this path. There is an output directory, and in that output directory there is build info dot text. Runs using Composite, this we already understand, and we don't have a jobs section. We right away have steps. The first step is generate build information. The shell I am defining is bash, and run. Then I'm using multi-line string, and I'm saying set -e. Now set -e says immediately terminate execution if any of these commands fail, and that is what we want. If something fails, we don't want the workflow to continue running, we want it to stop. So essentially, if anything results in a non-zero exit code, you terminate. Then I am defining a shell variable here. It's a shell variable. I don't see any export here, hence it is a shell variable. And the shell variable is build time, and here I'm saying print the build time. And then I'm saying I'm creating this file. So what I'm doing is I'm first, and here I forgot this, I'm saying make a directory output. Here -p says even if the output directory exists, do not result in failure. We want the execution to succeed. Then here I'm creating that build info file. So application, so all of these things will be inside my build info.txt. So most of these things are the things that are needed when you want to see what all happened, as in what was the run number, what was the branch, the commit SHA. This is essentially the metadata for the workflow run. Now I want you to know that if you were not doing this, then you would have to do all of these things in your actual workflow YAML, making your workflow YAML extremely lengthy. You don't want that. You want that to be succinct, right? So what we have done is we have taken all the commands, all the information that we need into a single file. So what we are saying application is take the application name from inputs.application name. Environment, take it from inputs.environment. And both of these we'll be asking the calling workflow to define. And then all of these are taken from the GitHub context. And we have already seen this context, so I won't show this to you in the browser now. So GitHub repository, this will give the repository name, this will give the branch name, commit SHA, the run number, workflow, and then who triggered it. And then finally, build time we are also printing, and we take that from this shell variable. And then we are echoing build information, and then we are catting this file. So if I go to this workflow, this build information demo workflow, I will open this here, and then I will split this to right so that we can see side by side. Let me close this and let's see what is going on here. Name build information demo on workflow dispatch jobs build information runs on Ubuntu latest. This is fine. Steps is fine. We are using an action here. And then here is the interesting piece. I'm saying name generate build information, and I'm giving this step an ID. Why I'm giving an ID, we'll see this in a little while. And I like to have a job suffix here so that I know it's a job. That's how I do things. And then here you have ID. We'll see why ID is used. Uses GitHub Actions generate build information. GitHub Actions generate build information, because this is the directory that holds my action.yml. And then I'm saying with block, because with block is used to provide whatever inputs you were expecting here. So application name, I'm calling my application name is Cloud with Varjosh. Environment is development. So this step, will display whatever is in this file, because at the end I'm saying cat this file. Okay, but what I also want to do is I want to retain this file somewhere, and that is why I have added an upload build information point. So we have already seen this in artifacts, but I wanted you to understand how things work in production. So in production you won't just cat it, you may want to upload this file somewhere. So I'm uploading this in GitHub's own storage ecosystem, but you may choose to upload this somewhere else as well. In that case, you will have a separate action or a separate command that you would use to upload it somewhere else. But what I want you to concentrate on is here what we are doing, upload build information. I'm using this action to upload it, upload artifact. This is by GitHub themselves, this action. And then I'm saying with, and if I go to this action, upload artifact action, let me go to my browser. And if I'll go one step back, and this time I'll just search for artifact, and here is upload a build artifact. And if I scroll down here, also there are multiple fields which can be used with in the with block, but they have mentioned what all things are optional, what are required. So name is optional, but path here is required, which is why if you see here, we are specifying the path. So like if you refer the documentation, name is optional. So we could have not used this at all. We could have just used path here. Anyway, so path is what is the file that you want to upload. So I'm saying go to steps, go to build info, and that is why we gave an ID to this step, because we'll be using it here. Okay, I went to build info, and then you go to outputs. Okay, outputs. Tada! That is why we defined outputs block here. Go to outputs. Okay, and then look for the key build info path. Build info path. And what will build info path have? The value for that output key is output build info.txt. Hence, this file will be available for you as an artifact. So I hope all of this made sense to you. Now let's push this. So I'll go to my terminal, I'll clear this, I'll go one step back, cd demo02. I'm here. Now let me do one thing. I will run git init here first, and then I will run git add dot, and then I will run git commit hyphen m demo chaining shell commands. It's essentially bash commands, but shell commands is a generic high level term that you can use. Anyway, I'll press enter, and then I will write git remote add origin, and then I'll go to the browser. We are using the same repository, folks. Okay, I'll just force push it because this has different content. I'll go to code here, and then I will copy this, and then I will paste this here, and then I will write git push hyphen u origin main. So if I do this, it will not push because our repo has some other content, right? So I'll add a force flag here to force push. And then what I will do is I'll go to my browser. I will refresh this, and you'll see other files are gone. Only .github is here. And then I will go to actions, and I'll go to build info demo, and here run workflow. I will run workflow. And if I go here, let this complete. It is still starting the job. It is checking out the repository because our repository has the action, right? And then I'll expand this, and of course the workflow, generate build information, and this is an important piece. If I expand this, generate build information, tada. And this is here because we run cat, right? And this one had all of these steps, but you see this here because we catted the file at the very last. Application, cloud with Varjosh, environment development, because this is what we provided as our input. You can have your own custom values. Repository is this. Branch is main, commit SHA is E7. So if I go here, you see B78B, B78B. So the commit SHA is that. Run number is, this is the first run. Workflow, build information demo, triggered by cloud with Varjosh. Build time is this time is in UTC, and I would suggest you to always use UTC time or Zulu time because that's an unsaid rule and it helps. So no matter in which country you are, you know the timestamps are in UTC, so it eases your job. And then finally we have upload build information. So here we are uploading this onto GitHub's storage, and you can download it from here. But also if I go here, build information demo, you see build information is here as well. So if you click here, it will download a file for you, and that file will have the build information. So I'll let you explore that. So I hope custom actions are understood, and if there are any other gaps, I would recommend you watch this video again, and once you see the other two custom actions type, it will start to make much more sense. That concludes this lecture. In this lecture, we learned why GitHub custom actions are an important building block for creating reusable, maintainable, and scalable CI/CD workflows. We also explored composite actions, and through hands-on demos, created reusable actions by chaining existing GitHub actions and multiple shell commands into a single reusable component. In the next lecture, we will continue our journey with GitHub custom actions by exploring JavaScript actions and Docker actions, and build both types through practical hands-on demos. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi, and I welcome you to lecture 12 of the GitHub Actions Basics to Production course. In this lecture, we will complete our journey through GitHub custom actions by exploring the remaining two action types, which are JavaScript actions and Docker actions. We will begin by understanding why JavaScript actions are needed, how they differ from composite actions, and the types of automation they enable. We will then build our first JavaScript action through a hands-on demo. Next, we will explore Docker actions and understand when they should be used, how they package both the automation logic and the execution environment, and then create our first Docker action through another hands on demonstration. So, let's get started. So before I start discussing JavaScript action, what I want to do is I want to take you back to lecture 11. In lecture 11, what did we learn? GitHub custom actions package reusable workflow logic into a single reusable component that can be used invoked across one or more workflows. And we understood that what were the challenges that led to creation of custom actions, and these challenges involve when you want to have some custom logic that is organization specific, then you would lean towards creating custom actions. And also when you have a repetition in multiple workflows, then what you may want to do is you may want to centralize the piece that is getting repeated into a custom action, so that whenever those multiple workflows require to access the common things, then they can just refer to the custom action. And this led to the birth of custom actions. And then we discussed there are three types of custom actions. We already understood that we use composite actions when we want to chain multiple steps, or we want to chain multiple actions or bash scripts, or a combination of whatever you see in the first bullet, that is actions, shell bash scripts, or both. Now that we have this quick revision, let's understand what are JavaScript custom actions. Implements custom automation logic using JavaScript or TypeScript. Now again, JavaScript is a programming language, and when I talk about TypeScript, TypeScript is a superset of JavaScript. Now, what does superset means? It means that any valid JavaScript program is a valid TypeScript. So if I talk about JavaScript action, they implement custom logic using JavaScript or TypeScript. In composite actions, we learned that the custom logic can be performed using bash scripts or shell scripts. But in here, we are saying that custom automation that is performed using a programming language. And the second bullet says executes on the Node.js runtime available on the GitHub hosted runner. Now, when I talk about JavaScript as a language in general, it requires an execution environment, and that execution environment must have the runtime available. And the runtime that is needed by the JavaScript programming language is called Node.js. Now understand, if your custom action has to be run onto a runner, or your workflow has to be implemented onto a runner, the job defined within the workflow, if it has to be implemented via a runner, then that runner must have the runtime that is needed to execute that action. And that makes sense, right? If I have written something in JavaScript and I then want that something to get executed onto a runner, then my runner must have the runtime that will help in running that code. And that code in our example is written in JavaScript, and the runtime environment that is needed is Node.js. Now, the third bullet says ideal for GitHub API automation and complex workflow logic. And I'm sure someone is saying, but Varun, I can call the GitHub APIs using a script. I can write complex workflow logic also using a script. Then why the heck should I use a JavaScript action? And because Varun, I as a DevOps engineer, I am comfortable with shell script, but I do not know JavaScript. So let's tackle this question in two folds. Firstly, you must know that a programming language is powerful when compared with scripting. And when I say powerful, I mean when you are using a programming language, it has all the bells and whistles. You know, you have functions, you have modules, you have exception handling, and the most critical thing is you have access to a rich ecosystem of libraries. JavaScript is a popular programming language, so most of the things that your automation requires, there is a possibility that a library to accomplish that is already available. Now, if you're not from a programming language, library might sound alien to you. So I'll give you a quick example. So if you're, let's say, developing a banking application and you want a calculator, in that scenario, you won't be writing the logic to, for calculations. What you would do is you would use an external library that already has that logic, so that you don't have to do everything yourself. You just concentrate on the business logic, and rest of the things that are needed by your software, by your application, can be taken from the existing library ecosystem. So similarly here we are saying that programming languages, they often have a rich libraries that can be used in your code. But when I talk about scripting, they do not have that rich ecosystem. So programming languages, when it comes to writing complex logic, complex workflows, they will always have a little edge over what you can achieve using scripting. So that's the first part. But the second piece is, as DevOps engineer, you may be familiar with shell scripts, and in that case no one is stopping you to use shell scripts to interact with GitHub APIs or to write complex workflow logic. So it all comes down to what your requirement is and how equipped your team is to cater that requirement, either using composite actions or JavaScript action. Now, if that use case has complex logic but your team does not have JavaScript competency, then of course, no matter how complex it is, you will be achieving that using composite actions, because that is good in the longer run, because your team has competency in shell scripting. But if you have mates which have JavaScript understanding, then of course certain complex logics can be easily achieved using programming languages. Now, what you must be using depends on your requirement and the competencies that are there in your team. So I'll leave it there itself. A JavaScript action is a popular one because most of the actions that we have been using, rather, I would say, now this is my figure, okay, 97% or 95% of the actions that you would see authored in the marketplace, they are authored using JavaScript. So checkout action, setup node action, cache action, artifact action, most of these are written in JavaScript. So these are quite popular when it comes to marketplace. But when you are developing your own actions, you are authoring your own actions, it depends on the competencies that are available in your team. And maybe you have a programming team which helps you in writing the code for that automation use case or for that workflow logic. And it is also possible that your DevOps team also have JavaScript competency. So possibilities are endless because these things are really subjective. The next point is, can be local, as in your action.yml and your workflow logic can reside in the same repository, or it can be remote, where your actions are centralized in a remote repository and there are multiple workflows that are referring to that custom action, that JavaScript custom action. Now this bullet, like I mentioned in composite section as well, is common across all three custom action types. Now let's move to the demo section. So I will take you to my browser, and from here I will go to GitHub Actions Basics to Production. And if you have not started this repository, then please click on this button and start this, if this is helping you only then. And then I'll scroll down, I'll move to lecture 12, which is JavaScript Docker action. I will click here, I will scroll down, and recently I have started giving personalized guidance on cloud and DevOps. So if you are stuck somewhere, be it your interviews, certifications, resumes, what to do next, or if you have any confusion career wise, then feel free to book a session. I'm offering this at a very nominal cost. Now let's scroll down and let's move to demo 1, creating your first JavaScript action. So let's do this. So the prerequisite is you should already have a repository, and preferably the name of the repository is CWVJ GHA practice, GitHub Actions practice. Visibility must be private and you must be authenticated, as in you must be able to push from local to remote. And if you have any confusions in establishing this authentication, then I would suggest you watch lecture 1. I'll move to step 2. Now this is a critical piece and I want to spend some time here preparing the directory structure for JavaScript action. Now in the previous lecture, since the inception of this course, we already know .hub is a meaty directory which holds most of the important things that GitHub Actions use. And we have been using a subdirectory workflows inside the .github directory since the very beginning. And this workflows directory will have single or multiple workflows that are used by your application. So here in this example, I just have one workflow, that is JavaScript action demo.yml, and this is essentially the calling workflow. And why I am calling this a calling workflow? Because this calling workflow will be calling the custom action that we will create shortly. So let's see, where is the custom action? Like we discussed in the last lecture, there is a actions directory within the .github directory which holds all your custom actions. Now it could just be one action or it could be multiple custom actions. So here I just have one directory created, that is workflow summary, and this directory has one custom action because there is action.yml inside this. I could have had multiple directories here under the actions directory if there were multiple custom actions that my workflows were using. In my example, I have a single workflow. In my example, I have a single custom action. You can have multiple. In my example, I am using a local action. I'm calling this a local action because both my custom action and my workflow is residing in the same repository, or rather will reside in the same repository. And if I take you to my diagrams again, we learned that in a remote action, what you do is you centralize all your custom actions, or you centralize your custom actions and split them into multiple repositories, so that that repository's role is just to hold the custom action, and there could be other repositories which are holding your workflows, and those workflows will be referring your action, your custom action, that is hosted onto its own dedicated remote repository. I hope this is understood. I'll take you back here and let's now understand the contents. First is action.yml. This is similar to what we saw in composite actions. Action.yml is a must file, and this is the file that holds your action. Now, I also have index.js. JS is an extension for JavaScript, and I also have a package.json. So when I talk about JavaScript, most of the dependencies, the project requirement, the project structure, what the project is all about, all of these things are stored in package.json. So any good JavaScript project, now this is not just limited to GitHub actions, custom actions, JavaScript custom actions. This is applicable for anyone who is writing the JavaScript code. You would often see that the package.json pretty much always exists. Now, again, it is not mandatory to have it, but it is recommended. That's why I'm saying 99.999% of the projects that you see for JavaScript will have package.json. We also include package.json file, which describes the JavaScript project and lists any external libraries required by the action. So if you have been following along with this course, you know that we have been using Python application for our demos. And that Python application, if you remember, had a requirements.txt file, and that requirements.txt file had the packages on which my application depended, and that package was often Flask. Here it's the similar concept. Package.json will be holding external libraries on which my custom JavaScript action depends on. You will also see index.js. Now, index.js is the name that you would often see, but it is not a mandate to have this name. Now, I have this name right under workflow summary, this file under workflow summary, but you can have it inside subdirectory. So let me show you one thing. So if I go to github.com marketplace, and if I go here, and then I listing type is actions, let's choose any actions. Okay, let's choose the checkout action. I'll go here, and we know this checkout action is by GitHub actions themselves, by GitHub themselves. So I'll go to actions. Now if I go to this action, so this contains all the actions that are official GitHub actions that are authored by GitHub themselves. And you see a lot of these we have been using. We have used, I think, setup node as well. And if you go inside this, if you see all the repositories, so most of what we have used, so let's search for checkout action. You will see checkout action is also, the repository for checkout action is also here. So if I search for, let's say, artifact, so we have used upload and download artifact. You would see that for that as well, the repositories are here. You see upload artifact, download artifact. Similarly, if I search for cache, you would see the cache is also here. The cache action is also here. Now these are repositories. So this is the repository for the cache action. What I want you to know is this has all the actions that are authored by GitHub actions. These are the repos for them. So if I, let's say, go to the checkout repo, for example, because I want to show you how you would know which type of custom action this action is using. So if I go to checkout, if I go to action.yml, okay, you see, if I scroll down, further down, you see runs using node 24. And as soon as you see node 24, create that mental map that JavaScript uses the node.js runtime. So this action is saying using node 24, which implies this action is written in JavaScript. Now another thing that this tells me is this is using node 24, and then it is saying main. So main is the part where you tell where is the automation logic, where is the code. For us, the code is in index.js, which is right under workflow summary itself. But in this example, the code is in this directory and then index.js. So if I go to this dist directory and then I go to index.js, this is the code that the checkout action is using. So I hope this is making sense to you. Okay, so now let's go back here. Now again, like you see here, this one is not just holding index.js or action.yml. This has many more files. This has license, readme, and there are plenty more. So what I want you to take away from this is what I am showing is not a comprehensive, exhaustive list of files. You can have multiple files here, but these three are the most common ones that you would pretty much always see. Index.js could be named something else, like I said before. Now that we understand this, let's go to our Visual Studio Code and see what I have in store for you. So what I will do is I'll expand this. I have two directories here, one for JavaScript action, that is 0202, because 01 was our composite action in our previous lecture. So I'll expand 02 here, and like we know, we have an actions directory and then we have a workflows directory. Both of these are in .github. I will expand the actions directory. What first I want to show you is the code, and I'll just give you a quick walkthrough because I know most of you are not developers, but the code that I have is extremely simple, so I'm sure it will make sense to you. So first is I'm just defining two variables. Now first is I'm saying I require this and I require this. So if I go to package.json, you see I have defined that my JavaScript custom action, it has two dependencies. It has dependencies on two external libraries, and these external libraries are actions/core and actions/GitHub. Now what you have at your disposal is you have GitHub Actions Toolkit. So if I go to my browser and if I search for GitHub Actions Toolkit, and then I go to the first link here. Okay, now what GitHub has done is they have created many external libraries which you may need while you are writing your custom JavaScript action, because this is helpful. Like I told you before, if I'm writing a banking application, I don't want to write the logic of calculator. I want to use something external that will do that for me, and I want to concentrate on my core logic. So if I talk about, let's say, the example custom action that we are developing, let's say we were doing these things. We were authenticating with internal platform, validating organization policies, and so on. So I want to concentrate on these things. If there are any other things that are needed, I want them to be available from GitHub or any other external library. Now, it is not always that you will find external libraries that will help you, but if something is there, then it doesn't hurt to use the validated external libraries, because security is of paramount importance. So now let's go back here to the browser itself, and then let's talk about this toolkit. So this toolkit is saying that GitHub has already authored few of the libraries that you may need. For example, if I scroll down, there is a core library, provides functions for inputs, outputs, result, logging, secrets, and variables. So you would pretty much most of the times using this core library. And if I go to Visual Studio Code, then the other library that I am using is GitHub. So if you want to use the GitHub context, then this is the library that will provide you access to GitHub context along with the GitHub's REST API. So you would see pretty much always actions GitHub toolkit. I mean, this library is often used. Now that we have this understanding, let's go back to Visual Studio Code. So I am in Visual Studio Code. I will go to index.js. So here I'm saying this external library. So import both of these libraries. Then I'm defining a new variable named name. Again, I am asking for an input here. Remember what I told you. Calling workflow will still have functionality to provide certain inputs. If you remember, in composite actions lecture, we also provided certain inputs. And here as well, I am asking the calling workflow to give the name, and name is the input. Now this name in your scenario could be application name, could be whatever naming that you want to follow here. And then core.info, these are just like echo statements. So what we are saying, GitHub JavaScript action, then we are saying hello name. So whatever input the user is providing, we will have hello there. So since we are using hello, it is likely that we are asking for the name of the user. Again, this is a simplistic example to show you how these actions are created. It does not imply that you be using the exact same action in your production implementation. I want you to understand how these actions behave, so that even if you don't know JavaScript, and when you look at these actions, you can figure out what is that you want to do, or what is that that custom action is doing. And then I'm just displaying the workflow information, and here is the library that I am importing is playing a role. We have the GitHub context here, so we are displaying the event name, the reference, the rum number, the SHA, the repo owner, and so on. And finally, in our code, we are catching the errors. Again, when I'm talking about JavaScript custom action in our index.js, I am defining my automation logic. If I were doing this thing, then I would define the custom logic to do all of these things here, because it is the code where you define your custom logic, and via input you specify what the calling workflow has the authority to define. If I wouldn't have provided this name here, the name input here, the calling workflow would not have authority to provide a name while that workflow would run. So I want these concepts to be engraved in your heads. Now package.json we have already seen. Now let's see the meatier part, that is action.yml. Extremely simple. I want you to correlate this with what you learned in composite actions. In composite actions, the action.yml had the steps which were to be executed, because composite actions execute the steps that are there in your custom action, in your composite custom action. But when I talk about JavaScript action, you have just defined the code. And where is the code? We are saying this runs on node 24. This implies that this is a JavaScript action. Main implies that the automation logic is held in this file. Now if this was placed in a different directory like we saw in the example, you would define that path here. I hope things are getting connected. And name is workflow summary. Inputs, I'm saying the input is name. Description, I'm saying this is the name of the user. So for me, it could be Varun, it could be Cloud with Varjosh. For you, if your name is Ramesh, it could be Ramesh. Required is true. So this input is mandatory to provide. I hope this is clear. Now let's expand the workflow that is using, that will be calling this custom action, the JavaScript action demo. Here the name of the workflow is JavaScript action demo on workflow dispatch. So whenever this API is hit, be it programmatically or be it manually via the UI, this will trigger this workflow. Jobs, I just have one job, I'm calling this demo job. This runs on Ubuntu latest. Understand one thing very clearly. This still run on Ubuntu latest like we have seen before. But in the actions.yml, I'm saying this custom action, when this custom action is used, then node 24, that is Node.js runtime is needed. So in this workflow, when this runs, when a runner is created for this job, you will see that the Node.js runtime is available on the runner that is Ubuntu based. Steps is the first step is to check out the code, which is fine. And why I'm using v5 here, I believe I want to go to GitHub Marketplace, checkout action, and v7 is the latest one, right? So let's go here, let's change this to v7. Then in the second step, I'm installing action dependencies. Now I have kept this step so that you can connect, and then I'll explain you one more thing. So what I'm saying here is, so here the name is install action dependencies, run npm install. And I am saying this because see, we have defined the dependencies in package.json. We have told that we require core and the GitHub libraries from GitHub Actions. But how do we install those dependencies, install those packages in our runner? We do that using npm install. Now I want you to understand one more thing. I have deliberately kept this step so that I can show you that this happens. But most of the actions that you would be using, what the action author would do is they will essentially club whatever the dependency is within the custom action itself, so you don't have to write this step explicitly. Last step is the important one. Here I am saying execute JavaScript action uses GitHub, go to god.github, go to actions, and then workflow summary is the directory. And only this is needed because this automatically, when this is getting executed, will look for your action.yml. And we have already defined that with block is used to provide customizations, and there is only one customization. We have just asked for one input, and that one input is name, and the name that we are providing is cloud with varjosh. As simple as that. So whenever this step is executed, whatever we have defined in action.yml gets executed. And what is defined in action.yml? This code. And where is this code? Here is this code. So this will get executed, and whatever is defined here you will see on your screen. So let's go to our CLI and push this. So what I will write is, I will first cd 0 to JavaScript action. I will write git init. I will write git add dot. I will write git commit -m demo1, and let's call this JavaScript action, and then I will close this. I'll press enter. I will write git remote add origin, and then let's go back to our browser. I will go here and let me go to the top, and then I will just expand this, and then here I will search for GHA. This is this. I'll go here, and here I will just, SSH is already selected. I'll copy this. I'll go to my CLI. I'll paste it here. I'll press enter. So now the remote is added. What I will now do is git push -u to define the upstream, the local to remote branch mapping, origin main. I'll press enter, and this will push our code to our remote. So I'll go here and ensure step 1, that is authentication, is in place, otherwise this won't work. I'll go to actions, and you see JavaScript action demo. I will come here. This is the workflow. I'll click here. I'll click run workflow. I'll go to demo job because this is what I named my job, demo job. That's why you see this here. I'll go to demo job, install action dependencies. So run npm install succeeded, execute JavaScript action. This is the part I am interested in. You see, whatever I provided as input, my input was cloud with varjosh. So hello cloud with varjosh, and I want to have that opened in front of you so that you understand why you see this. So if I go here, index.js, hello name, and what was the name? We defined that whatever the input was provided by the calling workflow. The calling workflow provided cloud with varjosh, hello cloud with varjosh. This is all our echo statements, right? core.info, workflow information, repository, workflow actor, and these are filled by whatever is the dynamic value for that. So for us, workflow was JavaScript action demo, and that is what JavaScript action demo is the name of the workflow. Actor is cloud with varjosh because this is the one who manually triggered it from the UI. Event is workflow dispatch because that is what we defined in our workflow dispatch. Main is the branch, run number, this is the first run, and this is the commit SHA F0781. So if I take you here, F0781, F0781. So this is the push that we just performed. Now that we understand how JavaScript actions work, let's go to the next one, that is Docker actions. So I'll take you back here. Docker action packages the automation logic, runtime tools, and dependencies into a Docker image. Now, firstly, if the name is Docker action, then I know that this would be using Docker somewhere. If we are using Docker, then there would be a Docker image. If there is a Docker image, there will be a container. So I want you to create a mental map with me. Whenever you are using Docker action, there will be a runner, there will be a virtual machine for you, but that virtual machine will have a container, and that container will be executing whatever you have defined. But Varun, why do I need Docker action if I have JavaScript action at my disposal? And you already told me that most of the actions that you would see in the marketplace are written in Java. Then why would I care for using Docker action? You care because not everyone is expert in JavaScript. Maybe you have a use case that cannot be accomplished using Composite or JavaScript action. Then you would use Docker action because Docker action is flexible in that nature. You can write your code in Python, in Java, in Go, in Shell, in Python, or whatever you are good at, because Docker understand Docker container is just providing you with the execution environment. And if that execution environment is provided for Python, that is, if you have the Python interpreter, then you can run a Python program on top of it. If you have JVM, then you can run Java on top of it, and so on. So as long as the base image and whatever you are installing suffices the need for the dependencies like libraries, like runtimes, like interpreters, then you can have your own programming language, as in the choice of your programming language. It could be Shell, Python, Java, Go, Node.js, etc. That is what a Docker action is. Now let's read the bullets so that we can put things into perspective. Packages automation logic, runtime tools, and dependencies into a Docker image. That's fine. Executes inside a Docker container created on the GitHub-hosted runner. GitHub-hosted runner, we know, is a virtual machine in Azure cloud. And on top of that, we are installing a Docker container. Supports any programming language or executable because Docker already simplified this. So you are providing the execution environment, you are defining what is the base image, you are defining rest of the things, and then you have your code. I want you to know that since you have a Docker image, since you have a Docker container, you will of course have a Docker file, and we will see how to do that in the demo section. Again, this can be local, same repository like this, or it can be remote, a dedicated repository like this. Now that we have this understanding, let's go to the demo section. I'll take you to the browser first. I'll go to lecture 12, and this is demo 2, creating a Docker action. Prerequisite part, the step 1 is the same. Step 2 is where things are getting a little different, not much. So again, we have .github directory, that's fine. In that we have workflows, and we only have one workflow, that is Docker action demo.yaml. I don't prefer YAML, so it's YML. Technically the same, but documentation refers YML. Anyway, actions under .github, we have actions. This we have seen. I only have one custom action, Docker system info. Action.yml is fine. This will hold my, what my action is and how to refer to the things that are needed by my action. Remember, in the previous part, action.yml has the path to the automation logic, index.js. Here action.yml will also reference something. Understand, only composite actions had steps in the action.yml. When I talk about JavaScript, they will just point to the code. Action.yml will just point to the code. If I talk about this, you will see what this points to. Then you have a Docker file, and then you have an entry point.sh. Now entry point.sh, do not think of this as a shell script only. This can be anything. So entry point.sh is where you would define your logic. Now this could be a Python code, this could be a Java code, this could be a Go code, this could be a Node.js code, and so on. Understand, this does not have to be a shell script. So whatever language you are comfortable in, that is entry point. And entry point, as the name implies, is run as soon as the container starts. So let's go to Visual Studio Code and understand this in a deeper way. So I'll take you to Visual Studio Code. I will minimize this. I'll also minimize this. I will expand Docker actions. I'll close this. I'll close this. I will minimize this, and I will expand actions directory. Here I have Docker system info. I first want to show you the entry point sh. Now here I have a shell script. Name is $1. $1 implies that whatever the first argument is provided, as in the first input is provided, we are defining that input with the name variable. Simple, and you will understand more about it as I explain you other things. Echo GitHub Docker action, echo hello name. So whatever is result of this, you display the name here. Echo container information. What did I tell you? I told you that there's a virtual machine. On top of that there is a container, and that container is executing your workflow. That is what I told you, is executing your job. Here I am displaying the information about that container. Echo OS information, cat etc OS release. Echo, then I'm saying current user. This will display the current user, and then this will display the working directory. Let's see what is there in the Docker file. So whatever automation logic is, if it is Python, you will have your code here, Python code here. If Java, you will have your Java code here. Docker file, I'm saying from, this is the base image I'm using. Copy, I'm saying copy the entry point sh in / entry point dot sh. I'm giving executable permissions to entry point dot sh. And then I'm saying the entry point is, whenever the container starts, the first thing I want you to do is run this script. And whenever this script is run, what will happen? This information will be displayed. Now let's go to action.yml and see what is happening there. Name Docker system info. This is easy. Description demonstrates a simple Docker action. Inputs, this is the important piece. I'm saying inputs, name, description, name to display, required is true. So input is true and the name must be provided, and whatever the input is becomes the first argument. That is what I'm saying here, and I'll show you how everything is connected. Okay, so action.yml, you are saying runs using Docker. So there you had node 24. In composite actions you had something else. Here you have using Docker. Image, Docker file. This is the important piece. How should the image be created? Where is the Docker file that should be referenced to create the Docker image? And we are saying here is the Docker file. If this were in a different path, you would have provided that. Arguments, this is the important piece. Arguments is inputs.name. So whatever is inputted here for the name becomes the first argument, and that is what we are saying here. Display the first argument, $1. And then we are calling that variable which has the first argument. So it will display whatever is given as name. And let's see what the input is in the workflow YAML. So I'll go here and you see here I am using that, I'm saying with name cloud with varjosh. This is the input that I am using, and then uses dot github actions docker system info. So this is the directory, and this will automatically look for action dot yml here, and rest we have already understood, and we have been doing this since the beginning of this course. Here as well, let's do this, change this to v7. Now let's go to our terminal, and let me go one step back. Cd dot I'll go to cd03. Here I'll clear my screen so that we have more real estate. Git init, I'll run git add dot git commit hyphen m. I'll write demo 2 docker action. I'll close this, press enter. Now I'll have to add git remote again. So this is a new local repository, right? So git remote add origin, and then I'll go here. I will go here. I will go here. I will copy this and I will paste this here. I will press enter. Git push -u to set the upstream. This is a local to remote branch mapping origin main. And this will not work because my repository already has something, right? So let me do one thing. Let me add a force flag. Do not do this in production, guys. Please have your own repositories. So now I'll go here, I'll hit refresh, and if I go to the actions tab, now I don't see that JavaScript workflow anymore. So this is the workflow run, you will see this, but if you look at all workflows, only Docker action demo exists here. So let's go here, run workflow, demo job like we did. I'll go here, and if I go here, this is the workflow. So this workflow will only have two steps: check out and execute Docker action. Check out and execute Docker action. So execute Docker action. Let me expand this. GitHub Docker action. Hello cloud with varjosh, and this is the container information. So this is the container that is executing our workflow. Let that be very clear in your head. There is a runner, there is a container on top of that, and that container is executing your workflow. And here you can be funky, you can use the programming language that you can use the shell scripts as well, but all of these custom action types, they have their use case. What I now want to show you is when to use which custom action type. So I'll go here and I have this section, which custom action should you use? Composite action, reuse existing GitHub actions, shell commands and scripts, or a combination of these. So if you want to do this, then composite action is your best bet. JavaScript action, write new automation logic using Node.js runtime. If you have flexibility that way, if you know that programming language well, then use JavaScript. Docker, if you want to package your own runtime tools and dependencies. So this one is the most flexible. Any programming language you can use Docker action, but understand that when it comes to JavaScript action, there is a rich library that is created for you by GitHub themselves. So this one has an edge like that. But if you can write everything yourself, then no one is stopping you to use Docker actions. And again, I'll let you read these because we have already covered these somewhere in the previous lecture or in this lecture. That concludes this lecture. In this lecture, we completed our study of GitHub custom actions by exploring both JavaScript and Docker actions. We understood when each action type should be used, how they differ from composite actions, and through hands-on demos, built our first JavaScript and Docker action from the very scratch. In the next lecture, we will explore GitHub Actions concurrency and learn how to prevent overlapping workflow executions, control concurrent runs, and build more reliable production CI/CD pipelines. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to lecture 13 of GitHub Actions Basics to Production course. In this lecture, we will explore GitHub Actions concurrency and understand how GitHub Actions handles situations where multiple workflow runs or jobs overlap. We will begin by understanding why multiple workflow executions can occur, when allowing them to run concurrently is beneficial, and when overlapping executions can lead to unnecessary work or conflicting operations. Finally, through a hands on demonstration, we will observe the default behavior without concurrency and then configure a concurrency group to see how GitHub Actions prevents related workflow runs from executing at the same time. And this is the final lecture of this series. And after this, I'll be releasing a mega project. So, without further ado, let's get started with this lecture. Why GitHub Actions concurrency? Firstly, when I talk about concurrency in general, in English, concurrency means something that is in parallel. It could be in our GitHub Actions course, this could be workflows that are running in parallel or a single workflow that is running in parallel. It could also be, if you look at the default behavior of the jobs that are part of a workflow, by default, all the jobs they run in parallel. Hence, in simple terms, concurrency means anything that is running in parallel. So let's understand what is there on the screen. A new workflow run can start while an earlier run is still in progress. And we have seen this. Let's say we have a workflow A. If that workflow A is already running because of run number 1, and if we try run number 2, then the same workflow runs again. And if we have run number 3, the same workflow runs again. So the executions of a workflow can be plenty, and all of them by default run in parallel. That's what this line says. A new workflow run can start while an earlier run is still in progress. There is no condition that says a workflow must first finish, only then the next execution of the same workflow will start. This can happen within the same workflow or across different workflows. So we all know that when I talk about a repository, when it has a .github folder and then .github folder has a workflows directory, that directory can have single workflow or it can have multiple workflows. And when you talk about GitHub Actions, any .yaml file, valid YAML file is considered as a workflow. So right now, if I talk about this directory right now, it just has one YAML, which implies this repository will have a single workflow. Now, if we had 3-4 workflows here, let's say we had 4 workflows, then we would say, when we push these, we would say that this repository has 4 workflows. So what I'm trying to convey is, it is your decision whether you want to have a single workflow or multiple workflows within a repository. But Varun, why would I have multiple workflows? Maybe one workflow is performing the build for you, another workflow is performing the test for you, another is performing security for you, or maybe a single workflow is doing everything for you. So it depends on your DevOps architect or your application architect, how they have designed your application to be. In our example that you see on screen, we just have a single workflow. Now let's go back here. This can happen within the same workflow or across different workflows. So if I have 4 workflows in my repository, all four workflows can run concurrently. They all can run in parallel. If I have a single workflow, that single workflow can be triggered multiple times, and the default behavior is they all will run in parallel, even if the execution of the first workflow has not finished. When can multiple workflows run occur? And we have seen this multiple times. If we perform first push, and let's say when the workflow was running we performed another push, then the workflow will run again and again. This depends on how you have configured your workflow to run. If you have, let's say in our example, let's say the workflow is configured to get triggered whenever a push happens, in that case, if you perform 10 pushes in a minute, then there will be 10 workflow executions, and no execution will wait for the previous execution to finish. What I'm saying is everything will run in parallel, and that is what this diagram is saying. If developer A performs a push, workflow run A is in running state. Developer B performs a push and that results in workflow run B, then there is a second instance of the same workflow running. And when developer C performs the push, again run C happens, and all of these, they run in parallel. And same applies to pull request. Maybe you have configured your workflow to run based on a push and based on a workflow dispatch event, which is you go to the UI and call the workflow dispatch API. You can also do it programmatically, but if you have these two things configured, your workflow will trigger upon every push and on every workflow dispatch API call. So understand your workflow or your workflows can run in parallel by default. But Varun, is this a problem? It depends. It is not a problem if each execution is independent, but it is a problem if the executions, if the workflows, they depend on each other. In that scenario, you may not want to run the workflows in parallel. For example, let's talk about this thing. Workflow 1 is modifying the production infrastructure. While the production infrastructure is getting modified, I may not want to deploy the application. Maybe workflow 1 was creating the VPC onto which my application will be deployed. But if workflow 1 has not created that VPC successfully and I try to run workflow 2, which is deploying my application onto that VPC, then do I want that to run in parallel? I don't. Hence, let's understand when workflows running concurrently or workflows running parallelly makes sense and when they do not make sense. So let's look at this. Are concurrent workflow runs always a problem? So we'll look at both the sections, when it is beneficial, when it can become a problem. So let's first understand when you may want workflows to run in parallel. Different branches or pull requests. And again, I want to be extremely clear that when I talk about workflows running in parallel, it could be a single workflow. So for example, if I have this workflow here, I may want this workflow to run on every push. In that scenario, my single workflow has multiple executions. But what if I have 4 workflows? I may want 4 workflows to run in parallel. In that case, I'm saying multiple workflows are running in parallel. So it can be about a unique single workflow which is running in parallel, or it could be multiple workflows that are running in parallel. So I want you to have that distinction in your head right now itself. So when it is beneficial, different branches or pull requests. Independent workflow runs can validate different changes at the same time. So if, for example, workflow run 1 is running for feature branch A and workflow run 2 is running for feature branch B, then it is okay, because both of these branches are independent. And as we have learned in our Git masterclass, what are branches? They are independent line of development. So if I have different branches, the same workflow, let's say this workflow, could be running for each branch. And even if it runs in parallel, I don't really care, because this is independent work and I would want independent work to be cross checked by workflows. And that is what is happening here. You see, feature A has a CI workflow, build, test, code scan is running. For feature B branch, the same workflow is running, and I don't mind this. And the second one is isolated test environments. Each run uses its own temporary environment or resources. Now look at this. Workflow run A could be playing with test environment A, workflow run B could be playing with test environment B, and C similarly is playing with test environment C. So they are independent. Hence, I may allow all of these to run in parallel, because in essence, each workflow run is independent. So even if they are running concurrently, parallelly, I don't really care. The last one is independent validation. Builds, tests, or scan run without modifying shared resources. Now, if your workflow is, let's say, modifying a VPC, but your parallel runs, you have configured them in such a way that they are not making changes to the same shared infrastructure, then you may want to allow that. But I want you to know that if workflow run A and workflow run B, they are modifying the same infrastructure, then that is not what you would want, because each workflow run would be modifying the infrastructure in whatever way the DevOps engineer has configured, and you may not want that. You may want things to be independent, and that is what here we are saying. So if your workflow is modifying independent resources, not shared resources, in that case you may want to allow your workflows to run in parallel. So the core principle is independent executions plus no shared resources or dependency. Concurrent execution is beneficial. When it can become a problem, duplicate or unnecessary work, multiple runs, repeat expensive operations for changes that may already be outdated. So look at this. Commit A. So let's say you are a DevOps engineer and you are modifying your infrastructure. You performed commit A, build happened, code scan happened, image scan happened. So let's talk about a containerized application, because we have image scan in the application. So let's say you are performing code changes, and when you perform commit A, it is, the workflow got triggered, and then you realized you forgot to modify one thing and you performed a commit B. The workflow runs again and you again remembered, oh, I had to modify one more thing. You performed a commit C. Now this results in 3 workflow executions. Do you really want them to run in parallel? No. What I would want is, when I perform commit B, the previous workflow run should be cancelled, right? When I perform commit C, the previous workflow run should be cancelled, because I know that the correct changes have been performed in commit C. So I do not want to pay GitHub for unnecessary runs. Hence, I want to optimize my runs. I don't want my workflow to run in parallel when it comes to duplicate or unnecessary work. Second is conflicting operations, and this is extremely important and critical, and this can run havoc in production if you do not control this. So let's take this example. Workflow run A, modify resource X, which is running. Okay, now let's say resource X is your security group and you are changing your inbound rules. Workflow B also modifies the same security group, and this time you are changing your inbound rules again. Do you want these to run in parallel? Because of course there will be conflicting changes and you may not want that. Hence, when you are modifying shared resources, then parallel execution becomes a problem. And that is what we learned here as well in the last step. That's what we are focusing on here. Conflicting changes must be avoided. Workflow run A is modifying your VPC, workflow run B is again modifying your VPC, and they both are running in parallel. What if there are conflicting changes? You do not want that. Again, I want to stress on one point here. I'm talking about a single workflow, and that single workflow, first is execution A, then there is execution B. Again, there could be workflows that are different. There could be workflow 1, workflow 2, and you may not want workflow 1 and workflow 2 to run in parallel. Example I already gave you. One is modifying your production infrastructure, another is deploying your application. You would want workflow 1 to first finish making infrastructure changes, and only then you would want to deploy your application. So again, it depends on your use case. Maybe whatever things that you want to do, both of these, modify production infrastructure and deploy your application, could be part of a single workflow, or it could be part of multiple workflows. It depends on how your DevOps architect has designed your GitHub actions. So please do not quote me on that. It really depends. Next is race conditions, and race conditions is saying runs complete in a different order than they are started, and this is important. So let's say first commit A was performed and then commit B was performed. Commit B has the latest changes. So the workflow run that resulted from commit B finishes first, and then the workflow run that results from commit A finishes second. But you had your latest changes in commit B. Would you want this to happen? No, you would want the latest commit, which in your opinion is the greatest. The changes that were brought for that commit must be applicable in production. But what if workflow run A finishes second? In that scenario, that would be the latest changes, because that's the latest run, that's the latest completion which happened after the workflow run that commit be performed. So race conditions, you may want to avoid such situations. If you think that there is variation, then it is better not to allow these runs run in parallel, and we'll see how we tackle these things later. But I want the why to be extremely clear at this stage. Processing outdated changes. Older workflow runs continue even after newer changes are available, and this is an overlap between all the points that we have discussed before. So commit A, workflow run A still running, and commit B, workflow run B, which is triggered. So they both will run in parallel, and we want the latest and greatest changes which was performed in the latest commit. So I hope you know both the situations where concurrency is useful and where concurrent runs are a problem. So what we are saying, the principle is extremely simple. When you have independent executions plus no shared resources or dependency, then concurrent runs are not a problem. And we have seen this in the past in our previous lectures. Now that we have this solid understanding of why, let's understand what is GitHub Actions concurrency. GitHub Actions concurrency ensures that executions belonging to the same concurrency group. So what you do is you create a concurrency group. This is something that you control. When you create a concurrency group, anything, any workflow that is part of that concurrency group, they are not allowed to run concurrently. So if you have workflow 1 and workflow 2 part of a concurrency group, and if workflow 1 is running, then workflow 2 will not be allowed to run. And that is pretty interesting. like the example we discussed before. So if workflow 1 is modifying my infrastructure, then workflow 2 will not be allowed to run, because workflow 1 and workflow 2 are part of the same concurrency group. I want you to clearly have one understanding at this stage itself, that I am not saying concurrency groups will decide the sequencing. No, concurrency groups are not there to tell workflow 1 will run first, workflow 2 will run second, or vice versa. Concurrency groups are just saying that when one execution is taking place, another execution is not allowed. So if you have 10 workflows part of the concurrency group, then only one execution will be allowed to happen. So if, let's say, workflow 5 is running, and then your workflow 6 is supposed to run on a push, and you perform the push, workflow 6 will not run until and unless workflow 5 has completed. I hope this makes sense. So here I'm saying the same thing. If execution A, B, C are part of the same execution group, then at once only one execution will be allowed, and this also applies to a single workflow. So if you have created concurrency group for a single workflow, what will happen? If that workflow is already running, then second execution of the same workflow will not be allowed, and we will dissect this as we progress with this lecture, where you can configure concurrency, for what things you can configure concurrency. We will look into this in detail in our demo section. For now, I just want you to focus on the theory part. And one more thing, if anything is not making sense right now, just stay with the video. When we move to the demo section, everything will connect together, I promise. So again, let's read the definition. GitHub Actions concurrency ensures that executions belonging to the same concurrency group are not allowed to run concurrently or parallelly. By default, multiple executions can run at the same time. I already told you this. Concurrency groups define which executions are controlled together. Same group executions follow the same concurrency rules. So for example, like I said, if 4 workflows are part of the same concurrency group, then they cannot run in parallel. If execution 1 is happening, execution 2 must wait. Control overlaps. Allow an existing execution to finish or cancel, and this is governed via cancel in progress. So let's say you configured concurrency for 2 of your workflows, workflow 1 and workflow 2. What I am saying is, if you have cancel in progress as false, and if workflow 1 is running and then there's a push performed for workflow 2, workflow 2 will wait for workflow 1 to finish, only then it will start. But cancel in progress, if it is true, if workflow 1 is running, that will be cancelled, and the latest workflow run will be given priority. So workflow 2 will be running, and this setting is extremely useful. Let's talk about this. I told you I performed commit A and the workflow run started. If I have defined concurrency and cancel in progress is true, and then I perform commit B, and the workflow will run and it will cancel the first one if I have this true here. So it becomes extremely useful in this scenario. When you are a single developer who is working on a repository, you don't want unnecessary runs. So when you perform commit A and workflow is running, and as soon as you perform commit B and your workflow is part of a concurrency group, in that scenario, the previous run will be cancelled and the latest run will start if you have this true. Again, it is called concurrency group, but you can also have a single workflow in that concurrency group. And that is what in this example we were discussing. It was, let's say, the same workflow. Commit A was performed, the workflow runs. commit B was performed, the workflow runs, commit C was performed, the workflow runs. So there were 3 parallel runs here of the same workflow. In here, you can have that workflow part of the concurrency group. So if you have commit A and then you perform commit B, the workflow run that happened because of commit A will be cancelled. It's so simple to understand, right? And then we understood both finish or cancel. Then the last one is flexible scope. Apply to workflow runs, jobs, or executions across workflows. I don't want to stress on this point right now because we will do that in a little while. So for now, let's go to the demo and see what we want to do. So what I'll do is I'll first take you to my browser, and here I will zoom in a little. I will go to the repository for this course, which is GitHub Actions Basics to Production. And my dear friends, if you have not already started this repository, then please do, if it is helping you. So I'll go here, then I will go to lecture 13, that is concurrency, and I'll scroll down a little. And here I've also started a personalized guidance on DevOps and cloud. So if you have any confusions about your career, if you are seeking for any guidance on that, then feel free to book a session with me, and I'm offering it at a very nominal cost. So let's scroll down and get back to the topic in hand. So I will go to demo, understanding GitHub Actions concurrency. And step 1 is you must already have a repository, and it is easier if you have a repository with name this, so you can copy paste the commands, and visibility is private like you would see in production. If you do not have authentication in place, as in if you cannot perform push to your remote, in that case go and watch lecture 1. We covered that in that lecture. So I already have authentication in place, and I already have a repository with this name. You can see here CWVJ practice. I already have it. And then step 2 is create a running workflow. So I'll go to my Visual Studio Code. I will go here because this is the workflow that we'll deal with. I'll zoom in a little, and then I will move this tool left, and then I already have a workflow created, and I have not defined concurrency in here. I first want you to observe again what happens when you have multiple runs of the same workflow. So we are dealing with a single workflow here, but concurrency can be configured across workflows, and we'll see that in a little while. But I want these concepts to be in your head at this moment itself, so that when we reach that stage or when we are discussing these things, you keep your imagination open. So we are calling this GitHub Actions concurrency demo. That's the name of the workflow. This is what you will see on UI. We are saying our workflow can be triggered in 2 ways. One is when the push is performed onto the main branch. Second, when the workflow dispatch API is called either programmatically or via click operations. Then you have jobs. I only have one job, and I'm calling that concurrency demo job. And intentionally what I have done is, if you see the steps, the first step will just display the run ID and the commit SHA. I'm using an expression for that. And if I scroll down, the second step, what we are doing is we are simulating a long running task so that our workflow run doesn't finish in a blink. So this workflow will at least take 2 minutes to complete execution. And I have kept this so that I can show you the behavior in a flexible way. The last step is just complete workflow. I'm echoing workflow completed successfully. Very, very simple. Let's now go to our terminal, and we have not touched concurrency yet in our demo. So it is yet to be configured. So please hold your horses for now. So what I'll do is I am already in project files. If I do ls-a, you see .github directory exists here. I am in project files. Okay. So what I will do is I will run git init first, and you see I am in the main branch. If your branch is called master, I would suggest you rename your branch, and steps for the same can be seen from here as well. So if you run this command git branch -m main, it will rename your branch from master to main. Anyway, so what I will run now is git add dot, so whatever is there, move it to the staging area. Then I will write git commit hyphen m. My commit message would be, let's say, feature. I am adding concurrency demo. I'll close the double quotes. I'll press enter. So the commit has happened, but I have not defined my remote yet. So what I will run is git remote add origin. You will see origin is a popular name, although you can have another name if you want to. I'll go there to my browser. I will copy the SSH part because we are using SSH for authentication. If we were using personal access tokens, we would have used HTTPS. And then we covered all of this in lecture 1. Okay, so I'll come here, I'll press enter, and if I run git remote, I'll see that origin is here. Now I will perform a push. So git push hyphen u origin main hyphen u defines the upstream, that is local to remote branch mapping. So I've run this. Now the push has happened. So let's go to our browser and observe what will happen. Okay, so if I hit refresh, this should now have a commit. It has a commit, and this is our commit message, feature concurrency demo. So I'll go to actions tab here, and you see, since our workflow was supposed to run upon a push, our workflow is running. So, but if I go here, I can also run it manually, run workflow. So another workflow execution has happened. I'll go back. Let's run it again. I will run workflow, and this is the third execution of the same workflow. So by default, you see in progress queued, and this will be in progress soon. So if I hit refresh, you see all of these three are in progress. And if I have another workflow run, it will again go into in progress. So what we are seeing here is the default behavior. So by default, all of the workflow runs are happening in parallel. So whatever you have configured your workflow to trigger on, so whatever events that you have defined here, I only have defined 2. Whenever those events happen, your workflow will trigger. And at times it is okay, and we have already discussed what are the scenarios where you would want workflows to run in parallel or concurrently, but certain scenarios you may not want that. And in this lecture, we are discussing those scenarios where you do not want your workflows, be it single or be it multiple, to run in parallel. And we have already seen the conditions, the situations where you would want workflows to run in parallel and where you would not want to run them in parallel. Again, the list that I shared, the examples that I shared, they were indicative, not exhaustive. There could be multiple scenarios where you would want your workflows to run in parallel or not run in parallel. With that understanding, we already know that by default they are running in parallel. So let's change that behavior now. So the first workflow run was already completed. 2 minutes and 8 seconds. 2 minutes was our sleep interval, and then 8 seconds more it took. So let's go back to our workflow and add the concurrency part. So what I will do is I will copy something and I will paste something here. We have already seen this block in the theory section, but let's see what is happening here. First thing I want you to note is concurrency. I have added this at the workflow level. Understand, this is extremely critical. I could have defined this at job level as well, and we'll see what are the possibilities in a little while. But for now, this concurrency is applicable for this workflow. And what I'm doing is I'm saying the group is, I'm calling the group concurrency demo. So for us, we only have one workflow, which is part of this concurrency demo. So what we are saying is, even when there are multiple executions for this workflow, do not run them in parallel. What I'm saying is only one execution. at most only one execution should happen for this workflow. Now, if you had, let's say, multiple workflows in this repository, then any workflow that was part of this group would be part of this concurrency group. So if, let's say, this is your workflow 1 and you have workflow 2 and workflow 2 also has this defined, in that scenario, workflow 1 and workflow 2 will not execute in parallel. As simple as that. And cancel in progress is false, like I already told you. If one workflow run is already executing, you let it complete and only then begin the second one. If this were true, then the first execution will be cancelled and the second one will start. Very simple to understand. Now that we have this understanding, I want to take you to the GitHub notes and explain this in a little more detail, because I feel this is a feature that you would pretty much always use in production implementations. So I want you to have a clear understanding on where these things can be defined. Okay, so I'll go at the very top, and then with the clickable table of contents, where can we define concurrency? I'll go here. Okay, and this is critical. First is workflow level concurrency, and as soon as you hear this, you already know this is dealing with workflows. This can be defined within the same workflow. We have already discussed this in the example. In the demo, we are doing this thing. It can be defined across different workflows. So workflow runs from different workflows in the same repository. This is the keyword, folks, in the same repository. So if I have this, let's say I go here, I only have one workflow, and this workflow is part of my repository GHA practice. Now, this thing will only apply if we are dealing with a single repository, same repository, and that same repository has 5 workflows. They all can be part of the same concurrency group. That is what we are telling here, and this is what I already told you while we were discussing this YAML syntax. So workflow level concurrency within the same workflow across different workflows. And if you see, this is what we are using. And in this scenario, like I already told you, workflow run A, workflow run B, they won't be allowed to run in parallel. By default, they were running in parallel like we saw here in our demo in the previous part. But here, when you define this, if workflow run A is already running, workflow run B will not execute concurrently with it. We already understand this. And same is this, controlling workflow runs across different workflows. So if I go back to the diagrams again, and if I scroll up, this is what we were discussing here, right? If workflow 1 and workflow 2 are part of the same concurrency group, in that scenario, they will not be executing in parallel. So only one execution will take place. And that is what we are defining here. But let's talk about the important one. And I'm not saying this is not important, but this is where a lot of students get confused. Okay, these last 3. This, because everyone teaches this, so this is clear, but this and these 2 are a little typical to understand. So let's see what is happening. Job level concurrency controls a specific job rather than the entire workflow. So first is within the same workflow. So here, very simple to understand. I have defined this block at the workflow level. I can also cut this and move it to a specific job. And when I move it to a specific job, what happens is that job, so for example, workflow run A happens and run B happens. Both the workflows will be allowed to run in parallel, but the job will not be allowed to run in parallel. So for example, workflow run A has this job, workflow run 2 also has this job, but the workflow will run in parallel, okay, but this specific job will not run in parallel. So that is what we are conveying here, and let's see how that works. Okay, I'll go to the browser and see. I'll scroll down, job level concurrency. Now there are 2 common ways this can be used. First is controlling the same job across multiple runs of a workflow, of a single workflow within a workflow. This example, let's say, then we are saying if workflow run A has build test deploy, workflow run B has build test deploy, What you can do is build and test. Both of these jobs can run in parallel, but when it comes to deploy job, they are not supposed to run in parallel. And this is so good. Maybe you are deploying to the same cluster. What you want is when the job part of execution 1 is running, then the deploy job part of execution 2 should wait for the previous one to finish, or maybe it cancels it. It depends on how you have configured this parameter. So I hope this is also making sense to you. The second one I want to discuss is across different workflows. And whenever you see across different workflows, be it here or be it here, understand that the same repository is the prerequisite. Specific jobs from different workflows in the same repository can be controlled together when they use the same concurrency group. It is so simple to understand once your foundations are well laid. So job level concurrency can be used when specific jobs from different workflows should not execute concurrently. For example, like I told you, infrastructure workflow has the infrastructure job, deployment workflow has the deployment job. If we drill down, previously we were saying this workflow run should not run in parallel with deployment workflow. What if I have a deeper use case where I only have this condition for a specific job, because this job is modifying my infrastructure, this job is deploying my application? What I would want is none of these jobs across different workflows should be running in parallel. See, concepts, I have laid them out pretty well. After watching the video, do read the GitHub notes and it will give you a solid understanding. Do not try to skip these sections, because in interviews you will be asked this question. In real production scenarios you would see these scenarios, you may have to use these things. And in my experience, any GitHub actions implementation I have seen, I mean, these are my figures. 95% of them have used concurrency somewhere, right? Be it in jobs, be it in workflows. So let's get back. I'll take you back to the browser. I'm already there. So I'll go here. So let's do one thing. So we have performed the change. Let's push that change. So I'll write git add dot. If I run git status, I should see some changes, right? Yeah, modified. This is good. So git commit -m. I'll add a commit message, added concurrency section, and I'll press enter, and then I will write git push. I've already defined the upstream, so git push should suffice. I'll go to my browser, I'll go here. So all of these 4 have completed. Now I should see a 5th one here, and in progress. Okay, so let's have another run here. So I'll run this workflow again and then go back, hit refresh. In progress. This is pending, my friends, and there is a clock sign that says this one is waiting. So if I go here, the workflow is waiting for GitHub Actions concurrency demo 5. This one is 6, number 6, the 5th one to complete before running. So if I go one step back, this is the run number 5, and this one is waiting for run number 5 to complete, and that's why this one is in pending state. Previously all of them were in progress at the same time, because parallel execution is allowed by default, but since we have configured a concurrency group, we can no longer do that. That's why this is in pending state. Now I'll show you one thing that is very interesting. So run workflow, and then when I go back, okay, this in progress is fine, but why do I see an exclamation mark here, and this one is waiting? Let's go here, GitHub Actions concurrency demo canceling. This job, this workflow run is cancelled. canceling since a higher priority waiting request for concurrency demo exists. So if I go back, you see the behavior. The behavior is the newly triggered run replaces the existing pending run. So I started this and this was replaced. This was cancelled, and now this becomes the one that will be executed once this finishes. So if I do it again, then this one will get cancelled. So see, and then I go back and let me hit refresh. Oh, so this completed, which is why this got triggered. So this is waiting. Now let's have another run here. It's so interesting, right? I'll go back. See, this is cancelled. Now, if I have, run number 10, let's do that, then this will get cancelled. Because understand, the newly triggered run replaces the existing pending run by default is the keyword. You can control this behavior, but see, this is so cool. These two got cancelled because this is the right behavior, right? So if I am working on my pipeline and I perform pushes simultaneously, then GitHub is saying, okay, Varun, I understand that you make mistakes a lot and you perform a lot of commits. That is how you learn, right? So I know your commit 2, your commit 3, you don't want them to execute anymore. That's why we'll cancel those. Only this commit will be taken into consideration, and you can change this behavior. So again, by default, a concurrency group can have at most one running and one pending execution. One running as in you may execute it 10 times, but only one running execution, and this is the one running execution that we are talking about, and one pending execution. This is the pending execution. Rest of them are already cancelled. If another run is triggered while one execution is already running and another is pending, the newly triggered run replaces the existing pending run. So that is what we saw here. I hope everything is now connected, and now this has completed and this has started getting triggered. And let's do one more thing now. So if I go to my Visual Studio Code, what I can do is I can mark this true so that the run that is already happening gets cancelled and the new one gets in the running state. So let's go back to our terminal. I will again run git add dot git commit -m feature. Now cancel is true, and then let's write git push origin main. Okay, we'll have to let's go here. Okay, this has started now. Nor cancel is true. Now is, please pardon the typo. So now when I do another run, this should get cancelled and the new one should start. Let's click on run workflow and then go back. You see, this got cancelled and this started. And let's do that again. This time too, this will be cancelled. And let's go back. And soon this will be cancelled and this will be started. So let's hit refresh. You see, this got cancelled and this started. I hope these things are making sense, and I want to show you how to change this behavior. So concurrency GHA, and then let me go to control the concurrency of workloads and jobs, and I'll scroll down, and the using concurrency and the default behavior, concurrency group. Now, yeah, queuing multiple pending runs. By default, only one job or workflow run can be pending in a concurrency group at a time. To allow multiple runs to queue instead of being cancelled, set queue max. Now, when you have this here, queue max, then what will happen is, then you will be allowed to have multiple runs in the queue, and the maximum is up to 100. I hope this makes sense. Another thing that I want to talk about is, note that Qmax cannot be combined with cancel in progress true, because the two options describe conflicting behaviors for handling in progress runs, which is obvious, right? If you're canceling the previous one, then what's the point of queuing, correct? So I hope everything makes sense. Now, there is one last thing that I want to talk about. See, what we have done is we have statically defined these things, right? If I go here, I have statically defined the group name, but in production there are multiple branches. These groups should be created based on branches, right? So if there is a feature branch, then everything that is related to that feature should be part of the same concurrency group. So I'll show that to you. Okay, I'll go to my notes, I'll go at the very top, and here I have a section on this, using dynamic concurrency group. So you don't name your concurrency groups like this. In production, what you would see is you are naming your group based on the branch. So let's say if there is a feature branch, feature A, and I'm showing that example here as well. So let's say there is a feature A. So what you would want is any workflow run that is for this feature A should be part of the same concurrency group, and anything that is part of feature B should be part of another concurrency group, because you don't have problem in feature A workflow and feature B workflow running together. That's fine, right? Because they are independent. But when it talk about feature A, any workflow runs that are for feature branch A, you may not want to run them in parallel, which is why you would want to use something like this when you are dealing in production implementations. And I will let you read this along with reading the official documentation, so that all of these things connect in a proper way. In the documentation as well, they have started with this example, and then later on they have also shown you static concurrency groups, but in production you would use dynamic concurrency groups. And its use case is pretty simple if you understand branching, which I believe you already do. So that is all I wanted to cover in this lecture. So that concludes this lecture, and with that, GitHub Actions Basics to Production course. Throughout this course, we started with fundamentals of GitHub Actions and gradually built our understanding of workflows, events, jobs, steps, variables, expressions, dependencies, matrices, reusable workflows, custom actions, and so on. In this final lecture, we explored GitHub Actions concurrency and learned how to manage overlapping workflow and job executions. My goal with this course was to help you build a strong understanding of GitHub Actions, starting from the basics and gradually moving towards concepts and patterns that you are likely to encounter in real world production implementations. However, this is not the end of the journey. In the upcoming days, I will also be uploading a production grade GitHub Actions project where we will bring together many of the concepts we have learned throughout this course and see how they work together in a production implementation. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.